So in this video, we are going to solve NeetCode 150 list completely all at just one place. Now, if you don't know, NeetCode 150 has been this awesome data structure and algorithm list created by a YouTuber who runs the channel named NeetCode, which I'm a big fan of, and definitely you should go and check it out his stuff. I can guarantee you that if you can solve all of these 150 questions flawlessly with understanding that what has been the logic behind those questions, you would be able to pass every single technical interview out there, no matter what company you are aiming for. And I can guarantee you that because this list is that much impressive. And that's why I have been trying to solve this entire list by myself as a personal learning journey. But along the way, I found myself recording these videos and then I have decided to share it with the team. Now, it took me a lot of time to go over and complete this entire thing. So I would really appreciate if you can watch it, support my channel, become a member and share it with your friends because it took a lot of time to complete this. And I want to pay my utmost respect to the YouTuber NeetCode who has been doing a tremendous amount of work helping people all across their careers. So now without any delay, let's get started with the list NeetCode 150 and we'll see you on the other side. So the LeetCode problem we are going to solve now is called contains duplicate. We can see that this one is a LeetCode easy problem and also an extremely well-liked problem. The statement is quite straightforward that we are given an integer array called nums. Now we need to check that if there exists any particular value more than one times, at least twice, then we need to return true, saying that yes, there exist duplicates in the given array. And if it does not exist, we need to return false. So let's try to understand this with an example. Suppose this is the input array we are given. Now we can notice that value 4 appears twice in this case, which means there exist duplicates in this given input array nums. So we need to return true in this case. Now if, say for an example, we are given one more nums array and all the values are unique or we don't see any duplicate values, so basically in this case we can return false, saying that there does not exist any duplicate values. And the statement is very simple to understand. Let's see that what is going to be the most common brute force approach we can use to solve this problem. We will take the first value and we would check against every single other value possible that whether one is present or not. We identify that one is not present. So in this case, now we would move on to the next value 2 and once again repeat the same operation. For 3, repeat the same operation, and at the 4 we would realize that there exists one value 4 that is being repeated. So basically found a duplicate, so we will return true in this case. And say for example, if we don't find duplicates and we reach to the end of the array, then we can simply return false, saying that there does not exist any duplicate values. Straight away you can see that what is the issue with this approach. Well, the idea is that for any particular n value or any particular work, we will have to repeat the same operation for every single other values, which means the time complexity is going to be big O of n square, which is definitely pretty expensive, and there are ways to make it faster. So the first optimal approach that comes to our mind is basically sorting. If we can somehow sort the given input array, then things would become much easier. Let's say that we are currently given an input nums and the values are scattered all across the place, and we can find that there are some duplicate values over here as well. If we sort this given input array, then the sorted input is going to look something very similar. And then for the sorted input, all we need to do is just keep checking all the values with its next value or previous value. And over here after 1 we find value number 3, which means it is not possible to have 1 in the remaining array because this is a sorted array. Same way for 3 we found value number 5, which means there is not possible to have another 3 inside the remaining array. But for 5, because there exists a duplicate, it has to be very next to it. We found a duplicate and we can simply return true in this case very easily. Now this is a much better approach than our brute force approach, but let's see that what is going to be the time complexity. Well, it is going to be big of n log n because it takes n log n time to sort the given input array. And the question is there a way we can do something better? And the answer is yes. The fastest approach in this case is going to involve something where we need to keep track of all the elements that we have already seen, and we should be able to access them quickly. And these are the two basically conditions that we need to follow. And for that, the best data structure in this case is going to be a hash set, that it cannot contain duplicate values, and it basically finds any particular element inside the hash set in big O of one time. So suppose this is the array we are given as an input. Now what we will do is that we will iterate over this array, and for every single value, first we will check that whether this value is present inside the hash set or not. If it is not present, we will simply just add it to the hash set and it move to the next value and repeat the same process. So let's see that how would that work, and let's say that this is going to be our hash set. Okay, so first we are at value number 3. Currently value number 3 does not exist inside the hash set, so we will simply add value number 3 and move on to the next value. Once again value number 1 does not exist, so once again we would add value number 1. Now 4 also does not exist, and now once again we would move to value number 1. Again at value number 1 we would check that whether this exists inside the hash set or not, and yes, it does exist inside the hash set, and we can check that in big O of one time, which is awesome. So in this case we can say that because there exists a value that is already present inside the hash set that we are trying to add to the hash set, which means the given array contains duplicate. So in this case we can simply return true, and say for some reason this value 1 is not present over here, and let's say that this value is maybe 6. So 6 currently does not exist inside the hash set, so we will add 6 over here. Once again we are at value number 5. 5 also does not exist, so we will add 5 to the hash set, and now we have reached to the end of the array. So if we reach to the end of the array, we can simply return false, saying that there does not exist any value that is duplicated. If we see time complexity, in this case the time complexity is going to be big O of n. Why? Because we are simply iterating over the given input array once, and for every single value, even though we are checking that whether it's present inside the hash set or not, it can be done in big O of one time. That is the power of hashing functions like hash set and hash map. And if we see space complexity is going to be big O of n as well, because we will have to use one more hash set to store all of these variables. But still this is much better compared to our brute force approach that had the time complexity of basically big O of n square. So now let's see the coding solution for this one. So the coding solution is going to be quite straightforward. First of all, we are going to initialize our hash set that we are going to keep track of the scene numbers. Then we are going to iterate over every single element that is present inside the nums array. And for each of those elements, we are going to check that if our hash set contains that particular number or not. If it does contain, then we can simply return true, saying that we have detected a duplicate. If it does not contain that number already, then we will just simply add that number. Say for an example, if we end up iterating over every single element in the array and we reach to the end of the array, which means there are no duplicates, so we can simply return false. Let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And as expected, code runs beautifully. It beats nearly 90% of all the other solutions that are present on the LeetCode, which is pretty awesome. And the solution of this code is present in our GitHub repository, so feel free to go and check it out from there. Thank you. So the LeetCode problem we are going to solve now is called valid anagram. We can see that this one is a LeetCode easy problem and also an extremely well-liked problem. Basically, we are given two strings s and t. Now we need to return true if t is an anagram of s and false otherwise. Now, what is the definition of an anagram? Basically, if every single character that is currently present in T is also present in S, then they are anagram of each other, not more, not less. So let's try to take an example. Suppose in this case, we can see that currently S has the words cat and T has the word tech. Now we can see that C is present on both. So that's good. Same way A is present on both, and same way T is present on both. So we can say that in this case S and T are anagram of each other, so we can return true in this case. Now if we take one more example, we can see S contains R, T also contains R, so that's good. S contains A, T also contains A, but the thing is currently s has m that is not present inside the t. So in this case we can say that t is not an anagram of s, so we can return false, and basically this is what we need to return. So let's try to see that what is going to be the most common brute force approach to solve this problem. Suppose we are given s is equal to rat and t is equal to tear. Okay, so in this case, as part of the anagram, what we'll do is we'll take a character inside the s. For this, we will iterate over every single other remaining character inside the t to make sure that whether that character is present or not. If it is present, we can remove it from here, from both sides. Same way, we will repeat the same operation for all of the different characters, and we will come to the solution. Now, if you see, this approach would yield correct result. But the thing is, if you see time complexity, basically it's going to be big O of n square, because for every single character present inside the s, we will have to check against all the remaining characters inside the t, which can be quite expensive. So this is like a bad approach. Now let's see that what would be the optimal solution in this case. And the logic is that first of all, we will have to check that if the given s and t, if they are to be anagrams of each other, basically their length has to be same. So first thing we will check is that if the length of s and t, if they are same, that's good. Then only we will proceed. If they are not same, we don't even have to check that whether they are anagrams of each other. So this would eliminate like all the bad examples. Okay. Now let's see that what is going to be the logic for the given subsequent s and t. Let's say that the current s has the word cart and the current t has the word rat, RATC. Okay, they are the anagrams of each other. Now we already know the pre-existing condition on what defines an anagram, that the frequency of any particular character present at s and t are going to be same in no matter what. So this fact we are going to use to basically come up with a clever solution. Now first approach is that we actually use a hash map, or second approach is that we basically use an array. Now why we are able to use an array in this case to solve the problem, because we know for a fact that English language only has 26 character. So we can actually initialize a character, an array with 26 size in it, and based on the index position we would mark like subsequent positions within the characters. So let's say that if we are dealing with character a, then a has to be present on the first index of our array. Same way b has to be present on the second index of the array. Okay, once we have an idea on how we are going to keep track of the frequency, now what we need to do is that frequency has to match both on s and t. So for that, what we will do is we will start iterating over for s and t at the same time. We know that they are both at the same length, so we can just use one for loop or one loop to iterate over them. For every single character that we find, we are going to, and for each of them we are going to initialize values with values 0. Okay, and now let me just arbitrarily mark values like c, a, r and t. So c, a, r and t, these, let's assume these are the values. Like actual values would be different based on their character positions. I'm just putting it here so that it would be easier for us to visualize. Okay, so first we have character c at position number s. All we are doing is that whenever we find a character in s, we are going to increment the counter within the array. And if we find a character inside the t, which means we find like a subsequent reciprocal character, so then we are going to decrement the counter. And how it is going to work is, first we identify character c over here, so we are going to increment the counter to value number 1. So let's just mark this as 1. Subsequently, at the first position the value is r, so once again for r we are going to decrease the counter, so this is going to become -1. Okay, now for a, once again we are going to increase the counter based on this s, and we are going to decrease the counter because this is also a, so that this would become -1. So basically overall this value would become 0 after this change. Okay, now next we have r. So in this case we are going to increment r. Now notice the value of r is already -1, so we will turn it back to 0, and this value is t. So currently t is 0, so this value would become basically -1. Okay, and last one is t. So in this case notice that t is going to become 0. So let's just mark t as 0. and this value is C. So we will have to reduce the value of C. So if we reduce the value of C, basically this is going to become 0 as well. And now notice that after iterating over all of this, we found out that every single character that was present inside the S is also present inside the T. And what is the way for us to check it? We simply iterate over this given array once. If we find for any particular character that there exists some value that is other than 0, then we can simply return false, saying that they are not anagrams of each other. And let's take that as that example as well. That let's say over here inside the input, let's say that this value is still cart and this value is over here it's, let's say, RATO. So notice in this case this C would have remained 1 because we had C over here that was not present inside this T. And notice that for this character O, let's say that this is the character O, this value would have been -1. So overall we would have like more than one values that does not contain value 0, and we can explicitly say that because this is the case, we can simply say that they are not anagrams of each other. So this is a very fast and beautiful approach. Now let's try to calculate time and space complexity in this case. Time complexity is going to be big O of n, where n is the total number of characters present inside the S or T. And in terms of space complexity, well, this is still going to be constant space complexity, because even though we are initializing an array, the maximum length of that array is going to be 26 characters only, which is a constant space. It is not continuously growing, and it doesn't change with the given original input. So that's why this is a beautiful time and space complexity. And now let's quickly see the coding solution for this one. So the coding solution is quite straightforward. First, we will check that whether the length of S and T are equal or not. If they are not equal, we can simply return false. If that is not the case, we will initialize our array called character counts that is going to be of size 26. Then we will increment the count for every single character that is present in S and decrement the count for every single character that is present in T. And we can just simply update the character counts array that we have just initialized. And after that, all we need to do is to check that if in the character count array, are there any other values that are not 0? The moment we find a non-zero value, we can simply return false, saying that S and T are not anagrams of each other. If we do find all the values are 0 and get out of this loop, which means they are anagrams of each other, and we can simply return true. So let's try to run this code. Seems like our solution is working. Let's submit this code. And the code beats nearly 45% of all the other solutions, which is pretty good. If we see memory, it beats nearly 80% of all the other solutions, which is awesome. So once again, the coding solution is present on our GitHub repository. Feel free to go and check it out from there. Thank you. The LeetCode problem we are going to solve now is called toSum. This is the number one problem on the LeetCode, and we can see that this one is an easy problem and also the most like problem on LeetCode. Let's understand the statement. Basically, we are given an integer array nums, and we are also given an integer called target. Now we need to return the indices of the two numbers within the nums array such that they are the sum of target. So basically they add up to the value target. And we are guaranteed that there is always going to be one solution, and we can return these indices in any order. So let's try to understand this with an example. We are given an input array nums over here, and we can notice the values are 15, 7, 2 and 11, and we are also given target value to be 9. Now in this example, we can see that the 7 and 2 sums up to target value number 9. Now if we see the index positions of the 7 and 2, they are located at basically 1 and 2 position. So we can return the answer as 1 and 2, or we can also return 2 and 1, whichever like sequence we want, but basically this is what we need to return. Now let's understand that what are the different ways we can actually find the sum of these two values. So first, let's understand the brute force approach. Basically, for the same example, let's say the values we are given, we are going to try every single permutation and combination. So what we will do is, currently this value is 15 and the target we wants to make is 9. Okay, so this value is 15, so we cannot use any other value to basically form the target value as 9, so we can just ignore this case. Okay, now this value is 7. So because this value is 7, the total target we wants to build is 9. So what we'll do is we'll do 9 minus 7. So we will check that if the value 2 is present inside the remaining array or not. And lucky for us, the value 2 is present, so we can just return basically the index positions of these two. Now notice that in the brute force approach, what we are essentially doing is for every single character, in the worst case, we might have to iterate over all the remaining characters to see if any particular value is present or not. Let's take an example that if this value was to 1, then we would have to check that whether 8 is present. So for that, we might have to basically go over all of them. So the time complexity would have been big O of n square. That is a bad time complexity. Now let's see that if there is any particular way we can improve upon that, and the answer is yes. If we do sorting, basically things would become slightly better and easier. How? Let's understand that for the same example, if the values are 15, 7, 2 and 11, once again if we sort these values, we would be left with value 2, 7, 11 and 15. Now we are at value number 2. Okay, so notice that if the target we want to generate is 9, if we already have value as 2, which means if we do 9 minus 2, the answer becomes 7. Now all we need to do is to check that whether 7 is present inside the remaining array or not, same as our brute force approach. But in this case, because we know that this is already sorted, instead of using linear search where we are iterating over all of these values one by one, we can use binary search, and that would help us alleviate a lot of questions. Because in the binary search, remember that we will find the middle value. So let's say we find middle value is 11 in this case, and from 11 we know the value we are trying to build is 7. So even if there were like 100 elements on the right of 11, they will all be greater than 7. So we cannot use them, so we will just ignore the entire right portion and only limit our search to the remaining piece, and we would be able to find the remaining value in essentially log n time, which is exceptionally fast. So this, if we see like the sorting approach of sorting the original input array, things becomes quicker, and we can actually solve this problem in big O of n log n time, and this is the time to basically sort the given input plus log n time to find any particular character. But the thing is, generically we can just write it big O of n log n as the overall solution. Now the question is there a way to do things quicker? And the answer is yes. We can even do things faster if we use an additional data structure in this case. And let's see what are the considerations for us to understand any particular data structure. Number one thing is, whenever we see a value, we are trying to basically determine that what is going to be the remainder. So in order to quickly look up that do we have that remainder or have we already passed that remainder or not, what we can do is we can use a hash map in this case. Now notice hash map contains two properties. First thing is a key, and second thing is an appropriate value. Now as part of the key, we would put whatever the array item that we currently have. So let's say that we are given once again this array as an example. Okay, now in this case we once again need to return the target value of, let's say, 9. So now in this case, what the algorithm we are going to use is, first we'll iterate over any particular character inside the given nums array. For that character, we will see that what is the remainder value we are trying to generate. So for this value number 1, we know that the remainder value should be 8. The question is 8 present inside the hash map or not? If it is not present, that's it. We simply add this value 1, saying that it could be potentially a match for some future target value that we are trying to generate, and continuously we will keep on doing that. So as a key, we will add value 1 over here, and as its appropriate value, we are going to store the index position. So index position for this 1 is going to be 0, so we will store value 0 over here. Now let's repeat the same operation. Now next value is value number 7. So for if we already have a 7 to be part of the 2 sum that we are trying to generate, we will need to have 9 minus 7, which means value number 2 as part of the hash map. But currently hash map does not have value number 2. So what we'll do is we'll simply add value number 7 with its index position as 1. Same way we have value number 3. If 3 were to be part of the answer, we need to find value number 6. 6 is not present inside the hash map, so we will simply add 3 over here with its appropriate subsequent value, that is index position number 2. Now we are at value number 2. For 2 we need to find value number 7, and lucky for us, 7 is present within this hash map, and we already know its subsequent value is 1. And since we are already at 2, we know the index position of 2 as well. So in this case, we can return the answer as, let's say, 3 and 1, or we can also return like 1 and 3, whatever we want. But basically this is the index position of the values that basically sums up to total value number 9. And this is the fastest way to solve this problem. Now let's analyze the time and space complexity. Time complexity is going to be much faster big O of n. Why? Because we are iterating over all of these elements just once, and we are coming up with the solution. Because remember, searching that whether any particular value is present inside the hash map or not happens in big O of one time, which is significantly faster than everything else. Let's analyze the space complexity. So space complexity is going to be big O of n as well, because we have to use an additional hash map to store the results. But needless to say, this is much quicker than both our brute force and also our sorting approach. So now let's see the coding approach for this one. So the coding solution is quite straightforward. First, we are going to initialize a hash map to store all the values and their index positions. Then we are going to iterate over the given input array nums. And for each of the array, we are going to calculate that what is the remainder value in a variable called complement. Then we are going to check that if that complement is already present inside the hash map or not, which we can do in big O of one time. If the value is present, we simply return a new array that contains the value of that particular key and the current ith position. These are the two index positions. If we do not find that value, we simply add this current number that we are iterating over within our hash map using map.put. And in the end, we simply return an empty array if no solution is found. But this wouldn't happen because in the problem we are already told that there is always going to be exactly one answer. We are just putting this return statement so we don't get into a compile time error. Okay, let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And we beat nearly 99% of all the other solutions, which is awesome. And in terms of memory usage, we can improve if we use some other solution, but this is also, needless to say, a very good time and space complexity. And this is the most popular problem, so you must know it by heart. Once again, the coding solution is present in our GitHub repository, so feel free to go and check it out from there. Thank you. Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to do group Anagrams lead code problem, and this problem has been really popular at some of the companies where I want to get a job. There are companies like Amazon, Microsoft, Facebook, Apple, Google, Affirm, Snapchat, Goldman Sachs, Uber, Bloomberg, Netflix, Instacart, ByteDance, and Twitter have already asked this question. So that's why I'm paying my utmost attention. I hope you also enjoy the video. So this is a LeetCode medium problem, and basically we are given an array of different strings and we need to group the anagrams together. Now we can return the answer in any order, so which is good for us. And we are also given the definition that what is an anagram. Anagram is a word or a phrase that is formed by rearranging the letters and then it turns out to be a different word. So if we take an example, suppose we are given a word like bat, then we can say that these all are actually anagrams of this original word bat, because the B, A and T, they are all occurring in all of them in the same number of occurrence that it is present in this bat. So now after understanding that what an anagram is, let's try to see some examples to understand that what this question is asking us to do and what is the expected answer we need to return. If we take this first example, essentially we are given S is equal to array of string that looks like this. Now over here I have clearly marked all the groups that can be potentially done in separate colors, so you can clearly look at them. But the thing is, let's try to understand. So first of all, we are given this word eat. If we see the what are the number of occurrences of characters, there are characters e, a and t occurring 1 times each. Now same thing happens for this word teat and for this word ate, which means we can conclude that all of these 3 words are actually anagrams of each other, and we can group them together in one single group. So that we are done with all of these 3 elements. Now next item we see there are 2 words tan and net. Again tan, this all 3 of them are occurring once, these 3 characters for both of these values, so we can also group them together. Now for this bat, we actually don't have any other value that we can consider it as an anagram, so this particular string will be a group of itself, which means in this case we can return an answer that looks like this, and we can return this as an answer. So clearly you would find that this answer, actually the sequencing is done slightly bit different than what is the answer given in this output. And the reason for doing that is that I wanted to show that we can return answer in any order. So that is the important part over here, that is specified in the question, that we can return the answer in any order. So that's why I ordered them differently, but as long as the groups are correct, we are good to go. One better way to solve this problem is actually by using sorting. And how we are going to use the sorting is that we are actually going to create another array for every single entry that is present inside this original S, and for all the elements that are present over here, we are going to actually sort them in alphabetical order. And then all we have to do is just we will have to iterate over this newly created array once, and we only need to find that what are all the similar pairs or all the similar values, and then we can simply return them as answer, and that makes our life much more easier. Let me quickly show you what I'm suggesting. So based on this array, we will actually create a sorted array, and the sorted array is going to look something like this. So now we have created our sorted array, and which we have derived from this original S. Now all we will have to do is we pick up any word or any string, then we just have to compare with all the other strings and find that which strings contains the same value. Whichever string contains the same value, we will take their values from the original string, because we know that they're index values, and then we can group them together. So the idea is, first of all, we'll take this string aet, then we find that okay, this and this, both of them, so the strings located at position 0, 1 and 3, they are all part of this original string that should be in the single group. So we will group them together. So in the answer we will mention eat, t and 8 as one group. Then again we will repeat the same process. So we find this ant and ant, so again we will group the whatever values located at this string at this index 2 and 4, and we find the values 10 and net, and in the end we will return this bat because it's the single one. So this solution would work fine. We will get our desired answer. If we see the time complexity, in this case the time complexity is actually going to be big O of n log n, just to create this original sorted string, multiply by k, and this k is actually the biggest length of the string that we will have to compare, and this would be the final time complexity. So this is much bigger improvement than our brute force approach, which was giving us the big O of n cube time complexity. Now let's see that can we improve any further in this one as well. Okay, before we come to the optimal solution, we will have to ask a very important question, that how do we determine that any 2 words are anagram of each other or not? Suppose we are given 2 words like ABC and CBA. We can clearly see that they are actually anagrams of each other, but how can we explicitly define that they are truly anagrams of each other? Well, we can define that based on the number of character repetition in each one of them, that any character that is present in this ABC, it is also present in the CBA in the exact same number of occurrences that both in both the words. So in other words, A, B and C is present exactly once in this particular word, and it is also exactly once present in this particular word, though the arrangement is different, and that makes them anagram of each other. Now you will ask that why am I dragging so long on this pretty trivial question that we already know the answer to? Well, we are actually going to use it to our advantage, and the good thing for us is that English language only has 26 characters. So because English language has the 26 characters, we are actually going to use it to our advantage. We are actually going to create an array of all the values that are initially located as 0, and that is going to be of size 26. Now any character that we identify in any single string, we are actually going to add it to our array, and we are going to increase the value of that particular character sequence. And then whatever the answer of that array is, we are going to put it in a string, and then we are going to use it as a key for our hashing hash map, and then we are going to do some interesting things. So let me quickly show you that what is the full plan. Suppose over here we are given an array that looks like this, right? Now we have this given word ABC. So what we are going to do is, initially all of these values, they are defined as 0 by default, but now we are given this ABC. So first of all, we take this A, we increase its value to 1. Again we get this B, we increase its value to 1. Again we get this C, we increase its value to 1. Now all the other values, they are 0 so far. So for this particular character, we can actually create a string based on this given array of 26 words. So string would be maximum of size 26, which means it is a defined finite number, which means we can create that. We will get a string that looks like this, 111, and then remaining 23 zeros. Again we are given this word CBA, right? So again what we are going to do, first of all, we identify this character C. So we are going to mark its value as initially this was 0, so we are going to mark it to 1. Again this B, again we will mark it to 1, and again this A, we will mark it to 1. All the other values would be 0. So even for this one, the string that we are going to generate is going to look like this, 111 and 000. Now the idea is that we will create a hash map. Now inside this hash map, as a key part, we are actually going to keep track of whatever the string that we are building. So let's just name this as string builder, that we are building a new string. That would be our key. Now in both the cases, notice that for this ABC and for the CBA, this string value is actually going to be the same, that it would be 111 followed by 23 zeros in both the cases, which means that they both have actually same key value, which means that over here, okay, this is 111 23 times. But in both the cases, as the value, we are actually going to keep track of a list, and inside this list we are going to store original words that were presented as an input for this original array string that we built. So over here, first of all, we will have an entry that looks like ABC, and then we will have an entry that looks like CBA. Now we already have both the values that is part of the same group, or they are, and which is an anagram of each other, would be in the list value, which means that makes our life much more easier. That in the end, all we need to do is just we need to return this whatever value we have stored in the list. Let's do this with one of the example that we have been following so far. So I'm not going to show you the whole ordeal with the array because that is too time consuming. I'm just going to show you that what would happen inside the hash map. So this is our hash map. Now as a key, we are going to have some string value. So first of all, we get this value eat. So suppose for this value number eat, we get a string that looks something like this, right? Whatever the value is. Now this same value is going to look for this t and for this 8, which means that these values eat, then t and 8 would be a part of the same value group inside this hash map for the same key. Again, same thing will happen for this tan and net. So even again for this tan and net, suppose we get some value, that string that looks like this, right? I'm just drawing a bunch of gibberish, but you get the idea. And we will add an entry for tan and net because they both will have the same number of occurrences of characters. And in the end, for bat, we won't have any entry, so we will have a new entry over here, and where we will add the value bat. Now in the end, all we have to do is just iterate over all the values that are present inside this hash map and return it as our answer. And this would be the optimal solution we are going to use. If we see the time and space complexity for this one, the time complexity is actually going to be big O of n times whatever the maximum length of k is. In terms of space complexity, we are actually creating an additional hash map, so that's why that is going to take some additional space. But this is also going to be big O of n times k, where k is the longest length of any given string, and n is the number of string that are present inside the given input. So first of all, we are going to check an edge case, that if the given string is empty, we are going to return an empty array list immediately. Okay, if that is not the case, we are going to initialize our hash map, and we are going to take string as key and list as value. Also, we are going to initialize our array of size 26, and we are going to name it as count. Once that is done, we are going to run a for loop across the given input string. So first of all, we are going to initialize our array with value 0. After doing that, we are going to iterate over this given string s, and we are going to add all the characters inside this given array by adding their value from 0 to 1. After doing that, we are going to initialize a string builder to store the string value that we have retrieved inside this character array. Now we are going to run across the count array, and we are going to add all the values to our string builder. Also at the same time, we are also going to add a hash before all the elements inside this given count array, and that is something per language trick that changes. For Python, you won't have to do it. Once this is done, we are going to assign this new string that we created as a key for our hash map. Now we are going to check that if this entry for this given key already exists inside the hash map. If it does, we are simply going to add whatever the string s that we are iterating over, and if the entry does not exist, we will create one value inside the hash map, and then we will add this value s for this given key. And we are done for this for loop. Now all we will have to do is return all the values from this answer map and return it in the manner that is asked inside this given question. So we will have to return a list of lists. Let's try to run this code. Okay, seems like our solution is working as expected. Let's try to submit this code. And our code works as expected. I will be posting the solution in the comments so you can check it out from there. Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to do top k frequent elements lead code problem, and if we see some of the companies where I want to get a job who have already asked this question, there are companies like Facebook, Amazon, Microsoft, Google, Uber, Apple, Bloomberg, Snapchat, Twitter, Tesla, Netflix, ByteDance, LinkedIn, eBay and TikTok. So that's why I'm paying my utmost attention. I hope you also enjoy the video. This is a LeetCode medium problem and also very well-liked problem on LeetCode. Basically, we are given an integer array called nums, and we are also given a separate integer called k. Now, we need to return the k most frequent occurring elements from this nums array, and we are also told that we can return the answer in any order. So first, let's try to understand this problem with this example. I have actually drawn it much bigger over here. So this is the array nums that we are given, and we are given k is equal to 2, which means we need to return top 2 elements that are present inside this given nums array, right? So if we see in this case, well, over here, this 1 is actually present 3 times. This 2 is actually present 2 times. This 3 is actually present 1 time. Now, if we see, we are given that k is equal to 2, which means we need to return top 2 elements, and clearly we can see that the top 2 elements in this case is this 1 and 2. So we can return the answer to be 1 and 2, or we can also return 2 and 1, because remember we are told that we can return answer in any case, and this is the answer we need to return. So let's try to see that what is going to be the approach to solve this problem. Now let me make one clarification. There are actually 2 different approaches to solve this problem. One approach, or the first approach I'm going to show you in this video, is actually sufficient for your interview. Any interview would be more than satisfied with that approach. But the thing is, the second approach I have is actually the golden key approach for any like top k element problems, right? Any heap problems, you can use the second approach, and I'm actually planning to make a separate video on that, depending on whether you want to learn it or not. So let me know in the comments that whether you want to learn this second approach. If you do, I'll make a separate video. We are actually going to use the combination of a hash map and a heap in order to achieve the top k elements. So I have created a custom example over here, and I have given the value of k is equal to 3. Now remember, whenever we need to define that, we need to return top k elements or top 3 elements in this case. How can we define that? Well, we first of all need to iterate over this given entire array. We need to find that how many times any single character is occurring, and depending on that answer, we will have to iterate over that whatever the list we create, where we have the number of occurrences for each character, and then we can conclude this answer. So one thing is clear, that we need some way to store the information that how many times any particular individual character occurs. For that, we are actually going to use the hash map. In the hash map, as the key, we are going to denote the distinct value of this given array, and as its value, we are going to note the occurrence of that particular character. So first let me quickly create a hash map for this given input, which contains the distinct values and their occurrences. So based on this given input, this is the hash map we can create. Now we need to select k is equal to 3, which means we need to provide top 3 elements. Now one approach to find the top 3 elements is that all the distinct values we have in this hash map, if we just simply create a sorted array, and in the sorted array we sort the arrays based on the descending values, which means the most occurring value to be first, and then we put down all the remaining values, we can actually generate a sorted array that looks like this. And now for this particular sorted array, we can simply return the top 3 elements. So we can return the answer to be like 4, 3 and 5 easily. And this is the solution that would give us the correct answer. But thing is, you would quickly ask me that why did I mention priority queue over here? Because over here, what I'm doing is I'm taking this hash map and I'm actually just sorting it, and we are able to generate the array. Well, first of all, in order to understand that, first of all, let's understand the time complexity of this approach. The time complexity of this approach is, first we need to iterate over the given entire input. For that, it takes big O of n time to generate this hash map. After generating this hash map, we will have to create this sorted array that takes n log n time to generate that answer, and this n log n is going to be the ultimate time complexity. So the thing is, this you would say, hey, n log n sounds reasonable, but the thing is, from n log n, suppose we have like 1 million distinct characters or 1 million characters, and we are given k is equal to 3, which means that we would have done like 1 million times log 1 million work. Meanwhile, the value of k in practice is supposed to be much smaller than whatever the input size is going to be. So the other approach is that if we create a priority queue, and remember, the concept of a priority queue is that inside the priority queue, basically we add the values and we remove the values, just like any queues. But the thing is, the values that we are entering, they have some meaning behind them, and depending on their valuation, we actually store the value. So whenever over here, suppose this is the priority queue and I have provided different weight to those elements. If I want to create, or if I want to enter an element that is in higher weight, then I would get rid of only the lower weight elements and add those over here. I would not be repeating everything. So based on that concept, what I'm suggesting is that rather than sorting this array, we get rid of it. Okay, so let me clean this up a bit, and over here from this actual hash map that we have created, we actually create a priority queue. And this priority queue is going to be of whatever the size we are given of the k value. Okay, so k in this case is 3, so we are going to only have 3 values in our priority queue. Now for our priority queue, first of all, we are going to check that, okay, we only enter the values based on the number of occurrences they have, and we only keep the higher number of occurrences. So first we add the value number 1 over here because we don't have anything. Now we add value number 2 over here because we still have room and 2 has 2 occurrences. Then we add value number 3 because 3 has 3 occurrences. And remember, we are using the occurrence to add the value, not the actual distinct value, right? This is the key part. Okay, now we have this value number 4. 4 actually has 4 occurrences, right? And so far, if you remember, this 1 had 1 recurrence, this 2 had 2, and this 3 had 3 occurrences. Now we have a value that is 4 that has actually 4 occurrences, which means it is greater occurrences. So we are able to insert that value inside our priority queue, and in that case we are actually going to get rid of the smallest value. So smallest value in this case was 1. Now we are not going to add 4 over here, but we are also going to maintain the ascending order in terms of the values that we are being added. So we'll just shift these values. Okay, so 2 will come over here, 3 will come over here, and 4 will come over here, and then we will have those subsequent values. Now after adding this, we still have value number 5 that we need to add. So 5 occurs 3 times. So 5 occurs 3 times. Currently we have 2 occurring 2 times, 3 occurring 3 times, and 4 occurring 4 times. Now 5 occurs 3 times, so 5 is able to enter over here because it occurs more times than this 2, and we can actually put 5 over here because it is also occurring 3 times, and this 3 is also occurring 3 times. So we are good up until this point. After that, all we will have to do is just convert this result into an array. So for that particular array, we are actually going to store the results, and remember, we can return result in any manner. So we can return like 5, 3, 4, or we can also return like 3, 4, 5, or whatever result we want to return, we can return, and this is going to be the solution. If we see time complexity in this case, the time complexity is actually going to be a bigger improvement than our sorted array approach. Why? Because okay, over here this takes big O of n time to generate this hash map. That process remains same. But now from generating this hash map to this priority queue, it takes n log k times, because we are only maintaining k elements. This is the important part, and this is what your interviewer is going to focus on. So in this case, the time complexity is actually going to be big O of n log k, which is good. And in terms of space complexity, well, you must have guessed it correctly. It's big O of n, because we are using couple of additional data structures. We are using a hash map, and we are also using a priority queue. And this is a very good time and space complexity. And that is basically the ideal approach. Now let's move on to the coding. First of all, we are going to take care of an edge case, that if the given k is equal to whatever the length of this nums is, we can simply return nums. That is not the case. We are going to initialize our hash map. Now we are going to iterate over all the elements that are present inside this given nums. So we are going to run a for loop, and after the for loop ends, we are basically going to populate the values inside our count hash map that we have just created. Now we are going to initialize our priority queue. And inside our priority queue, we are going to assign the method of insertion. So we are inserting based on the number of occurrences based on this count hash map. So let's put the condition for that. So now now everything is set up. Now all we have to do is just iterate over all the keys that are present inside this count hash map that we have created. And for every single key, basically we are going to add that value to our heap priority queue. And whenever the priority queue gets full to the size of this k, we are basically going to pop the element. And the element that will get popped is going to be the least occurring element. So we are only keeping higher occurring elements inside our heap. And now we check that if the heap size becomes greater than k, we remove the value from heap. That's it. So now all we have to do is just simply initialize a new array variable called answer, and we are going to populate this answer array. So we will run a for loop for k times, and we will keep on pulling the values from our heap. Then we can simply return the answer. And let's try to run the code. Okay, seems like our solution is working as expected. Let's submit this code, and our code runs pretty efficiently, and I will be posting this solution in the comments so you can check it out from there. Thank you. Hello friends, we are not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to do product of an array except self lead code problem. If we see some of the companies where I want to get a job who have already asked this question, there are companies like Amazon, Microsoft, Facebook, Apple, Uber, Bloomberg, Lyft, Google, Goldman Sachs, IBM, Twitter, TikTok, and LinkedIn. So that's why I'm paying my utmost attention. I hope you also enjoy the video. This is a LeetCode medium problem and also very well like problems on LeetCode. Basically we are given an integer array called nums, and we need to return a new array called answer array, such that every single value of that particular index position inside this answer array is actually equal to the product of all the other values that are present inside this given nums array except that particular ith element. So suppose we are given an input array that looks like this. In this case, we will have to create an answer array for the answer, and that would be of the same size of whatever this input array we are given. Now in this answer array, suppose we want to enter the value at this second position or corresponding to the second index value. What we are going to do is we are actually going to take the product of this value number 1, 3 and 4, and whatever the product of these three values are, we will actually put it as the answer for this value. Same thing we are going to do for this next value, where we are going to take products of these two elements and this element, but we won't take the product of this element from this original given input array, and whatever the answer is, we will actually put it over here inside the answer array. In order to enter this first element, we will actually have to do the product of these three values. So then the product of these three values is going to be 24. Now for the second element, we will have to do the product of this first element and this last two elements, so that is going to be 12. For this third and fourth element, we will again repeat the same process, and we will get subsequent values like 8 and 6 by doing the corresponding products. And at the end, we will have to return this as the answer array, and basically this is what the problem is asking us to do. Even the name is also self-explanatory, that we need to return the product of an array except self, but we are given a very specific declaration over here that we need to use it in big O of n time without without using the division operator. And why it is asking us to use solve this problem without using division operator? Because if we were allowed to use division operator, suppose we are given an input, we can just do the product of all of these value and we will get an answer called 24. And then all we have to do is for this answer array, we will take this value 24 and then we will iterate over this input array and start dividing it with this 24. So even in the answer we will get, if we divide 24 by 1, we will get the value as 24. If we divide 24 by 2, we will get value 12. If we divide 24 by 3, we will get value 8. So on and so forth. So it would become very easy for us to solve this problem. So that is why they are explicitly asking us that we should not be using the division operator. Now the most basic brute force way to solve this problem is actually we take any single value and then we iterate over all the remaining values and do its product and put it in the answer array. So we will create an answer array that looks like this. We will first take this value, so we will iterate over this given nums array, and for all these three values we will do its product and we will get the value as 24. Now again we will repeat the same process, but this time we will be iterating over the second element. So because we are iterating over the second element, we will take this first value and we will take these two values and we will do that sum, so we will get value number 12, and again we will repeat the same process. So essentially this is bound to give us the correct answer and we would get it in this case. But thing is, this would not be the correct way. Why? Because if we see the time complexity in this case, the time complexity is actually going to be big O of n square. Why n square? Because we will have to iterate over this array. For every single character we will have to iterate once, and even for any particular character we will have to iterate over all of the other values again just to find their product number, and that takes n square time, and we are explicitly told that we will have to solve this problem in big O of n time. So let's see that what would be the way to achieve that. Okay, so now for the better approach, we will actually have to put down one intuition to use. And the intuition is, suppose this is the element we want to get the product for in the answer array. So the idea is that we are actually going to take the product value of first two elements and we will take the product of this last element. Again, if we take this portion, this value number 2, we will take the product of all the elements that are present on the left of this value number 2, and we will take the product of all the elements that are present on the right of this product number, this value number 2. So that is the idea, that for every single location we will have to take product of all the values that are behind or pre to that particular level. So we can call it as prefix, and all the values that come after that value, and we can call it postfix. So now the idea becomes quite simple. What we are going to do is we are going to have two arrays called prefix and postfix, and we are going to iterate over this nums array once, and for every single position we are actually going to keep track of all the values that come before it and after it, and we are going to put down their values like their product values, and at the end we will just do a multiplication between this pre and post arrays, and then we should get our answer. So let's see that in action. And also one more thing, that because for this particular element that are at the edges, so for this value number 4 there is nothing on the right side, so like we can't do anything. But for the simplicity purposes we will consider that anything on the right side is actually 1, because anything multiplied by 1 remains the same. And same thing we are going to do for this left edge as well, that because for this value number 1 there is nothing in the prefix, so again by default we will treat this as value number 1 as well. So that will help us in doing some counting, right? So let's see that in action. So first of all, for this value number 1, we are calculating the prefix values. So this 1 actually has nothing on the left, but it only has 1, so we'll do 1 times 1 and we will get the answer as 1. Now for this value number 2, actually all we need to do is whatever the left element is, we just need to do the product of all of them. So the left element in this case is only 1, and we will just put it over here as well. Now in this case, the value number 3, we will have to do product of all these elements. So one way to do it is to do this like 1 times 2. So do the product of all these two elements, but that is actually time consuming. One better way to do it is that if we take this particular element value number 2, this already contains the product of all the values that are present before that. So why are we doing the effort of doing the product of this value number 1 and 2? That is just costing us additional resources. The better approach is that we, for this value number 3, we are over at this position. All we have to do is we just take whatever the value we have stored over here, which is the prefix of all the values before this value number 2, multiply by whatever this value is present, and that would be the prefix sum for this value number 3. So what we are going to do in this case is we will take this value number 2. So we will take this value number 2 and we will take this value number 1 from here, from the prefix array that we have already calculated, and we will do 2 times 1. In this case we will get value as 2, so we will add 2 over here. And again for this value number 4, again we are going to repeat the same process. So now this time we are going to take the value before 4, that is 3. So we will take 3 and we will multiply it by whatever value we have already found in this prefix array, which is 2. So 3 times 2 is actually going to be 6. So now we are done with this prefix array. Again we are going to repeat the same thing for the postfix array. So this is the edge value, so we can simply do 4 times 1. So we will add the value 4 directly over here. Now this is value number 3. For this value number 3, all we will have to do is just take product of this value. So this is already 4, so we will again add 4 over here. Now for this value number 2, all we have to do is we will take the value, this whatever value that is present over here, 3, multiply by whatever value we have already calculated in the postfix over here, which is 12. So we will have a value called 12 over here for this element number 2. And now again for this element number 1, we are going to repeat the same process. So we will take this 2 and multiply it by whatever value we have calculated inside our postfix array, and this is going to be 2 times 12. Okay, now we are done with both of our arrays. Now the task is actually quite simple. Now we will create our answer array, and we are going to simply do the multiplication of every single one of these values. So this becomes 24 times 1, 24, this becomes 12, this becomes 8, and this becomes, oh, I made a mistake over here. This has to be 1, not 4, because we are actually doing the multiplication of all the elements that are present on the right side of this value. So this would become 6, and this is the solution that we are going to do. This solution actually works perfectly fine. There are no issues with that. If we see the time and space complexity in this case, the time complexity is actually going to be big O of 3 times n. Why 3 times n? Because we will have to iterate over this n to first of all create this prefix array, then we have to iterate over n times to create this postfix array, and then again we will have to iterate over both of them to create this answer array. So we are doing like 3 times n work, but in general we can write this as big O of n. And in terms of space complexity, we are actually creating a couple of arrays, so we also have to do big O of n as space complexity. So the idea is, can we do something better? And the answer is yes. There is one way to actually do this, both prefix and postfix array in a single array, and that too inside the answer array that we are planning to create. Okay, so let's keep the same example, and we want to find the optimal solution for this one. Well, the idea is that rather than doing two separate prefix and postfix arrays, we are actually going to create an answer array, and we are going to add all the values, and now we are going to do prefix and postfix multiplication inside the same answer array. And let me quickly show you how. First of all, we are going to use a couple of variables called prefix and postfix. So let me add their values, and by default they are going to have value as 1. Now what we are going to do is, first of all, we are going to iterate over this given input nums, and we are going to calculate the prefix for every single element inside this answer array, and we are also going to update the value inside this pre function or pre variable. And then again we will iterate in the reverse order, and we will keep on updating the postfix values inside the answer, and by the time we are done, our answer array should have been completely filled out. Let me quickly show you that in the action. So first of all, for this value number 1, this is actually the prefix of every value that is present behind this 1, and the multiplication of all of those values. So because there is nothing over here, we can consider this to be 1 by default. So I'll not write it over here. I'll just write over here that for this first element inside this answer array, the nums actually does not have anything on the left side, so we can consider this to be 1. Now we are going to we are at this second position. For the second position, what we are going to do is, we are going to take the multiplication of whatever the value we have on the left side, right? So even on the left side we only have value 1, and even the prefix value is also 1 so far by default, so we are going to add 1 over here again. Now we are at this value number 2 or 3. So for this value number 3, what we are going to do is, we are actually going to take the value that is before that, which is 2, and we are going to multiply it with whatever the pre variable we have. So we were also doing the same thing for this value number 2 as well, but because both the values are 1, we were not getting any other result. But in this case we will actually get a result of 2, and because we are getting a result of 2, the result of pre is also updated, also being updated to value number 2, because it will help us to know further down for the next elements that what is the value of prefix. Now we are at this value number 4. So again we are going to repeat the same process. We will take this value number 3 and we will take whatever the value of this prefix we have, which is 2. So 3 times 2, the value is 6. So we'll add value 6 over here. Okay, and now we are done filling up this prefix portion, and we have taken the prefix of every single element inside this answer array. Now we are going to do the reverse order. Now inside the reverse order, again for this value number 4, actually there is nothing on the right side of this value number 4, which means there is nothing on the postfix, so we can consider it as 1. Now because this is already 1, what we are going to do is whatever value we have calculated so far, we are going to multiply it. So if we multiply 6 by 1, the answer we get is 6. Okay, so far for this value number 4, the answer is 6. Now we are at this value number 3. For this value number 3, what we are going to do is we will have to calculate everything on the postfix side. So this value is 4. So we are going to take value 4 multiply by whatever value of this postfix variable we have, which is 1. So 4 times 1 becomes 1. So now we have the value as 4 for this postfix. So we are going to update the value of the postfix to be 4, and we are also going to multiply this 4 with whatever the value we already calculated for this value number 3, which is 2. So 4 times 2 is going to be 8, and this is going to be answer for this value number 3, that this is the product of all the numbers for this value number 3 except itself. Now we are at this value number 2. For value number 2, we are going to take value number 3 multiplied by whatever the post variable we have. Post variable is actually 4, so 3 times 4 is actually 12. So we are going to update that value over here first of all. So now we have the value 12 over here, and we will have to take this 12 and multiply it with whatever value we have already stored over here, which is 1. So 1 times 12 is also 12. And now again we are at this last position. So again for the last position, we are going to repeat the same process. We will take whatever the value that is after this value number 1, which is 2. So we'll take this 2, we will multiply it with whatever value we have stored inside this post variable, which is again 12. So 2 times 12, and this becomes actually 24. So we will do 24, and we will take 24 multiplied by whatever value we have already stored inside this answer array, which is 1. So 24 times 1 becomes 24, and this is the answer. And if you look closely, this actually becomes the complete answer that we are looking for, and we have actually done everything in place without using any additional data structure or any additional array, and we don't have to use basically any extra space. So this is the best way to approach this problem, and this is the solution that any interviewer would want to see. If we see the time complexity, in this case the time complexity is actually going to be big O of 2n. Why 2n? Because first of all we are iterating over from left to right, calculating this pre variable, and then we are iterating on the reverse order, calculating this post variable and updating the values, but still, which is good. If we see the space complexity in this case, well, space complexity is actually constant because we are not using any additional space. For this answer array, we are given inside this question statement that we have to create a new array, so that we are anyways going to create. But apart from that, we are only using couple of variables to store some data, and that's why this is a very good approach. Now let's move on to coding. First of all, we are going to create a new array called result, and by default we are going to set all the values as 1. We are going to initialize the two variable called prefix and postfix, and we are going to assign the value as 1 for both of them. Okay, now we are going to run our first for loop to iterate from left to right, and we are going to update the value of prefix inside our answer array. So first of all, we are going to update the value inside our result array, and then we are going to update the value of our prefix variable. So after this loop ends, basically we should have prefix values filled out for every single position inside our result array. Now we are going to run another loop, and we are going to come in the reverse order. And first of all, we are going to update the value inside the result array. So any single value inside the result is actually going to be multiplication of whatever the value we already had, multiply by postfix variable. We'll also have to update the value of postfix variable. We are good to go. Oh, actually I made a mistake. This should be pre only, not prefix. Okay, and after this second loop ends, essentially our result array should have been populated, so we can simply return that. Let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. and our code runs pretty efficiently compared to a lot of other solutions. So that's why this is really good approach. I would be posting the solution in the comments so you can check it out from there. Thank you. Keeping with that goal in mind, today we are going to do a very interesting lead code problem called valid Sudoku. Now, if we see some of the popular companies who already asked this question, there are companies like Amazon, Apple, Nvidia, Uber, Microsoft, Facebook, Google, Bloomberg, DoorDash, Goldman Sachs, and Snapchat. So that's why I am paying my utmost attention. I hope you also enjoy the video. So this is a lead code medium problem and also very well like problem on lead code. In this problem, basically we are given a 9x9 Sudoku board and we need to determine that whether this given Sudoku board, if that is valid or not. Now, we are told that only filled cells needs to be validated according to following rules, and we are given 3 rules to determine that whether the board is valid or not. First rule dictates that each row must contains the digits between 1 to 9 without repetition. This is the key phrase, that there should not be any duplication. First rule defines that every single row must have unique characters from 1 to 9. Second row defines that every single column must have unique characters between 1 to 9. The third definition shows that the box of 3 by 3 or the sub boxes in the grid must contains the digit 1 to 9 without repetition. So this is a little bit tricky one, but basically amongst the 9 by 9 box, we can make 9 different 3 by 3 boxes where the values 1 to 9 should be present without any repetition. Now we are told that the Sudoku board in this case is partially filled, and we need to only check the boards based on the filled items, nothing more than that. So it could be possible that we cannot be able to complete the entire Sudoku, but given the filled elements, if they are at least behaving these 3 definitions that are mentioned, where every single row, every single column and every single box, they all should have 1 to 9 unique elements, then we can determine that this Sudoku board is valid. If it is not the case, then we can determine that this is not valid. So if we take a look at this particular example, this is the example of a valid Sudoku box. And what makes this Sudoku box valid is that every single row, or all amongst all the 9 rows, the filled elements are filled in a manner that there is no repetition between 1 to 9. Now if we just take one example, say for an example for this first particular row, if I add one more 5 over here, then it completely makes this Sudoku board invalid, because the elements 5 is repeated 2 times in this particular row. We are not concerned with the empty cells because we can determine that can have any particular value, but if there is a 5 or any duplication present over here, we can determine this to be invalid. But let's just say that 5 is not present over here, so we are good. Same way, if I just put an 8 over here in this middle portion, then this column would be invalid, and that would make this entire Sudoku box invalid. So that is also one more thing that we need to take care of. And the third and little bit more complicated thing is the boxes that we need to be concerned with in this case. So there, as we can see from this image, there are actually 9 boxes present in any given Sudoku board, and we need to determine that 1 to 9 values are remain non-duplicated for all of them. So basically, say for an example, for this particular box, now this box currently only has one value 6, which means this box is valid because there is no duplication. But if I add one more 6 over here, which means then the 6 is repeated 2 times, so that would make it invalidated. So basically we need to take care of rows, we need to take care of columns, and we need to take care of boxes for this particular problem to solve them. Basically, I'm going to show you 3 different solutions, one for the row, one for the column, one for the boxes, and then we will find a way to combine all 3 of them. So say for example, this is the row we are given, right? Now we are only considering one row for now, because same solution can be applied to all the remaining 9 rows. So that is a trivial fact. So basically, first we will try to determine, suppose this is the row we are given. What is our objective? Our objective is to make sure that all the filled values over here, they are unique between 1 to 9 and there is no repetition. So the simplest way to do is to create a hash set. So if I create a hash set, currently this hash set is empty. Maximum possible length this can have is going to be 9, because there are only 9 cells in any given row. Okay, now the logic we are going to use is,
that first we are going to iterate over the row. If the value, there is some value, we will try to first check that whether that value is present in the hash set or not. If it is not present, then we will add that particular value in the hash set and move on to the next element. If the value is already present, which means that there is a duplication we find, and then we can simply return false, that this given Sudoku board is invalid. So let's try to do that. First we are at position number 1. Currently there is nothing in the hash set, so because there is no value, we will add entry 1 over here, and we can determine that this node has been visited, or this cell has been visited for the row perspective, and there is nothing wrong we find. Now this one is a dot. So if there is a dot, or if there are no values, we can simply skip over that, because that is none of our concern. We are only concerned with the elements that are already filled. Now the next element is 3. So we will add an entry 3 over here, because 3 was already not present. This one is again empty. This one is value number 6. So we will add 6 over here, and then same way we will add 2 over here. And these two cells are not empty. So we have reached to the end of the row, which means we can determine that this particular row is currently valid and there are no issues with that. But say for an example, for this last cell, rather than adding this value, if we had one more value number 3 over here, then what would happen? Once at this position, when we add value number 2 over here, now we are over here. This one is a filled value. Because this is a filled value, we will try to see that whether this value is present in the hash set or not. Since this value is already present, this is a big no-no, and we found a duplicated entry, which means immediately we can call this entire Sudoku board invalid, because we find an invalid row. So that is how we are going to determine the rows. Now currently this one only had one row, so we use just one single hash set. Say for an example, we were dealing with 9 different rows. If that was the case, what we would have to do is we would simply have to create 9 different hash sets, and basically for every single hash set we are going to repeat the same process. So this is just repeating the same process for different set of inputs. If the given Sudoku board is, let's say, 16 by 16, we would have had 16 hash sets, but still the core concept would remain same. Now the way we've solved for the box, the same way we can actually solve for the columns. Again, for the columns, we are also going to create a hash set. So say for an example, this is the column. We will create the hash set and we will repeat the same logic. So currently this value number 1 is not present. We will add value number 1 over here. This 3 is not present. We will add 3. Same way we will add 6 and we will add 2. And now we are at the end of this column and we didn't find any duplicated entries. So we can say that this particular column is valid, and then we can move on to the next column. And same way for the next column, we would create a new hash set. And if any point in time we find duplicated entries, so say for an example, for the second column, we have two values 1 and 1 over here. First we would add this 1 over here. Then the moment we move on to the next value and we see that, hey, in the hash set 1 is already present, we can say that, okay, this particular column is invalid, and that is why this entire Sudoku board is invalid. So this is also a very simple thing to understand. Same logic we are using, what we use for rows, we are going to use for the columns. The thing is for the box. Now for the box, this is a matrix kind of a structure, okay? And for the matrix kind of a structure, again, our main logic or the thing we need to achieve is going to remain the same. That we need to make sure that there are no duplicated entries for the filled values between 1 to 9. So again, even for the box, we would be able to create a simple matrix or a simple hash set. Now for this even hash set, we are going to apply the same logic, and we would keep adding the entries until we find any duplicate entries. And if we find duplicated entries, we will call it invalid. So this is a very simple thing to do, but the tricky part is, okay, now say for an example, we need to determine for rows and columns. Okay, currently, say for an example, we are just ignoring the boxes for now. We are only considering that how to solve this problem for just row and columns, and we need to find that we don't find any duplication between 1 to 9 for every single row and every single column. How we are going to achieve that? We are going to achieve that in the same manner I explained earlier. The only logic we are going to use is that we are going to create 9 hash sets for rows. Okay, so for rows, we are going to create 9 hash sets. Every single row, we are going to check for the duplicated entries. If we find any duplication, we can return invalid immediately. If we don't find the duplication, we will move on to the next row, and we will keep on repeating the same process. The same thing we are going to use for the columns as well. That even for the columns, we are going to create 9 hash sets. So again, and we are going to repeat the same process to check that whether there are any duplicated entries or not. and since there are none in this particular case, we can simply in the end return the answer valid. Now remember, we only solve this problem for the rows and columns, okay, but the thing is we need to take care of the boxes as well. Now for the boxes there is just one tricky part, and the tricky part is that actually for the boxes it is not as simple as just the correlation between row and column. Because for rows we had the particular separate entries for every single rows that we can traverse over them or determine them pretty easily. Even for the columns we have the direct way to identify that whether this is a column or not. But when it comes to the boxes, we need to establish a correlation between the set of different rows and different columns. And how would we be able to achieve that? Okay, so even for the boxes, basically we need to create 9 hash sets. But the thing is, how do we define which number goes where? So basically these are going to be all the boxes that we need to create, okay, and these are the 9 boxes. But the thing is, how do we able to define the 9 boxes? The answer is quite simple. We are actually going to do a division by 3 for any particular row value and any particular column value. So that would be a very clear indicator on what box we need to choose. And let me give you a quick demo. So basically the idea is that, okay, currently this row position is 0, 1 and 2, okay. Now say for example, if we do like 0 divided by 3, what is the value we are going to get? 0, of course. If we do like 1 divided by 3, what is the value we are going to do? We are actually going to consider the floor value, okay, not the ceiling value. So if we consider the floor value, 1 divided by 3 is going to be like 0.33. So basically in the integer it is going to be 0. So these 3 values are going to represent 0. Same way these 3 values are going to represent 0, which means if we are iterating over any of these cells, we can say that we need to consider box number 0 for that. So that is pretty good. Same way, if we are going over any other these 3 or these 3 values, so okay, this is going to be 1, 1 and 1, because if we divide them by 3, and same way this is going to be 1, 1, 1, because if we divide them by 3, same way this is going to be 2, 2, 2, and same way this is going to be 2, 2, 2. Now say for example we are at any cell amongst this particular box. Now we need to identify that which particular hash set to select. Now this one is going to be box number 6. So hash set number 6 we need to select, okay. But how do we define this hash set number 6 is going to be the correct one? And this is where we are going to use this formula, where for any particular cell position we are going to do this formula where we are doing row divided by 3 plus we are doing 3 and plus we are doing column divided by 3, okay. So this is the formula we are going to use to determine that what is the correct box number. Now suppose for this particular formula, suppose we are at this particular box or this particular cell, okay. Now if we take a look at this particular cell, currently the row is going to be row number 4, okay, row is 4, and currently the column position is going to be 7. Let's apply this particular formula for this row and column position. If we do that, we are going to do 4 divided by 3 plus 7 divided by 3, okay. So in this case 4 divided by 3 is going to give us the answer number 1, plus 3 and plus 7 divided by 3 is going to give us the answer 2. If we do sum of these 3 values, we are going to get the value of 6. And the 6 is going to determine that the box currently, if we are at this particular position, we need to check it against hash set number 6. This is the only complicated matter for this particular question. If you are able to identify a way to find the correct box, then this is a very simple problem to solve, and which we just did. So this is the whole logic. And basically now we know that how we are going to solve for row plus column plus box. The idea is that for row we are going to use 9 hash sets, for column we are going to use 9 hash sets, and even for boxes we are going to use 9 hash sets. And we already know how to determine what is the correct box we need to look at, and based on that we simply need to check for the duplicated entries. If we find any duplication, we simply get rid of it. If we don't find any duplication, awesome, then we can conclude this given Sudoku to be valid, and this is the whole optimal solution. Now, if we see time and space complexity for this one, the time complexity is actually obviously going to be big O of n square. And why n square? Because we are given n to be same for both rows and columns. So that is why this is going to be big O of n square. If we see space complexity, now this one is like a debatable question, because we already know that we are going to use 27 additional hash sets. The thing is, why did we come up with this number 9? Because we are given n is equal to 9 by 9 matrix. So we are given n is equal to 9. So that is why this 9 came in. So basically space complexity is going to be big O of 3n. So in general, we can write this to be big O of n. But if we are explicitly told that we are only going to use 9 boxes, then we can also conclude this to be a finite number, and this could also be considered as constant. So if you do this discussion with your interviewer, you are going to look very clear in your concepts regarding time and space complexity. Since this is already pretty long video and the coding is just a bunch of repetition, so I am just going to explain you the code, and then I'm going to paste this in the comments so you can check it out from there. So first of all, we are going to create an array of hash sets. So first we are going to create an array for row, second we are going to create for column, and third we are going to create for the boxes. And the size of this particular array is going to be the size of 9 that is given over here, and we are hard coding this value because we are basically told that this is going to be a 9 cross 9 Sudoku. Now, after filling these values, we simply need to initiate the hash set for every single one of them. So we are going to just iterate over all the values, and we are going to initiate the hash set to accept the character as the input. Now we are going to run two loops. First is to iterate over the row, and second one is to iterate over the column. And using the two inner loops, like one inside the other, we would be able to iterate over the given input matrix. Now, the moment we are iterating over the given input matrix, first of all, we are going to determine that what is the current character at any particular position or any particular cell. Now, if the value is dot, or if there is no value, we can simply continue and move on to the next element. But if there is a value, we are simply going to first do these things. First, we are going to check that whether for this particular row hash set, is this value already present. If the value is already present, we can simply return false. If that is not present, we are going to add the value to that particular row hash set. Same thing we are going to do for the column, that if the value is present, we are going to return false. If the value is not present, we are going to add that value to that particular subsequent columns hash set. And then we are going to apply our formula where we are going to check for the particular box, and then we are going to check that for that particular box, if the value is present, we are going to return false. If it is not present, we are going to return the subsequent correct value. And basically, if we get out of the loop, we are simply going to return true, that we did not find any place where there was invalidity and we could have written false. So now let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs decently fast compared to a lot of other solutions in terms of time complexity, and also it is very convenient in terms of space complexity. So I would be posting this solution in the comments so you can check it out from there. Also, at the same time, if you want to check all the solutions that I have done so far, I have created a public GitHub repository where I'm putting all of my answer, and this is going to be a great resource for anyone who is trying to prepare for different tech interviews. So I would be pasting this link in the comments as well, so you can check it out from there. Thank you.
Hello friends, we are not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to do encode and decode strings lead code problem, and as you can see, this is actually a lead code premium problem. If we see some of the companies who have already asked this question, where I want to get a job, there are companies like Facebook, LinkedIn, Google, Square, Uber, Microsoft and Apple. So all of my favorite companies have asked this question, so that's why I'm paying my utmost attention. I hope you also enjoy the video. So this is a lead code medium problem, and basically we are given a list of strings. Now we need to design an algorithm where we are actually encoding this given list of strings into a single string. then we are told that that single string is supposed to be sent over a network, and then when we get back to the second machine, we need to decode that given string into the original list of strings. So let's try to understand this with an example. So suppose we are given a string s, where we are given bunch of different strings that looks like this. So after this, we will actually create an encoded string. Now this encoded string is combination of all of these four items, and it is just a single string. So let's say that this is the encoded string we have created. Now after creating this encoded string, we need to write a function to decode the string as well. And after we decode the string, we should get a response that exactly looks like this, and this would be the original decoded string we would get. And this is what we need to return. So we need to return the algorithm to encode the string and also an algorithm to decode the string. So let's see that what would be the different approaches we can take. Okay, suppose this is the original string we are given and we need to encode the string and decode the string. The idea is we are actually going to use an extra character, and where we are going to use an extra character, we would put it where one string ends before other string starts, and we will keep on repeating the same process, and all we have to do is, so that would be the way to encode the string. After encoding the string, when we have to decode, we will just simply take that character, and the moment we reach that particular character, we would know that okay, this is the place where one string ends, so we would create a new string for that, and then we will repeat the same process. So let's see that in action. So first of all, suppose we take this character that looks like this hash, right? I'm just taking any random character. The idea is you can discuss with your interviewer that what kind of character you can take. So suppose I take this hash. Now I do encoding string. So the encoded string is going to be AB. Then the moment I identify that this strings ends over here, I would put a hash and I would keep a continuous string. Now I realize that okay, this is a new string B, so I would add a value B. Again I would put a hash. Now again this value is C, again I would put a hash, and again at the end I would find this value A B C, and that would be the end of the string. So now I have created an encoded string. Now if I want to decode the string, the decoding would work like this. So first of all, I'm iterating until I find that this is a valid string. So valid string is AB. Now I realize that okay, this is the hash, and hash is the character that I put it as an extra character as an encoding mechanism. So I would remove this hash and I would treat this as a single string. Now I would again start creating a new string. So again I find this value B. The moment I encounter the string hash, I would treat this B to be a separate string. Again I would encounter this value C, and again I would encounter this value ABC, and this is the way we are going to encode and decode the string, and this solution would work as expected. If we see the time complexity in this case, the time complexity is actually going to be big O of n. Why? Because we will have to iterate over all the characters that are present inside this given string s to first of all encode and then decode. So overall it would be 2n, but we can generically write it to be big O of n. Now if we see the space complexity in this case, the space complexity is actually not that much, because we anyways will have to create an encoded string and decoded string, and all we are doing is just using an extra space to solve this problem. So this is pretty simple to me. Okay, suppose this is the string we are given, and the idea is we are actually going to add 4 bits that are going to store the length of any given substring, and then we are going to keep on repeating the same process, and we are going to create the encoded string. So let me quickly show you what I am suggesting. First of all, we would have an encoded string where first 4 character is actually going to store the information that what is the next length of substring that is coming that we are going to iterate over. So in this case, this is actually length 3. So if we add it in binary, it's represent as 0 1 1. So we are actually going to have 0 0 1 1 to be the length, and then we are going to store these 3 characters as A B C. Okay, now we are done with that. Again now this ends the first substring, so now this is of length 2, so length 2 becomes 0 1 0. Now we are going to do the same thing, and then we are going to store this value AB, and now this is also of length 2, so again we will repeat the same process, and we are going to store the value of x and y, and this is the encoded string. What we have done basically is we have actually created block of 4 bits that keeps the information that okay, in the next subsequent value, these are the 3 characters that you will have to iterate over, and that is how we are going to decode it. So let's see the decoded string in action. In the decoded string, first of all, we are going to iterate over this given encoded string. Now we iterate over these 4 characters, and we find that okay, value is actually 3, which means that next 3 characters are the characters of one of the substrings that we will have to separate. So we will iterate over these 3 and put it in a substring, and we will get a substring like ABC. Again we will iterate over these 4 characters, and we realize that the value is actually 2. So because 2, we will have to iterate over these 2 elements, and we would get the value AB. Now again we would iterate over this next 4 bits, and we find that value is actually 2 again. So we will iterate over 2 more characters, and we will get the value XY, and then we would have a decoded string. So this is also another way to store all the values. Now this solution also works as expected, but I don't think that anyone is able to come up with this in the interview. So I just showed you this approach just for the explanation purposes, but actually I'm going to, in the coding, I'm going to show you the first approach that I solved earlier. So first of all, we are going to do the encode function. So let's take care of some edge cases first. If that is not the case, we are actually going to take a random variable that is not part of this original given string. So we are given the condition that there could be 256 characters inside the ASCII character for this given string I. So what we are going to do is we are going to take the 257th character as the character that is a separator between any two strings. So first of all, let's just create a string called a separate, and we are going to assign the character 257 to it. Now we will start building our string. Now we will iterate over this given list of strings. So first of all, we are going to append the value of whatever the string we are iterating over, and the moment this string ends, we are going to add the separate character. Once this loop ends, basically we should have done with encoding our string. Now all we have to do is just delete the last character because that would be an additional room. And once that is done, all we have to do is just simply return this new string builder we have created. So now we are done with encoding our string. Let's decode our string. If this given string s is actually of size whatever the located at 258, which means we are dealing with an empty string list. So in that case, we will simply return a new array list and we should be done. If that is not the case, which means that we have a separated string. So let's just assign a new character. All we have to do is just return an array list where we are going to separate based on this given separate character. And that's it. Let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our solution is actually pretty fast compared to a lot of other solutions. It's not most optimal because I did not choose the approach 2. And let me know if you want to see the code for approach 2 as well. Thank you. Hello friends, we are still not employed by FAANG company, so let's not stop lead coding till we get there. Today we are going to do longest consecutive sequence problem, and this problem has been asked in Google, Microsoft, Facebook, Apple, Goldman Sachs, Uber, Twitter, ByteDance. So it's a lot of companies and a lot of huge ID companies that have asked this problem. So I'm going to pay my most attention. I hope you also do it. And I just have one request for all of you guys. Like my YouTube channel, if you see, most of the people, they are not even subscribed, and it takes a lot of time and a lot of effort to make these videos. So I would really appreciate if you can just subscribe. Like basically we are given an unsorted array of integer nums, and we need to return the length of longest consecutive elements inside the sequence. Also, there could be possible that there might be duplicates in our given unsorted array. So we just need to take care of those as well. And let's try to understand this with an example. So the example we are given over here is, and over here, if we find that what is the longest consecutive sequence we can find, the longest consecutive sequence we can make is 1, 2, 3, 4 amongst these values. And we can ignore just this 100 and 200 because there does not exist any consecutive sequence from those values. So over here, since we found 4 elements, we can return the length of this as 4, and this would be our answer. Same way, if we take another example, over here we are given 9 elements, and all 9 elements are actually part of the longest consecutive sequence. So in this scenario, we are going to return 9. So in the brute force approach, we are not going to do anything clever. We are just going to take the most basic approach that we can and try to find the longest consecutive subsequence. So suppose at any moment we are given an input like this, we are given an empty list, we can say that there exists 0 longest common subsequence elements. And suppose we are given an element like this, suppose this is 100, we can say that there exists exactly one longest common subsequence element in this given input. So that is a given, right? That even if with a single element, we can at least define that there exists one single longest common subsequence element. Now over here in this example, since we know that there are at least more than 0 elements in this given input, and initially we are at this 100th position, which means that we can say that the current longest consecutive subsequence we can find is 1. And now if we want to find a subsequence in the remaining group that consists this 100, how can we do it? Like, we can only do it in one scenario, that in this remaining portion, in this remaining elements, if there exists element 101, if this exists, we can say that 100 is also part of the or could be part of the longest consecutive subsequence. So this would be our basic approach, that at every single position we will try to find that whether the next elements could they be in the remaining input, and if they do, we will update our longest consecutive subsequence, and whatever the maximum value we find, we are going to return it as our answer. So we will also create another variable called current subsequence, and that would take care of what is the current subsequence that we are trying to find. Let's just name this current. Okay, and initially the current subsequence is also at also 1 over here at this 100th position. Now we'll try to see that whether this 101 exists in the remaining portion, and it does not exist, which means we will move forward. So we'll move forward with the element 4. Now for this element 4, we need to see that whether element 5 exists or not. So element 5 also does not exist, so we'll move on with this 200. For 200, we will see whether 201 exists. This also does not exist. For this 1, we will try to see that whether 2 exists. So 2 exists in the remaining array. Now because 2 exists, the current subsequence we had was of value 1, we will update it to value 2. Now because this 2 exists, we can not break right now. We'll try to find more values. So we'll again try to see that whether 3 exists, and 3 also exists, which is over here. So again we will update this value to 3. Again, because 3 exists, we will try to see whether 4 exists. 4 also exists, and it is present over here. So we will update the current value of longest consecutive subsequence we have found to 4. Now we will try to see whether 5 exists. Now 5 does not exist, which means that 4 is the longest we have found so far, and then we will try to update the value of longest consecutive subsequence we have found to whatever the current value is, because previous value of this was 1 and now this new value is 4. But we are not done yet. We have only checked up until this 1. So now we will check for this 2. So again for this 2, we will, and by the way, we will re-evaluate this value back to 1, because now we are starting with the new element. So again for this 2, 3 exists, so we will update the value to 2, and 4 also exists, so we will update the value to 3. But we cannot update the longest common subsequence because 4 is greater than 3. And now we again check for this value number 3. So for value number 3, 4 also exists, which means that this value would become 2 for this value number 3, but we won't update, and in the end we are going to return this 4. So this is our brute force approach. Like, this solution works, we get the desired answer. The thing is, we get the desired answer at a very bad cost. Like, even if we just try to calculate the time complexity, in this case the time complexity would actually be big O of n cube. Why n cube? Because we will need to iterate over every single elements at least once to find the longest common subsequence. So that is n amount of work. Then suppose over here we are initially at this position 100. So we wanted to check that whether 101 exists. So in order to do this check, we will also have to iterate over the entire loop. So then in that case, we will have to do n more work. And at any given moment, suppose over here we identify that for this 1, 2 also exists, right? And once we identify that 2 exists, we will again check whether 3 exists. Again we will check whether 4 exists. Again we will check whether 5 exists. So even to do these checks, we will have to do n more work. So again we will do n work. So in total we are going to do n times n times n, so n cube work to solve this brute force approach, and this is a very disastrous solution. Now, one better approach we can think of is, suppose that with the given input, if we do some sort of modification, can we come up with better solution in faster time complexity? Like, of course we can. So remember that what we are needed over here is that we need to find the longest consecutive subsequence of this given input. And we are going to see with this custom example how can we modify the input and how can we come closer to solution. So suppose in this given example, rather than keeping the input just like this, if we do sort the given input, things become much easier for us. And let's see that what would be the sorted result. Okay, so now we have our sorted result. Now in the sorted result, we simply need to find that what is the longest common subsequence that exists, longest consecutive subsequence that exists. And it's pretty simple to find now, because all we need to do is that at any point we know that the definition of common subsequence is that suppose we are currently at the value I, then I plus 1 would be a common subsequence, then I plus 2 would be a common subsequence, and this is the only condition we have to take care of. And the only other thing we need to worry about is having two duplicate values right next to each other. If at any point we encounter two duplicate values, we simply ignore one of those values and move forward. So in this example, we are only going to do two checks with the sorted input. First check we are going to do is, at first position we are going to check that whether this position is exactly same as whatever the previous position we had. If that is true, we would skip over, because we don't need to do anything with that, because there are two same values. And if that is the case, so which is the case in this scenario, that both values are same, which means we would skip over. So we would go to the next element, and now we are at this next element. Again, we are going to check that the value we are currently at and the value before that, if they are same or not. So in this case, they are not same. If they are not the same, we are also going to check one more thing, that whether the current value of a of I, so suppose this 0 is actually a of I, and minus whatever the value of a of I minus 1. So a of I minus 1 in this case is minus 1. So if difference between these two values, if it becomes exactly 1, which means we can conclude that these two values are part of the longest common subsequence, and we could update their value. Again, like brute force, we are going to use two variables. One variable to keep track of longest common subsequence we have found so far, and second one is to keep track of the current subsequence that we are working on. So let's see that how it would work. And both the values would be set up as 1 initially. Now initially we are at this 0 and 1 pair, and because they are sorted, we know that they are always going to be adjacent to each other. So this is the only condition we need to worry once we identify that the both values are not same. So in this case, we can say that the current subsequence we have found is actually size 2. So we can update the value over here, that this is 2. Now again we check with this value. Now this value, again it's 0, it's the same as this one, so we ignore it. We don't need to do anything. Now again we check with this value. So this value is actually 2. Now with this 2, if we put down this equation, so 2 minus 0, this is not equal to 1, which means that this 2 and 0 are not part of the common subsequence. If they are not part of the common subsequence, we check that now we can't update this current anymore. So we check between the current and longest common subsequence we have so far, and the current is actually greater, which means we will update the longest consecutive subsequence to 2 as well. And now current, we will put it back to 1, because we will repeat our search again. Now we are at this position 3. So 3 and 2 are not same, and 3 minus 2 is actually 1, which is true, which means we update our current. So current would become 2. Now we are at this 4. Again 4 minus 3 is equal to 1. So again we update our current to 3. Again we are at this 5. So again we need to update our current. So current would be updated to 4, because all of these values 2, 3, 4, 5, they are in a common subsequence. Now we are at the 7. So 7 minus 5 they are not equal to 1, which means we can't update the current, so we will need to reset the value of the current. So before resetting the value of the current, we are also going to check that whether the longest common subsequence needs to update, and this needs to be updated to value 4 because this one was 4 before because of these 4 values. And now we can set this value to 1 again at this position 7, and now we are at this position 200, so 207 they don't have any correlation, so we can't do anything about it. And in the end, at the end of the loop, we are simply going to return whatever the longest common subsequence or current subsequence, whatever the maximum value we have found between these two. And in this case, the maximum value we have found is actually 4, so this would be our solution. Now this solution works pretty efficiently, it's pretty neat, and if we see the time complexity, we can complete everything in just one single iteration. So we are only doing n work, but the thing is the time complexity in this case would be go of n log n, because initially remember that from this given input we will actually have to sort the array as well, and sorting takes n log n time. But overall, if we still compare it with whatever the brute force approach we had, brute force was actually big O of n cube. So this was really bad time complexity, and this is much more and much bigger improvement upon our scenario. Now in the optimal solution, we are actually going to try a couple of things. First thing we are going to do is we are going to create an additional data structure called hash set, and in the hash set we are going to enter all the values that we have found from this array. So suppose we create a hash set something like num set. Now in this hash set we are going to add all of these values. Now because we have our hash set ready, what we are going to do is when we are going to iterate over this hash set, and we are only going to start checking for the longest consecutive subsequence from the elements that could be at the start of the longest common subsequence. And what elements can be start of the longest common subsequence? Well, so if we take this example, we can actually see couple of common subsequences or consecutive subsequence. One consecutive subsequence we can find is 99 and 100, which is at these two positions. And second consecutive subsequence we can find is actually 1, 2, 3 and 4. Now in the what we were doing in the brute force is we were checking at every single position that what would be the longest common subsequence we can find. The thing is we can only find the longest common subsequence from the first element of the start of this consecutive subsequence. Same goes over here, that whatever the subsequence we can find at this value number 100, the subsequence that we can find at value number 99 would always be greater than whatever we can find over here, because this by itself is already a subsequence. So we are going to use this logic. Like over here, if we put this 3, 2, 3, 4, we will only find the consecutive subsequence of length 2, but this 2, 3, 4 would be of length 3, and this 1, 2, 3, 4 would actually be of length 4. So we can only find the maximum consecutive subsequence at the start of the any subsequence, not somewhere in the middle. And the only way to check that whether we are at the start of the subsequence or not is by just checking one very simple condition, that at any point we check that whether the exact value before that value, like one value before the value we currently are at, if that exists, which means that we are not at the start of the common subsequence. Let's take it by an example over here, and let's see that what would be our approach. So first of all, we are going to be at this position 100. We are going to check that whether this 100 is a start of any consecutive subsequence or not. So we check that whether in this given num set does the value 99 exist. Now we know that 99 exists. So because 99 exists, 100 cannot be at the start of the common consecutive subsequence. So we are going to ignore this case. We don't have to do anything with this 100. We come up at 99. Now we come up at this 99. We check that whether there exists a value before 99. So 98, does it exist in this num set? 98 does not exist, which means that at 99 we can be at the start of any common consecutive subsequence. So we start a subsequence at 99, and now we will initiate our logic. And in our logic, we are simply going to check that from this 99, how many consecutive numbers we can reach. So we are going to check that, okay, 99 by itself is a common subsequence of length 1. So we know that. Now from this 99, we are going to check that can we reach value number 100. so 100 we can reach, and because we are using a hash set, we can do all the operations in constant time, so we are not adding any strain in our time complexity. Now we can find the value 100, so we can reach 100, which means that the whatever the longest common subsequence that we longest consecutive subsequence we found, we will increase its value to 2. Now again we will try to see that whether we can find 101. Like 101 does not exist, which means we would break out of over here, and the longest common subsequence we have found up until this point is actually of length 2. Again we are going to repeat the same process. So now we are at this position 4. We check that whether whether 3 exists in this set or not. So 3 exists, which means we ignore this 4. Now again we are at 200, so we check that whether 199 exists. So 199 does not exist, which means 200 can be start of the any consecutive subsequence. So we again check that whether 201 exists, but 201 does not exist in this given example, so we ignore this 200 as well, because the longest consecutive subsequence we find at this value number 200 is always going to be 1, and we already have a value that is greater than 1. Again we check at this position 1 that can 1 be start of any consecutive subsequence. So we check that whether the 1 minus 1, so we check whether 0 exists in this example or not. 0 does not exist, which means 1 can be start. So now we set our current subsequence to value number 1, and now we check that from this value 1 how many other values we can reach to. So first we check that can we reach the value number 2. Yes, we can reach value number 2 because 2 already exists. So we update whatever the current subsequence we can find to 2. Now from this 2 we check can we reach 3. Again we can reach 3, so we will update the current value to 3. Again we check that whether from this 3 can we reach 4, and yes we can reach 4 as well. So again we will update the value of our 4 value of the current subsequence to 4, and from 4 we check whether we can reach 5. So 5 we can't reach, which means we are at least able to reach this 4. So we are able to see that the the longest current subsequence we have found is 4, and previous value was 2. So we will update this, so this will become 4. And now again we are going to check the same thing for this value number 2, so that for value number 2 does 1 exist and 1 exists, so we will ignore this. Again we check for 3, does 2 exist, 2 also exists, which means we are going to ignore this 3. And now since we have reached the end of this hash set, so we are going to reach whatever we found in the as the longest consecutive subsequence, and this would be our answer. Now if we calculate the time complexity, the time complexity would actually be big O of n in this case, because we are only iterating over the entire input just once through this hash set. So this is a very efficient time complexity. And if we see the space complexity, the space complexity is actually big O of n, because we will have to create this additional numerical set, and we are going to store n memory for that. And let's see the coding. I will be showing the hash set solution in this code, but I'm going to post both the codes in the comments so you can check it out from there. So first of all, we are going to check that whether we are given an empty list or not. If that's not the case, first of all, we are going to create a hash set. We are going to name it num set. Now we'll run a loop across the given input, and we are going to store all the values to our hash set. This is going to do two things. It's going to eliminate all the duplicates values, and it will only add unique entries in the hash set, because hash set has a property that does not allow us it to store duplicate values. Now we are going to create a parameter to store the longest subsequence, and we are going to initialize it with value 1. Now we are going to run a for loop across the given num set. So initially we are going to check that whether we are starting from the middle of any longest consecutive subsequence. If that's the case, we are going to ignore that number. So if this condition is true, we are going to continue and go to next element in the loop. If this is not the case, we are first of all going to mark the number we are at as current number. because this is the beginning of any longest consecutive subsequence. We are also going to create another parameter called current sub that is going to take care of the current maximum consecutive subsequence we can find, and we are going to initialize it to 1. And now we are going to put a condition that while our hash set contains the current number plus 1, while this condition is true, we are going to increase the number, and we are also going to increase our current subsequence. And after this loop ends, we need to check that whether we have found the longest common subsequence or not. So once this loop ends, we should have our answer in the longest sub variable, so we can simply return that. Let's try to run this code. Okay, seems like our solution is working. Let's try to submit the code. And seems like our solution works pretty well, and it is faster than a lot of other solutions. I will also post the sorting algorithm solution. Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to do valid palindrome lead code problem, and if we see some of the companies where I want to work at who has already asked this question, there are companies like Facebook, Amazon, Microsoft, Apple, Bloomberg, Spotify, Adobe, TikTok, Google, and Uber. So that's why I am paying my utmost attention. I hope you also enjoy the video. So this is a LeetCode easy problem, and basically we are given the definition of what a palindrome is. We are told that after converting all the uppercase letters into lowercase letters and removing all the non-alphanumeric characters, if the string reads same as forward and backward, then we can determine that any given string is a palindrome. Now we are given a string s, and we need to return true if the given string is palindrome. If not, we need to return false. So let's try to understand this with an example. Over here we are given a string that looks like this, where you can see that there are some alphanumeric characters as well, which we will have to get rid of. This is only put there just to add some sort of additional complexity. Apart from that, it serves no purpose. This is the original string that we are given. Now if we convert all the uppercase letters to lowercase and remove all the alphanumeric characters, we will actually get a string that looks like this. And if we see for this particular string, if we start going from the front and even going from the back, we will see that all the characters that are present from the front, they are also present from the back in the same order. So that is why we can determine that this string is actually a palindrome, and we will return true in this case. We are given another example that looks like this. Over here we can also see that there are some alphanumeric characters which are the two space values, so we will have a string that looks like this. And over here, if we try to see that whether this is a palindrome or not, currently this R matches, A matches, C matches, but this E actually does not match over here, and over here actually we have an A. So that's why this is not a palindrome, and we will return false in this case. So let's see that what would be the approach to solve this problem. Now suppose this is the example that we are given, and we need to determine that whether this given string is a palindrome or not. The approach I'm suggesting is, first of all, we iterate over this given string, we get rid of all of these characters that are alphanumeric. Once we do that, then we will create a new string that is actually reverse of this original given string. And now we have two strings at our disposal. All we have to do is compare both the strings. If they are same, we can determine that they are actually palindrome, and we can return true. If they are not the same, we can return false immediately. So let's see that in the action. So first of all, we are going to create a string from this original input string, where we are going to get rid of all of the non-alphanumeric characters. Once we are done that, now we are going to reverse the string. So we are going to create a new reverse string from this original given string, and we are basically reversing whatever this given input is. In this case, if we compare this given reverse string and whatever the string we are given, they both possess the same value, which means we can determine that this given original input is actually a palindrome and we can return true in this case. So this is one of the solutions where we can work with, and this solution would work as expected, no issues with that. Let's see that what would be the time and space complexity over here. So for the time complexity, actually first of all we are iterating over this given string to remove all of the alphanumeric characters, and then again we are iterating over this given string to create a new reverse string, which means that we are essentially iterating over this original string 2-3 times and comparing it, and basically we are doing big O of n work, but actually we are doing like big O of 2 times n work. In terms of space complexity, because we are creating this new original reverse string, so that is why we are also consuming some space. So that's why the space complexity in this case is also going to be big O of n, where n is the number of characters that is present inside this given string. So this approach is okay, it's justified, it works as expected, but the question is, can we do something better in terms of space complexity and even in terms of time complexity? And yes, there is a better approach, and let me quickly show you how. Okay, so for the optimal solution, what we are going to do is, suppose we are given an input that looks like this. Now over here we are actually going to use a 2-pointer solution, and we are going to have a left pointer and a right pointer, and initially the left pointer is going to be located at the leftmost position and right pointer is going to be located at the end of our string. Now at any given moment we are going to compare that what is the character value of left and right pointer, and we are also going to check that whether this given left and right pointer, if there is that like a non-alpha numeric value. If that is the case, we will just like increase the value of left or right pointer, and if both the values are same, essentially we will move the left pointer on the right side and we will move right pointer on the left side, and we would keep on doing this process until left and right are adjacent to each other before right crosses the left. And if we are able to reach to that point, we can determine that this is actually a true and valid palindrome. If that is not the case, we will basically return false at any given moment if we identify that left pointer and right pointer character values are not matching up. So let's see that in action. Suppose this is the string we are given. Currently the left is located at this m and right is located at this small m, but in both the cases we are only dealing with lowercase English letter. So even if we encounter an uppercase English letter, we would convert it to lowercase English letter. We would treat it like this. So this m is equal to m. So far we are good, which means we will have to update the value of left and right pointer. So now this left pointer is going to go to the next value, which is over here, and this right pointer is going to go to a previous value, which is over here. Now at this position right, we actually identify that this is not an alphabet, so we would again update the value of right pointer and we would ignore this case, and this time right pointer comes over here. Now because both of these are valid alphanumeric value, we will try to see that what are their values, and both are located a, which means they are same. So if they are same, again we are good up until this point. Again we will update the value of left and right pointer. So now left pointer is at d and right pointer is actually located at this column over here. So because this is not an alphanumeric value, again we are going to ignore this and we are going to update the value for right pointer. So now right pointer would end up at the same position where left pointer is. If we again compare the value, both are going to be dd. So again we are good up until this point. Now we don't have to do it, but because in our algorithm we are specifying that we need to check before right pointer crosses the left, and in this if we do one more iteration, essentially right would come and left would come over here, which means that they would be crossing each other, and which is not what we want. So we have already concluded that all the characters inside this given string, they are actually part of a palindrome, and we can return true in this case, and this is the approach we are going to take. Now if we see the time complexity in this case, the time complexity is actually going to be big O of n only, because we are completing everything in just single iteration. We are having our left pointer move to the right side and we are having our right pointer move to the left side, and we stop when they meet. Now in terms of space complexity, we are actually doing it pretty efficiently. We are only using couple of pointers to store in our space, so that's why it's only a constant space that we are consuming, and this approach is much better approach, and we will conclude this as to be an optimal solution. Now let's move on to coding. First of all, we are going to initialize couple of variables called left and right, and we are going to assign the left to be value 0 and right to be value to the end of the string. So now we are going to run a loop that while left is less than right, So now first of all we are going to check that if the current value on the left side, if that is not alphanumeric, we will have to update the value of left pointer. Same thing we are going to do with the right pointer, but we are actually going to reduce the value for the right pointer. And if we identify that both left and right are correct letters, we are going to check their values, and if they are not same, we can return false immediately. If they are same, we will continue updating the loop. So if that is the case, if the characters are not matching, after converting them to lowercase, we can return false immediately. And if that is not the case, we would update the values of left and right pointer. And once this loop ends, essentially if we get out of the loop without returning false, we can simply return true. Now let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our code is actually pretty efficient. I would be posting this in the comments so you can check it out from there. Thank you. Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to do 2sum2 lead code problem where input array is sorted. And if you see some of the companies where I want to get a job who have already asked this question, there are companies like Amazon, Apple, Uber, Google, Facebook, Bloomberg, Microsoft and Goldman Sachs. So that's why I'm paying my utmost attention. I hope you also enjoy the video. This is a LeetCode medium problem and also a very well-liked problem. This 2sum2 problem is actually very similar to the 2sum problem which we originally solved over here. So you can check it out, that solution, if you want. Now let's understand this problem statement. So basically we are given a one index array, and this is only given one index just to add some additional complexity, nothing more than that. And we are also given an array of numbers. Now we are told that all the numbers, they are already sorted in non-decreasing or ascending order. Now we need to find two such numbers that they add up to a specific target, and we are also given this target value as the input for our method as well. Now we need to provide the index values for those two numbers as the answer. So let's try to understand this with a couple of examples. So if we take this example 1 and 2 over here, I have drawn it much bigger over here. So first of all, we are given a nums array like this, and if you notice that the indexing is actually starts from 1 rather than starting from 0. We are also given some target values. So in this case the target value is 9. So now we need to find any two values that sums up to 9. So we can clearly see that 2 plus 7 equals to 9, and in this case we need to return the index value of this 2 and 7. So the answer in this case is going to be 1 and 2 as the answer. If we take second example, over here we are given the target value to be 6. So clearly we can see that 6 is going to be the sum of actually 2 plus 4. Now remember, we can also do over here like 3 plus 3, but the thing is we cannot repeat the same character again. So in this case the answer has to be 2 plus 4, that equals to 6, and we need to return the index value. So index values in this case is going to be 1 and 3, and this is going to be the answer. So after understanding the problem statement, let's see that what are going to be the different approaches to solve this problem. So the first approach that comes to our mind is a brute force approach. In the brute force approach, what we can do is we can simply take every single possible two pair that we can make and try to see that whether we can come up with the target value for those two pairs. If we do get the target value, we simply return their index numbers. So in this case, we are given the target to be 11. Now we can make different pairs that looks like this. That first of all, we'll take the first number and then we will make all the possible pairs. We don't find any sum that comes up to 11. So we can ignore this one. Now we'll start with the second value and keep on repeating the same process. So the moment we do that, when we do the sum of this 5 plus 6, we get 5 plus 6 to be 11, and this is the answer. So in this case, we can return their index values. So in the index values in this case is going to be 2 and 3, and that would be the answer we can return. Now this brute force solution leads up to the correct answer in terms of the index values that we are looking for. But the thing is, this is not the most efficient way to do it, because we have to deal with lot of different sub arrays or sub pairs. So if we see time complexity for this brute force approach, it is actually big of n square, because for every single value we have to compare it with all the other remaining values, and that is pretty disastrous. So let's see that what is going to be the better approach. Okay, so the next approach that comes to our mind is a binary search. Why binary search? Because remember, We were originally told that this input array we are given, that is already a sorted array, which means all the values that they are sorted in ascending order. So we can actually use binary search to our advantage in order to find the target value pair. The approach I'm suggesting is that first of all we take any value. Okay, so the current value in this case is 2, right? So if 2 is supposed to be part of this answer, let's imagine that 2 is part of this answer, then 2 can only be part of the answer if the value 11 minus 2 equals to 9. If this 9 is somehow present inside this given input array, we can clearly determine that 2 and 9 can be part of the answer that leads up to the target value 11. So all we need to do is once we identify the value number 2, we come up with the remaining value that is needed to generate the answer, that is 9, and then we can simply do a binary search in this case to see that whether 9 exists or not. We can find this immediately in log n time because this array is already sorted. So at any given moment, all we have to do is just calculate the middle value and see on which side of this middle value does this 9 falls, and eventually that would lead up to the correct answer. So first of all, if we see for this value number 2, 9 does not exist, right? So because 9 does not exist, we can ignore the case for this value number 2, and we can define that 2 is not part of solution that leads up to the target value 11. Now again we are going to repeat the same process. Now the next value we have is 5. So now if the value is 5, all we have to do is to see that what is going to be the remaining value, and remaining value in this case is going to be 11 minus 5. So 11 minus 5 is equal to 6. So now we only have to check that whether this 6 exists inside the remaining array or not, and that we can do using the binary search in log n time. So now what we will do is we'll try to find the middle value. Let's say that middle value in this case is 12. So 12 is greater than 6. So because 12 is greater than 6, we only have to compare between these three values. So again the middle value is 8. Again 8 is still greater than 6. So now we only have one value on the left of the 8 and right of the 5, so which is already 6. So immediately we can find that value, and because we find both 5 and 6 to be existing, so 5 plus 6 equals to 11, we can simply return their index values to be 2 and 3. So 2 and 3 is going to be the answer in this case. If we see, binary search actually works pretty better than our brute force approach. Why? Because if we try to calculate the time complexity in this case, the time complexity is actually going to be big O of n log n. Why n log n? Because in the worst case we might have to iterate over every single character in order to find the target value, and for us to find the remaining value we have to do log n work. So again, if we see this solution is much better compared to our brute force approach, which had the time complexity of big O of n square. Now the question is this the most optimal way to solve this problem? And the answer is no. There is still one more solution that can give us the answer in big O of n time. Okay, so the optimal solution I am proposing is actually using two pointers. So suppose this is the array, input array we are given, and we are given the target value to be 13, right? Now we already know that 6 plus 7 is going to be the answer. But let's quickly see the approach I'm suggesting. Basically, we are going to have two pointers, left and right. Now remember, all the values that are on the right side of this left pointer are actually greater than this value of left, right? And same way, all the values that are on the left side of this right pointer is actually less than whatever the value at right pointer we had. So the idea is, originally we are going to do the sum of this left pointer and right pointer. We are going to compare that sum to this target value. Now if the sum is actually greater than target value, which means we need to lower the sum. How can we lower the sum? We can only lower the sum if we move this right pointer on the left direction, because remember, all the values that are on the right that are on the left of this right pointer, they are actually less than this right pointer. So if we reduce the values, automatically sum is supposed to go down, and that would lead us near the target value, right? Again, same way, if we identify that sum somehow is actually less than the target value, if sum is less than the target value, which means we will have to increase the value of the sum. How can we increase the value of the sum? By increasing the value of the left pointer, because all the values on the left pointer are actually greater, and right pointer will remain constant in that case. And if we keep on repeating the same process until we come up to the sum that equals to target value, eventually we would get the two pointers located at the correct position that would lead us to the correct answer. How? Let me quickly show it to you. And by the way, let me also mark the indexes in this case as well. So now we have our left pointer and we have our right pointer and we have the variable sum, right? Currently left is equal to 2 and right is equal to 42. If we see sum of these two, sum is actually going to be 44. 44 is definitely greater than 13. So because 44 is greater than 13, we will have to somehow reduce the values. So what we are going to do is we are going to update the right pointer to move one point to the left side, right? So now our new right pointer is going to be this one. So now our right pointer value is 21. So 21 plus 2 is still going to be 23. Now 23 is again greater than 13. So because of that, we are going to shift our right pointer again. So now right pointer is at 12. 12 plus 2 is 14. 14 is still greater than 13. So again, we are going to switch our right pointer. So now right pointer is at position number 10. So now the right pointer value is 10. So now 10 plus 2 is equal to 12. So 12 is not greater than 13, is actually less than 13. So now we will have to update our left pointer. So if we update our left pointer is going to become value number 5, right? So now this value is 5. 5 plus 10 is again 15. So 15 is again greater than this value number 13, right? So now again we are going to switch our right pointer to go one point to the left. So now the right pointer value is actually 7. So if we do 7 plus 5, 7 plus 5 actually gives us the answer to be 12, right? So now this 12 is still less than the value number 13. So because this is less than the value number 13, again we are going to update the value pointer of the left pointer. So now left pointer is at position number 6, right pointer is at position number 7. 6 plus 7 is equal to 13, which is exactly equal to whatever the target value we had, and that is the correct solution. So now basically the positions of left and right pointer, we simply need to return that as the answer. So the answer in this case is going to be 3 and 4. And this is the correct way to solve this problem. Now, what is the benefit of this approach? Well, if we see, we are actually computing everything in just single iteration. We are not doing multiple repetitive work. So if we see time complexity, in this case, the time complexity is actually going to be big O of n, which is a much better improvement compared to our brute force approach and also our binary search approach. If we see space complexity, in this case, the space complexity is actually going to be constant because we are not using any additional space apart from storing a couple of variables, which is also a good sign. Now let's move on to the coding. So first of all, we are going to initialize the two variable left and right. Now we are going to run our while loop, that while left is less than right. Now inside the loop, first of all, we are going to check that whether the combination of left and right, if that is greater than the target value. So if that is the case, we will have to reduce the sum, which means we will have to reduce the value of the right pointer. So right is going to become right minus 1. Else if we are going to check that whether the sum is actually less than the target value. If that is the case, we are going to update our left pointer to go one step to the right. That is not the case, which means we are actually at the correct position. So we can simply return the index values. But remember, we are presented with one index array, so we are going to add one value to the left and right, and this was just the additional small complexity they added to the problem. Otherwise it would have been too simple. And basically in this loop we are taking care of everything, so we should have gotten the answer. If somehow we get out of the loop without returning the answer, we can simply return null, that we were not able to find the answer, and that should do the trick. Let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code, and our code runs decently efficiently compared to a lot of other solutions in terms of time complexity. In terms of space complexity, it's actually pretty efficient because we are not using any additional variable to store the sum. And that's it. I would be posting this solution in the comments, so you can check it out from there. Thank you. Today we are going to do three-sum LeetCode problem, and it is a very interesting problem. If we see some of the companies where I want to get a job who have already asked this question, there are companies like Amazon, Microsoft, Apple, Facebook, Uber, Bloomberg, Google, Tesla, ByteDance, and LinkedIn. So that's why I'm paying my utmost attention. I hope you also enjoy the video. So this is a LeetCode medium problem and also a very well-liked problem on LeetCode. Basically, we are given an integer array called nums, and we need to return the triplets. Now we need to return the triplets such that the sum of all of those triplets is actually equal to 0. And we are also given the definition that the elements has to be unique. So I, j and k is supposed to be the triplets, and they should not be the same. They should be different values. We are also told that the answer set must not contain any duplicate triplets. So this is an additional set of complexity that we will have to take care of. Now let's try to understand this problem with a couple of examples that are provided over here, and I have actually broadened these examples. So let's try to understand them. So suppose this is the input array nums we are given. We need to find the triplets such that the sum of each of all the triplets is equal to 0. So if we see that in this example, we can actually find the sum of these three values to be 0. So first of all, we are going to add these three entries into our answer, that -1, 0 and 1. This triplet equals to 0, so we can add that to our answer list. A second triplet we can find is the value -1, again -1, and value +2, because -1 plus -1 plus +2 is also equal to 0. So again we can add it to our answer set, that 2, -1 and -1 as the answer. And now apart from that, we cannot find any more triplets, so this is the only answer we are going to return. One critical thing to understand over here is that this -1 is actually using 2 times in 2 different answers. That is perfectly fine, but we cannot have an answer where we already have the value like -1, 0 and -1, and again we have the value -1, 0 and +1. This should not be the answer. So this is one of the conditions that is given. Second condition is that all the values of I, j and k has to be unique, so they are located at unique positions, because we cannot use the same value again and again. We cannot do something like 0 plus 0 plus 0 equal to 0 and return that as the answer of the triplet, because in this case we only have 1 0, not 3 zeros. So just keep all of these things in mind. If we take a look at the second example, over here we actually do not have any pair that equals to 0, right? So in this case we are only going to return an empty array as the answer, and basically this is what the problem is asking us to solve. Now there can be two potential solutions for this three-sum problem that we are trying to deal with. First solution is actually a two-sum problem solution. That is also another LeetCode problem where we use hashing to generate the solution for this two-sum problem. Second solution is two-sum 2 problem where we actually use 2 pointers to come up with that solution. And in this case we are going to see that how using hashing we can solve this three-sum problem, or how using 2 pointers we can solve this three-sum problem, because both of this concept can be useful. We can choose either one of them. Now I'm going to show you the theoretical knowledge of both the problems, but I'm only going to show you coding for this two-sum 2 problem. Let me know in the comments if you want to see the code for this two-sum problem as well, and I can show it to you. Okay, so first let's see that what is going to be the optimal solution using the solution we used in the two-sum problem. Now, if you want to know more about two-sum problem, you can check out my video over here, and that is going to give you much more clarity. Okay, now let's get back to our question. So if we suppose this is the original input that we are given, and we are trying to find a set of triplets that sum up to 0, right? Which means we are trying to find 3 different values where I plus j plus k is equal to 0. Okay, that is the whole idea. The technique we are going to use is that, okay, suppose this is the first value, right? Suppose if we consider I is equal to -5. Once that is done, what we will have to do is we will have to try to find that if j plus k is equal to +5, if that exists inside this remaining array, if that is the case, then we would actually have a triplet called I plus j plus k that sums up to 0, because I is equal to -5, j plus k is equal to +5. And now we simply need to see that inside the remaining array, do we have a pair j plus k that is equal to +5? And that was actually the original question for this two-sum problem. So that is how everything is linked internally. The idea is, okay, that we can find it easily using a hash map or a hash set, and then we would be able to get this answer. The problem that would come in this case is that because we are trying to avoid duplicates, and what would happen with this approach is that, okay, suppose if we consider I is equal to -5, right, we would actually have an answer where the values of -5, 0 and +5 exist as one of the answer, and we are able to generate this. Okay, so now we are able to say that, okay, this -5 we have already taken care of and we found the correct answer. But if we look somewhere inside the remaining array, we would also find another -5. So when we try to repeat the same logic, basically even for this -5, we will also have the I is equal to -5, and we will try to find j plus k is equal to +5. Then again we would have another answer that also looks like -5, 0 and 5. And remember, these is going to be the duplicate value that we are trying to avoid. So in order to make our lives easier, what we can simply do is, if we take this input array and if we sort this input array, and because when we sort this input array, we are going to have the same looking values right next to each other. So we can only have a condition that the moment we find out that two adjacent values, they are same. If that is the case, that if we find the two adjacent values to be the same, then we are simply going to ignore that case and move on to the next value. Okay, so now after this whole explanation, let me clean this up a bit and create the sorted array. So now we have our sorted array, right? Now we will try to see that what could be the potential I, j and k values. Now based on the I value, we will also have to determine that what should be the j plus k value, and based on the jth value, we will also have to determine that what should be the kth value, right? That is how we are going to do the things. So first let's try to see that if I is equal to -5. If I is equal to -5, we will have to find j plus k is equal to +5. If we have to find j plus k is equal to +5, we will try to start iterating over this remaining array. Again, we are going to create a hash map or a hash set over here. So let's create a hash set first. Okay, now we are going to start iterating over all the remaining values. Okay, so suppose this value is -5, so we'll try to consider j to be -5. If j is equal to be -5, then k has to be +10. And now we are trying to see that, okay, we'll see that if this k is equal to 10 exists. If that is the case, we will return that. If it does not exist, we are going to add that value to our hash map. Okay, so because k is equal to 10 does not exist, we will have to add all the values to our hash map. And remember, there is a property of a hash set where it does not exist duplicate values, so we will only have unique values inside over here. So since j is equal to -5 didn't work, we'll try to see that whether j is equal to -3 works or not. So if j is equal to -3, then in that case we will need the kth value to be +8. +8 also does not exist, and we can look that up immediately because of this hash set, right? Now we'll try to find another value. Okay, so if that didn't work, we'll try to see that whether j is equal to 0 works or not. Okay, so if j is supposed to be 0, then the value of k has to be +5. Okay, that we can look up immediately, and we would be able to find that k is equal to +5 already exists inside our hash map. So immediately we found that we are actually going to have an answer list where we are going to populate the values of I, j and k we found. Okay, so we are going to add the values -5, 0 and +5 immediately. Now we are going to repeat the same process for all the remaining values, right? So, and for every single value, we will also have to create the new hash set and new I, j and k values. So we will empty this one. Okay, now the new I value is actually -5. The thing is, this is a track because we already had a value -5 that we already iterated over. So we will not have to use this one, and that is how we are going to avoid duplicates. Now suppose if next I value is -3. Okay, so if I value is -3, then j plus k has to be +3. Okay, so if j plus k has to be +3, let's see that what could be the potential remaining j plus k values over here. Okay, so over here currently jth value is 0. So if jth value is 0, then kth value has to be +3. Okay, so we'll try to see that inside the remaining array whether +3 exists or not. +3 does not exist, but that is going to help us fulfill our hash. So we are going to add all the entries to our hash map, and we couldn't find k is equal to 3. So now we are going to try the new value of j is equal to 0. So again, because this 0 we already consider for j, we should not be considering this 0, so we can just simply jump over. Okay, so now next value is j is equal to 1. If j is equal to 1, we will try to see that whether k is equal to 2 exists or not, and k is equal to 2 already exists, that we can clearly see over here. So because it exists, we are actually going to have j and k values properly set up, and we are also going to add one more triplet to our answer, that is -3, 1 and 2. Okay, now we can ignore this one. Okay, now current ith value is 0. Okay, if ith value is 0, then j plus k has to be 0. Okay, so now we'll try to find j plus k to be 0. Now inside the current method, okay, now this next value of j, potential value of j, this is the 0th value. So we'll try to add this value, and by the way, I forgot to clear the hash, but it would be cleared. Okay, now if j is equal to 0, then k also has to be 0. Okay, so currently k is equal to 0 does not exist inside the remaining array. So because it does not exist, we will try to jump on to the next value of j. If j is equal to 1 can work or not. So if we try to put j is equal to 1, it is definitely not going to work, and we won't be able to find a pair j plus k is equal to 0. So I is equal to 0 is also not going to work. Because I is equal to 0 not going to work, and we have already taken care of this 0, so which means we don't have to see for this 0. Now we will try to see that whether I is equal to work or not. But the question is, do we really want to check whether I is equal to work 1 is going to work or not? Because inside the remaining array, all the values are actually going to be positive values. So because these values are going to be positive values, j plus k is always going to increase the value of whatever the sum of I, j and k is going to be, because this I is positive. So immediately we can stop our search, and whatever the answer we have found, we can actually return that as the answer. And that is the whole approach. Now, and if we see time complexity, in this case the time complexity is actually going to be big O of n log n, that is to sort the array, plus big O of n square. Why? Because for any single ith value we will have to find j and kth value, which means for every single one of them we will have to iterate over the entire list of all the arrays. So that takes like big O of n square, and that is the best we can do. If we see space complexity is also going to be big O of n, because for this sorting operation it takes big O of n time, and plus we are also creating this hash, so that also takes big O of n space. Okay, now we will try to see that what is going to be the optimal solution using the 2 sum 2 problem. Now if you want to learn more about this problem, you can check it out my video over here, and this is a very good explanation for that. Now we are going to use the same example as the input, and as mentioned for the reasons explained before, basically we are going to use the sorted array in this case as well. So from this original input we are actually going to create a sorted array first, so that is going to help us avoid duplicates. Now the again idea is that currently we are going to consider the one value to be I. Okay, so suppose we are going to consider I is equal to -5. If that is the case, j and k value could be potentially possible, where j plus k is equal to +5, right? And inside this remaining array we will have to find the +5 value. So what we are going to do is we are going to initialize couple of variables. So first is going to be left pointer, and second is going to be right pointer. Now every time we are going to do left plus right. If left plus right is equal to 5, then basically we are good, our life is set, and we can simply add it to our j plus k values. If that is not the case, if we somehow find that left plus right is actually greater than 5, if that is the case, then somehow we will have to reduce the sum of this left plus right. How can we reduce the sum of left plus right? By shifting this right pointer on the left hand side. Why? Because all the values on the left of this right pointer are actually less than whatever this right value we had. And if somehow we identify that okay, this left plus right is actually less than the answer 5, if that is the case, we are going to update our left pointer to go one step on the right side, so then we would be able to increase the sum that we are trying to achieve, and that is how we would be able to generate the correct j and k values. So let's try to see the approach in action. So suppose currently the ith value is equal to -5. Okay, I is equal to -5, j plus k is equal to +5 we are trying to find. Okay, so once we have the j plus k value we are trying to find, we are going to initialize two variables, left and right. Okay, so currently our left pointer and right pointer, we are going to be concerned with that, and we are also going to be concerned with left plus right sum, and how that is referring to whatever the value we are trying to find. Okay, so currently the target value is 5. Okay, now the current left position is -5, current right position is +5. So left plus right is equal to 0. 0 is actually less than -5. So because 0 is less than -5, we will have to update the value of our left pointer to go one step on the right. So now the current left pointer is -3. -3 plus 5. So if we do -3 plus 5, the value we get is 2. 2 is still less than 5. So because 2 is less than 5, again we are going to update our left pointer. So now the left pointer is at 0th position right over here. And currently the sum we are going to get is that okay, this is 0, this is 5, so 0 plus 5 is equal to 5. So currently left plus right is equal to 5. 5 is exactly what we are looking for based on this remainder value we have created. Okay, so now this left pointer can be assigned to this j value, and right pointer can be assigned to this k value, and we can actually populate our answer. So inside our answer we are going to have the first entry called -5, 0 and +5 as one of the answer. Okay, now we are done with taking care of this -5. So now we'll have to take care of this another value, but again same thing, this value is also -5, same as the previous value. So again we are going to ignore this case as well, and now currently our I is going to be -3. Okay, so now if we put our I to be -3, our j plus k sum has to be +3 in this case. Okay, so j plus k has to be +3. Again, if j plus k has to be +3, we will also have to update our left and right pointer. So currently left pointer is also going to be at the position 0, right is going to be position number 5. Okay, and we will also have to update this value as well, that this has to be 3. Okay, Now currently 0 plus 5 is actually 5. 5 is actually greater than 3. So because 5 is greater than 3, we will have to reduce the value of our right pointer. So currently our right pointer is going to come over here. So now the right pointer value is actually 2. Okay, so if we do 0 plus 2, 0 plus 2 is actually going to be 3. So 3 sorry, so now if we do 0 plus 2, 0 plus 2 is actually going to be 2. 2 is now less than whatever the value of 3 is. Because of that, we will have to update our left pointer to go on the right side. Now, the moment we do that, okay, this value is also 0, same as the previous value. So because of that, because we have already calculated this 0, we are actually going to ignore this 0 as the left pointer, and our left pointer is going to come over here. Okay, so now the value of our left pointer is actually 1. So 1 plus 2. So 1 plus 2 is actually 3, and 3 is what we are looking for, that we already find the answer. So we are also going to populate the values of left and right over here, and inside the answer we are going to have one more entry called -3 plus 1 and plus 2. Okay, now now we have taken care of all the cases. Now again, this value I is equal to 0. If I is equal to 0, we will not be able to generate the answer, and now in this case I is going to be 1, so that is going to be the positive value. So because of that, we are actually going to break out of it, and simply whatever the answer we have found, we are able to return that as the answer using this 2-pointer solution. And even for, if we see the time and space complexity, in this case the time complexity is also going to be big O of n square plus big O of n log n. Why? Because we will have to do the sorting operation. If we see space complexity, the space complexity is also going to be big O of n. That is going to depend on the implementation for the sorting we are using. So that is how we are able to generate the solution. If you see, in this case we are actually not using any additional hash set, so that is a plus benefit in my opinion. And if you show both the approaches in any interviewer would be like more than happy with you. So first of all, we are going to sort the given input nums, and we are also going to create a new variable called result to store the list of lists that is needed over here. Now we are going to run a for loop across the given input nums. Notice inside the for loop, we are only running it up until the point where the value of nums of I is actually less than 0. And the moment it gets greater than 0, there is no point in continuing with the loop. So we just simply ignore that. Now inside the loop, we are actually going to call our toSum2 function, but for that we actually have a couple of conditions that we are going to take care of. So first condition is that if the given value of I is equal to 0 or the starting position, then we do it, or we check that whether the two adjacent values of I and I minus 1 are they same or not. If they are not same, then only we call our toSum2 function, otherwise we ignore that particular entry. Inside the method, we are going to call the toSum2 method, where we are going to pass in the value of the given input integer nums, the current ith position, and the result variable. And basically that's it. Once this for loop ends, basically with the help of this toSum2 method, our result should have been populated, so we can simply return the result. Now it's time to create the new toSum2 method. First of all, we are going to initialize two pointers called left and right. Now we are going to have our while loop, that while left is less than right, we are going to do some interesting things. First of all, we are going to have a variable called sum that is going to calculate the current total sum. Now we are going to check that if the given sum, if that is less than 0, if that is the case, we will have to increase the value of the left pointer. Else if we are going to check that if the given sum is greater than 0, if that is the case, then we will have to reduce the value of our right pointer. And if both are not the cases, which means our current sum is exactly 0, so first of all we are going to add a new entry to our result variable that we have created. After adding the values to the result, we will again have to update our left pointer until the point that whether the two adjacent values of left pointer, they are same or not. Basically that's it. This should have taken care of all the scenarios, and this should be working. Now let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code, and our code runs decently efficiently. Today we are going to do container with most water LeetCode problem. And if we see some of the companies where I want to get a job, we already asked this question. There are companies like Amazon, Apple, Google, Microsoft, Facebook, Goldman Sachs, ByteDance, Bloomberg, TikTok, Uber, and Tesla. So that's why I'm paying my utmost attention. I hope you also enjoy the video. This is a LeetCode medium problem and also very well liked problem on LeetCode. And like any LeetCode problem, we are given some input and we are expected to get some results from this particular input. But before we start understanding this problem, first let's see this concept that I'm trying to explain. Okay, so suppose we are given a container that looks like this and we are trying to see that how much water can we fill in this container. Well, the logic is actually quite simple. We can only fill water up until this point inside this given container. Anything more, if we try to add water over here, that water would simply spill out. We won't be able to fill our water above this line. So that is a given fact, right? That is a very simple explanation. Now, if I ask you that how much water is present in this container, so then in that case, the answer is simple. There can only be water up until this point, nothing more than that. So in this case, for this particular container, rather than considering this container to be a container, if we consider this to be a rectangle, things becomes easy for us. Because we know that the surface area of rectangle is the amount of water we can store in this particular container, and we know the formula to calculate the area inside any given rectangle. Suppose this is the height of the container and this is the width of the container. If we are given these two values, basically if we do h times w, height crosses height multiplied by width, we will get the amount of area, and that would equivalent that how much water we can hold in any given container. Now let's try to understand another scenario. Suppose we are given a container that looks like this, or we are given a container that looks like this. In these two cases, how much water can we store? Well, the answer is again simple. We can only fill water up until this point, till the lower edge on any given container, not more than that. So now in this case, we are actually given two different heights for each sides of the given container, right? So suppose this side is h1 and this side is h2, and same goes over here. This one is h1 and this one is h2. If that is the case, if we try to calculate the area in this case, the area equation for the water is gonna change. Why? Because we are not going to use h1 over here, because this is the higher side. We are actually going to use h2, which is the lower side. So in this case, the area is going to be h2 times width for this particular container. But for this particular container, the equation is actually going to be h1 times width, because this h1 is actually smaller in this case. So these are the two concepts that you will have to understand. And now let's go back to the problem. Okay, so now in the problem, we are actually given an array called heights of length n. And now if we try to plot this array of height on a graph, we can consider that based on the x-axis, we can actually create a container. And then we need to find that what is the container we can create that contains the most amount of water. And then we need to return the amount of water that the maximum container can store. Now, I know that the wording may sound confusing, so it would be better by understanding with this example. Suppose we are given an array heights like this. So if we try to plot this array heights on a graph, we can actually get a graph that looks like this. Now in this graph, you can see that there is a difference between lines, and based on these line differences, we can actually create some sort of containers between any two vertices. And the amount of water we can fill will depend on the lower side of the height rather than higher side of the height. So in this case, we can actually create a container that looks like this. So if we try to consider this index number 1 and index number 4, the container we can create is going to look like this, where this is the amount of water we can fill, nothing more than that. Now remember, as mentioned earlier, that for every single time, if we want to calculate that what is the amount of water we can find, we need to calculate the area of the presumed rectangle, and for that we need the height, which we already have based on these values, which we can derive from the array. And we need the value of the width. So width we can achieve by calculating the difference between any two places on the x-axis, and these values we can determine depending on the index values of the given input array. So it makes our lives easier. So in this case, if we try to see that some of the containers that we can make a container that looks like this amongst these two values, and then we can calculate its water. So I'm just showing you for an example. So in this case, the minimum height is actually 5. So height is going to be 5, and the width in this case is actually going to be 2. So 5 times 2, we can say that okay, there is 10 units of water we can put in this container if this was to be the be the container. The thing is, we are trying to find the maximum water we can make amongst any given container. So in this case, the answer is actually going to be this container, where the current height is 7 among 7 and 8. So we are going to choose 7 as the height. Okay, so h is equal to 7. So okay, it's going to be 7 times the distance. So distance in this case, okay, this value is 2 and this value is 9, so distance is also 7. So in this case, 49 is the maximum unit of water we can contain, and that is going to be stored between this container. Basically, I hope that this makes understanding this problem easier. And after understanding the problem, now let's focus on different solutions that we can achieve. The first approach we have is a brute force approach, and suppose this is the input we are given. If we try to plot it on a graph, we can actually create a graph that looks like this. Now the idea is, we are actually going to check every single container that we can possibly make, and depending on that, we will try to see that what container contains the most amount of water. So basically, we are going to have a two variable. First variable is called area to calculate the water at any given container, and second is going to be the max variable that is going to be update its value whenever we find a better area or maximum water we can contain, right? So first we will start with this first index, and we will try to see that, okay, what is the container we can make with between the index 1 and 2. We can make a container that looks like this. What is the container we can make between 1 and 3? We can make a container that looks like this, and say so on and so forth. We will keep on repeating our graph. After being done with this value number 1, we will ignore that, and we will start focusing from value number 2. So from value number 2, we can make container that looks like this, and then again a container that looks like this, and blah blah, so on and so forth. And eventually we would find an answer in this case between this value number 2 and 7 indexes, that if we make this container, that is going to hold maximum amount of water. And in this case, the answer is going to be, okay, so for this area, height is going to be 4 because that is the smaller amongst these two, and the width is actually going to be 5 because 2 minus 7 is 5. So maximum area is going to be 20, and 20 is the answer we are going to return. So this solution would work as expected, but if we see the issue with this solution, the issue is actually time complexity. Why time complexity? Because for every single value, we are comparing it with all the other values to see what is the container we can create, and we are not doing things efficiently. So basically, the time complexity in this case is big O of n square, which is very bad, and we will have to do something better. So let's see that what is the better approach we can get. So for the optimal solution, we are actually going to use two pointers to our advantage, and we will try to see that what is the optimal container we can make. So we are going to have a pointer left located at the first position, and we are going to have a pointer right located at the last position. The idea is both pointers are going to come towards each other until they meet or cross each other. Now every single position, we will try to see that depending on the values of left and right, what is the container we can make. And then we will try to calculate its area, and after calculating the area, we are going to compare the heights between left and right, and whichever has greater height, we are going to keep that height, and then we are going to update the remaining counter. So left counter will go on the right side, or right counter will come on the left side. So let's see the solution in action, and it will make more sense. So basically, initially first, if we see currently the height at left is 3 and height at right is 2. Okay, so if we want to calculate the area, we are going to calculate the smaller amount. Okay, so currently the smaller height is actually 2, and if we see the width in this case is going to be 7. Okay, so current area we are able to calculate is 14. We are also going to have a variable called max area. So currently the max area we have been able to find is 14. Okay, so far so good. Now we will try to compare the heights between left and right. Okay, so currently left height is actually greater, so it is in our interest to move right counter one step to the left rather than moving the left counter. Okay, so in this case, right counter is going to come over here. Now again we are going to repeat the same process. So now currently the height at right counter is 6 and left counter is 3. Okay, so now if we will have to calculate the area again. So we are going to choose the smaller value amongst the height. So currently this is going to be 3 as the smaller height, and width is going to be 6. Okay, so currently the area we can get is 18. 18 is greater than 14, so we are going to update the maximum area, maximum water we can contain to 18. Now we are going to compare the height between left and right. Now in this case, the height at right is actually greater than left, so we are going to update our left pointer to go one step to the right. Now this left pointer is located over here. Currently the height is 2. again we are going to calculate the area. So this height is actually going to become 2 and the width is actually going to become 5. So 2 times 5 is actually 10. So because 10 is less than 18, we are not going to update the maximum value we have been able to find. Again we are going to calculate the heights between left and right. So again right height is greater, so we will update the left pointer to go on one step on the right side. Now currently the height over here is 7 and currently the other height is 6, so we are going to choose the smaller height. So the height we are going to choose is going to be 6. 6 times the width is going to decrease. Okay, so currently the width value we have is going to be, okay, this is this is left pointer, so 3 minus 1 4. Okay, so 6 times 4, so this area becomes 24. 24 is actually greater than 18, so because 24 is actually greater than 18, we are going to update the maximum area we are being able to calculate. Okay, so this is 24. Now again we are going to compare the heights between the left pointer and right pointer. So currently right pointer is actually less, so now we will have to update the value of the right pointer. So currently this becomes our right pointer. Now this value is 3, this value of left pointer is 7. So again the height is actually going to be 3 and the width is going to be 3 as well. So this is going to be 3 times 3, so this is 9. We don't need to update the max value. Again if we compare the heights, the right is actually smaller, so again we will update the value of the right counter. So now this time the right counter is reaching at this value number 1. So if we calculate this container, the area is actually going to be 2. So 2 times 1, so 2 times 1 is only 2, so we don't need to do anything. Again we will update the right counter. So currently the value of right counter is 4 and the left counter is 7. Okay, so we are going to have a container that looks like this. So 4 times 7 4 times 1 is going to be 4 as well. So then we, in this case, we don't need to update the max value. And if we try to update the left or right variable again, that they would cross each other. So because they would cross each other, now we can get out of our loop. So whatever the maximum result we have found so far, that is going to be the solution we need to return. So in this case, the answer is actually going to be 24, as that this is the maximum units of water we can contain between basically this container, this water container, and that is the answer we need to return. If you see the beautiful thing about this solution, this whole solution gets completed in a single iteration between these two pointers. And if we see time complexity, in this case the time complexity is actually going to be big of n only, which is much better improvement compared to our brute force approach, which had the time complexity of big of n square, which was really bad. So we can avoid that. If we see space complexity, the space complexity is also really good, because apart from using couple of pointers, we are not using any additional space. So space complexity is actually constant space, which is wonderful. And this is a very good approach and a very good way to learn two pointer problem. And I hope you understood it. Now let's move on to the coding. First of all, we are going to initialize couple of variables. So first variable is going to be max, and that we are going to initialize it to 0. Then we are going to initialize two pointers, left and right, and left is going to have the value of 0 and right is going to have the value of whatever the length of heights array is. So we run our while loop, that while left is less than right. Now first of all, we will have to calculate the width. So width is going to be right minus left. So now we have the width and we already have the height from this heights array. We will calculate the area. So this equation should give us the area. We are selecting the lesser height amongst right height and left height. And now we will see that whether we need to update the max value as well. And now we will have to update our left or right pointer. So we will check that, okay, if the current height of left is less than or equal to the right height, we will update the left counter. If that is not the case, we will update the right pointer to go one step on the left side. And in the end, we can simply return the max variable that we have calculated. And that should be it. Let's try to run this code. Okay, seems like our solution is working as expected, and our solution runs pretty efficiently compared to a lot of other solutions. And I would be posting this in the comments so you can check it out from there. Thank you. Hello friends, we are still not employed by FAANG company, so let's not stop lead coding till we get there. We are going to do trapping rainwater problem today. And if you want to see that what are the list of companies that have asked this question, that comes later in the video, so you can directly check it from there. Let's understand the problem statement. we are given an array called n, where all the integers are non-negative, and any single integer represents actually the height at that particular position inside the array. We are given that the width at any two positions is actually 1, so we can consider that. And we need to see that how much water can we trap when it rains. We know that it's going to rain a decent amount, so we all the cells that could trap water would trap water, and our aim is to see that what is the maximum unit of water we are going to store. So let's try to understand this with an example. Over here we are given an elevation graph, and all of those values are represented as bars inside the given graph. And we notice that because there are some height differences, due to the height difference there exists an empty space inside this given input. And because that empty space exists, rainwater can actually fall in and be stored on those particular positions. So if we see over here, like this first position is actually 0, but and suppose the rain falls, can any water be stored over here? Well, it cannot be stored, because in order for water to be stored, we need a vessel like this or like this or something like this, where at least water can be stored. Like over here, if we see, water can be stored for all of these positions, because all these three edges were covered with some sort of solid material. Same goes over here. Like over here, we can only fill water up until this point, because on the left side the edge is only up until this point, not more than that. Like though on the right side the edge is actually higher, but if we try to fill in more water, or if rain falls and more water falls on top of it, all the water is gonna spill out, and no amount of water is gonna be stored. So that is one key important part, is to understand that how water is stored. And second is that we need to iterate over this given input height, and at every single position we are going to basically calculate that how much water can be stored due to this height difference. So if we see in this example, at this first position no water can be stored, so like there is no water pointed with over here. Like this is a bar by itself, and in this particular bar, this is the boundary, that is a solid surface that cannot store any water, and we cannot store any water on top of this one, because all the water that gets stored on top of this one will also spill out, because on the left side the boundary is actually non-existent. Now if we look at this third position over here, actually because of there exists a height difference between these two positions, we have a scenario something that looks like this, where water, when the rain falls, on the left side we have a bar of height 1, which is represented over here, and on the right side we have a bar of height 2, which means that we are creating some sort of value over here, where on the left, at this particular position on the left side, the bar is actually of one size, so this is of one size, and this is bar of two size, so this is actually two size, which means that there exists an empty vacuum where water can fall in and water can be stored. So this becomes our point, and we can check that over here we can store 1 unit of water. Now the question comes that why can we only store 1 unit of water? Why cannot we store more than 1 unit of water? The formula is actually quite simple. Like at this particular position, we see that on the left side there exists some height, on the right side there exists some height. So suppose this one is left height, this one is right height. There are two heights that exist at any moment, and this by itself can have some height, as mentioned in this input, that there can be some height that can be located at this position. And suppose this position is actually the height we are currently at, so we just name it as height. Okay, now how can we determine that in this scenario? In this scenario, if we see thus all these values, so left height is actually 1, okay, right height is actually 2, and the height we are currently at, which is this position, is actually 0. And over here we were able to store only 1 unit of water. So why we were only able to store 1 unit of water? Basically we were following this condition that first of all we need to check that what are the bar height difference between on the at any given position on the left hand side and at the right hand side, and we need to take the minimum out of both of them, because over here, though on this right hand side the bar is actually of height 2 units, because on the left hand side the bar is only of at a height 1 unit, we cannot store water more than this height because the water is gonna spill out. Now that is one condition. Now second condition is, in this case we got lucky that over here there is no height at all, so that's why we were able to store 1 unit of water over here. So basically we can say that at any given moment the amount of water we can store in 1 unit is actually following this formula, that the minimum of whatever the right height is, whatever the left height is, so whatever the lower value of both of these minus the height we are currently at. And if this is greater than 0, then only we can say that we can store some water at any given position. Like let's say for an example that why at this first position we are not able to fill out any water, and if we see both the values, so on the left at this particular position I'm referring that on the left side the left height we had was actually 0, the height at current position was also 0, and the right height was actually 1. So if we apply this formula, we can clearly see that on the amount of water we can try to fill in this space is actually going to be minimum of these two. So minimum of left height and right height is actually 0 minus the height we are currently at. So current height is also 0, which means that we cannot store any water, or we can store 0 units of water at this particular position, or at this first position, because there exists height difference. And same formula can be applied for all these places to calculate that what is the amount of water we can store. Like if we see over here, the bar height is actually 2. Now for this particular position, if we want to check that what is the amount of water can be stored, we know that over here we can store 1 unit of water. And why we are storing 1 unit of water is because if we see the left height over here, that is 2. Now on the right side, the right height, there is no right height over here. There is no right height over here which is greater than this one. Like this, there is some right height over here, but that is less than this height. So there is no point in us to treat it as valley up until this point. But over here we know that the height is actually greater than whatever height we currently had over here. So this right height is actually 3. So we are going to check, so we are going to apply the same formula. So we are going to check the minimum out of 1 and 3, one minimum out of 2 and 3. So this is left height, this is right height, and we are going to minus whatever the height we are currently at. So current height is actually 1. And if we apply this formula, we get 2 minus 1, so we get 1, which means that over here we can store 1 unit of water. Now let's try to understand this one with another example, and I'm spending a lot of time in this one because this is the actual crux of the entire example. So over here, if we want to calculate that how much amount of water we can store, we are again going to repeat the same process. So what is the left maximum height we can find for this particular unit? Like the left maximum height we can find is actually 2 units. So we can say the left height is 2, the right height is this one, so right height is 3, and minus whatever the height currently we have at this position. So this position we don't have any height, so which is 0. So if we apply the same formula, we can get 2 minus 0. So we can say that over here we can actually store 2 units of water, and which is what is presented over here. Like that's how we can store 1 unit of water over here, and that's how we can store 1 unit of water over here. So at any given position for any particular element, we are only going to need 2 things, because height we are already given. So we remember that in this equation we are actually comparing 3 items: the right maximum height, left maximum height, and height we are currently at. So height we already know, and our aim is to find that how can we find this right maximum height at any given element, left maximum height at any given element, and then it would be piece of cake to for us to identify that how much water can be stored at any particular position. So we can have a brute force approach where at every single position we iterate over the entire left array and entire right array, and we find that what is the maximum left height we can find at any given position. We can also find what is the maximum right height we can find at any given position, and we already know that what is the height we are currently at. And once we have both of this information, we would calculate our result, and we would try to calculate our output. The thing is, this scenario is pretty darn bad, like at any single position. So even over here we will have to iterate over the entire left array and entire right array in order for us to calculate these two values. And yeah, this is brute force. So brute force is tend to be dumb, like we are not doing anything clever over here. So that's why we would end up with the time complexity of big O of n square, because at any single position we are going to iterate over the entire array to find these two values, left height and right height. Now can we do something better over here, and how can we find a better approach? Like so for the given input example, we can actually do something clever. What we can do is whatever the input we are given, we can actually iterate over it from the left side, and at every single position we can see that for any single element, what is the leftmost value or left max value we can store. Again, we are going to iterate over the given input example on the reverse order, and then we can find that at any single position what is the right max value we can find. And then it becomes pretty simple for us. We can just simply apply this formula on the entire input that were at any single position. So at any single position we only need to find the minimum value of right max and left max minus whatever the height we are currently at, and if this becomes greater than 0, then we will add it to our whatever the output we have, and this would be our answer. So let's iterate over first on the left max side on this given input. So on the first element the maximum left height can be 0. Over here it can be 1, again over here it can be 1. Now over here this value is 2, so left max height at this position would actually be 2. This would actually be 1, but thing is we have already find a greater value, so again we are going to keep it as 2. Again we are over here this one is 0, so again the left max height we can find is 2. Over here this one is 1, so again this would be 2. Now this is 3, which means that left max height we can find is actually 3. This is 2, so left max height we can find is actually 3. Again 3, again 3, and again 3. So this is how we can fill out this left max table. Same way we are going to fill out the right max table, but we are going to do it in the reverse order. So over here the right max edge is actually 1, and we are going to repeat the same process. Now we have both of these tables filled out, it becomes pretty easy for us to find the solution, and we can actually do it everything. Now this approach would work perfectly fine. The thing is, what is the issue with this approach? Like if we calculate the time and space complexity, the time complexity for this one is actually big O of n, because we are doing everything in just a single loop, and we are running this loop 3 times. Like first we are running this loop, so we are doing n work, again we are running this loop, so we are doing n work again, and then we are running the n work to find the output. But thing is still time complexity is going to be big O of n, and the space complexity for this one is actually going to be big O of n as well, because we are storing these two additional data structures. So this is much better improvement than our brute force approach, where in the brute force we are doing everything in big O of n square time. So we are gaining significant improvements over here. Now this question has been really popular with a lot of different companies, and if we just look at the number of companies that have asked this question, and if we just see the amount of frequency that they have been asking this question, I wouldn't be daring to skip this problem. Like even if you see up until 2 years, almost all the companies that are like one of the biggest companies in the world, they are continuously asking this problem. Just look at the numbers, like Amazon, Facebook, Goldman Sachs, Bloomberg, Microsoft, Google, Adobe, Uber, Apple, Tesla, Lyft, Expedia, Morgan Stanley, Swiggy, ByteDance, Databricks, Walmart, Flipkart, ServiceNow. These are the companies that pay you in gold bricks. And getting job or getting employed at any of these companies at least for 2 3 4 years is going to change your financial situation drastically. Like it's going to be 180-degree turn, and you only need to clear the technical interviews just once. Like after that you are sitting on top of gold. So if you are also dreaming to changing your life completely, like make sure to focus your utmost attention to this problem and try to solve it as many times as possible, because it has been asked in so many companies. So that tells you something. Okay, now for the optimal solution, we can actually observe something pretty interesting in this given left max and right max that we have calculated. If we notice in the given input, this is the biggest bar of height that is possible, and we know that at any moment at any location, if we want to find the height, the equation is this one, that the minimum of whatever the left max and right max we have minus whatever the height at current position we have. This is the equation to find that how much amount of water we can trap at any given unit or any given elevation. Now the thing is, if we notice in these two values, left max and right max, we are actually finding something pretty interesting. And the interesting thing we are finding is that the tallest part that we have, it actually divides the given input in two parts. And it divides how? That if we observe the left max portion, the left max portion is always less than whatever the right max portion is up until this point, number 7. Because notice all of these values, in all of these values the value of left max is actually less than whatever the value of right max is, and over here it's equal to right max because of this particular tallest bar that divides two arrays. And all on the right side, actually the R max is less than left max, and we can see those things over here, that over here these are all the values that are smaller than whatever the left max there is, because for these four values actually this particular the tallest bar actually becomes the left max element. And using this we can actually use it to our advantage, because remember, at any moment if we want to find that what is the amount of rainwater we can find, we only need to find the minimum value of amongst this left max and right max, which means that this tallest bar can actually be used in our help, and we don't even need to calculate this whole left max and right max array by itself. We can actually use a very beautiful concept that is present inside the given array traversal problems, and that is two pointer solution over here. In the two pointer function, we are going to have two variables, left and right, initially located at first and last position, and at every single time we are going to check that whatever current element we have, so whatever height at element left or pointer left, and whatever the height at pointer R, we are going to compare these two. So suppose the height at left pointer is actually less than right pointer. What we are going to do is, first we'll check that whether the current left pointer we are at, does it contains the left max height, and we are going to initialize the left max variable to 0 at the beginning, and at any point we are going to check that whether we need to update the value of left max. So for left max we are going to check two things. We are only going to check one thing. We are going to check that whether the left max should be the maximum value out of whatever the left max we have stored and whatever the height of left we are at. So this will always make sure that we have the most updated left max value. Once that is done, we only need to use one equation in this scenario, and that equation is left max minus whatever the height we are currently at of pointer L. If this is greater than 0, we can actually add it to our total. So we can just say that total is whatever value we already had for total, plus we can add this whole function to it. And once that is done, we will need to update our left pointer. So on the left side we will move towards the right pointer and we will do left plus plus. And again, suppose at any point we find out a scenario where the height at right is actually, so height at right is actually less than height at left. if that is the case, we are going to repeat the same process. Let me use a different color, but this time we, rather than doing it for left max, we are actually going to do for the right max. So again, we are going to check for right max, that what is the maximum amount we can find. So we are going to take maximum of whatever the right max we already have and whatever the current right height we are at, and once that is done, again we are going to use the same equation, but rather than using left max, we are going to use right max minus whatever the height we are currently at for this r pointer. And if this is greater than 0, we are simply going to add that value to our total variable, whatever we calculate for this one. And once that is done, our right variable is actually going to move towards left side, and we are able to achieve this because there exists some bar that actually divides the array in two portions. Because over here, up until this bar, always left max is going to be minimum value, and over here always right max is going to be minimum value. And at any single position, whenever we are at any left and right, we always check their heights, which means that suppose we reach this right before, still in the left side we will have to calculate all of these values before we get here. And once we get to a point where left is actually greater than or equal to right, then we can simply break out of the loop, and whatever value we have stored in the total, we can simply return that. This is a very beautiful approach, and notice that we don't even have to use the full equation over here. We are only comparing any one variable at any point in time, a left max and right max, and every single time we are keeping track of whatever the left maximum or right maximum value that we have been able to find. So if we use this approach, if we use two pointer approach, and if we calculate the time and space complexity, basically the time complexity for this one is actually going to be big O of n. So that is same as it is, because in any case we are going to traverse over the entire input array, but the thing is we are only doing it once, we are not doing it more than that. And if we see the space complexity, actually we are only storing couple of additional parameters, like right max, left max, and we are storing two pointers, left pointer and right pointer. So we are not doing any additional data structure, or we are not storing anything else, which means that our space complexity is actually going to be big O of one constant time. So this is really amazing solution compared to all the other approaches. This is the most optimal approach. So first of all, we are going to initialize our two variable left and right. Left is going to be 0, right is going to be a height length minus 1. We are also going to initialize a variable total, that is going to be total amount of water that can be stored, and we are going to initialize it to 0. We are also going to have two variables, left max and right max, and left max would be the first element in whatever the height we are given, so height of 0, and right max is going to be the height of last element, so we can say height of right pointer. And now we are going to run our loop. So while left is less than right, first we are going to check for the height difference, and whichever side has the lower height, we are going to work on that side. If left pointer has lesser height, we are going to work on the left side. So we are first of all going to see that do we need to update the left max. We are going to check that whether we are at any valley where we can store some value. So we are going to check that if left max minus whatever the height we are currently at on the left pointer, if that is greater than 0, then we know that we are at a valley and we can store some water over here. So we will update the total amount of rainwater that can be harvested to total plus whatever the height difference we have found over here, which means that left max minus whatever the height we have found over here. And once that is done, we need to update our left pointer to move towards the right side. And if that is not the case, which means that we need to repeat the same process but now on the right side. So first we'll try to see if we need to update the value of right max. if we don't need, and now again we are going to check that are we at the valley on the right side where we can store some rainwater. If this is greater than 0, then we can update the total rainwater. And once that is done, we will need to update the right pointer to move towards left direction. Okay, I think that is it. Once this while loop ends, the total variable should have all the entire result, and we can simply return that, and this should give the total amount of rainwater we can harvest. Let's try to run this code. Okay, seems we made some small mistakes. Seems like our solution is working. Let's try to submit the code. And you can see that our solution works pretty fast compared to a lot of other solutions. That is because we are using the most optimal approach. I'm also going to post this solution in the comments. Also, I have created the solution where we need to use two separate arrays to store the left max variable and right max variable at any single position. And you can check it out, that solution as well, from the comments. Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to do best time to buy and sell stocks lead code problem. This question has a very real life practical application. That is why it is very famous amongst IT companies as an interview question. If we see some of the companies where I want to work at who have already asked this question, there are companies like Amazon, Microsoft, Facebook, Bloomberg, Google, Goldman Sachs, Apple, Uber, Snapchat, Yahoo, ByteDance, DoorDash, eBay, Netflix and Reddit. So that's why I'm paying my utmost attention. I hope you also enjoy the video. So this is the LeetCode easy problem, and you can see that it has been one of the most liked problems on LeetCode. If we try to understand the problem statement, basically we are given an array called prices, where any single value inside this given array indicates the price of that particular stock and on that particular day. Now we want to maximize our profit by choosing a single day to buy the stock and choosing a different day to sell the stock sometime in the future, and our aim is to maximize our profit. So if we try to see it with an example, suppose this is the example that we are given, where we are given 6 different prices for a stock and we are told that we need to maximize the profit. So I have drawn it on a graph over here, so it makes things more easy to understand. And we know that at any given position it shows that what is the price of that particular stock. So initially the stock price on first day was price 7. Now on the second day the price fell down to price 1. So we are not making any profit, we are actually going down and we are losing the money. But if we see over here, so this day it's 1 and this day the price is 5. So if we see over here, between these 2 days we actually made a profit of $4. Again price fell next day to $3, and then again price rise to $6. So over here we lost $2. Over here we again made some gain of $3, and at the end the price was 4. So over here again we lost $2. So the thing is, if we just do it like this, we don't get the maximized profits. Why? Because we are only seeing that what is the difference between every single day. But if we see that if we do something, if we buy the stock on this particular day, which means that we are buying the stock when the stock price is at 1, and if we sell the price when the stock price is at 6, so which means if we sell when the stock price is at 6, we can actually make a profit of $5. This is the answer we need to return, that this is the maximum profit we can make based on these stock prices. So let me show you that what would be the brute force approach, and then I will show you that what would be the optimal approach. So for the brute force approach, One thing we can do is that we take every single position of a buy and sell price for these given stocks, which means that we make every single pair. So first of all, we see that if we buy the stock at price 7 and we sell at price 1, again we sell at price 5, again we sell at price 3, and so on and so forth, what is the maximum profit we are getting, and we will create a variable called profit, and we will keep track that what is the maximum number we have found so far. Once we are done with this value number 7, we would ignore this case, and then again we will repeat the same thing with value number 5. So we start buying, so we start that our buy price is at value number 1, and again we start checking all of the comparisons that what would be the profit, and eventually we would find a pair where buy value is 1 and sell value is actually 6, which means that we would gain profit of $5, and then we will return this as our answer. Like, this solution would work as expected, we will get the desired result. But the thing is, this is not the most optimal approach. Why this is not the most optimal approach? Because if we see the time complexity in this case is actually going to be big O of n square. Why n square? Because for any single entry, we will have to take a look at every single entry in the remaining array, and we will iterate this process. So that is why it is a very time consuming process, and we need to find a way to do something better. And let me quickly show you that what would be the optimal solution in this case. So for the optimal approach, what we are going to do is we are actually going to see that when do we get the maximized profit. We only get the maximized profit when we buy at the lowest value and we sell at the highest value. So this is the logic we are going to apply over here, that we are going to buy the stock at the lowest value and we are going to sell the stock at the highest value. But the thing is, it is not as easy as finding like the maximum value and the minimum value, because in this case maximum value is actually 7 and minimum value is actually 1. We don't need to get the difference of these two values, because if we do that we will get an answer of 6. But the thing is, we are actually dealing with stocks, so we can only buy stocks in the past, which means that if we decide to buy a stock over here, we can only sell it afterwards. We can't sell it to some value in the before. So that's why that is one thing we need to keep track of, that we have to make sure that this linear property of buying and selling is maintained in this case. So what we are going to do is we are going to have a variable called buy, and that is going to keep track of what is the minimum value we have stored so far. And we are going to see that at any given moment, whatever the minimum buy value is, if on that particular day we try to sell a stock, what is the profit we are getting. So let me quickly draw 3 variables over here. So we are going to have 3 variables called buy, sell and profit. Now first of all, we are at this position number 7, which means that we are buying the stock at 7 and we can't do anything about it because we don't have any way to sell it. So we will start with the second position. So now on the second day, the stock price fell down to 1, which means that if we have already bought this stock at value number 7. If we try to sell it at value number 1, it really does not give much progress. But one thing we can do over here is that because today the stock price is actually low, we can reduce that whatever the buying price is from 7 to 1. So we will do that. So now the buy price is actually 1, and we are not selling anything, or we are not doing anything again. Now the next day the price of the stock is 5. So we'll try to do that. Okay, what is the 5 minus 1, which is the minimum price we have bought stock so far, and 5 minus 1 is actually 4, which is the maximum profit we have made so far. And we don't need to update this buy value because we have already bought it at a lower price than whatever the current price of the stock is. Now we will move on to the next value. So next value, the stock price is actually 3, which means 3 is still greater than value number 1, which means we don't need to update this value number 3, but we will have to check that whether we are making any greater profit or not. So again we will do 3 minus whatever this buy value is. The buy value is 1, so 3 minus 1, so the current profit we make is actually 2. But the thing is, 2 is actually less than 4, which means we don't need to update the profit we have made so far. Now again we will ignore this case, we will move on to the next value. So the next value, the stock price is actually at 6, so stock price is now at 6, and now again we will do 6 minus 1. So 6 minus 1, selling price would be actually 5, and because this is 5 and this profit is actually greater than whatever profit we have achieved so far, so the current maximum profit we have made so far is 5. Now again the stock price is at 4, so again the selling price on this day would be 4, and we don't need to update the buying price because the buying price is already at 1, which is lower than 4. And now we will do 4 minus 1. So 4 minus 1, if we do, we still make profit, but this profit is only $3, and $3 is actually less than whatever the maximum profit we have made so far. Now we are at the end of our loop, and now we don't have any more values to iterate over inside the given array, which means whatever the result we have stored inside the maximum profit variable, variable, we will just return that, and in this case we will return answer as 5, and this answer would work perfectly fine. This is like the most desired answer we need. If we see the time and space complexity, in this case the time complexity is actually big O of n. Why big O of n? Because notice that we are completing everything in a single iteration. And in terms of space complexity, for the space complexity we are not actually using any additional space apart from storing couple of variables, so that's why space is also constant. So that's why this is a very good approach. We are solving this in big O of n and big O of n time and big O of 1 space complexity. So first of all, we are going to initialize a variable called min, and we are going to give it the first value of the given prices. We are going to create a variable called profit to note down the maximum profit we can achieve, and initially we are going to mark it as 0, and then we will update the value inside our loop. So now we are going to run a for loop across the given array. Now inside the given loop, first of all we will check that whether we need to update the value of min or not. So we will check that if the current min value is less than whatever the value of I is, then we will update the value of min. And also we will check that whether the current profit we can make by selling the stock on that particular day comparing with the min value, we will choose the maximum profit we can. And once this loop ends, we simply need to return the whatever value we have stored in the profit variable. Let's try to run this code. Okay, seems like our code is working as expected. Let's submit it. And our code is actually pretty efficient. It runs faster than a lot of other solutions, and I would be posting this code in the comments so you can check it out from there. Thank you. Hello friends, we are still not employed by FAANG companies, so let's not stop lead coding till we get there. Today we are going to do longest substring without a repeating character lead code problem, and this is actually number 3 problem in the lead code and also very popular problem. As you can see the number of companies that have already asked this problem. So if I just check the companies where I want to get a job and I have already asked this question, there are companies like Amazon, Microsoft, Facebook, Bloomberg, Apple, Google, Spotify, Uber, Goldman Sachs, Yahoo, Walmart, eBay, Lyft, ByteDance, Morgan Stanley, and Paytm. So that's why I am paying my utmost attention to solve this problem. I hope you also enjoy the video. So this is a LeetCode medium problem and also one of the most liked problems on LeetCode. Basically we are given a string s and we need to find the length of the longest substring without a repeating character inside this given string. So suppose in this example we are given a string like this. And in this case, if we check that what is the longest substring without a repeating character, that is this one ABC, and the length of this is 3. We can also conclude this one as well. This has also length of 3, and we can return either of them, but the answer in this case we are going to return is actually 3. Let's see that what would be the different approaches to solve this problem. So suppose this is the input that we are given, and let's see that how can we solve this in a brute force manner. Well, the most basic idea is that we can take this input and take every single substring that is possible and then check on all of those substrings that whether there are any repeating characters or not, and whichever the substring with the longest length we found without any repeating characters, we will just present it as an answer. So if I just show you by an example, in this case the number of substrings we can make is, okay, let's start from this A. So from this A we can make a substring of A, we can make a substring AB, we can make a substring ABA, we can make a substring ABAT dot dot dot, and so on and so forth. We can make all of these substrings. Next substring we will make starting from this value number B. So from B we can make B, BA, BAT, BATM, and so on and so forth. So in this case the longest substring we would be able to make is actually this one BATM, that is of length 4, and this is the answer in our case. So even if we use the brute force approach, eventually we would have found this substring by comparing all of the bunch of different substrings that we would have created, and then we would have written 4 in this case. But what is the issue with this approach? Well, the issue is actually quite trivial, that we are actually doing a lot of unnecessary work and we are trying to find a lot of different substrings. Even if we just see the time and space complexity in this case, the time complexity is actually going to be big O of n cube. Why n cube? Because we are going to do n square work to find all the substrings, and then we will have to do n work for every single one of them to find that whether they're existing repeating character or not. So this is a really bad approach. Let's see that what is the improvement we can make. To optimally solve this problem, we are going to use very important concept called sliding window, and in addition with two pointer. What we are going to do is we are going to have two pointers called left and right, and these left and right pointers, we are going to have them to follow a very important property, and that property is that between these values of left and right, all the elements has to be unique. If at any moment we encounter that there is a duplicate entry, which means that we will update the value of L to the point where the duplicate entry is mitigated or it's eliminated, and then we will again keep on progressing with this right pointer. Let me quickly show you how we are going to do that. So first of all, left and right both are going to start at the same position. Now we are going to make our right pointer move to the next element until the point where we find a place that is actually repeating. So we are now, our right pointer is at this position, our left pointer is at this position. So far we have two elements in our substring and both are unique. So because both are unique, we are good up until to this point. Also at the same time, we are going to have an answer variable where we are going to store the length of the maximum substring we were able to find with all the unique characters. So far initially this value was 1, but now we have found that there are actually two elements for this substring that has all the unique elements so far. Now we are going to update the value of our right pointer again. So right pointer will come over here. Now again right pointer is here, but at this point, okay, we need to check that, okay, amongst this A and B, does A exist somewhere? And we know that A exists over here. Now you will quickly ask me that, okay, in this case, since we only had two elements and we were comparing this A, it was really easy for us to identify. What if we had like 10 elements like this, and then we are comparing this A, and we need to check that whether at all these 10 positions does this A exist or not, and that would make things really inefficient, and that would be big of n square time complexity. So what we are going to do is we are going to have a visited hash set, and inside this visited hash set we are going to store all the characters we have found so far between L and R, and we are going to keep on adding until the point we find a repeating character. So initially this only had the value A when we are at this point, then we added a B. So far inside our hash set we actually have A and B, and now when this R pointer comes at this position A, first of all we'll check that whether A exists or not, and we realize that, okay, A exists inside this hash set, which means that amongst this substring we cannot add this value A because A exists over here. So now what we are going to do is we are going to remove A from this our set, and we are also going to update our left pointer to remove this value A. So okay, we ignore this A, and now our left pointer is at this position, our right pointer is at this position. So far the values are B and A, and now we are again going to add this value number A over here because this right pointer is here. Okay, what is the length so far? So the length is still 2. So because length is 2, we are not going to update in our answer, because in our answer the length is also 2. Now we are going to update our right pointer to come to the next element, and when we update the right pointer, it comes over here. So this t does not exist inside our hash set, so we will add entry t over here, and our we will update our answer as well. So now our answer becomes 3. Now again we will update our right pointer to come over here. So when the right pointer comes over here, we will have an entry M. So again we will add the value M over here inside our hash set because it does not exist before, and we will also update our answer to be of length 4 so far. Now again we will add our right value over here. So when we add the right pointer over here, and at this moment this is A, so we try to check that whether A exists in our hash set or not, and we can realize that, okay, A exists already. So immediately, because A exists, now we will have to move this left pointer up until the point where we encounter this A. So okay, this B, we can ignore this, and we'll jump our left pointer. Okay, left pointer comes over here, and again this is A. So again we will ignore this, and then we will come for the left pointer to be over here, which means that left pointer is going to be here and right pointer is going to be here. And also at the same time we will have to remove this B and A from our hash set that we were currently visiting. So currently the entries we have is T and M only, and then because this right is at this position number A, so we are going to add an entry for A. Now we are going to update the and so far the length of this one is actually 3, so we don't need to update in our answer. And then again we are going to update the right pointer. So right pointer comes over here, this is N, n does not exist inside the hash set, so we will add an entry called n over here, and then this length is actually 4, so answer is 4, so we don't need to update so far. And then if we do try to do next to this right pointer, we come to the end of the list, and the string is empty now. So because we are done iterating over the entire string, now all we need to do is return whatever the answer we found in this case, and the answer we found in this case is 4, and that would be our final solution. So if we see the time and space complexity in this one, it's actually really efficient. So in terms of time complexity, we are actually completing all of these things in a single iteration, so it's actually big O of n. And in terms of space complexity, we are using this additional hash set to store the value, and the space complexity at any given moment is actually going to be big O of whatever the answer we have, or whatever the longest increasing subsequence we have. Because remember, at any moment we are only having that whatever the maximum number of unique characters in the substring we have. The moment we increase the moment we encounter a repeating character, we are actually getting rid of all of them. So that's why the space complexity is going to be big O of whatever the longest repeating character we have found so far. So first of all, we are going to check couple of edge cases, that if the given string is empty or if it only has one character, then we will return. So now we are going to initialize couple of variables called left and right, and we are going to initialize its value to 0. We are also going to initialize a variable called answer, and by default we are going to have the value as 0, and we are going to initialize a hash set of characters. So first of all, we are going to run a while loop till the point where right reaches to the end of the string. First of all, we are going to initialize a character variable, and to find the value of that particular index. And then we will check that whether this value exists inside our hash set or not. So if the value exists inside our hash set, we are going to remove it from our hash set, and we are also going to update the value of our left pointer. And if the value does not exist, we are going to add it to our hash set, and then we are going to calculate that whether the current answer we have is actually greater than whatever the answer we had before. And we are going to do right minus left plus 1. And at the end we are going to update the right pointer as well, and that should be it. So when both of these loop runs and after it ends, we should have our answer inside the answer variable, so we can simply return that. Now let's try to run this code. Okay, seems like our solution is working as expected. Let's try to submit it. And our code runs as expected. I will be posting this solution inside the comments. Hello friends, we are now employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to do longest repeating character replacement lead code problem that contains very important properties related to string based problems. If we see the companies where I want to get a job and that have already asked this question, there are companies like Google, Amazon, Uber, Adobe, Facebook, Apple, Bloomberg, and Microsoft. So some of the top tier IT companies. So that's why I am paying my utmost attention. I hope you also enjoy the video. So this is a lead code medium problem, and basically we are given a string s and we are given an integer k. Now we are told that inside this given string s, we can replace any character with any other character in the English language, and we can repeat this operation k times. Now after repeating this operation, what is the main purpose of this question is that we need to return the length of the longest substring that contains the same letter by doing this replace activity, and we need to return that length. Okay, so now we will try to understand this problem with this example. So suppose we are given our s is equal to a b a b, and we are told that k is equal to 2, which means we can replace any two character with whatever two characters we want. So in this case we have two options. Either we replace these two b's with value number a, then we will get a string that looks like a, or we can replace these two a's with the letter b, and then we will get a string Our concern is we don't care what is the value of the string. Our aim is to find the longest substring that contains all the repeated character, and we need to find the length of it. In both the cases, the length of these two is actually 4, and this would be the answer we need to return. So this is what the problem is asking us to do. Let's take one more example to make our understanding more clear. So suppose our given s is equal to h. If this is the case, and our given k is equal to 2 again in this case. So now if we see the options we have, we can replace like these two p's with the value h. So that will give us a string like h. And so if we see the longest substring that contains the same letter, the length in this case becomes 5. Second option we have is that we choose any two h value, suppose these two, and we replace it with value number p. If we do that, we will get a substring that looks like this. So in this case, if we see that what is the longest length of the subsequence that contains the same letter, it's actually 4. So this is 4 and this is 5, and we need to return the longest. So that's why this is the most optimal way to approach this problem in this case, where we are going to replace these two p values with the letter h, and we don't do this p operation. So there are few ways to solve this problem, and there is also a brute force way to solve this problem. So first I'll show you the brute force way, and then we will see that what would be the optimized approach. First of all, we identify that what is the thing that we want to find. We want to find a substring, and then we want to replace the characters, and then we want to find a substring that contains the longest length with the same characters, right? So first approach we can take in the brute force is that we take every single substring that is possible. So even if we just see that substrings that starts at a, we will get substrings like a b, a b a, and a b, something like this. Again, if we see substring that starts with b, we will get b a, and so on and so forth. So we would end up with bunch of different substrings. Then we will start this replace operation on all the substrings, and eventually we would find some substring that will look like this a, or this b, and in any case we would be able to return the length as 4. Like, okay, this solution would work and we will get the desired result, but there are a lot of issues with that. Even if we just see that for a single character, we end up with like so many substrings, and we still have more substrings to go to. So this is a very inefficient approach, and we should avoid doing it at all costs. Okay, before we come up with the optimal solution, first of all, we will have to identify that what is our need. Our need in this case is that we are given this string, and we are told that we can replace any two characters inside this given string with any other characters because k is equal to 2. Now we need to find a substring where all the characters contains the same value, and because they contains the same value, we need to return the length of it. So first of all, we will have to identify that what is the substring where we can actually create all the characters of the same length. So first of all, let's see that can we apply this thing on this whole substring for this entire string of all the 5 characters, and this given k is equal to 2. So first of all, we will try to identify that what is the number of occurrences of every single character. So a occurs 2 times, b occurs once, c occurs once, and d also occurs once. So which means that because a occurs most of the time, our logical or rational conclusion is to create a substring where all the characters are a, because in that case we will actually have one additional character. If we try to create all the characters with value b, c, or d, obviously we are always going to fall short by one character, because the value of a actually appears twice, which means these 3 things, they have less significance compared to this a, because a is the most repeating character. And why I'm putting so much emphasis on most repeating character, because this along with this k and the length of the string or substring defines that whether any substring we can convert it to all the repeating characters or not. Let me show you how. Suppose in this case we consider all these 5 characters. Even if we replace any 2 characters, in this case we have 3 characters to replace from. If we replace any 2 characters, no matter what happens, we won't be able to create a substring where all the 5 values are actually a. Why? Because we only have the option to replace 2 elements, and there are 3 different elements that contains different values. So how we come up with this value that there are 3 different elements that contains different value than a? Well, what we did was we took the length. So length in this case for this substring is 5. So we took the length of this substring minus, we subtracted the most occurred character. So most occurred character in this case is a. So length 5 minus a 2, and this we get 3. So at any case, this value, if that is greater than or equal to this value number k, which means that this particular substring, we cannot do anything about it. We cannot convert into a valid or legitimate substring where all the values contains the same character. But if we just shorten our search, if we try to search in these 4 characters, okay, now what is the breakdown of the number of occurrences of every single character? Well, a still occurs twice, b occurs once, c occurs once, but d is not appearing, so we ignore this one. Now in this case, the length of this is equal actually 4, which means that if we apply the same formula, that length minus whatever the maximum occurred value, so maximum occurred value is still a, which means that we do 4 minus 2. So 4 minus 2 is 2, and this 2 is actually equal to whatever the value of k is. Because this is equal to k, and in this case we can define that for this particular substring we can actually convert it to all the characters being same by using this replace function. And if we just replace this value b and c, we will get actually a substring that is all the a's, and this is the answer. So basically this is the critical part. Now remember that in order to generate this, what are the things we needed? We actually needed that what is the current length of the subsequence that we are following, or what is the length of the substring that we are doing. We actually need to know that what is the maximum occurrence of any particular character in any given subsequence. And we also needed that what is the value of k. Based on it, we were able to identify that whether any subsequence can it be converted to having all the characters to have the same value or not. And based on this concept, so formula we can create is that a valid subsequence is a subsequence where the length of the subsequence minus the most occurred character. If this one is actually less than or equal to whatever the value of k is, if this is true, then we can say that this is a valid substring, and the length, whatever the length of this particular substring is, that is also the length of the substring which contains the most repeated characters. Let's see it with an example. Okay, suppose this is the example that we are given and we want to solve this one. First of all, we are going to see that what is the formula that we have to use. Well, the formula we have to use is that for any subsequent to be valid, what we are going to do is we are going to do length minus whatever the max occurrence in that particular subsequence, and we will see that if that value, if that is less than or equal to k, if that is less than or equal to k, whatever the length is, we can treat it as our answer, and whatever the maximum answer we find so far, we will conclude it as our solution. We already know this formula. Now we need to see that how can we implement that. Basically, we are going to use a sliding window plus 2-pointer solution. And inside this solution, what we are going to do is we are going to have two variables called left and right to be initialized at the first position. We are going to update the right value to the next element. Then we will check that whether the substring is valid or not. If the substring is valid, we will calculate that what is the answer. We will update the answer. Again, we will move the right value, and again we will move the right value. Again, we will move the right value until the point when the substring is not valid. The moment the substring is not valid, we can conclude that now we need to shrink our substring. So basically, suppose the r is now at this position, we will have to update the value of left. So we will ignore this element and we will move our left value over here, and then subsequently we will keep moving on, and every single time we will keep track that what is the maximum answer we have found so far, which is the longest repeated character substring, the length of it. And whenever the r reaches at the end of the list or at the end of this string, we can conclude that whatever the value we have stored in the answer, we can return it as the answer. So now, because we are using this 2-pointer approach, we know that at any given moment, what are the things we need? Well, we need a couple of things. First thing we need is we need this length. So length we can identify based on the difference between this left pointer and right pointer. That gives us the length of the current substring. Now we need to know that what is the maximum occurrence at any given moment of any particular element. So we don't know that, right? So what we can do is we can actually create an array of size 26. So one for every single character in the English language, because we know that there are only 26 characters. and whenever we find any value on the right side, we will add that value to our array, or if we move any character on the left side, we will reduce that value from our array. So at any given moment, we would always know that what is the maximum value we have at any given position. And let's see by an example that how we will complete this operation. So let me quickly show you an example that how we will iterate over for this given example. Let me clean this up a bit. Okay, so initially our left value and right value are located at these two positions. We are also going to have an array to store the maximum occurrence of any single element. So currently I'm just showing you the elements that are coming in, but that is the idea that we will keep in mind. So first of all, currently the value is p. So we will add p over here, and we will notice that okay, the occurrence of p is one time. Just this is for understanding purposes. When we do the code, it would be slightly different, and I will explain it to you when we would be coding. Now so far this list has to be valid because there is only one character, right? Now we will update the value for r. So this is x, and x is also present one times. Now we will see, so current length of this string, so now r is located over here. Okay, so current length is actually 2. And what is the k value? K value is also 2 because that is constant, so that won't change. And what is the maximum occurrence of any character so far? So maximum occurrence is still 1, as we can see over here. So maximum occurrence is 1. So if we apply this formula, 2 minus 1, so 2 minus 1 is actually 1, and 1 is less than or equal to value of k, so that is true. So because this is true, we can say that the length of at least 2 characters can be part of the answer. So we will mention that in the answer. Now again we will update the value of r. So now r comes over here. Because r comes over here, we will update the value of q over here, and we know that it occurs one time again. So the length, so the current length is actually 3, and the maximum character is still 1. So we will do 3 minus 1. So 3 minus 1 is again 2. 2 is still less than or equal to value of k. So this is also true. Because this is true, the current length can be part of the answer. So we will update our answer to have the value 3. Now we will again update the value of our r. So now r will go over here, and this is x. So for x value, we already have 1 as its occurrence. Now x has the occurrence 2 times. So we will update the occurrence of maximum number over here called 2 times. The length also increases, so length will become 4. Now again we will try to see that what happens with our equation. So we will do 4 minus 2. So 4 minus 2, this is 2. 2 is still less than or equal to k, which is 2, which means that we can update the answer to the value 4. We will update the answer to be 4. Now again we will update the value of our r. Now r moves one value to the right. Now this is y. Y is occurring 1 times. Now the current length is 5, and the maximum value we have is x, which is 2. So far we are good. Now we will try to do 5 minus 2. So 5 minus 2 is actually 3, which is greater than k, which means that this condition is not satisfied. So because this condition is not satisfied, what we need to do is we need to update the left element. So we will update the left element over here. So now left comes at this place, but because we are updating the left element, we will also have to remove this 1p over here. So we will remove p from here, and now we will update the value. So now length will become 4. Again maximum occurrence is still 2, so 4 minus 2, that is 2. 2 is still less than or equal to k, which is good. So far we are good. Now again we will update the value of our r. So now r comes at this place. Because r comes at this place, the occurrence of x comes to 3. Now because this comes to 3, we will update the value of maximum occurrence to be 3, and we will update the length to be 5. Now we'll do 5 minus 3. 5 minus 3 is 2. 2 is still less than or equal to k. So because 2 is still less than or equal to k, we can update our answer as well to the whatever length we have found, which is 5. So we will update our answer to be 5. Now again we will update the value of our r. R comes over here. Now this is a we don't have any entry, so we will add an entry for a, and we will call it as 1. Now in this case the length is 6. Length is 6, but maximum number of occurrence of x is still 3, which means that now we can do is 6 minus 3. So if we do 6 minus 3, 6 minus 3 is equal to 3. 3x is actually greater than k, which means this condition is not satisfied. So now we will have to update the value of our L over here. So now we will get rid of 1x. So because we are getting rid of 1x, the current maximum occurrence we have so far is 2. Okay, now our left is located at this position. Now the length is 5, and the maximum we can make, maximum occurrence is 2. So again 5 minus 2 is still 3, which is greater than k. So again we will have to update the value of our left. So now this time left comes over here and we will ignore this q, which means the value of q becomes 0. So I'll just remove that entry. Now again this time the length is actually 4 and the maximum occurrence is 2. So 4 minus 2 is still 2, which is actually less than or equal to k. So because this is less than or equal to k, we know that okay, length 4 is can be our answer, but our answer is already 5. So there is no point in updating length to be 4. Okay. Next what we are going to do is, now this time we will have to update the value r. So when we update the value r, we actually reach to the end of the string, and because we reach to the end of the string, whatever the value we have stored in the answer, we can return it as our answer. So in this case the answer is going to be 5 from this sequence, and we can mention that after doing 2-word replacement, the maximum substring we can make that contains all the same characters inside this given original string is actually of length 5, and that is the solution. If we see the time and space complexity for this one, the time complexity will actually be big O of n, where n is the number of characters that are present inside given s. Now you will think that okay, in order for us to find the maximum occurrence, actually we will have to iterate over this entire array, and it might take like there are 26 entries, so we might have to do this work 26 times. But the thing is, we are actually going to use a clever trick over here. What we are going to do is, at any moment we update our right pointer, at that moment only we are going to update our maximum occurrence, because remember, our maximum occurrence can only increase when we update the value of our right. Whenever we update the value of our left, we essentially decrease the whatever the maximum count we have, which means that our maximum count is never gonna go high. So that's why by using this clever trick, we can actually reduce the time complexity to big O of 26 times n to only big O of n, and you will see it in the coding. Also in terms of space complexity, we can conclude this actually 2 times. We can either conclude this to be big O of 26 because we are storing an array of 26 characters, or we can consider this as big O of 1 or constant space, because this 26 is a finite number. This is not an infinite number. So that is why depends on your interviewer how he wants to treat it, and that way you can take it forward. Now let's move on towards coding now. First of all, we are going to create an integer array to store the occurrences, and we are going to name it as occurrence. Now we will create few variables. So first of all, we will create variable left and right, and we will initialize it to value number 0. Now we will create a variable called answer, and we will initialize it to 0 as well. Also we will initialize a variable called maximum occurrence. Now we will run a for loop on all the characters of given string. So first of all, we will calculate that whether we need to update the maximum occurrence or not. So now we will check that whether the current substring, if that is valid substring or not. So we are going to use an if condition. First of all, we are going to check that whether the length, so in this case length is going to be right minus left plus 1. So if the length minus whatever the maximum occurrence is, if that is greater than k, which means that if that is greater than k, which means that the current substring is not valid. If that is not valid, we will have to update the value of left variable, and we will also have to decrement the value that is located at current left counter on the given string. Once that is done, for every single update, we will have to check that whether our answer is the longest string or not. So we will check that what is the value of our answer. That should be it. So after this loop ends, basically we should have our answer stored in the answer variable, so we can simply return that. Let's try to run this code. This should have an occurrence. Okay, seems like our solution is working as expected. Let's submit this code. Oh, our solution is not working. Oh, we need to decrement the value first before we update this left pointer. So let's try to run the code again. Okay, let's submit it again. Seems like our solution is working as expected. So friends, hope you are having a fantastic day today. So once again, we are going to do an awesome LeetCode problem that has been asked at tons of companies. So without any delay, let's get started. So the LeetCode problem we are going to solve is called permutations in a string, and we can see that this is a LeetCode medium problem and also extremely well-liked problem on LeetCode. The problem statement is very straightforward, that we are given two strings s1 and s2. Now we need to check that if any of the permutation of s1 is present inside the s2 string, then we need to return true. If that is not the case, we need to return false. Now let's try to see this with an example. Say for an example, we are given s1 is equal to value a and b, and we are given a string s2. Now there can be two permutations and combinations of a and b. It's a and b itself or either b and a. Now we can see that in this string s2, ba is actually present. So because it is present, we can actually return this as true, saying that a permutation of ab or string 1 is actually present inside the string 2. Now let's take one more example. In this case, we have ba as partial permutation of this string 1, but we does not have anything like c, or we have, in this case, we have ac, but there is an x in between. So we do not have any direct permutation of string 1 present inside the string 2. So in this case, we can return false. Now, even though we have a, b and c, all three present inside the string 2, but they are not present together. So that is the main problem. So now let's see that how can we actually solve this problem. And the number one approach is very simple, brute force approach. So for the brute force approach, what we can do is we can take string 1, suppose the values are a, b, c, and then we can take string 2, suppose the given values are once again b, a, x, c, d, z, something like this. So we can take every single possible permutations of s1, and then we can check that whether those are in any given moment present inside the string 2 or not. So this is going to be very inefficient approach. So we need to do something better. Now the question is, in any given case, suppose the string 1 is abc, then what are the different permutations and combinations possible? In either case, you can notice that instead of keeping track of all of these permutations and combinations, we can say that currently for the string 1, we actually have 3 different characters, and the frequency of each of these 3 characters is actually 1 time. So we have a present 1 time, b present 1 time, and c present 1 time. So at any given moment inside the string 2, if we identify that, suppose string 2 is, let's say that x, b, a, c, d, z, something like this. And if we identify that amongst any given moment, we can identify these 3 occurring in any subsequence in the same amount of frequency. So I'm not talking about order, that A has to come before B has to come before C. I'm talking about the frequency, that at any given moment we want to check that whether all 3 A, B and C are present in the same number of occurrences, which we can see over here, that if we take a look at this portion, we can actually see that we can also make another frequency map that contains once again characters A, B and C, and each occur 1 time. So because there is a match in this regard, we can actually say that this string 1 is actually present inside the string 2 as one of the permutations or combinations. So this is the approach we are going to use. Now, in order to use this approach, we actually need 2 things. Number 1 item we need is that we need a way to create a frequency map to contain that how many times any single character is present inside the given string 1. Then we need to create the window of that exact same size and then iterate over every single possible windows of the string 2. And once we do that, all we need to do is just compare 2 different frequency maps. So what are the efficient ways for us to compare frequency maps and create frequency maps? Well, there are actually 2 ways. So number 1 way is that we can actually use a hash map, because in the hash map we know that it is a key value based pair data structure. So as a key, we can set up the character, and as its subsequent value, we can set up the frequency. So once we have the hash map or frequency map for string 1, we can do that. And same way, the existing window we have for string 2, we can actually create a very similar frequency map for the string 2 as well. So that is option number 1. The option number 2 is that we actually create an array with 26 characters, and we create two arrays. So one array is for string 1, one array is for string 2 for that specific window. And let's assume that in string 1 the value is ABC. So we can mark ABC as 111, and for rest of the characters we can mark them as 0. And this can be also an efficient way for us to check that what is the frequency and how many times it is present. So same way for S2 we can also create an array. So both ways would yield the same space complexity. So what I'm going to do is in the example I will explain it to you using hash map, but in the code we will use the array method. Okay. Now let's try to understand the approach I'm suggesting using couple of examples. So suppose we are given our string map is equal to value ABA, and we are given our string 2 as the values A, B, C, D, E, F, E, X, then A, B, something like this. Okay. Now we know that what is the approach we are going to do. For string 1 we will have to create a hash map. So let's quickly create a hash map. The idea is that string 1 hash map is going to look very simple, that it only contains 3 characters that are A and only 2 characters A and B. Now A is present 2 times and B is present 1 time. Now we have the hash map for string 1. Now for the string 2, what we are going to do is that we are going to create an exact same size window, and then we are going to keep sliding that window over from left to right. And using that approach we would be able to solve this problem very easily. So let me tell you what we are trying to do. So initially this string 2 does not have a hash map. So let's create a frequency map for string 2 as well. Okay. And I'm marking 3 values. So now let's see. Okay. Currently this one does not have anything. So we are going to consider these 3 values as our first window. Now we are going to create a frequency map. And the idea is that we can keep on comparing the 2 frequency maps, or if you don't want to create 2 maps, you can actually start deducting values as well. But in either case, you will have to remember that what was the original state. Okay. So that's why for our simplicity, I'm creating 2 maps. So now for this A, we have this A and it is occurring once. Once again, we have this B, it is also occurring once. And then once we have C, that is also occurring once. But if we compare these two, then we can see that A and B is partially there, but C should not be there, and we are still missing one A. Okay, so in this case, this is not the correct approach. So now we will have to migrate our window one step forward, which means previously we were considering this ABC. So now we will get rid of this A and we will treat as if this A is currently no longer needed. And now we are going to be dealing with this particular window. Now the thing is, when we are dealing with this window, the question is, do we need to create another same window for this new portion? The answer is no. We can actually do something very simple. The idea is that whatever the value was present over here, we can actually get rid of that value because we are moving to the next step inside our sliding window. And then whatever the new value is, we can simply add that new value to the hash map. So now we are going to get rid of A, and we are going to add one other value D, and we are going to mark its frequency. So D is also present once. But once again, this window also does not yield us the correct result, and these two are still not equal. Okay, so now we will have to consider this window. So once again, we will keep on repeating the same process. We will get rid of B. Once again, we will get rid of B. We will include value E again. So now E is present one time, but also this window does not work as well. So now we are also going to get rid of this value number C. Now C is no longer present. But now we are going to include value number X. So X is present one times, but once again, this is also not correct. So we will get rid of D, and we will have this window to consider. So now we are going to get rid of D, and we are once again going to add value number A one times. Now, once again, this is not the correct approach. So we will once again get rid of value number value number E, and the new value is A. So because new value is A is already present, which means we do not have to add A again. So we can just increase the value of A second time. Now, currently we are considering this window, but this is also not the correct window. So we will also get rid of this one. We will kick X out, and then we will add value number B. So adding value number B would allow us to add one more value B inside over here. And now this is our final window. But in the final window, we can see that both string 1 hash map and string 2 hash map are same. The frequency of character occurring is exactly same. which means we have found our optimal solution, and we can say that currently one of the permutation of string 1 is actually present inside string 2. So we can return true as the answer in this case. And in case, say for an example, this one was not B and this one was something else like character D. So the moment we reach to this value and we have a string that looks like D1, something like this, then there is no longer a window possible for us to move forward, which means we have exhausted every single possibility in string 2. Still, we did not find the same set of frequency of character present inside the string 1, which means we can simply return false in that case. And this is the whole approach. So this would be the optimal solution. If we see time and space complexity in this case, the time complexity is very simple. It's going to be big O of n, because number one, in order to create this hash map, it takes us big O of n time. And then using a sliding window, we simply have to iterate over this given array. So this is also big O of n. In terms of space complexity, so this can be big O of 1. Why? Because we know that there are only 26 characters inside the alphabet. We are not dealing with any special characters or any extra elements, which means there is only a finite number of characters we can store inside our hash map or frequency maps. So that's why space complexity is going to be 1. So this is a very good time and space complexity, which yields us very good results. So now let's quickly see the coding solution for this one. So first of all, we are going to check that if the given string 1 is actually greater than string 2, which means we can directly return false. If that is not the case, we are going to initialize two arrays with the size 26, which we are going to use as frequency maps. Then we are going to initialize the frequency map for the string 1 and also for the first window of string 2. And the first window of string 2 is going to be the length of a string 1. Okay. Then we simply have to slide the window through S2 and compare it with the frequency map of string 1. If both match, then we can simply return true. If that does not match, we are going to keep on updating the window of the given string, which means we are going to drop off the left side of the element and we are going to add the right side of the element. And then we can once again keep on repeating the same process until the very last window. If we do find that there is a match, then we can simply return true. At any given moment, we find that we are able to reach to the very end, then we can simply return false. And we are creating a helper function to compare the frequency of two maps, which is going to be just running for loops across both the arrays and check that at any given moment, whether the frequency is deviating away from a single character or not. And then we can simply break out of that loop. Okay, so let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs extremely fast in terms of time complexity and also very efficiently in terms of space complexity. So you can find this code in our GitHub repository and the link is in the description. Thank you.
Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to do minimum window substring problem. And if we see some of the companies where I want to get a job, there are companies like Facebook, Amazon, LinkedIn, Microsoft, Lyft, Airbnb, Apple, Adobe, Google, Snapchat, Flipkart, ByteDance, Spotify, TikTok, Bloomberg, Uber, Pinterest, and Goldman Sachs, who have already asked this question. So that's why I'm paying my utmost attention. I hope you also enjoy the video. So this is a LeetCode hard problem, but it is also a very well liked hard problem. Basically, we are given two strings called S and T, and we are given the lengths M and N respectively for each S and T strings. Now we need to return the minimum window substring of given string S such that every character in T, including all the duplicates, that is the key part, is included in the window that we have created from this S. And if there is no such window, then we need to return the empty string. So if we try to understand this with an example, if we take this example, for instance, we are given a string S that looks like this, and we are given a T that looks like this. Now we need to return a substring in this given S such that this A, B, C is present. Now we don't care about the order of this A, B, C. They can be in any order in the new substring that we are trying to create, but we need to return the smallest substring. So if we see one of the substrings that where this a, b, c is present, we can find a substring that looks like this. If we see this particular substring for an instance, we can see character a, b and c is being presented. But the thing is, the question is this the minimum window substring? No, this is not the minimum window substring. Why? Because there exists actually a smaller substring where a, b, c is also present, and we can take one more substring that looks like this. So this substring is smaller than this first one, where also A, B and C is also present, though they are in different order. But this is again not the minimum substring. There is actually a substring which is B, A and C, where all the values of A, B, C is present. That is continuous substring of this S, and this is the minimum substring where we can find all the characters that are present in T, and we need to return this as an answer. If we see couple of more examples over here, suppose we are given S is equal to A and T also equal to A, we can simply return A as the substring because that is the only substring we can create. Now if we are given S is equal to A and T is equal to double A, which means that there is no way possible for us to create double A from this single A. So in this case we need to return an empty string. So now since we have understood the problem, let's see that what would be the different approaches to solve this problem. So first of all, I'll show you the brute force approach, and if you directly want to check that what is the optimal solution, I have already provided the timestamp, so you can directly jump onto the optimal solution as well. Okay, suppose this is the S and this is the T we are given. We are looking for a substring inside this given S which contains all the letters of this T, and we need to find the minimum length substring for that. Now we can clearly see that there is one substring HBPO which contains all of the elements that are present in T, but the smallest substring we need is actually OBH, which contains all the elements of this T, and that contains the smallest length. The brute force way to solve this problem is that we actually start creating every single possible substring out of this given string S. So we can create substrings like, we will check that okay, this can be a potential answer, we will put it as a potential answer and we will mark its length. Now eventually we would find a substring that looks like this OBH, that is the correct answer, and then we would return this answer as our solution. So this solution will also guarantee to provide us the right answer, but this right answer is actually very costly. Why very costly? Because we know that it takes big O of n square to actually create all the substrings, and for every single substring we will have to check that whether it contains all the elements of T or not, which means we will have to multiply this by the whatever the length of T is, which is let's say m in this case, which means that we are actually essentially doing big O of n cube work to solve this problem, which is very expensive. Okay, suppose this is the example that we are given, and we are trying to find that what is the minimum substring inside this given S where all the characters of this T is present. So to optimally solve this problem, we are actually going to use sliding window technique with 2 pointers. So now I have presented the input in a slightly different format, and I have also created that what is the answer we are going to store, because remember in the answer we need to return that what is the minimum substring, and for any minimum substring we need the left pointer and right pointer value, and we also need the length, and we will only choose the minimum length. Now initially we are going to have our left and right both pointers starting at the first position, and now what we will have to check is that we are going to have our right pointer go on the right side until the point where we create a substring where all of these A, B and C are present. The moment we do that, we will note down that what is the answer we have found so far, what is the minimum length, what is the left pointer, what is the right pointer. Once we do that, we will start updating the value of the left pointer to go on the right side until the point when this condition is no longer true and we are not able to make ABC in the given left and right string, and again we will update the process on our right portion, and then again we will try to see that whether we can find a better substring or not. So let's see this approach in action. So now to achieve this approach, what we are going to need is that we already have our 2 pointers left and right over here. Now we need to check that at any given substring whether this T is present or not. So if we for every single substring try to check that whether all of the characters of T is present or not, it takes a lot of time. One quick way to do it is that we actually create a hash map for all the characters that are present inside this value number T, and inside the hash map we note that what is the elements and what are the number of occurrences they have. So in this case, for this T hash map, we actually have 3 characters only, and we have one occurrence of each of them. So we are going to note it somewhere so it becomes easier for us to record. Now at the same time, for any substring that we create, we will also have to check that whether we have all the satisfied words inside our substring or not. So again, we are going to create a hash map for our substring that we are creating as well, and inside the substring hash map we are going to keep on adding the values as we move forward. Now to check hash map every single time is not a very good approach. A better approach in this case could be that we already know that what are the number of unique characters we need inside this hash map. So why don't we just create two variables called the number of unique characters. So we just name it as unique that are present inside this t hash map from this given original input, and whatever the substring inside the substring, whatever the unique characters that we have already been able to create. So let's just say that this name is create, and we will keep track of it, right? I'll just show you that how we are doing everything when we keep moving forward on the with our example. So initially left and r both are at this position, and currently we will note that okay, a is not present inside our given substring, so we will add an entry for a, and so far we have received one occurrence so far, right? Now originally this t hash map had 3 unique characters, so we are going to note that there are 3 unique characters that we have to find in any given substring. And so far, because this current right position is at a, we have already found one of the characters of the required occurrence, right? So we will note down that okay, we have already received one of the characters. Now our right pointer is going to the next element because we haven't satisfied our full condition. So now we identify that okay, this value is actually b, so we are going to add an entry over here inside our substring hash map, and we are going to say that we have found one occurrence of b, and this one occurrence of b is already also required inside this given hash map as well. So we can note down that okay, out of this 3 required, we have actually found 2 unique characters that are needed, right? We are good so far. Now next thing we are going to do is that again over here we are going to update the value for right pointer. We encounter that this value is actually a, so we are going to add one more entry to our required pointer. So over here we have found 2 occurrences of a, but that does not solve our problem because our unique and create are still not same. So now we are going to update the value of our r again. So now again r is at this position, x is not present over here, so we will add an entry for x is equal to 1, but this x is actually not present in this t hash map, so we can't do anything about it. Now again we will going to update our value of r. So r is at this position. Now because r is at this position, remember that this is the value of c is actually 1, c was the remaining value inside this t hash map. Now we have 3 unique characters that were needed, and we have already created 3 unique characters inside this given hash map. So now we are going to treat this substring as our answer, because remember we needed to have the values a, b, c, and a, b, c are actually present over here. This is a, this is b, and this is c inside this given left to right substring. So we have found one potential answer. So first of all we are going to check that okay, what is the length of this one. So length in this case is 0, 1, 2, 3, 4. So length is actually 5, and the left pointer is at 0 position and right pointer is at 4 position, and we are able to add this entry to our answer because we don't have anything before. So that's why we were able to add an entry to our answer. Now we are going to update our left pointer until to the point when this condition is no longer true. So now because previous value of left pointer was over here, and now we jump to this place. So now left pointer is at here, but the moment we updated the left pointer, we will also have to remove the value of our reduce the value inside our substring hash map. So now a there is only one occurrence of a. So far this condition is already true because both this 3 and 3 is matching, right? Now again we are going to update the value of our left pointer to one more character. So now left pointer is over here. Now this b is actually 0, so we are going to remove the entry for b. Now because we remove the entry for b, we have only created 2 elements that are needed inside this substring from this position 2 to position 4, which is a and c. We don't have b entry, which means now we will have to update the value for right pointer until we find the b. Now lucky for us, b is actually very next to this right pointer. So now right pointer is over here and b is actually over here. So b is 1, we will add an entry over here, and now we have already created all of 3 elements needed rather than 2, and we are done with this case, right? So which means we can say that this new substring is also a potential answer. And let's see that whether this substring is actually better than our previous answer or no. How can we determine that? Remember, the aim of this question is to find the minimum length of the substring. So we are going to compare the length of this one. So length of this one is actually 4, and the current answer we had was actually of length 5, which means it is in our interest to update the length over here. And the moment we update the length, we will also have to update the left and right pointer over here. So left pointer currently is at 2 position and right pointer is at currently at 5 position. Now we have found a potentially better answer. Now again we are going to update our left value because we have already found the answer. So now left comes over here, which means we will have to reduce this value of a. So again we are going to reduce the value of a. So a is now 0, so there are no occurrences of a. Because there are no occurrences of a in this new substring, we have only created 2 elements out of this 3 unique characters that we are needed, and which we can see in this particular substring from this position number 3 to position number 5, that we only have c and b, we don't have a. Now we are going to update the value for right pointer. Now again when we update the value for right pointer, lucky for us, we are actually able to find one a. So we will add an entry inside our substring hash set that okay, now we have found one character. Now we can say that we have created all 3 characters that were needed. Now this is also potentially a new substring, and can this be a better answer? So we'll check. Okay, in our length we already have an answer of 4 inside our answer array that we have stored, and this is also an size of 4. So which means that there is no point in updating our answer. We already have the same answer with the same length. So we are going to go to the next case. So now again we increase our value of left. So now left is again at this position. So we will have to ignore this x because we already got rid of it, which means that we have already traveled all the values so far. And now we are at CBA. Now CBA, again this is all of these 3 elements that were needed, and we already have that, which means that this is also potentially a better substring that we have found, and the length of this is actually 3. So because the length of this is 3, this can be a better answer. So we will note it down. So this is 3. Now left pointer value is 4 and right pointer value is 6. So we have found a potentially better answer. Since we have already found an answer and we know that this is a valid substring, now we will have to update the value for left pointer. So once we update the value for left pointer, we are actually going to ignore the c. So now we get rid of the c inside our hash set. Now we also get rid of this l, and now we have taken care of all of these elements so far. Now that we only have BA, which means we only have 2 elements out of 3 that we needed. Now again we will have to update the value for right pointer. So again we update the value of our right pointer over here. We find that okay, this value is actually c occurrence is 1, which means we have created this element actually 3. All of this is successful. Now we check that okay, length of this is actually 3. We already have an answer of length 3, which means there is no point in updating that. Now we will update the value for left pointer. We will ignore this b. So if we ignore this b, now we only have 2 elements out of 3 needed. So because we have 2 needed, we will have to update the right pointer. So now when we update the right pointer, we are actually going to be at the end of our string, and because we are at the end of our string, we can actually break out of the loop. And the moment we break out of the loop, which means that whatever the value we have stored inside the answer, we have the left pointer, we have the right pointer. So all we need to do is we need to return the substring. So if we return the substring in this case, we will have to return the substring that looks like this. So the answer in this case is actually going to be CBA, which is the minimum substring that we can achieve that contains all the elements of the T that are present over here. And remember, over here we are using hash map and substring hash map to find the answer. In order to make our lives easier, we have created 2 elements to know that what are the unique characters that we need to compare. In case, because this was a string and we know that there can be only a finite number of unique characters, which is 26, we were able to use this technique. But your interviewer is for sure going to ask you that rather than having a string and having finite number of unique characters, you are actually going to have millions of hash code characters or something like that. In that case, you will not use this technique, and you will actually just simply have to check over the hash map for every single substring that you are going to make. So this is one of the approach where we can find the optimal solution, and it works as expected. If we see the time complexity is actually going to be go of whatever the length of string is plus whatever the length of t is. And why we are able to achieve this time and space complexity? Because we are using this technique. So that makes our lives a little bit easier. If we see the space complexity is also going to be actually big O of the whatever the size of s is plus whatever the size of t is, and this also works because we are creating 2 additional hash maps and we need to take care of that space into account. But overall, this is still much bigger improvement in compared to our brute force approach. Now there is one more approach to solve this problem. that whatever the input that is already given, first of all, whatever we create the same hash map we create for this element number t, which means that we actually use the same hash map that I have drawn over here to compare all the values of t. But for this value number s, actually remember that we only need to find the substring of characters that are present in t. But so if that is the requirement, why do we even bother checking this element x or any other element that is not one of these values? So a better way to solve this problem is to create another hash map where we ignore this x and we only keep character inside this given string that are also present in the inside this given t. And in this particular hash map we also identify that what is the index value for every single element. So in this case we will determine that okay, this a is actually present at 0th position, then again we have a b that is present at first position, again we will mention that there is an a that is present at second position, and so on and so forth, and then it will make our lives a little bit easier and we can solve this problem. But I don't think in an interview, even if you show this approach, they are going to completely reject your suggestion. So that is why I am choosing this one. Let me know in the comments if you want me to solve the other approach as well, where we are only going to use the unique characters that are also present inside this given t. So first of all, we are going to check some edge cases if the given string is empty or if the length of the given t is actually greater than length of s. If that is the case, we can simply return as empty string. Now if that is not the case, we will create a hash map to store the value of this t string inside the hash map for all of its characters. We are going to name it as map t. Now we are going to run a for loop across this given string t, and we are going to add all the entries to our map t. After the loop ends, we are going to create a variable called required that gives us the number of unique characters that are present inside our given map t hash map. Now we are going to initialize bunch of different variables to keep track of different things. So first of all, we are going to initialize variable called left and right to keep track of our 2 pointers. Once that is done, we will create a variable called create that defines that what are the number of variables that we have created so far that are also present inside the given t. And we are going to initialize an integer array to store the value of answer, and we are going to initialize the first value as -1 inside the answer, where we are going to keep track of the length of current substring, and we are going to have 2 more entries to store the value of left and right pointer, and we are going to initialize those values as 0 as well. We will also create a hash map to keep track of all the values that we have found so far inside the current substring. And now we are going to run our while loop across the string s, and we are going to run it until the right pointer reaches to the end of the string. So inside our loop, first of all, we are going to add an entry to our hash map for any particular given substring. After adding a value to our substring, now we will check that whether all the elements we have added in the substring is that element also present inside our map t as well. If that is the case, we can increment the value of number of characters that we have created in our substring that are also required inside our map t as well. So if this condition is true, we will update the value of our create variable. Now after updating that, we will also have to check that whether the current substring, if that is valid or not, and by valid I mean that whether the required and create has the same value. If that is the case, we will have to update the left pointer and we will have to shrink our size. Also we will have to add entries to our answer array as well. So we are going to run another while loop that while left is less than or equal to right, and the required is and created are same. We are going to check that whether we need to update our answer or not, and we are also going to update the value of the character c variable to help us in doing a lot of other things, and we are going to assign it the value of the current left pointer. Now we check if we need to update the answer. Okay, after updating the answer value, we will also have to remove the entry from our substring map because we are updating the left pointer. And after removing the entry, again we will have to check that whether the value of our entry that we just removed, did it caused us to reduce our create variable, which means that have we removed any entry which was also present inside our map t hash map as well, which was required for us. If that is the case, we will have to reduce the value of our create variable, and it could make us break out of this loop as well. In any case, we will have to update the left pointer, so we'll update the value of left pointer. And after that is done, we are done with the inner loop. In the outer loop, we will have to update the value of right pointer, and that's it. So basically, after this loop ends, essentially we would have taken care of all the scenarios that are needed for this loop, and now we will work on returning the answer. So for the answer, we will have to check that if the value of answer of 0 is equal to -1, which means that we are not able to find any value that were suitable to create as a valid substring. If that is the case, we will return an empty string. If that is not the case, we will return the value inside our answer array for this left and right pointer value, which means answer of 1 and answer of 2. But we will have to do right plus 1. Why plus 1? Because the indexing works from 0 to r, so that's why we will have to add one more entry to our right. Let me try to run this code. Oh, we made some mistake in generating the answer. Okay, seems like our code is working. Let's try to submit this code. And our code runs as expected, and I would be posting this solution in the comments so you can check it out from there. Thank you.
Hello friends, hope you are having a fantastic day today. So in this video, we are going to do an awesome LeetCode problem called sliding window maximum. This problem has been asked at tons of different companies. It is extremely well liked and also a LeetCode hard problem. So without any delay, let's get started. Now let's try to understand the problem statement for this problem. We are basically given an array of integer called nums, and we are also told that there is a sliding window of size k, which is moving from the very left of the array to the very right of the array. So which means sliding window is moving constantly. Now we are told that we can only see the k numbers of the sliding window, and each time the sliding window moves one step to the right position, now we need to return the maximum sliding window for every single sliding window that we have been able to find. So let's try to see some example for this given problem. So initially the window is going to be located at this position. Then window is going to keep on moving one step towards the right, which means this one is going to get eliminated and we would have a new window created like this. Same way, this 3 is going to get eliminated and we would have a new window created like this. For every single moment, we need to return the maximum sliding window. Okay, is that for this? We will have to create another array where we are going to note that what was the maximum character for every single sliding window that we have been able to make. So the very first sliding window is going to be this portion 1, 3 and -1, which means the maximum value in this one is value number 3. So we are going to add value number 3 to our answer. Next, this one gets eliminated from the given input array, and then we will have a new window that appears of this size, which means once again the maximum value is going to be 3. So we are going to mark 3 as the maximum value. Next, for this window, now we have this value number 5 that is going to be the maximum window for the current given input. So now we are going to add 5 to our answer. Same way, we will also have 5 for this particular window as well, and we will add 5 once again. Now we also get rid of this element, and now we have this window to look after. So in this case, we have a new maximum value that is 6. And then in the end, we will have this last window where it contains 7 as the maximum value. And this is the answer that we will have to return in order to understand that what is going to be the maximum sliding window. So this is what is expected of us to return. For the brute force approach, the way we are going to do is that we are first of all going to create a window of size k. So suppose even in this case we are given k is equal to 3. We create this window, then we iterate over every single element and we try to find the maximum element. So we found maximum element as 3. So we mark that as the answer. Then we get rid of this one, we create another window and once again repeat the same process until we reach to the very end, and then we would be able to find the solution. Now in this case the answer works perfectly fine, but the issue is for every single element we will have to iterate over 3 different elements to find the answer, and every single time we are creating a new window, which means the time complexity is going to be big O of n cross k, which is an expensive time complexity. So let's see that how can we improve on this one. One major improvement that we can make for this our given input is that instead of every single time creating a new window, what if we just use this logic of this existing window we already had and try to find the maximum value that we have already identified and then move forward and then play around with that maximum value. That is one of the option, and this is going to be an intermediary step that we are going to use in order to generate the optimal solution. So that's why I'm explaining this approach. The idea I'm suggesting is that, let's say in this case, first of all we have an element called max. This max element is going to keep track of the maximum character that we currently have inside our array as the window. Okay, and let's say that first, okay, currently we are at value number 1, which means we can only start adding the value after we have reached to the index value 2. So any value before that should not be added to the answer or should not be treated inside our answer array, but we can still keep track of the maximum element we have been able to find so far. So the idea is that first the value number is 0. Okay, currently maximum value is null, so we can add the maximum value we have been able to find so far as this value 1. Then we are at value number 1. Now once again this value is 2, so because 2 is greater than 1, so we will add value number 2 as the maximum element we have been able to find so far. Then we are at this third value, that is minus 5. So once again the maximum element we have been able to find is 2. So we are amongst, for this first window we will have to add one answer, and that answer we can directly take from our maximum element, so we can take value number 2. Next we will have to add one more element. So now we are at this value number 6. After at value number 6, this 6 is definitely greater than the current maximum value we had, so we can add value number 6 as the answer for this one. Okay, and now once again we will have to add the maximum value, so we can add value number 6 over here. Once again we find value number 7, so that is going to replace our maximum value, and then value number 8, that is also going to replace our maximum value, so we can add these values like this and build an answer. So you must be thinking that, hey, this looks quite straightforward, then why is it even this a hard problem? The thing is, we actually intentionally I chose an input like this because this is a very simple input where we don't have any particular issues. But if we are given an input, let's say now in this case, currently we are going to put our maximum value as this value number 3. Okay, and then now we are iterating over for this first sliding window, we will have to choose value number 3. But the thing is, we are not sure which value number 3 we picked. And in this case, let's assume that this becomes value number, instead of this being 4, this is 1. Okay, so let's assume that in this case, so far we know that this is the 3 that we added, but it could also be this 3. And now when we do move to the next element, which 3 do we have to remove? Because we are not keeping track of the index value of the maximum element, and that's why when our sliding window moves, we would be confused with this element. So that is a problem number 1. The second problem that we can think of is that we are not dropping the elements as we are moving forward. So every single time we move forward, we will have to drop all the elements that have already passed the given existing window, which means the approach that we found is to use the maximum element is correct. But the problem is
that number one, we are storing the value. That is an issue because we don't know that what is the index position. That can be fixed by storing the index position. But second issue is that we are only too much focused on just one character. Meanwhile, we should be focused on an entire window rather than just one character. And the approach of this window is very simple and very straightforward, that at every given moment, whichever the first element that entered inside the window would be the first element to be kicked out of the window when we move to the next window. So using these two approaches, what I'm suggesting is that instead of using a maximum variable just to store the value, I'm suggesting that instead of this, number one, instead of storing value, we store index values. So index values will allow us to calculate that whether we are at the current window or not, which means it would help us to kick elements out. And second thing is that instead of only using one variable, because we are using an input of a window where we are continuously removing the previous elements, which means we are using the concept of first in first out for the current to maintain the current window, which means we can have a queue where we can keep track of the values that are currently present inside the given window. And we know the concept of queue is very simple, it's first in first out, so we can manage that. On top of it, inside the given existing window, we don't have to worry about storing all the three elements. We only have to worry about that what is the maximum element in any given window. So what we can do is that for our given queue, we will always keep track of the maximum element that we have been able to find at the very first location, so that we don't have to iterate over the entire queue to find the value. We can simply do a peek operation to see that what has been the maximum value inside the given sliding window. And now this should be able to solve a lot of the issues we were facing previously. So let's understand the approach I am suggesting. The logic is quite simple. Let's quickly take one example. Okay, so let's say that this is the given input that we are dealing with, and we are given that the value k is equal to 3. Now I have created an array to store our answer, and I have also created a queue where we are going to store all the values of the given current window inside the ascending order, and we are going to maintain the maximum value as going to be the very first element inside the queue. That is going to help us out a lot. Once again, I'm iterating. We are going to store the index values inside the queue, not the actual values itself, so we can quickly navigate that what should be the current window size. Okay, so I hope these things makes clear. And remember that since our given k is equal to 3, we can only able to start adding values after we reach to the index value 2 onwards. Okay, and I'm also creating one more variable I, just to understand that what is the current variable we are iterating over. So let's say that currently I is equal to 0 we are iterating over, which means this value. Now currently our queue is empty, which means we don't have any maximum values. So let's quickly add one value. So currently our queue contains just one element, that is 0, and I'm also writing the corresponding value 1 just for our sake of understanding. Okay, now we cannot add anything to the answer until this point, so we are going to move forward. Now once again we identified index value number 1 that contains value number 3. So this value is actually greater than the current value of the index position we have inside the queue, which means that we need to add this 3 over here. So we are going to add value number 1 as an index value, and which has the corresponding value 3. And we are simply going to remove this value number 1 or this index value 0 all itself. Why? Because for any given window size that we are able to create, it is always going to be that this is going to be the maximum element. So why do we even keep the non-maximum elements inside the queue? So the moment we are going to identify any maximum element, we are going to iterate over the given existing queue to remove all the elements that are going to be smaller than that for that particular sliding window. That is going to help us out a ton. Okay, so now we got rid of this element. Okay, now still we cannot add anything to the answer. So now we are at I is equal to 2 position. So currently this is value number -1. So -1 is actually not greater or smaller than the current maximum value we have inside the queue, which means we are still going to add it inside the queue as index value number 2, which contains value -1.
but this would not be the first position. And now since at this I is equal to 2 position is equal to k is equal to 3, which means we are at our first window. Now whatever the maximum element we have inside our queue, at the very first position we are simply going to peek that index value and then go back to our actual given input array and find that maximum element and put it in the answer array. So now we are going to put value number 3 first. Okay, now we are at index position number 3. So once again, index position number 3, the value is -3. Now what is the current maximum value we have inside our queue? That is index number 1, which means for our ith position, what is the sliding window? It is value 1, 2 and 3, which means the very first element inside the queue we have is still inside the valid window. So we don't have to kick that value out. That is number one thing we need to check. Next, we need to check the value for index I is equal to 3. So this value is -3. So because this value is -3, it is less than the current maximum value we have. We are going to add it normally inside our queue. So we are going to add index position number 3, which corresponds with the value number -3. Okay. Now, and once again, we will have to add the maximum value, because now for every single value, we are going to add one value inside the answer. And once again, for maximum value, we are simply going to do a peek on very first element. That is our maximum value. And we are simply going to add it inside our queue. Okay. Now next, we are at I is equal to position number 4. So now we are at I is equal to position number 4. For this one, the window size is going to be 2, 3 and 4, not 1. So 1 should be removed. And currently in the very first element of the queue, we have value number 1. So which means we are going to remove value number 1 right here and now. Okay. Now after this, we are going to compare the value that we currently have for this value number 4. That is this value number 5. And we are going to compare it with very first element. So since 5 is greater, which means the moment we identify that the 5 is greater, we are going to check every single element that are smaller than 5 and we are going to remove all of them. We don't need them inside the window because we are only keeping track of the maximum elements. So now we are going to store index number 4 that contains value number 5. And after doing this, we are going to once again add it to the answer. So we are going to add value number 5 to the answer. Next is element number 5 that contains value number 3. So once again, this particular value inside our queue, index number 4, is still part of the current sliding window. So now we are going to check the values. So 3 is obviously less than value number 5. So we are going to add value number index number 5 or value number 3 inside our given queue. And then once again, we are going to add value to the answer. That is once again going to be value number 5. Now we are at this position where the value is value number 6. And once again, just for our understanding, we are dealing with this window. So index values 4, 5 and 6. Okay. Now for this I is equal to 6, we will first check that whether 4 needs to be removed. No, it can stay there for now. Now we compare the value. So currently this value number 6, or the index I is equal to 6, contains the value number 6 that is greater than the index position 4 that contains value number 5. So we are going to get rid of this one and we are going to check all the values that are smaller than 6. So currently all of these values were smaller than 6 and we are only going to store index number 6, answer number 6, once again marking 6 as the answer. And lastly, we are at I is equal to 7. So if I is equal to 7, then the valid queue or the valid window becomes 5, 6 and 7 index values. So the current index value we have inside the queue is 6, which is still valid. Then we compare the value. So 7 is greater than 6, which means we are going to replace 6 with value number 7, and which also coincidentally have the value number 7. And then because this is the maximum value we are able to find, we are going to also mark it to the answer. And in the end, we are just simply going to be done with our existing loop. And that's it. This is the whole approach and this is the whole solution that gives us the desired answer in a single iteration on the given input array. And all we are doing is just sometimes we are doing repeated work inside the queue to change the value of the array. But apart from that, we are not doing anything. So this is a wonderful approach to solve this problem. And this is actually the optimal solution. If we see time and space complexity for this approach, The time complexity is actually going to be big O of n because we are simply going to be iterating over this given input array once, which is pretty awesome and pretty convenient. So yeah, that's it. And in terms of space complexity, because we are using an extra queue, so that is going to be big O of k, because at max this can be of size q, nothing more than that. So let's try to run this code, and so now let's try to build the coding solution for this one. Okay, so this is the coding solution. First, we are checking for some edge cases, that if the given input is equal to null, or if the given k is equal to less than 0, then we can just simply return a blank or an empty array. If that is not the case, first we initiate a variable to store the length of the array. Then we also create a new value to store the result of the given array. And then we are also initializing a dequeue to store the queue values that we just discussed in the solution. Now we are simply creating an array to iterate over the given list. Very first, we are checking that are there any indices inside the current window that are exceeding or that needs to be kicked out. For that, first we check that if the given queue is not empty and the very first element or the largest element inside our given queue, if that is less than the value of I minus k plus 1, if that is the case, then we simply poll that element out. If that is not the case, then we simply iterate over all the values that are smaller than the given current value. If we identify that scenario, we simply keep on iterating all the values and keep on removing them. Then we simply have to add the value to the queue, and we need to find the maximum value that is currently located at the very first location inside the queue to our array, and we simply add it after the value I becomes greater than the value of k minus 1 that we just explained. And in the end, our result array should have been populated, so we can simply add all the values and return that. So let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs extremely fast compared to a lot of other solutions. Once again, the coding solution is present on the GitHub repository that we have created, so you can go and check it out from there. Thank you.
Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to do valid parentheses lead code problem, and this problem has been asked by some of the companies where I want to work at. There are companies like Amazon, LinkedIn, Facebook, Microsoft, Bloomberg, Spotify, Adobe, Google, Apple, Uber, TikTok, Goldman Sachs, Twitter, Netflix, Twitch, Tesla, ByteDance, Lyft, and Airbnb have all asked this question, so that's why I'm paying my utmost attention. I hope you also enjoy the video. This is a LeetCode easy problem and also one of the most liked problems on LeetCode, and that is because this problem actually solves one of the very real life application where a compiler has to check that whether the code has valid parentheses or not. And so that's why a lot of companies like to ask this problem as an interview question. If we understand the problem, basically we are given a string s that contains just these three types of parentheses: opening parentheses and closing parentheses, and we need to determine that if the given input is actually a valid input or not. We are also given the definition that what counts as a valid input, that if the opening brackets are closed by the same type of closing brackets, and also we are told that the opening brackets must be closed in the correct order. So let's try to understand this with some examples over here. I have drawn a bunch of different potential examples, and we will see that if they are valid or not. So first of all, if we see this example, we know that okay, we have two opening brackets and we have two closing brackets. We can consider this as a valid string, so I'm just noting it as V. Now again, in this case we have two different types of opening brackets and we have two different types of closing brackets, so this is also a valid string. Now in this case, this is an opening bracket, this is an opening bracket, we have corresponding closing brackets. Again we have opening and closing brackets, and again we have opening and closing brackets. So everything is in order and the same kind of brackets are opened and correct in proper shape and size, so we can consider this also as a valid format. Now if we come to this example, this is an opening bracket, this is also an opening bracket, but we only have a closing bracket for this original opening bracket, so we can consider this as invalid option. So we get an idea why it is invalid. In this case we have three opening brackets and only one closing bracket, so again this is an invalid string. And in this case, actually if we see the number of opening brackets and number of closing brackets, they are actually same. So we have one opening bracket and one closing bracket, again one opening bracket and one type of closing bracket, but this is still invalid. Why it is invalid? Because this bracket, this curly bracket is actually opened before this particular round bracket, so that's why it has to be closed before this round bracket closes. And in this case, this round bracket actually closes first before this curly bracket is being closed. So this is very important property that we will have to keep track of, and that is why we are told that we need to keep track of the order in which they are opened and closed, and then only we can determine that whether they are valid or not. So this is also an invalid formula. So let's see that what would be the potential solution. So let's start from the very simple example and see that what would be the intuition behind building a solution. Suppose we are given an example that looks like this, where we are given all of the brackets that are of the same kind, and we are given some opening brackets and some closing brackets. Well, we can clearly see that this is a valid approach, and how we can determine is that we can actually create a counter. And what this counter does is that at any given moment we identify an opening bracket, we are actually going to increase the value in this counter, and at any given moment if we encounter a closing bracket, we are actually going to decrease the value in this counter. And at the end we have to check that whether the value inside this counter, if that is equal to 0, which means we can determine that the same number of opening bracket and closing brackets are present, and then we can say that the string is actually valid. If that is not the case, we can say it is invalid. So if we see that in action, first of all we have 3 opening brackets, so we will increment the value of this counter 3 times, and if we do that, we will get the counter value to be at 3. Again, now we identify a closing bracket, so now this value from 3 becomes 2. Again we identify 2 more closing brackets, so again it gets decreased 2 more times, and then we get the final counter value to be 0. And because we get this value as 0, we can say that okay, this string is actually valid string, and the same number of opening and closing brackets are happening. So this is one way to identify a solution, but in this case the complexity is actually very simple. Why? Because we are only using one kind of opening and closing brackets. In our original problem we are actually told that there are 3 different kinds of opening and closing brackets, and we will have to keep track of them. Also we need to keep track that in what order they were opened and closed, and that order also has to be maintained. So it is not just as simple as keeping track of counter, that we create 3 different counters for all single type one of them, and then we see that at the end whether this value is 0 or not. We also have to keep track of that what is the order they were opened in and they were closed in. For the optimal solution, we know we need to take care of 2 things. First thing is we need to check that whether the opening and closing number of brackets are same for each 3 different types of parentheses or not. Second thing we have to take care is that what is the order in which they are opened and closed. So first let's tackle the first problem. We know that for every single opening bracket there has to be a closing bracket, and they are always in pair. So now to quickly look them up, we are actually going to use a hash map. Now inside our hash map we are actually going to have all of these closing brackets as the keys and their opening brackets as corresponding values. So we are going to have 3 entries. Now we have to take care of their order and number of occurrences. So the idea is we are actually going to use another data structure called stack, and the stack is actually going to be very helpful to us. So let's try to understand this with an example, that how we are going to use a stack over here. Suppose we are given an input that looks like this. Okay, so I'm going to show you 2 examples on how we are going to solve this problem. So first let's take this example, and the idea is that at any given moment we identify an open bracket, we are going to add that value inside our stack, and at any moment we are going to encounter a closing bracket, we are going to pop a value from the stack, and then we are going to see that whatever the value we popped out, if that is the same value that is for any given hash map value we have inside the string for that particular closing bracket. So let's see that in the action. First of all, we identify these 3 opening brackets, so we are going to add all of the entries inside our stack. So first we will add a curly bracket, then we will add these 2 brackets. Once we are done with this one, now we have a closing bracket our hand. The moment we identify a closing bracket, remember we will have to pop the value out of our stack. So we are going to pop the value out of the stack, and the value we have popped out is actually this one. Now for this closing bracket, we are going to see that what is the value of that bracket inside our hash map, and the value of that bracket is also like this. And we are going to compare these 2 elements, that whatever we took out from the stack and whatever we got from this hash map, and both are same. So because both are same, we can say that okay, we are good so far. And now so far we have actually taken care of these 4 elements, and now we are on this element. Again, this is also a closing bracket, so because this is also a closing bracket, we will have to pop a value out, and we are going, if we pop a value out, we will get a value that looks like this, that we had arrived from our stack. And now we are going to check that for this particular bracket that we were iterating over, what is the corresponding value inside the hash map. So the key is this one and the corresponding value is this one. So the value we found from our hash map is also this one, and they both are same. So because they both are same, we can say that okay, we are good up until this point. Now we are iterating over this curly bracket, so we again pop, and also I have forgot to delete this value. Now again we pop out a value from our stack, so now we don't have this value over here, and we have a bracket that looks like this. Again, for this closing bracket, the value inside our hash map is also an opening curly bracket, and both are same, so we are good up until this point. Now we are only up to last two characters, so this is also an opening bracket. The moment we identify opening bracket, we will add an entry to our stack, and now this is a closing bracket, so again we will pop this entry out. After popping this entry out, so this is the value we popped out from the stack, and then we will compare from our hash map, so the value is this one, and both are same. So we are at the end of our string, and because we are at the end of our string, we are going to check that whether inside the stack we have any entry or not. We don't have any entry, so we can return true in this case, and we can say that the given string is actually valid, and this would be the answer. Now let's take one more example where the string is not valid and see that what we are going to encounter in this case. Suppose we are given a string that looks like this. So in this case, we have two opening brackets and one closing bracket. So first of all, we identify that this is the opening bracket. We are going to add an entry over here. Again, we encounter an opening bracket. We are going to add an entry over here. Now we encounter a closing bracket. The moment we encounter a closing bracket, we are actually going to pop out the value from our stack, and the value we popped out is actually a curly opening bracket. Now for this closing bracket, we actually have a corresponding value inside our hash map that looks like this one. Now these two are actually not same. So the moment we identify that these two are not same, we can immediately return that this string is actually invalid and the parentheses are not in correct order. So we are done with this one. Time complexity is actually going to be big O of n, where the n is not the number of entries present inside the string, and even in terms of space complexity, because we are using a stack and hash map, but we don't care about hash map because it has finite number of entries. But for the stack, the values will be dependent on big O of n as well, on the number of entries present inside the string. Now let's move on to coding. So first of all, we are going to initialize our hash map, and inside the hash map we are going to store the values for three different brackets that we are given. Okay, we are done with this one. Now we are going to initialize our stack, and we are going to name it as stack as well. And now we are going to run a for loop across the given string. So first of all, we are going to initialize the character C, and that is to keep track of whatever the character we are looking over inside the given string. Now we are going to check that if the current bracket is opening bracket or closing bracket, which means that if the key value is present inside this mapping bracket, then we can define that it is a closing bracket. If not, then we can define it as an opening bracket. So if the value is not present inside this mapped bracket key, which means that we will have to push the current value inside the stack. If not, which means that the value is actually a closing bracket, and then first of all we are going to pop the value out of our stack, and then we are going to compare it with whatever the value pair inside the map bracket we have. And if the stack is empty, we can return false immediately. So in the else condition, we check that if the stack is empty, we can return false immediately. If not, we are going to pop out a value from the stack, and we are going to name it as top element. And now we are going to check that whether that is the same value that is present for the map bracket value key. And if the values are not same, we can return false immediately as well. And if that is not the case, eventually if we get out of the loop, then we will have to check that whether the given stack is empty or not. If the stack is empty, we can return true, or else we can return false. Let's try to run this code. Okay, seems like our code is working as expected. Let's submit the code. And our solution is actually pretty fast compared to a lot of other solutions. So I would be posting this in the comments, so you can check it out from there. Thank you.
Hello friends, hope you are having a fantastic day today. So once again, we are going to do a very popular LeetCode problem that has been asked in companies like Facebook, Amazon, Microsoft, Google, Apple, and bunch of more. So without any delay, let's get started. So the LeetCode problem we are going to solve is called min stack, and you can see that this is a LeetCode medium problem and also a very well-liked problem on LeetCode. The problem statement is very simple, that we need to design a stack that can support push, pop, top and retrieving the minimum element inside the given stop, these 4 operations, and it needs to run in constant time or big O of 1 time. So we need to implement the minStack class, and these are all the methods that we need to implement. Now we know that how does a typical stack work. Stack operates in LIFO principle, last in first out. If we decide to push element number 3, then we will have an entry 3 presented inside the stack. Next we can push another entry called 1, then once again we will have entry called 1, then once again we can have push another entry called 5. So currently we have 3 elements now inside the stack. If we have to pop this element, then the element 5 would pop out. So let's quickly pop one element, so then we will get an answer number 5. Then if we do pop once again, we will have value number 1. After doing that, if we were to add two more elements or push 2 more elements, let's assume 2 and 6. So once again we will have elements 2 and 6, something like this. Then if we do top operation, at this moment it should return answer 6 because that is the top element inside the array. And then if we do get min, then it should return us the value s2 because this is the current present minimum element inside the given stack. So these are all the operations that we need to do. We need to solve all of these in big O of 1 time, which means we will have to do something different when we are designing our stack. So what are some of the considerations that we can do? The thing is, this push method, pop method and top method, all of these 3 methods can operate in big O of 1 time, no issues with that. In either case, this get min is a little bit tricky because we will need to know that what is the minimum element at any given moment. Now the very first thing that comes to our mind is that when we are designing the stack, why don't we just have an extra variable called min to keep track of the minimum value we have encountered so far. So currently this is an empty stack. Let's assume that we enter value number 5. So this has been the minimum value so far, 5. Next we add value number 6. So 5 is still the minimum value. Next we add value number 2. So once again we update this and add 2 over here. Once again we add value number 7. So now currently the minimum value is 2. But now there is one problem that you did not see. And that problem is that let's assume that we decide to pop one element out. So now currently 7 is no longer here. But once again the minimum variable is still 2 because that is the minimum variable. Let's say that if we do pop once again. So once again 2 is now no longer inside the given stack as well. So now if we do min operation, we don't know that what is the minimum value inside the array because we just overrode the value. So if we have to check for the minimum value, we will have to pop all the elements out of the stack and then find the minimum value. That is option number 1, which takes big O of n time. And if we don't do that, we basically don't have any other way. So now to overcome this issue and to keep track of the minimum value at every single variable, we can actually do things slightly differently. So the moment we are storing the values inside the given array, we are actually storing different nodes, right, for every single location. Now in this design of node, we can actually have node have multiple items, not only just its value. So let's assume that this is our given node. And so in the node, I'm suggesting to add 3 values. First value is the value of the node itself, that whatever the value we wants to enter, that is your integer value like 1, 2, 3, 4, whatever you wants to put. Next is that what has been the minimum value up to this point inside the existing stack. And if we keep on updating this value with every single entry inside the stack, this would be pretty easy to maintain. And last thing is the reference to the next node, because in case we will have to remove or get rid of the element, we might need to update the minimum value we have entered so far. So let's see that how would this approach is going to look like. Let's say that we want to add these values inside the stack. Okay, so first we want to add value number 3. Currently the node is empty. So because node is empty, we are adding value number 3. What has been the minimum value we have added so far? That is also going to be value number 3. And the reference to the next node is going to be null. So we are not going to be concerned with that this is the very last element inside the stack. Okay, now we need to add value number 5. So we add value number 5. But what has been the minimum value is so far? So for that, we can either check the minimum value of the next pointer using this next pointer. So we check that what has been the minimum value of the next pointer at location number 5, that is value number 3. and what is the value of this current value we are trying to enter, that is value number 5. So whichever is the smaller number, which is 3 in this case, so we will still mark 3 as the minimum value we have been able to find, and then we simply have a reference to the next node. So reference to the next node, once again I'm just marking as 3, but that is simply going to be this node. Okay, once again we want to enter value number 1. So now at 1, what has been the minimum value up until this point, that is this value number 3. So instead of using 3, because 1 is smaller, so the smallest value so far is going to be 1, and the reference to the next node is also going to be this one. Same way, now we want to add value number 7, but what has been the minimum value we have been able to find so far, that is value number 1, and then just the reference to the next node, and then in the end the value is 0. So now the value is 0. We are trying to see that what has been the minimum value up until this point, that is 1. So compared to 1, 0 is smaller. So then this is also going to be 0. And then we simply have a reference to the next node. Okay. So now this is what our stack looks like. We are simply updating the node that we are storing the values in. And now let's see each of the operation. So I just mentioned that push operation can happen in big O of one time because we are just simply pushing one node inside the stack. Let's try to do a pop operation. So pop operation can also happen in big O of one time because we are simply popping one element out. So we will get rid of this element. Okay. Now once again, let's try to do the top operation. So top operation, we can return 7 immediately because that has been the latest value we find. And then if we do the get min operation, this can also happen in big O of one time because we can simply find the minimum value we have been able to identify so far. So this is the logic on how we are going to solve this problem, basically by simply redefining the way we are storing the values and then keeping track of the minimum value at every single position. That is the whole trick. And if we see time complexity in this case, well, time complexity we already know that is going to be big O of 1. And in terms of space complexity, well, this is debatable, but I think it has to be big O of 1 because anyways we are being asked to create a stack, so we cannot create extra space for that. So first let's define the node for our given class where we are going to store 3 values. First one is the value of any particular position. Next is the min value, and third is the reference to the next node. And this is just a simple constructor to store the values. Okay, now coming back to our main class, we are going to have a private node head and we are going to initialize our data structure here. Next, we are going to have a main push method. So whenever we need to push any single entry, so if the value is very first, then we are simply going to provide the value as it is. Then minimum value is also going to be the same value because there are no other entries inside the stack. And then the next element would be simply null. If that is not the case, we are going to add a new node where we are going to keep the value as it is. Then for the minimum value, we are actually going to compare it with the current value and the minimum value we have been able to find so far, and that we can simply find using the next node. And then as a part of the next node, we are simply going to point to the head node, and this is going to be keep on updating with every single entry. For the pop, it's very simple. We simply take the very first element that is currently present. For the top, we simply return the very first element. And then inside for the get min method, we simply return the minimum value for the head. And this is the whole solution. Let's try to run the code. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs extremely fast compared to a lot of other solutions in terms of time complexity and very efficient in terms of space complexity. So once again, I would be posting this in our GitHub repository, so you can check it out from there. Thank you. Hello friends, hope you are having a fantastic day today. So in this video, we are actually going to solve a very popular LeetCode problem. So without any delays, let's get started. So the LeetCode problem we are going to solve is called evaluate reverse Polish notation. And we can see that this is a LeetCode medium problem and also an extremely well-liked problem on LeetCode. The problem statement is quite straightforward, but it actually has a bunch of different conditions that we need to understand. So we are given an array of strings called tokens. Now these strings represents an arithmetic expression in the reverse Polish notation. Now we need to evaluate the expression and we need to return the integer that represents the value of the expression. Now let's try to see some of the conditions that we are given. Number one, the valid operations are plus, minus, multiply and division. So these are the 4 operations that we can imagine to expect in our string that is coming in. Now we are being told that each operand may be an integer
or another expression. So we will see this in another example. Then we are being told that the division between two integers always truncates towards 0, which means we are always considering the ceiling value the floor value of any equation, and then we are being told that all the inputs are going to be valid and there are not going to be any issues. So let's try to see one example, one very simple example. So in this case, the answer is going to be that the moment we identify an operator, we will have to go back and take the previous two elements, and if these two are whatever the numbers are, we are going to be using that with this operator. So we are going to be treating this as A, we are going to be treating this as B, and since this is a plus operator, we are actually going to be doing A plus B. So we need to return 3 as the answer in this case. Let's try to take some slightly more complex examples. First we are going to, okay, so this is the number, we move ahead. Once again a number, we move ahead. We identify an operator. So now we are going to be treating these two values as A and B. So we are going to be doing A plus B. So 1 plus 2. So the answer of this portion is actually going to be 3. Our equation looks like 3 and then 3 and then plus. So once again we are going to be doing 3 plus 3. So the answer is 6. So out of this operation we need to return 6 as the answer. So this is the whole logic of what the problem is actually asking us to solve. That whenever we are given the values, we keep moving forward until we find either one of these three operators like plus, minus, multiplication or division. The moment we identify these four operators, we are going to be treating the previous two values as A and B, and then apply this operator and then keep on repeating the same process until we run out of all this every single digits inside the given inputs, and we are being told that all the inputs are valid. Now after this extensive explanation, let's try to understand the most simplest brute force approach. So brute force approach is actually quite straightforward. Suppose we are given the values 4, 5, plus, and then minus, and then 7. Suppose these are the values we are given. So idea is that we are going to keep on iterating one by one. The moment we identify an operator, then once again we go back to the previous two elements and we use it with that operator, and then once again we identify, okay, so now this becomes 9 and then minus and then 7. So once again we keep on repeating the same operation using the operator. But the thing is, many times, for let's assume that if this is a very long string and we identify operator at very late, the moment we identify operator, once again we are going to be repeating the same process in order to find the values A and B. So this becomes very tiresome operation. So the idea is that we need to make it better and find some smarter ways to keep track of all the elements from the point we find the operators in the reverse order, and also have an idea on how we can keep on moving forward with the given input array and start parsing the values. So these are the two main considerations that we will have to understand. So the idea I am suggesting is that we can actually use stack to solve this problem. So suppose this is the long operation that we are given. Now the idea I am suggesting in using the stack is that at the very beginning we are actually going to be iterating the same way we are iterating. All the values we find, we are going to be pushing these values inside the stack. The moment we identify the operator, we are going to be popping the previous two elements and treating them as A and B, and then applying that operator with that value. And once again, whatever the answer we find, we are also going to be pushing those answer inside the stack, and then we are going to keep on repeating the same process until we identify the operator. And then when we reach to the end, we should have our answer ready, because we are being told that the given input is actually valid. So let's see the solution in action. So currently our stack is empty. Now we are at very first element number 2. So we are going to be pushing element number 2 inside the stack. Now we are element number 3 and once again element number 7. Okay, now we identified an operator plus. So the moment we identified the plus operator, we are actually going to be popping these two values out. So if we do that, we will have value 7 and 3 that we need to do the sum of. So 7 plus 3 is going to give us the answer 10. So currently the answer of this portion is going to be 10. So we are going to be pushing this 10 inside the stack. And now look at the stack. It actually contains the equation for this portion, because sum of these three values is 10, that is present over here, and then 2 was already here. Now we have 10 and 2. Once again we identify a multiplication sign. So we need to do 2 times 10. So we get the value as 20. So now once again we are going to be pushing the value 20, because we already popped out 2 and 10. Okay. So now we have value 20 inside our array. And now we once again identified value number 8 and then once again value number 19. So let's push that. Okay, after doing that, now we identified symbol plus. So once again for plus, we are going to be doing 8 plus 19. So the answer is going to be 27. Okay, so now we are, because we popped out 19 and 8, we push 27 down, and then we have this minus operator. So last operation we are going to be doing is 27 minus 20. So the answer is going to be 7. So 7 is what we need to return in this case to solve the problem. And this is the whole solution that I'm proposing using the stack. Look how beautiful it is. Look how at any given moment, but the moment we identified the operator, we can actually find the previous two elements back, and we can actually do the sum that needs to be done, or some division, subtraction, whatever. And this is how we can solve the reverse Polish operation very beautifully using stack. This is one of the most awesome way to use stack in the real life problem, and that's why this is such a popular problem that we have seen in tons of interviews being asked. So if we see time complexity in this case, the time complexity is actually going to be big O of n, because we are going to be iterating over every single character just once, nothing more than that. In terms of space complexity, we are using an additional stack. So depending on how apart the characters are from any operation, the size of stack can increase or decrease, but overall it is going to be big O of n, so which is good and acceptable time and space complexity in this regard. So now let's see the coding solution for this one. So the idea is quite straightforward. First of all, we are going to be initializing our stack. Then for every single token, we are first of all going to check that if the given token is operator or not. If the moment we identify that if the given token is operator, we are going to be popping two values out. So first value we pop out is going to be our B, and second value is going to be our A. And then we are going to be applying our operator that we have found using this method. So let's see a couple of the helper methods. First helper method is the isOperator helper method, where we are simply checking that if the given token is equal to any of these four values. And second one, we are applying the operator, where we are simply going to go over the given input values, that is the string and then A value and B value, and we are simply returning depending on the operator to whether do the addition, subtraction, multiplication or division. And if none of this case is there, we are simply adding one extra argument, but I don't think this is going to be called, because we are being told that the given input is valid. If that is not the case and we did not find that these are the operator, by the way, the moment we identified the operator, we also do the calculation, and whatever the result we found, we once again push it down the stack. If that is not the case, which means the given token is not an operator, so we simply push it down the stack, but we first of all convert the value inside the integer, because we know that this is going to be the integer value. And once this loop runs, we should have been done with our reverse Polish notation, and whatever the value left inside the given stack would be the answer that we need to return. So we can simply pop the very last element. So let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs pretty fast in terms of time complexity, which is pretty awesome. Once again, the coding solution for this problem is present inside our GitHub repository, so you can find it from there. Thank you. And today we are going to solve a LeetCode problem called generate parenthesis. Now, if we see some of the popular companies who have already asked this question, there are companies like Amazon, Facebook, Microsoft, Apple, Bloomberg, Uber, Lyft, Google, ByteDance, Spotify, and Nvidia. So that's why I'm paying my utmost attention. I hope you also enjoy the video. Okay, so this is a LeetCode medium problem and also very well-liked problem on LeetCode. Basically, we are given an input number n, and now we need to generate n pairs of parentheses. So basically, we need to write a function that generates all the possible combinations of well-formed parentheses. Now, these round parentheses, I think they are called well-formed parentheses. Now, we can try to understand these two examples, but I'm actually going to take it one step further, and I'm going to show you 4 different examples to understand that what this problem is asking us to do. Okay, now in this first example, we are basically given n is equal to 1 pair, which means we need to make one possible pair and all the combinations of this well-formed parentheses. So obviously the answer is going to be quite simple. We simply need to return like just one possible pair that we can make out of this one. Now suppose n is equal to 2. So now for n is equal to 2, we have the choice to take like 2 of these and 2 of these. right? We need to take 4 values. So basically the number of possibilities we can make is that we can actually make a parenthesis that looks like this, and we can also make a parenthesis that looks like this. These are the only 2 possibilities we can have, and this is what we need to return as the answer. Now things becomes a little bit interesting when we reach to n is equal to 3. So when we get to the point where n is equal to 3, the possibilities we can make is, so these are the 5 possible pairs we can make when n is equal to 3. Now notice that over here for every single piece we are using like 3 opening brackets and we are also using 3 closing brackets, but we are just putting them in different pairs so that they generate like the well formed parentheses. Same way, if we try to do it with n is equal to 4, the answer is going to be pretty huge. So let me just draw it over here. So these are all the possible pairs we can make when n is equal to 4, and basically we are using 4 opening brackets and 4 closing brackets and arranging them in different sizes. So this is a very interesting problem. Now let's see that what are going to be the different approaches to solve this problem. So now the first approach that comes to our mind is a brute force approach. In the brute force approach, what we can do is, suppose we are given n is equal to 2, right? If we are given n is equal to 2, there is one thing guaranteed. We need to have 4 characters inside every single block of our answer. Why 4 characters? Because we are generating 2 pairs of parentheses. So 2 pairs of parentheses is basically going to be 4 characters at least, right? So what we can do is, now we have 2 options to choose from. Either we can choose an opening parenthesis or we can choose a closing parenthesis. So what we are going to do is, basically we can take every single possible pair that we can make of size 4 using these 2 characters, and only the valid pairs we put them in the answer. So suppose we are given n is equal to 2, what are the different pairs we can make? Let me make just a few pairs. So these are just some of the few examples that we can make for 4 characters using like this opening and closing parentheses for n is equal to 2. And over here we only need to find the legitimate pair. So okay, we can find one legitimate pair and we can find another legitimate pair, and I think this is going to be the answer that we need to return. So we will put these 2 in the answer and then just return them. But if you see, this brute force approach is extremely inefficient. If we see like time complexity, the time complexity goes sometimes into like 2 to the power of 2n something multiplied by n just to check that whether the pair is valid or not, and that is disastrous. So no one is going to accept that. So we will have to find a way to do something better. So what we are going to do is, we are going to do things smartly. How we are going to do things smartly? First, let's define our purpose. Our purpose is to generate 2 pairs of opening and 2 pairs of closing brackets, and they has to be well informed or valid. Now we need like 2 opening brackets, so that is a given fact. We need 2 closing brackets, that is also a given fact. Now there are some properties that we can use at our advantage, taking consideration the definition of being valid. Now what is the definition of being valid? So basically, if we are given n is equal to 2, there has to be 2 opening parentheses and 2 closing parentheses. So that is one definition. Second definition for being valid is that we can only put a closing parenthesis if there exists an opening parenthesis before that. Again, I'm repeating myself. We can only put a closing parenthesis if there exists a closing parenthesis before that. We cannot start our answer with a closing parenthesis because that wouldn't be valid. Third thing that we need to consider is that we can only have that many number of open parentheses that is equal to the number of n. Now you are saying that why am I repeating myself? Because this is going to be the very important property that we are going to use. So now once we know all of these things, let's try to make some smart decisions on how we can actually generate the answer for valid parentheses. Basically, we are given n is equal to 2 over here, right? Now we have option to choose like 2 opening parentheses and 2 closing parentheses. So okay, now what we are going to do is, for our answer generation, always we will have to start with an opening parenthesis, right? Now we created the opening parenthesis that starts with this one. Now we are going to keep track of few values. First value we are going to keep track of is the number of opening parentheses, right? So number of opening parentheses that we have used so far is 1. And what is the maximum we can use? Maximum we can use is 2 because that is the value of n. We are also going to keep track of the number of opening parentheses. We already know that is 1, right? We are also going to keep track of number of closing parentheses, and so far we haven't used any closing parentheses, so that this value is 0. And we can only add a closing parenthesis if
the number of opening parentheses is greater than the number of closing parentheses, because we already proved that over here. Now using this logic, let's see that what is the sequence we can make. Okay, so first we start with this value. When we start with this value, number of opening parentheses is 1, number of closing parentheses is 0. Now over here we have two options, and those two options are we can either add one more opening parentheses or we can add a closing parentheses. So let's see options in both of the cases. The number of opening parentheses is going to be 2, and we can have this value to be 2 because we are given n is equal to 2, and in this case the number of closing parentheses is still going to be 0 because we have only used 2 open gap parentheses over here. Now in this case the answer is going to be a little bit different, because the number of opening parentheses is going to be 1 and number of closing parentheses is also going to be 1, and this is also valid. Why? Because the number of closing parentheses can be 1 because we already had 1 open parentheses. So far both of the cases are legitimate. Now again at this position we also have 2 more choices. So over here we have the one choice to open and we have one choice to close. Now let's see both the options. If we try to go one choice to open, what will happen is number of opening bracket is going to be 3, but that is not valid. Why? Because we are given n is equal to 2 explicitly. So in this case we cannot go down this path. So if we cannot go down this path, we will actually backtrack and come back to this position. Now from this position we can only go towards the path of closing. So if we go towards the path of closing, so far the number of open brackets we had is 2 and the number of closed bracket we had is 1. So that is still valid, that is still legitimate. Now again from this position we still have 2 options. We can either open or we can close. If we try to open, we cannot do that because number of open is going to be 3, so we are not going to go down this path. If we go down this path, basically the number of open bracket is going to be 2, number of closed bracket is going to be 2 as well, and this is the exact condition we need because we are given n is equal to 2. So which means that there has to be 2 open brackets and 2 closed brackets. So we can put 2 conditions, whether we can put like the combination of open plus close is going to be 4, that is going to be the double of what is n, or we can have like O is equal to 2 and C is equal to 2, both of them equal to 2. So this is also good. So now we have reached this condition, which means that whatever the path we actually make can make ourselves into the answer. So what is the path we took? So first we started with taking the opening bracket, then again opening bracket, then again closing bracket, and then again closing bracket. So let's put this value in the answer, right? So we are going to create a new variable answer over here, and over here let's put one entry that okay, 2 open, 2 close, that is good. Now let's start following the other path. I'm going to clean this up a bit so it does not become any more distraction. So now in this case, okay, currently we have 1 open bracket, 1 close bracket. Now again we have 2 possibilities. So first possibility is we can open 1 more bracket or we can close 1 more bracket. Now let's analyze both the possibilities. If we try to open 1 more bracket, basically the number of open brackets we are going to have is 2. Let me clean this up a bit more. And over here number of closed bracket we had so far is still 1. So okay, this is valid, we can put this one. Now if we try to put 1 more closed bracket, the number of open bracket we have so far is only going to be 1, but number of closed bracket is going to be 2, which is a big no. Why? Because we cannot have more closed bracket than the number of brackets we have opened, because that would defy the possibility of having a legitimate scenario. So we cannot go down this path, so we won't. And now again we have 2 choices at this position. We can open 1 or we can close 1. If we open 1, then the number of open is going to be 3. That is not valid, that is not good. So we are not going to do anything with this one, and we will not go down this path. If we go down this path, then over here number of open brackets we have so far is 2 and number of closed bracket we have so far is also 2, which is also the legitimate scenario. So which means that this path is also going to be a path that we can add to our answer. And let's see. Okay, so currently we have, okay, we have 1 open bracket, 1 closed bracket, we have also have 1 open bracket and 1 closed bracket, and that's it. Now initially, remember, we only started with this 1 opening bracket and then we had 2 possibilities, and we actually exhausted both the possibilities, so we cannot go down further anymore. Now because we cannot go down further anymore, we can conclude that whatever the values we find so far, this is the complete answer, and we can return this as the answer. And basically this is the whole crux of the finding the optimal solution. Now you must be asking that hey, what we actually did was we did something very important. First we identify, okay, the one value, Then we had the final case. So final case was that whenever the number of opening is equal to n and number of closing brackets is also equal to n, this is our final case. And then at every single position we had two options to either choose an opening bracket and closing bracket and keep on repeating the same process until we reach to the end, and we had some parameters in mind. So if you see, we are actually using dynamic programming at its finest, because at any single previously computed value that is being used to calculate that which path we need to take and whether we can take that path or not. So we are basically using dynamic programming plus backtracking to solve this problem, and this is going to be like an amazing way to explain this problem. Logically think that in the brute force, what a disastrous result we were having, and we actually brought it down to such like beautiful answer, and then we are just presenting it. So this is the whole power of using any like computer language. So before we start implementing the generate parentheses method, first we are going to create our backtrack method. That is going to be our helper method that we are going to use recursively. Now for the backtrack method, it is not going to return anything, but it is going to add all the values towards the answer. And inside the method, we are actually going to create a list of lists that is going to store the answer. We are also going to have a string builder to keep track of the current values we have, and the number of opening and number of closing brackets, and also the maximum number of values we can generate. Okay, so now first let's create the acceptable scenario. So if basically the current length is actually going to be maximum times 2, which means that we have reached to our answer and we can add it to our answer. So this is the legitimate scenario. Now let's see, say for an example, we find out that we have not reached the answer. Then what could be the possibility? Well, first possibility could be the number of open brackets that could be less than the number of maximum brackets that is allowed. If that is the case, basically for the current string builder, we can actually append an opening bracket. So let's do that. And after adding the opening bracket, basically we will have to call the backtrack method again with a reduced value of one open bracket. So let's do that. So in the backtrack method, we are going to call the answer, and we are also going to call the current string builder list we have. But for the open, we are actually going to add one value, and for the number of close brackets, we are going to keep it as it is. The max is also not going to be changed, and that is awesome. Now there is also one more important thing we will have to do every single time we make a backtrack call, and that is to delete one character that is located at the current length -1, because it is going to add an extra character. So let's do that. Okay, now same way, say for an example, if the number of closed brackets, they are less than the number of open brackets, if that is the case, basically we can also add one closed bracket to our self as well. So let's do that, and we are also going to call the backtrack method, and everything else is going to remain the same. And basically this whole logic sums up our backtrack method. Now all we need to do is, from our main method, we simply need to create a list of list called answer. So let's do that, and then we are going to call our backtrack method. Now inside the backtrack method, we are going to provide the value of answer. We are also going to provide a new instance of a string builder. Going to provide the number of opening brackets that we have used so far is 0, number of closing brackets is also 0, and the maximum number of opening and closing bracket we can have is going to be the value of n. And after getting the answer from the backtrack method, we can simply return the answer to be return the answer that we got, and basically that's it. Let's try to run the code. Okay, seems like our solution is working as expected. Let's try to submit the code. If we submit the code, our solution beats a lot of other solutions. It is really good in terms of time complexity, and it is also really efficient in terms of space complexity as well. So yeah, I'm going to be very satisfied with the approach, and now I would be posting this solution in the comments, so you can check it out from there. Thank you. Hello friends, hope you are having a fantastic day today. So once again, we are going to solve an awesome LeetCode problem. So without any delay, let's get started. So today we are going to solve daily temperatures LeetCode problem. That is a medium problem and also an extremely well-like LeetCode problem. So the problem statement is quite simple. We are given an integer array called temperature that represents the daily temperature over a certain span period. Now we need to return a new answer from this given temperature array such that any particular item in that particular answers array should define that how many number of days you have to wait in order to generate a warmer temperature compared to that particular day's temperature. So let's try to understand this with an example. Suppose this is the temperatures array we are given. Now in the input you can see that bunch of different values for every single day's temperature. Now if we see, on this very first day, the temperature is 73, which means how many number of days we have to wait in order to get a warmer day. Well, a warmer day is right next, which means if we just wait one more day, we can actually get a warmer day. Same way for 74, if we just wait one more day, we also get a warmer day because next day's temperature is 75. Now at this 75, if we have to find a warmer day, then we have to find a day that contains higher temperature than 75, which means this temperature 76 is higher, which we can see that that is actually 4 days away. So over here we will have to actually wait 4 days in order to get a warmer day. Same way for this 71, we have to wait 2 days in order to get a warmer day. At position 69, we only have to wait 1 day to get a warmer day. At 72, once again we will have to wait just 1 day because next day is 76, which is warmer. At this 76, we do not find any particular warmer day subsequently, which means we cannot find a warmer day. So we are just going to mark this as 0, that no warmer day exists in front of the value 76. And last one is 73. So since this is the very last entry, we don't know what the upcoming temperatures looks like. So we are also going to return 0. And this is the answer array that we need to return. That defines the days you have to wait in order to get a warmer day from any particular day. Okay, so first let's try to understand a brute force approach to solve this problem. The idea is very simple. We simply go to a day and then we keep on iterating the array until we find the next day that has higher temperature. The moment we find this one, we actually find the difference between the index positions, and whatever the difference is, we mark that in the answer. So for this first one, we can mark first as the answer. For the second one, once again, we are going to repeat the same process. We are going to iterate over every single value inside the array till we find a higher value, and which we find 2 days later. Same way we are going to keep on repeating the same operation, and eventually we would have our entire answer array to be populated. Now this is the most simplest method, but we can inherently see some issues with this approach. The number one issue is that at any given position, we will actually have to traverse over maybe the entire rest of the array in order to find the optimal solution. What if let's assume that this, instead of being 50, maybe this was 80, and we don't have any particular solution in mind. We would have still iterated over the entire array, and then once again, in order to find the lower temperature for this next element, we would still have to iterate over the entire given array. Maybe this was 82. So in this case, this is an inefficient approach. And if we see, time complexity for brute force approach is going to be big O of n square in the worst case scenarios. So let's try to see if we can improve upon this time and space complexity or not. The thing is, at this given location, at the very first moment, we don't know that what is the temperature that is higher than this one, because we have only iterated this one element, right? But what if we are at this element? We can at least predict that how many elements actually has lesser temperature than this, and based on that we can immediately update their temperature, and we can immediately say that if we are at, let's say, value number 75, then at 75 we should be able to tell that 74 is only 1 day away from having its warmer day, and same way at 74 we should be able to tell that 73 is actually just one day away from having a warmer day. Same way at 72 we should be able to tell that 69 is only 1 day away. So how can we actually do that? For that we will have to find some way to actually iterate the array in one direction, note that what the current temperatures are, and based on that we will also have to check that what are the immediate temperatures that are actually smaller than this current temperature or greater than this current temperature, so that we can mark their answers. In order to do that, we will have to use an extra data structure to store the values of all the temperatures for which we have not been able to find the warmer days. Second thing is, for any particular temperature, not only we will have to find the warmer day, we will also have to find like the immediate warmer day. So for this 75 is actually greater than both 74 and 73, but we should not waste our time marking this 73 as having a warmer day as 75, because there is 74 that is more closely associated with 73, which means we have to worry about the immediate before elements. So we are traversing in one direction, but at the very quickly we will have to understand that what was the last item we were at before moving to any particular previous elements. So the best data structure in this case is going to be a data structure that contains the property of last in first out, and the answer becomes very simple, that we are actually going to use a stack to solve this problem. Now how we are going to use the stack is actually quite interesting. Let's first understand a couple of properties. Number one thing is, we are using the temperature to compare the difference between any two given values, which means we are dealing with the value of this given array. But in the answer, we need to store that how many number of days are apart between any two entities, and that we can find using the index values. Why? Because at index value 0 we have this value 73, and at index value 1 we have this value 74, which means index value 0 is only 1 day away from finding a warmer day, because index value 1 minus index value 0 becomes actually value number 1. So this is how we are going to find the answer, which means in the stack it would make more sense to store the index positions rather than storing the actual values. But using the index positions, we can very quickly look up inside the array, find the answer, and then subsequently traverse the answer. So after this long explanation, let me walk through the solution that I'm proposing. So currently we are at 0th index, the value is 73. Currently we don't have any value inside the stack, so we are going to add index 0 inside the stack. Okay, and now we are at index position number 1, the value is 74. The very first thing we are going to do is we are going to check that whether the value located at 0th position, which means the value located at temp of 0, if that is actually less than the current index positions we are at. So if that is less than the temp of 1, which is correct condition, because this one was 73 and this is 74, which means this value can be popped out of the given stack, and we can actually mark the answer for this one by doing the subtraction between the current element minus the index position that we just kicked out from the stack. So this is going to be just 1, where we did a simple equation 1 minus 0. Okay, now we are going to put 74 in the stack, but we are going to put the index value. So now in the stack we have index position number 1. Now once again we are at index position number 2. So this value is 75. 75 is greater than 74, which means we can do 2 minus 1 and the answer is 1. So we can store that 74 is 1 day away from finding a warmer day. Now we popped out 1 from the stack. Now let's add entry number 2 inside the stack. Okay, now we are at this position 71. So currently 71 is actually smaller than 75, which means for 75 we have not yet found a warmer day. So we are going to add entry number 3 inside our stack as well. Next we are going to be at position number 4, which is 69. Once again 69 is actually less than the current top value we have inside the index, which means we haven't found a warmer day for this top element, and we are going to add one more element that we haven't found a warmer day for. Okay, now we are at position number 72. So 72 is actually greater than this value, the value at index number 4. So we can actually find the answer for index number 4. So let me just go. Okay, so this is for index number 1, 0 we have, 1 we have, for 2 we don't have, for 3 we don't have, but for 4 we found the value, that is 5 minus 4. So we can add 1 as the answer for index number 4. Once again, the moment we pop out index number 4, we should not be pushing index number 5 yet, because we still have to check that whether 5 is greater than index number 3, and yes, it is once again greater. So for index number 3 we are going to mark the answer as 2, and same way for index number 2 we are also going to mark the answer as for index number 2 we are still not able to find the answer, because this is 75 and this is 72. So we are going to have index number 2 still living inside the stack, and then we will have index number 5 now residing in the stack. Now we are at index number 6, so this value is 76. 76 is actually greater than 72, and so in this case we can actually mark down the answer over here as 1 for this index number 5, and we can get rid of this index number 5. Now once again this index number 2 is also smaller than index number 6, so we need to do the difference, 6 minus 2, so we find answer 4, and we are going to populate answer 4 over here. And then we have an empty stack, which means there are no more values we need to check, so we are going to add value number 6 inside the stack. And then in the end, next value is value number 7. So 7 is 73. 73 is actually smaller than the current stack value we have, so we are also going to add value number 7 inside the stack. And the moment we reach to the end, we are going to fill out all the rest of the elements by 0, that there are 0 days that we have been able to find the answers for, and this is what we can return in the answer. So you see how using a stack we actually need to traverse over just once on the given temperature array, and then we have been able to find the answer, which means this is a much better approach, and this is the optimal solution compared to our brute force solution. So let's try to see the time and space complexity. In this case, the time complexity is actually going to be big O of n, because we are simply iterating over the temperature array once. Now it could be possible that for some values we might have to go back and find the values that are smaller than that where we are doing multiple operations inside the stack, but that number is going to be limited, because we are being told that we can find out that how many values are there, and we are only iterating over the values for which we haven't find the answer. And in terms of space complexity, once again in the worst case scenario this is going to be big O of n, because we are using an additional space additional stack to find the answer. So the coding solution is actually quite straightforward. First we initialize a number n in order to mark down the length of the given array. Then we initialize a new answer array of the size n. We also initialize our stack that we are going to use. Now we simply iterate over the given temperatures array using the for loop. We first have a while loop condition that while the given stack is not empty and the temperature that we are iterating over currently, if that is greater than the temperature that is currently present inside the stack, then we simply mark the index value that is currently present at the very first element of the stack that we popped out, and then we mark the answer index by doing the subtraction of I minus the current index position that we have just been able to find by popping the element out of the stack. And then we simply push down the element inside the stack, and in the end our answer array should have all the answers, so we can simply return that. Now let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs pretty fast compared to most of the other solutions. It is also decent in terms of space complexity. And once again, the solution is available on our GitHub repository. The link is in the description, so you can check it out from there. Thank you. Hello friends, hope you are having a fantastic day today. So once again, we are going to do an awesome LeetCode problem. And trust me, this is an awesome LeetCode problem. So without any delay, let's get started. So now we are going to solve the LeetCode problem called car fleet. Now personally, this is one of my favorite problems. And we can see that this one is a LeetCode medium problem and also decently well-liked problem. The thing is, this is a very long description for this problem because it covers a lot of edge cases and a lot of conditions that you have to understand. If you want, be my guest and read the whole description. If not, let me just point out few important topics and then we will try to understand what the problem is asking us to do through an example that would make things much more simpler. So first thing is, we are being told that there are n cars going in the same destination along one lane road, So it's a single lane road, and we are told that the cars are not going to be overtaking each other. This is not Fast and Furious, this is LeetCode. Okay, then we are also given a target miles that we need to reach, that is the final destination for our cars. Now we are given two integer arrays. First one is position and second one is called speed. So position defines that what is the starting position for any particular given car compared to that target distance. Okay, and the speed is at what speed that particular car is running on. So we are given both the values inside the car. Now we are being told that cars are not going to overtake each other, but if they are close enough, we can consider them arriving at the destination at the same time. And any car arriving at the destination or set of cars arriving at the destination would be considered as car fleet. And now we need to consider that how many number of different car fleets actually arrive to the destination. So I know that this was quite complicated and very extensive description. Let's try to make it simpler using some example. So over here we are given a target value of 12 that we need to reach, and we are given the positions, and we are also given the speeds of subsequent cars. So here I have actually plotted a graph or a number sequence where this 12 is the target that every single car is trying to reach. Now this C1, C2, these represents different cars, and we can see that based on their positions inside the subsequent array, I have already plotted them on this given line. So this defines their starting position, and subsequently this portion defines that what is the speed that is given to every single car. Okay, and we are being told that the distance we are trying to cover is 12 miles, and the speeds are given in per hour basis. So which means this car C2 actually traverses 4 miles in 1 hour. Okay, so now we need to understand that how we define car fleets. So let's try to understand it one by one. So we will try to go over that how every single car is actually going to reach to the final destination. And we know for sure that no car is going to overtake one other. So if one car comes closer to the other car, we would consider both of them reaching to the destination at the same time, and they would be part of one single fleet. So first, let's see. So currently this car C1 is located at position number 10, and its given speed is 2 miles per hour. We know that this C1 has to be the first car to reach to the destination because it is the closest car to the destination. So in the first hour, this car is actually going to reach to the destination, and it's going to take 1 hour. But during this 1 hour period, because how do we come up with this 1 hour? Because we calculated the distance from the current position to the final destination we are trying to reach, which is 2 miles, and its speed is also 2 miles. So we can easily calculate the time that it takes to reach to the destination. Now for this C2, also subsequently, this C2 would also reach to the destination in just 1 hour. So based on this, we can conclude that both of this C1 and C2 are actually going to reach to the destination around the same time, around at 1 hour mark, which means C1 would be here and C2 would be right very close to it. So these two cars are going to reach to the destination in around the same time, which means this is going to be one of the fleet that is going to arrive into the destination. So now we already took care of one fleet, so let's just get rid of these. Okay, and also let's try to understand that we have already spent 1 hour. So during this 1 hour, what would be the position of all of these cars? So during 1 hour, the C4 would have traveled 1 kilometer. So C4 would be here. Same way, the C5 would have also completed 3 kilometers because its speed is 3. So after this 1 hour, this C5's position should have been at position number 6. But at position number 6, we can clearly see that C4 is already present, which means after 1 hour, the position is going to look something like this, where C4 and C5 are going to be right close to each other. Now remember that the speed of the C4 is 1 and speed of the C5 is 3. But because C4 is ahead compared to C5, even though it has higher speed, it is not going to overtake it, and it is only going to reach to the destination when the C4 arrives. But essentially, both of these cars are also going to reach to the destination in around the same time. And how much time will it take? Well, currently this one is at position number 6, so it is going to take 6 more hours, and we already spent 1 hour, which means this C4 is going to take 7 hours to reach to the destination. And because C5 is behind that and it is able to catch up to the C4, it is also going to complete and reach to the destination in 7 hours. So after 7 hours, the second fleet that would have reached to the destination would be the cars that we just saw, that is the car C4 and also C5. So they both will also reach to the destination in around the same time. So this would be our second fleet that is going to reach to the destination. And now we already spent 7 hours, which means after 7 hours, this C3 would have been around here, because its speed is just 1 miles per hour. So it would have covered the distance of 7 miles, and then still it would have 5 more miles to go, which means it would still take like around 12 hours to reach to the destination. And in the end, the C3 car would be the very final car that would reach to the destination, and still this would also be considered a fleet in its own. So over here we can see that actually we are getting 1, 2 and 3 fleets reaching to the destination. So for this given input, we need to return 3 as the answer. And this is the whole problem statement. Now I know understanding this problem statement took us a lot of time, because there were a lot of moving parts and moving cars that we had to understand. But honestly, this is an awesome LeetCode problem, because if any interviewer dares to give you this problem, this is not very difficult to solve, but it's very peculiar for interviewer to explain. Also, you will have to navigate through a lot of different edge cases and then think about coming up with the optimal solution. So now I'm not even going to be bothered to show you the brute force approach, because that would be an insult to this beautiful problem. So let's talk about the actual complete optimal solution that we can use in order to solve this problem. And in order to generate the optimal solution, we need to make some assumptions, and we need to do some calculations. So what are some of the calculations we need to do? Number one thing that is most important is that for any particular car, we will have to understand that how much time it takes to reach to the end. That is number one thing. And second thing is, cars can only reach to the target based on the current sequence locations they are present in. So even though if we see the car numbers over here, this C1 and C2 are located at the correct space, but this C3 is actually going to, even though this is the third car, this has to be the last car to reach to the end. So number one thing we are going to do is we will try to find that how much time does it take for any single car to reach to the end. We will try to store this information with the cars. So we actually have a couple of ways to store this. We can either store it using a hash map. That would only make things more complicated, because we don't need like a constant time access to that data. And same thing can be achieved using a 2-dimensional array as well. So we will try to use it, store it using 2-dimensional array. Okay. So in the 2-dimensional array, we are going to store the information for a subsequent car and how much time does it take to reach to the end. That is number one thing. Number two thing we are going to do is that we will actually sort these cars based on their positions. So number one car in that is going to reach to the destination is going to be the car that is closest to the destination position. So based on the position size, we are also going to sort them. And once we have that, we would be able to identify the answer quite easily. So now first let's try to understand that how do we actually calculate how much time does it take for any single car to reach to the destination. And that is a very simple calculation. All we need to do is we need to calculate the distance between the current position and the destination position, and whatever this distance is, we need to divide the speed by that distance, and that would give us the time on that particular car would take to reach to the final destination. Okay, so now the idea is quite simple. So let's just do that. So for C1, currently we can see that this is located at position number 10 and it needs to reach to the position number 12, which means the distance is 2. And the speed for C1 is also 2 miles per hour, which means it is going to take 1 hour for C to reach to the destination. Same way for C2, it is also going to take 1 hour to reach to the destination. Same way for this C4, it is actually going to take 7 hours to reach to the destination, because the difference between 5 and 12 is 7 and the speed of C4 is 1 miles per hour. Same way for the C5, the distance is also going to be 9 miles, and then the speed is 3. So it is only going to take 3 hours to reach to the destination. And last one is the C3 car. So for C3, it's actually going to take 12 hours to reach to the destination. Now we have our this list ready. Now let's try to sort this given list based on the position of the cars, which means once again C1 is at the correct position and C2 is also at the correct position. Both times are 1 hour and 1 hour. Then we have the car C4 and C5. So for the car C4, it is going to reach into the 7 hour mark, and car C5 should reach in 3 hour marks if there were no cars ahead of it. And the last one is the C0 car, or I think C3 car. So C3 car is going to take 12 hours to reach to the destination. Okay, so let's quickly do a recap what we did. We found out how much time does it take to reach to the destination. Then we sorted all of these cars based on the position where they are compared to the target location. So the higher the position, the first it is going to be inside our list, and in order to store this information, we are going to be using a 2D array. Now, after having this information, it becomes very easy for us to solve this problem, because all we need to do is we simply have to check, because we know for sure that this has to be the first car to reach to the destination. At any given moment, we realize that the speed of this is actually lesser or equal to the speed of its subsequent car. Then we can conclude that both of these cars would reach to at the same time. Let me rephrase. I used the word speed, but the correct word should have been time. So if the time it takes for the C1 car to reach to the destination is 1 hour, and we see that for C2, the time it takes is also 1 hour, which means C1 and C2 both are going to reach to the destination around the same time, just in a scenario where C2 is just behind C1. So we can conclude that these two has to be one single fleet. So this becomes our one of the fleets. Now in the second scenario, we have the time it takes for C4 to reach to the destination as 7 hours, and the time it takes for C5 to reach at the destination at 3 hours, which means C5 actually is much faster than C4. So eventually C5 would be close enough or just behind C4 before C4 actually reached to the destination. Let's try to once again understand using this plot, because after the very first hour, actually C5 and C4 would both be at the same place. And how do we find out? Because we can see that the time it takes for both of them to reach to the destination. So these two also has to be part of a simple fleet. Now say this last for the C3, instead of this being 12, maybe this also took 3 hours to reach to the destination. Then C3 would have also been part of this fleet, because C3 would reach to the destination in 3 hours, C5 would reach in 3 hours, and C4 is going to block both of them and cause both of these cars to reach at 7 hour mark, because C4 is ahead compared to C5 and C3. So this would have been part of this fleet as well. But in this scenario, because the time C3 takes to reach to the destination is actually greater than the previous fleet, the largest value in the previous fleet, then we can conclude that this C3 is not going to be able to catch up to the C4 and C5 fleet. So this is going to be our second fleet. And in the end, the C3 is going to be our third fleet. So that's all you need to do to solve this problem. Once we do have the sorted version of subsequent cars with the time it takes to reach to the destination, we can actually very easily compute, because for every single fleet, all we need to check is that what is the longest time it takes for those fleet to reach to the destination. So in this case, for the C4 and C5, it's gonna take 7 hours to reach to the destination. So if this number would have been anything less than 7, then it would have been part of this C4 fleet. But because it's not less than 7, so this has to be a fleet on its own. And that's it. That's what we need to do. And this is the whole solution. So now you see how beautiful this problem is and how awesome the solution is. Like, that's why this is really one of my favorite questions, because it's a combination of math and data structures, and then how do you make things more efficiently, and how can you think about different scenarios and different mathematical equations and stuff like that. Okay, so now let's try to understand the time complexity. It is going to be big O of n, because we are going to be simply iterating over the given input array bunch of times, but still it is going to be big O of n. But you forgot one critical thing, that is we will also have to do the sorting operation, and that is actually going to cause our time complexity to be big O of n log n. And if we see space complexity, well, for the space complexity is actually going to be big O of n square, because we are using a 2D array to store the information of the cars to its subsequent time it takes to reach to the destination. Overall, this is also a very good time and space complexity. Now let me know in the comments if you also want to see a solution using a monotonic stack, because this is pretty popular problem for that. So if you want, I can also show a solution with that. But I think this is a good enough solution for your interview. Your interviewer is going to be more than happy. And now let's just quickly see the coding for this one. So the coding solution is quite simple. First of all, we create an integer n to store the length of the given input array. And then we initialize our 2D array that we talked about, where we are going to store the information about cars and its subsequent time it takes to reach to the end. Then we are simply going to iterate over the given input array, and we are going to populate our cars 2D array that we just created, where we are going to mark the positions of the car, and also we are going to calculate that how much time does any single car takes to reach to the destination. Then we are going to do the most important operation, where we are going to sort the given cars based on the current positions of the given cars. Once we have that, now it is very convenient to solve this problem. We are going to initialize a counter 0, that this is going to calculate the fleet on what time it is going to arrive. And then we are going to have another variable where it is going to keep track that what was the previous time for the car to reach to the end. Then we are simply going to iterate over the given input 2D array cars, and we are going to check that if the value of any particular given car is actually greater than the previous time, which means that is a new fleet being created. So we are simply going to create a new fleet or add the value to the counter. And also we are also going to mark the previous time of the last car that just came in. And that's it. In the end, we can simply return this counter that we have created that was keeping track of every single fleet. And now let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs decently efficiently in terms of time complexity, extremely efficiently in terms of space complexity. And once again, the code is present inside our GitHub repository, so you can go and check it out from there. Thank you. Hello friends, hope you are having a fantastic day today. So once again, we are going to do an awesome LeetCode problem that is extremely popular at all sorts of IT companies. So without any delay, let's get started. So the LeetCode problem we are going to solve today is called largest rectangle in a histogram. This is a LeetCode hard problem and also an extremely well-liked problem. Now the statement is quite simple and straightforward. We are given an array of integer called heights that represent the histogram's bar height, and we are also told that the width of every single bar is 1. Now we need to return the area of the largest rectangle that we can make inside this given histogram. So this is all we need to return. And now let's try to understand this with an example. So for this, we can make a rectangle that looks like this. Now the area of this rectangle is going to be 2 because the width of this portion is 1 and the height of this portion is 2. So 2 times 1 is going to be 2. So same way, there are multiple different options we can have in order to generate the area, but we need to find the maximum area. And in this case, the answer would be retrieved using these values, where if we make a rectangle like this using these two bars, so now in this case, the area is actually going to be 10. Why? Because the height of this portion is 5 and for this one the width is 2. So 2 times 5 is going to be 10. So this is what we need to find and this is what we need to return. So brute force approach is actually quite straightforward and very simple. Now one thing we can do is that we can take this one single rectangle starting at position 0, and then we can see that what are every single possible areas we can make. So one area would be like this, second area would be like this, the third area would be something like this, fourth area would be something like this, and so on and so forth. And eventually we do every single possible combination based on every single position of the given rectangle bar height, and then eventually we would find a solution like this that contains the most optimal approach, and this solution would work fine. We would be able to eventually find the answer, but this is going to work in big O of n square time, because at every single time we are doing a lot of extra and overhead work. So what is the most common thing we can imagine? Well, number one observation we can make is, because we can see that the height for this 0th index is 2 at the moment, but the moment we want to consider this first index as in combination with this 2, then the maximum height we can imagine is only going to be able to 1, which means we are only at the higher height until we encounter a height that is lower than our current height. And whenever that happens, we will have to start considering the lower height, and we need to understand a couple of things. If we want to calculate the area, we need two items. First item is the height. So we already know that which height are we going to consider based on the lower height compared to all the other possible heights. That is number one observation. Second observation is we need to consider the width. So width we can simply calculate based on the current index position where we have, or we can also keep track of that where did that height started existing. That in terms of finding the right side boundary of any particular rectangle, we can only find it until we find a lower height that reaches. So there are actually three examples we can see very easily. First example is at this position number 2, or this initial first position where the current height is 2 and the current height is located at position number 0. But the moment we try to consider the next element, we will have to get rid of this height too, because now it is no longer in the existence, which means the maximum area we are being able to generate using this bar 2 is only going to be 2. Okay. Now next thing, another example is we just saw with the value number 5, that with value number 5 we can only say that we can use rectangle 5 or bar 5 until we reach to this index position number 4, and then so which means maximum area that this bar 5 can make is going to be of width 2 and height 5, so total is going to be 10. Same way for this 6 comes into the existence at index number 3, but since the height at index number 4 is actually lesser than the index number 3, which means this 6 only remains in existence just for one single bar. So the maximum area we can make over here is only going to be of size 6. And this is the whole logic. This is the whole meat of the solution. Now, after understanding this, we can actually make a suboptimal solution using the same very simple approach, and then we will try to improve upon that solution. So the suboptimal solution that I'm proposing is that at every single position we identify that what its right side boundary is and what its left side boundary is. So what is the maximum height and width we can make, and based on that we can do all sorts of calculations and then find the solutions very quickly. So let's try to see this solution in action. The idea is at this position, the maximum left side height we can make is 2.
The maximum right side height we can make is also going, the maximum width we are able to achieve is 1, which means the maximum area we can generate is only going to be 2. For this position number 1, the maximum width we are able to achieve is going to be 6, because this 1 remains in existence throughout this whole process, and the maximum height we can achieve is only going to be 1. So over here maximum area we can make is only going to be 6. Now at this 5, the maximum left side we can go is only up to 2, because it starts at position 2. The maximum in terms of right we can go is only up until position 4 or before position 4. So up to 2 and 3. So width is going to be 2. So over here we can make the area 10. For this height 6, we can only make the maximum height as 6. Same way at this position number 2, the maximum we can make is actually going to be this much, where currently the width is going to be 4 and the height is going to be 2. So maximum area we are able to generate is 8. And same way at this 3, the maximum we are able to generate is simply going to be just this one, because one before that is actually in the lesser height. So we can, maximum area we can make using only or the entire height of this area is going to be 3. And in the end we can simply return 10 as the answer. So what we did is, for every single element we try to see that what is the left limit, what is the right limit, and what is the total area we are able to generate, and then we can very easily store the answer. Now this solution would just be good if you provide this solution in an interview. It might even work, but the thing is there exists a better solution, where if we just use stack to keep track that what is the current index position and until what previous index positions we are maintaining that height, then we can very easily solve this problem. Why we need to use the stack? Because think about it, for every single position we are only going to have that position in existence until we find another bar with a lower height, which means the moment we find another bar with a lower height, we can actually go back to the elements that are already present inside the stack with the higher height and calculate the area. That's it. That is the whole logic. So now let's try to see the solution I'm proposing in action. So now let's just quickly initiate our stack. Now inside the stack, we know that this is going to operate in terms of last in first out principle. And the other thing is, we can actually keep track of the bar heights, but then we would also have to find that what was the initial position of this particular value. So rather than, a better approach is that we actually store the index values, and using the index values we can quickly look up that what has been the bar height at that position in big O of one time, because we already know the index position. And then we would be able to also calculate the width depending on the current index position and the existing index position inside the stack. So let's try to see the solution in action. So initially stack is empty, okay, and we are also going to have a variable where we are going to store the area. So let's just mark this one as max area that we have been able to calculate so far. Okay, so initially stack is empty. Now we are at this index position number 0. So we add index position 0 inside our stack. Okay, and currently we know that this height is 2. Now next thing is, we iterate over to the next element and we identify that currently we are at index position 1. So the height at index position is actually less than the height we currently have on the element that is already present inside the stack, which means this position of this element 2 is no longer relevant, because we found out a value that is lesser inside in its existence, which means this only exists until this portion. So we will try to we will pop this element out and we will calculate the possible area that this element has been able to generate. So currently for this first position, this has been the area it is able to generate. That area is going to be 2, that is the height, and multiplied by width, that is 1. So the maximum area we have so far is 2. Okay, now once again we are going to add value number 1 inside our stack, saying that currently 1, so the height of this 1 is also 1, and currently we will only pop 1 out when we either reach to the end of the array or end of the heights, or we find some place where the height is actually 0 and then we have some more elements. Okay, so this is always going to be relevant in this example. Now we are at index position number 2. So notice what happened at index position number 2. The height suddenly increased compared to what the height we already have, which means this 1 is still valid. So because it is still valid, we are going to keep it inside the stack, not popping it out, and we will add one more element 5 or this index position 2 on top of the stack, because now this is also relevant so far. So we are going to put 2 inside the stack, so its subsequent value is bar height 5. Then we identify height 6, which means this 5 is still relevant. So because 5 is relevant, we are once again going to add value number 6 on top of the stack, or sorry, not value number 6, but the index position of 6, which is value number 3. So we put value number 3 inside on top of the stack, and the height is 6. Now we suddenly encounter the value at index position number 4, that is height 2. So any single value that has greater than 2 height has to be popped out of the stack, because now that is no longer relevant, which means first of all this 6 is now no longer going to be relevant because the height is 6 and currently this index position is 3. And notice that the index position for this bar height 2 is 4, which means depending on the index position difference, we can actually calculate the width for which this 6 was relevant. So 6 was currently relevant for width 1. So currently let's pop 6 out. If we pop 6 out, currently this 3 is no longer present. We know that this was relevant for 1 width, which means width was 1 and the height was 6. So now the maximum rectangle we have been able to find is of size 6, which is greater than the previous maximum we had. So we are going to update that. Okay. Now are we done? No, because this is 2 and this value is 5, which means we would still have to pop one value out. If we pop one value out in this case, now notice that the height at this position is 2 and the height at this position is 4. So because this is a greater position compared to over here, so what is the width we found? The width is actually 2 and what is the height we have is 5. So this is the height, and also let's get rid of this 2 from our existing stack. Okay. And now this area is going to become 10. So let's just add an area 10. Now once again, we have this element 1 and currently this element is 2. So 2 is greater than 1. So because 2 is greater than 1, we are not going to pop 1 out because this 1 is still relevant. So we are just going to simply add 2 on top of 1. So let's just quickly add this index position number 4 with the height 2. Okay. And now currently next one, we found the increase inside the height, which means this 2 is still relevant. Because this 2 is relevant, we are simply going to add an element 5 on top. So we are going to add element 5 on top. Now adding index position number 5, now we reach to the end of the array, which means the moment we reach to the end of the array, we will have to start popping every single value out compared to its current position. So currently we pop value number 5 out, which means what is the height over here? The height is 3. What would be the width? Width would only be 1 because it is only relevant for this one portion, because currently we are at the end of our loop. So the area we have been able to calculate by popping this value number 3 out is going to be 3. Now currently 3 is less than value 10, which is the maximum area we have. So we are not going to update the maximum area. Okay. Now we are going to next pop out element number 4. So if we pop element number 4 out, it has been relevant for this much portion of the time, which means currently we have 2 multiplied by 2. So the area is going to be 4. 4 is also less than 10, which means this area is also not relevant. And last one, we will have to pop element number 1 out that has the size 1 or the height 1. So for this, height is going to be 1, and this has been relevant since position 1 until the very last position. So this has been relevant for the width 5. Oh, sorry, for the width 6. Since the very first position, it has been relevant. So now because this has been relevant since position 6, so the maximum area we have been able to generate is also going to be 6, but still it is not greater than the maximum area. So after the end of this loop, we can simply return the max area to be 10. And that's it. That's the whole answer. Now if we see time and space complexity, in this case the time complexity is going to be big O of n, and the space complexity is also going to be big O of n.
So the coding solution is actually quite straightforward. First, we have a variable called max area where we are going to be storing the maximum area we have been able to identify so far. Then we have our stack that we initialize, and we also have a variable n to store the length of the given array. Then we have our for loop to iterate over the given array. Now first we check for a condition that if the given I is equal to n, which means we have already crossed every single element, then we can mark the current height as 0, because this is to take care of the last element. If that is not the case, we simply take the value of the given subsequent height from the heights array. Okay. Now we have our while loop where we check that while the given stack is not empty and the current height that we have been able to identify for any given ith element is less than the current height that is already present inside the very first element of the stack, then we will have to calculate the area for that, where we simply calculate the height based on by popping the element out of the stack, and then we calculate the width by subtracting the value of the current I minus the current element that was present inside the stack minus 1, and then we calculate the max area where we compare two elements based on the given max area that we have been able to identify so far, and the given current height and width multiplication, or the current area that we have been able to identify, whichever is greater, we are going to keep it that. And in the end, after we run out of this while loop, we are still going to push the current element inside our stack. And by the time we are done with all the elements, we should have our maximum area being populated with the correct value, and then we can simply return that. So now let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And once again, our solution runs beautifully, extremely fast in terms of time and space complexity. So once again, the solution is present in the GitHub repository. The link is in the description, so you can check it out from there. Thank you. Hello friends, hope you are having a fantastic day today. So now we are going to do an awesome LeetCode problem that is extremely popular, and you are guaranteed to encounter this question in one of your interviews. So without any delay, let's get started. So the LeetCode problem we are going to solve today is called binary search, and we can see that this is a LeetCode easy problem and also one of the most liked problems on LeetCode. Now the thing is, you are always going to be using binary search in your interviews, but this is never going to be the direct question, because this is a technique that you have to master. So let's understand that what the problem statement is asking us to solve. We are given an integer array nums which is sorted in ascending order, which is great, and we are also given a target value that we need to find that whether it's present inside the given array or not. If it is present, then we need to return the index position of the target. If it is not present, we need to return -1. And we are also being told that we must write this algorithm in big O of logarithmic and time complexity. So let's try to understand what is being asked us to solve. Suppose we are given an input array like this. We are given the target value to be 9. So in this case, we can see that 9 is currently present inside this given array, and it is located on index value number 4. So in this case, we need to return 4 as the answer because 9 is present. Now in the same problem, suppose we are given that 10. So 10 is currently not present inside the array. So then we need to return -1. So this is what the problem is asking us to solve. It is very simple to understand. So brute force approach is quite straightforward. Suppose we are given the values like this, and we are being told that we need to find value number 4 inside this given array. So all we need to do is we can simply start iterating over this given array one by one and keep on going until we find the value or we reach to the end of the array. So in this case, since we did find value number 4, we can return the index position of this value. And we can see that brute force approach works as expected. But the thing is, if we see time complexity for this brute force approach, this is simply going to be big O of n. And we need to do things smartly. And for that, we need to take care of the property that is currently given to us in this array, that this given array is actually sorted. So if we use the sorted portion property of this given array, we can actually solve this problem in logarithmic time. So let's quickly see the optimal solution. So we can see that 9 is currently present inside this array. Now how we are going to use the sorted property of this is by doing binary search. So what binary search means is that we are going to take this entire array as whole. We are going to find the middle pointer of this array, and using the middle pointer we will compare that whether this middle pointer is smaller than our target array or is it greater than our target array. If this middle pointer is smaller than our target array, which means the target array has to reside on this portion of the given input array. So we can basically eliminate all of these three characters because they are no longer relevant. And if it is the other case, then in that case we can eliminate these three characters as well. So we will keep on doing that until we either reach the target value or we run out of the values to search for. And in this case we are going to initialize our array with having a starting pointer and ending pointer. So currently starting and ending are going to live at the edges, and this is going to allow us to find the middle pointer. So in this case, we can see that the target value is 9. The middle pointer we are able to identify is located at value number 6. So we need to check that whether this value number 6, if that is greater than or less than. So we can see that 6 is less than our target value. So because 6 is less than our target value, we can say for certainty that the target value can never reside on the left hand side of our given value 6, which means we will have to migrate our start pointer once again back to 6 and repeat the same operation. So now our starting pointer is going to live over here, ending pointer is still going to live on the same place, and now we are trying to find the middle pointer. Okay, so we in just one single iteration we eliminated 3 characters, and this is the pure definition of logarithmic time complexity. So once again for this we are going to find the middle pointer, and middle pointer is going to be find at value number 11. So now the next middle pointer is value number 11. 11 is actually greater than target value, which means that the target value can never reside on the right side of the this 11. So we can eliminate this character, and now we only have these three values 6, 9 and 11, and we are going to mark 11 as our ending pointer. So now once again we repeat the same operation and try to find the middle value. The middle value is 9 in this case, and 9 is actually equal to target, which means the index location of this 9 I think it's 4. So this is what we can return in the answer. And you see that we were originally given 7 different elements, but within just 3 iteration we were able to find that where does the middle point, where does our target value is present inside the array or not. If it was not present, let's assume that maybe this was value number 10. So we realize that we find the middle pointer, and now this is also not the target value we are looking for. So now we are going to have starting pointer and ending pointer living next to each other, and once again if we try to find the middle pointer we would not be able to find it. So we could have concluded that now the target value is not present. So in both the ways, using binary search is extremely efficient. You are going to be seeing the binary search in a lot of different problems across your entire technical interview journey, and also across a lot of LeetCode problems. So you must master this technique. If we see time complexity, in this case the time complexity is going to be big O of log n, because that's what we just did. And space complexity, well, we did not use any extra data structure or any extra space apart from storing a couple of variables. So this is going to be a constant space complexity as well. Now let's quickly see the coding solution for this one. Okay, so very first thing we are going to do is initialize couple of variables. First one is the left pointer and second one is the right pointer. Then we are going to run a loop that while left is less than or equal to right, we are first of all going to calculate the middle pointer, that is going to be the sum of left plus right divided by 2. And then we are going to check the conditions that if the given middle pointer is equal to the target value, then whatever the index position is, we can simply return that. If that is not the case, and we find out that the given middle pointer is smaller than the target, then we need to update our left pointer to come to the middle pointer. If that is not the case, then we need to update the right pointer, and that's it basically. In the end, we should have find the target in this loop if the value is present. If it is not present, we can simply return -1. So let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code.
and our code runs 100% faster than all the other solutions, that is because our code actually runs in constant time, or the number of test cases are very small. So that's why. And once again, the solution of this code is actually pasted in our repository, GitHub repository. So let me quickly show you that where all of the solutions are present. You can see on this GitHub repository, we have over hundreds of different LeetCode solutions. These are the most popular, most asked and most important LeetCode questions. And if you are preparing for your technical interviews, for sure, this can be a great resource for every single one of you. So you can go ahead and check it out. Also, I want to show you one more extra resource, that is this sheet that I have created. So you can see that over here I have a couple of lists. First list is 130 most popular and most liked technical interview questions of all time. Over here, all of these questions are separated based on topic, and I have also included that how many times these questions were asked at any particular company and what is their difficulty level. Is it easy, medium or hard? And for most of the questions, you can see that there are solutions available as well. So if you want, you can go and check it out. On top of it, NeetCode 150 is one of the most best resources for technical interview preparation. So I also started working on solving NeetCode 150 so I can get better at LeetCode, and also I can create videos that might help other people as well. So over here, once again, these are all the questions separated based on the topic and difficulty level. Majority of them are solved and the rest would be solved soon. So you can go and check it out. So both the links are in the description. I hope you find this resource helpful. Hello friends, hope you are having a fantastic day today. So now we are going to do an awesome LeetCode problem. So without any delay, let's get started. So the LeetCode problem we are going to solve today is called search in a 2D matrix. Now we can see that this one is a LeetCode medium problem and also an extremely well-liked problem on LeetCode, also really popular amongst top tier IT companies. Basically, we are given an m cross n integer matrix and we are told that it contains two important properties. First property is that each row is sorted in non-decreasing order. And next thing is that the first integer of each row is greater than the last integer of previous row, which means even the columns are also going to be sorted in an increasing order. Now we are given an integer target and we need to return true if the target exists inside this given matrix and false if it is not present inside the matrix. Also, we are told to solve this problem in big O of logarithmic m cross n time complexity. So now let's try to understand this with an example. Suppose this is an m cross n matrix we are given where m is equal to 3 and n is equal to 4, and we are told that target value is 3. So now let's first quickly assess the properties. We can see that every single row is in sorted order, and we are also being told that the last element of any particular row is smaller than the next element inside this next row, and so that eventually makes the columns sorted as well. Okay, and we can see that in this case this 3 is clearly present inside this given m cross n matrix, so we need to return true. They're saying that the 3 is present, but if we are being asked the target to be like something like 37, then that is not present, so we need to return false. Okay, so let's try to quickly see that what are the different approaches we can take to solve this problem. For the brute force solution, we don't need to do anything. Since this is an m cross n matrix, all we can do is just simply iterate over the given matrix one by one in a normal sequence, which can be done using two loops, and then try to see if the target value is present or not. If the target value is present, return the true immediately, and if we don't find and we reach to the end of this given list or given matrix and we don't find the target value, then we need to return false. This brute force solution would work as expected, but the thing is the time complexity is going to be big O of m cross n because we are iterating over all of these 12 characters that are present inside the matrix. So we need to speed things up. Number one thing I'm suggesting is that we know the target value we are trying to find is 3. We also know that the entire rows are for sure sorted. We also know that all of the columns are also sorted. So one approach we can take is that we compare the columns, and based on the column values, we check
that under which row should this target value be presented. So we can clearly see that when we compare the first element in this column versus the first element in this row versus the first element in this row, we can see that the target value 3 lies somewhere between column 1 and row 1 and row 2, which means if the target value is present, it has to be present inside this first row. So once we find that information, after that all we need to do is just simply do a binary search in this operation. So now we only have one row that we need to worry about. So now we can actually solve this problem using a simple binary search where all we have is a starting pointer and ending pointer. The target value we are given is 3. So we first try to find the middle pointer. Middle pointer in this case is going to be 5. So this is not the target value, and the target value is less than the middle pointer we find, which means target value has to reside somewhere over here. So once again we repeat the same operation. We update our end pointer, and then once again we do the binary search. We find the middle pointer, and then we simply return saying that yes, true, the given target value is present inside the given list. So let's try to see that what is going to be the time complexity in this case. So time complexity would be inside the given corresponding row, we will have to do and log n cross m work. So this solution would give us the desired result. But the thing is, we are doing an intermediary step in between to solve this problem. So let's try to see that do we have a more optimal solution than this one as well. And yes, we actually have a better optimal solution. The idea is we already know that every single rows are sorted. We also know that every single columns are sorted, which means the last value of any row is always going to be less than the first value of the subsequent row. So logically, instead of treating this as a 2D matrix, if we just try to understand this in a one-dimensional direction, we can actually see that this is a perfect example of completely sorted 1D array that is currently represented inside the 2D environment. And we can plot all of these 12 values inside this given graph. This is just a one-dimensional representation of this 2D array, and we can see that this is a fully sorted array. Now if we have to find the target value, let's say 3 in this case, the solution becomes quite obvious. All we need to do is just a normal binary search, and we should be able to find the result. But the thing is, we don't want to create an additional array. We want to do the binary search treating as if this 2D array was 1D array in this one. So once again we can also do that. For that, all we need to do is just we might have to play around with the starting and ending pointers. So initially our starting pointer is going to reside over here and our ending pointer is going to reside over here. We will need to find the middle pointers. So now if we have to find the mid pointer, the 16 is going to be the mid pointer. So compare 16 with our target value, and we can see that the target value is actually smaller than the mid pointer we find, which means we will have to update our end pointer to come one value before the mid pointer, because this is also not the target value. So once again, now we have our new starting pointer. Starting pointer is the same, and we have our new ending pointer. Once again, we are going to find the mid value. Mid value in this case would be value number 5. Once again, we can see that because this value number 5 is greater, so once again we are going to update our end pointer. So end pointer is going to be over here, start pointer is going to be over here. Once again we do the binary search, and we should be able to find the target value to be value number 3, and that's it. This is what we need to do, and this is the much better approach than brute force approach, and also a step improvement on our better approach that we saw. Time complexity, for sure it is going to be big O of log n m cross n, and we are not using any extra space, so space complexity is going to be constant space, which means this is a really good approach. And now let's quickly see the coding solution for this one. So first of all, we are going to define our m and n based on the given matrix value. We are also going to initialize two variables, left pointer and right pointer. Left pointer is going to be at the very first position inside the given matrix. Right pointer is going to be on the very last position of the given matrix. Then we are going to run our while loop. During the while loop, first thing we are going to do is to find our mid pointer. After finding the mid pointer, we will also have to point that mid value inside our given matrix, because remember the mid pointer is a single 1D value. Meanwhile, we are given the 2D matrix. So that we can do by doing the division of mid pointer with the value 9 and doing the modulo or with 9 or finding the remainder value. So this is going to give us the exact value of the what the mid pointer should be in a 2D array. And then we simply do our binary search, and based on that we update and manipulate the left pointer and right pointer values. And in the end, if we do find the target value, it should have been returned through here. If it is not present, then we can simply return false. So let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs 100% faster than all the other solutions, which is pretty awesome. This is also an excellent use of space complexity as well. So once again, the solution is present in the GitHub repository that we have created, and the link is in the description. You should be able to find it from there. Hello friends, hope you are having a fantastic day today. So once again, we are going to do an awesome LeetCode problem that has been asked at tons of companies, and it's actually a pretty fun question to solve. So without any delay, let's get started. The problem is called Coco eating bananas. This one is a LeetCode medium problem and also a very well-liked problem on LeetCode. Basically, we are being told that Coco loves to eat bananas. Now, Coco is a very famous gorilla, and we are given two items. We are given a piles array which contains that every single element in this array represents the number of bananas that particular pile has. And we are told that there are guards who are typically protecting the bananas, but they have gone out for 8 hours. So we are given these two items as an input. Now Coco decides to eat her bananas per hour eating speed of k, and each hour she chooses some pile of banana and then she eats k bananas. So whatever the speed we decide, she tries to eat that. If the pile has less than k bananas, then she eats all of them and will not eat any more bananas during this hour. And the most important thing is we need to return minimum integer k, such as she completes all the bananas within each hour, and we need to make sure that this k is the smallest element possible, because Coco likes to eat slowly. So let's try to understand this problem with an example. So over here we are given piles. This represents that pile 1 has 30 different bananas, next one has 11, and next one has 23, and so on and so forth. And we are being told that the guards have gone for 6 hours. Okay. So now we need to figure out that in this 6 hours, what should be the speed of banana eating for Coco in order to complete every single banana in each of the pile, and also at the same time make sure that she tries to eat in the slowest speed possible. Now, one important detail is that at any given moment, Coco can only eat bananas from only one of these piles. She cannot jump around between the piles from hour to hour. So let's say that currently we have the speed of banana eating at 50 per hour. Then let's assume that in the first hour, she decides to eat 30 bananas, which means she still has time to eat 20 more bananas, but she would not go to the next pile to start eating them. She will only eat 30 and then wait for 1 hour, and during the next hour she will go to the next pile and once again start eating bananas. But once again she still has room to eat 39 more bananas, but she would not move to the next element. Okay, so maximum hours we have is 6. That is number one thing. Now let's see that what are some of the options that we can consider. For assumption, we take the largest number in this pile, that is 30, and we say that Coco eats 30 bananas per hour. So then in how many hours will she complete eating all the bananas? So during the first hour, she would complete this pile. Then during the second hour, she would complete this pile, and so on and so forth. In every single hour, she will complete each of the piles, and then she would have still completed her banana eating in 5 hours. So less than 6. But the thing is, question is, can we go smaller than 30? That is also a question. We need to find the minimum number. So let's say that we try the second smallest element, that is 23 per hour. Then how many hours will it take for Coco to complete all the bananas? So if we do 23 hours, so k is equal to 23, then logically in the first hour she will complete 23 bananas, so she would still have 7 more bananas left in this pile to complete. So during the second hour she will also complete 7 more bananas. Then during the third hour she will complete 11 bananas. Then during fourth hour she will complete 24. Then fifth, then 4, and then sixth hour she would complete these 20 bananas. And then by the time of 6 hours she would have completed all the bananas in every single pile, and her speed would be 23, which is significantly less than the previous speed that we were considering, that was 30. Let's try to consider one more speed. Okay, let's say that instead of 23, can we go smaller than 23? So let's try 22. Okay, so if we try to do 22, then this pile would take 2 hours, this pile would take 1 hour, this pile would once again take 2 hours, and then these two piles would also take 1 hour. So if we do total sum of this actually becomes 7, so that is greater than 6, which means speed 22 is no longer feasible for Coco to eat bananas. So minimum speed she can use in order to complete all the bananas and at the slowest speed possible would be 23. And this is what the problem is actually asking us to solve. Well, brute force approach is actually quite simple, because we know for sure that the maximum value has to be the maximum value that is currently present inside the given piles, because we are being told that the inputs are valid and legitimate, which means that if she eats the speed at the maximum number of bananas that are present inside all the piles, then by that limit she should be able to complete every single one of them. But that is not going to be the ideal scenario. Maybe it might have been ideal if instead of over here, instead of this h being 8, we only had 4 hours to finish, then we have to eat at the speed of 11, but that is not the case. So what is the minimum range? Okay, so maximum range that Coco needs to eat bananas is going to be the maximum value, so 11. The minimum range can be value number 1. Okay, that let's say that in this case we actually have sum of all of these values. We have 28 hours. If we have 28 hours, then if she eats 1 banana per hour, then also she can complete this entire pile, but that is also not the case. So we find our maximum and minimum ranges. So logically what we can do is we can simply take every single range and then try to go over to see that if that range satisfies the property of completing the banana eating, and then we can come up with the answer. So we already know the logic. Let's say that with 1 we can complete, it would take us 28 hours to eat all the bananas, but 28 is greater than 8, which means 1 would not work. So we try to do it with 2. If we have to do it with 2, once again it's gonna take, let's say 15, so it's gonna take 15 hours, but this is also greater than 8, so 2 is also not going to work. So on and so forth. If we repeat the same process, we would find the answer 4 in this case, that this is the number of bananas she needs to eat in order to complete the entire pile. So logically this solution works as expected. Okay, that is number one thing, brute force approach. But the thing is, the time complexity in this case would be big O of n, where n is the number of the sum of all the bananas that are currently present inside the combination of all the loops. But we will try to do things slightly faster. So let's try to see that what would be the optimal approach in this case. Now, for this given example, I have actually calculated the speeds from 1 to 11 for every single hour, the banana eating speed, and I have marked that at that particular speed, how many hours will it take for Coco to complete eating all the bananas. And the important thing in this case is we need a value where we reach value number 8 at the very first time. The moment we hit very first time, that is the minimum speed Coco should eat bananas at in order to complete all the bananas within the given hours for which guards are away for. So logically, we can make a very important distinction over here, that with increase in the value of k, we can see that the value of h reduces significantly in a sorted and descending order, which means we can see that there is a descending property over here that is being maintained. Now the question is, we need to find the minimum value, but the lucky thing for us is that we actually can use the benefit of this property of this value being sorted to our advantage. What we can do is, instead of using the brute force approach where we were starting from k is equal to 1 and then just going in the linear fashion for every single bananas until we hit value number 8, we can actually use binary search in this case in order to complete this problem. Now let me show you that how doing binary search would be the greatest thing since sliced bread in this approach, because we have our minimum range, we have our maximum range, which means we know for sure that our answer has to lie somewhere between this, because any value above 11 will always yield us the result as 4. We can go even with a speed of 50 and still it is always going to give us the result as 4. Which means the important thing is that once we have our left and right pointer or the minimum and maximum values, so let's mark them. So currently we have our left pointer and we have our right pointer located at these two positions. Our aim is to find the minimum value in this k that represents that h becomes 8 for the first time. And the logic is quite simple. We take L and R, we try to find the mid pointer. So we check that for this particular one, what is going to be the mid pointer? I think mid pointer is going to be this value number 6. So for value number 6, what is the total number of hours that we can use in order to generate the answer? So we can see that this value is 6. 6 is actually less than value number 8, which means this is one of the legitimate scenarios. But the question is this the minimum value we can reach 8? No, because we will need to find the value that equals to 8 at the very first moment. So then once again, now we are going to bring our right pointer one step before this one and we will have a right pointer on this location. Once again, we will try to do the mid operation. So now if we do the mid operation, we realize that mid pointer is actually this one. So this is actually hours is equal to 10, which is greater than the target hour we had, that was value number 8. Which means we will have to increase the speed in this case. So since we have to increase the speed, we will have to update our left pointer. So we will update our left pointer to come over here. Now we have two values left and right located adjacent to each other, but still we will try to find the mid pointer in this case. So in this case, if we try to take the advantage of the ceiling value, we will find mid pointer to be value number 4. Okay. And then this refers to value number 8, which means this is exactly what we are trying to find. But the thing is, we are not sure if this is the smallest value or not. So for that, what we can do is we can simply check one value adjacent to it before it to see that if that value is actually greater than or less than value number 8. If that is less than 8, which means we might have missed some values where 8 started forming, which we did not. So in this case, we know for sure that this has to be the smallest value of banana eating speed that we can use in order to finish all the bananas within the given 8 hours. Now we all know that how to calculate hours for any single pile. For that, we simply have to iterate over the given array, see that what are all the bananas are, and at that speed, how many bananas can be completed in that particular aisle. So that for that calculation, we can simply use a helper method to complete that. And basically this would yield us the complete result in order for us to find the answer. So now this is a beautiful solution for an awesome problem, and it contains one of our very near and dear species. So that's always pretty good. So now let's try to find the time and space complexity in this case. Time complexity is quite simple. It's going to be big O of log n in order to complete the binary search. And if we will also have to do some computation in order to find that how much time it takes to eat all the bananas. So let's say that becomes big O of h. But the thing is that calculation is always going to be finite. Why finite? Because we know that the number of given input size n is going to be finite, and we will have to iterate over all the elements in order to calculate that. So that operation in itself is going to be big O of n. So in this case, the total time complexity is going to be big O of n log n, because for every single pair that we can make up until this log n time or till that optimal period, we will have to find that how many hours it takes to calculate the results, which is going to be much faster than our brute force approach, because in the brute force approach, we had to do this big O of n work, but we had to do it for every single possible value of k. So we were actually getting big O of n square result. And if we see space complexity, well, in this case, I just draw this additional data structure for your understanding. But actually, apart from storing few variables here and there, we don't have to use any extra space. So this is also going to be big off one. So this is a beautiful time and space complexity to solve this problem. Now let's see the coding solution for this one. So here is the solution. So first we are going to initialize two variables, left and right. Now for the right pointer, we will have to find the maximum value inside our given piles. So we are going to do that with using a for loop. Then we are going to run our binary search logic, where we are going to check that while left is less than right, we are going to find a mid pointer, and then we are going to call our helper method to check that whether we can finish finding the given piles using the given mid pointer or the speed that we have been able to find with the given h hours in the input. Now let's understand the logic for the can finish helper method. First, we are going to mark that the initial hours are going to be 0, and then we are going to compare that in order to complete this piles, how many hours it's going to take. So we are going to check that if the number of speed is going to be greater than any particular pile, then we can finish it in 1 hour. If not, then we need to increase the hour. If the number of hours are less than or equal to the given value h, we can determine that speed can actually finish all the bananas. Then we need to check that whether the right pointer is equal to mid. If that is not the case, we need to find that left pointer is going to be mid plus 1. And in the end, whichever is the left pointer has to be the answer. So this solution would work as expected. And now let's try to run this code. Okay, seems like our solution is working. Awesome. Let's submit this code. And our code runs pretty fast compared to a lot of other solutions in terms of time complexity. It is really good in terms of space complexity as well. So once again, the solution for this code is presented in our GitHub repository, so you can check it out from there. Thank you.
Today we are going to do find minimum in a rotated sorted array. And if we see some of the companies where I want to get a job who already asked this question, there are companies like Microsoft, Amazon, Uber, Facebook, Apple, Bloomberg, Google, and TikTok. So that's why I'm paying my utmost attention. I hope you also enjoy the video. So this is a LeetCode medium problem, and basically we need to find the minimum inside a rotated sorted array. Now you will ask that what does a rotated sorted array means? We are actually given some definition of what a rotated sorted array is. If you want, you can iterate over this definition. The thing is, let me quickly show it to you by an example. Basically, we are originally given a sorted array. Now for this sorted array, if we take the rightmost element and put it on the leftmost position and all the other subsequent elements, we flip it one side on the right side, we can determine this to be rotated one time. So if I take this original sorted array and if I rotate one time, so one time rotated array is going to look like this. You can see that this 5 that was originally at the rightmost position has been flipped to the leftmost position, and all the other values we shifted them one position on the right. Now if I rotate this one more time, so eventually I would have rotated this array to 2 times. Basically the result I would get is going to look like this, there where the first two values are 4 and 5, and then we have 1, 2 and 3. Now over here, this 4 that was originally over here, that came to this place. Now we can rotate it like 3 times, 4 times, as many times as we want. Like we can only rotate it up until 5 times because there are only 5 elements. Now basically in any rotated array, we need to find that what is the minimum value that is present in it. So if we try to understand this with an example, over here we are given some array where the original version of array was 1, 2, 3, 4, 5 that got rotated 3 times, and we were given this as the input. Now if we see the minimum value in this case is 1, so we need to return 1 as the answer. We are also given one key important detail that we have to find, that we must write an algorithm that runs in big O of log n time. So that is the key part. First, let's see that what is going to be the brute force approach to solve this problem. Well, the brute force approach that comes to our mind is that why don't we start iterating over the given array. We have a variable called min or answer or whatever you want to call it, and then we start iterating over all the subsequent elements one at a time, and whenever we find a lower value, basically we update that in the min variable. So eventually when we start iterating, when we would have completed iteration, we would find the value 1 to be the lowest value that we can find inside this array, and that we are going to return as the answer. This solution leads us to the correct answer. There are no issues with this one. But why this brute force solution does not work in your interview or anywhere else is because this solution actually happens in big O of n time, because we are iterating over all the n elements. And we were explicitly told that we need to solve this problem in big O of log n time. So that's why this brute force solution won't work. Now, whenever we see log n solution, immediate thing that comes to our mind is that we are going to use binary search, right? And that is true, that we are going to use binary search in this case. But before we do that, let's make some logic clear. Well, the key part of the logic we have is that if we compare the left and right element for any given array, if the array is completely sorted, which is the case in over here, that the entire array has been completely sorted, there are no mismatching pairs, right? So because this array is completely sorted, if we compare the leftmost element and rightmost element, or any element with its left element, basically we would find that the value at the left element is always less than whatever value at the right element we have. Like if we compare these three variables, and if we compare the right variable to be over here, basically again in this case the right is 3 and left is 1, so we can conclude that this whole portion is sorted. If we have the right variable located at this position, basically we have the value of left to be 1 and right to be 5. Again, left is less than 1, so we can conclude that this whole portion is actually sorted. So the lowest value that we can achieve in this whole portion between this left and right is going to be whatever value that is located at the leftmost position. Now whenever we compare the left value and right value, and we determine that left is actually greater than right, if we find that left is actually greater than right, we can determine that the minimum value exists somewhere between left and right. We don't know that at what position minimum value exists, but the thing is we need to achieve to the direction where we can actually find left is less than right. Because remember, over here currently the value of left is 3 and value of right is 2. So in this case left is actually greater than 2. Whenever we have to find the minimum value, we will have to move in a direction where we will reach to a conclusion where left is less than right. And in order to achieve that, what we are going to do is we are going to compare the value of the left to the middle pointer that exists, and depending on the value of the middle pointer, we would determine that the minimum value, if does it exist on the left side of the middle pointer or on the right side of the middle pointer, and depending on that we will update our value of left pointer or right pointer. So let me show you with a broader example what I'm trying to say. So I have drawn a big example over here, and first let's assign our initial values of left and right. So we have the values of left and right set up for us. Now we know that we need to reach to a position where left is less than right. If that is the case, then we will have some interesting results, right? But currently if we see, the value of left is 2 and value of right is 1, so left is actually greater than 1. So now we will have to move in some direction. So now what we are going to do is we are going to find the mid value, and also remember we are going to have an answer variable that is going to store the lowest value we have been able to find so far. So currently the value of left is 2, value of right is 1, right? So we are not going to do anything in the answer yet. Now we are going to find the middle pointer. So the current middle pointer is going to be at position number 4. Why? Because left position is 0, right position is 8. So 0 plus 8 is equal to 8 divided by 2. That gives us the middle value, and middle value in this case is going to be the 4, right? So the value that is located at the 4th position is 6. Now we need to compare the values between left and mid. Left and mid, if we compare, left is 2 and mid is 6, so 2 is less than 6. Now remember, whenever we identify that the left value is less than whatever the value we compared, we can dictate that every value in between is actually greater than the value of the left, which means that no value amongst these values can be the answer or can be the minimum value, because remember, we already know that on the right hand side the value is actually less than left, and because of that we will have to update our migration on the right side. And also remember, whenever we compare the value of left value with the mid value, whatever the lower value is, we are going to store it. So currently the lowest value we have been able to find is 2, so we are going to store 2 as the answer, right? Now we are going to switch our left pointer to go on the right side of the mid. So now let me clean this up a bit. So now this is going to be our new left pointer and this is going to be our new right pointer. Again we are going to compare the value of left and right, so left is actually greater than right? So now we will have to find the mid pointer. Mid pointer in this case is going to be left plus right divided by 2. So current value of left is 5, right is 8. So 13 divided by 2, if we put it floor value, we will get the value of 6. So 6 is going to be the middle pointer in this case. So now we have this 6 to be the middle pointer. Now we are going to compare left with the middle pointer, and now in this case left is actually less than middle pointer, which means that answer cannot lie between left and middle pointer, and again we will have to update the value of the left pointer. Also for this leftmost value we will compare that whether we need to update the answer or not. So answer currently we had was 2 and this is 7, so we don't need to update the answer and we are good up until this point. Okay, now again we determine that this value is not the answer. Now our left pointer comes at this position, our right pointer comes at this position. Again we are going to compare the values of left and right. So currently left is actually less than right, and that is the ideal scenario, that we found that left is actually less than right, which means that now left is at the correct position to be the lowest position that it can be before it iterates or it takes over right. And now because of this one we are going to update, we are going to see that whether we need to update our answer or not. So current answer we had was 2, and because left was less than right, we are going to compare the left value with this answer value, and the left value is actually 0, so we are going to update the answer to be 0. And in this case this is the correct answer that we are able to find, and we are going to return that. Let's try to understand the same thing with another example. So in this case left is over here, right is over here. Currently left is actually greater than right, so because of that we will have to find the middle value. So middle value is going to be this one. So now if we see, currently the left is actually greater than middle value as well, which means we cannot determine that the left and middle portion is actually completely sorted. We can only determine that the middle and right portion is completely sorted. So in this case we are actually going to update the value of the right pointer, and we are going to determine that these are all the values that are not part of the answer, so we can just simply ignore them and we will not do anything for these values. So now currently our right pointer comes over here. Now because of that we are again going to repeat the same process, and we will try to find the middle value. Middle value in this case is going to be 8, right? So we are going to compare left with the middle value. So left with the middle value, if we compare, left is actually less than the middle value. If that is the case, we can determine that no value over here is the minimum value, so we can simply ignore that, and now our left value becomes this one, our right value becomes this one. And now if we compare, left is actually less than right. Left is less than right, that is the ideal scenario that we were looking for, which means that now left is at the correct position where the value is actually minimum, and in the answer we are going to denote the value to be 0, and that is going to be the answer we are going to return. Now if we see time complexity, in this case the time complexity is actually going to be big O of log n, because remember, during any single iteration we actually removed the half of the candidates that we were trying to search for, and that is why we are actually using binary search in this program to solve this problem, and that is the logic we are going to use. And now let's move on to the coding. So first of all we are going to initialize 3 variables, left, right and answer. Now we are going to test for an edge case that if the nums array only has one element, basically we can return that as the answer. Okay, if that is not the case, we are going to run our while loop, that while left is less than or equal to right. First we are going to check that if the current left and right position makes the array completely sorted or not, and that can only happen if the value at number of left is actually less than whatever the value of nums at right we have. And if that is the case, we are going to see that whether we need to update our answer or not. If that is not the case, we will have to calculate the middle pointer. So first we are going to initialize a value called mid, and we are going to calculate the middle pointer. After calculating the mid pointer, we are again going to check that whether we need to update our answer or not. Now we are going to see that which way on the mid pointer do we need to take the jump. So if we find out that the current value of left is actually less than or equal to mid value, then we will have to update the value of left pointer to the right side of the mid. And if that is not the case, which means we will have to update our right pointer. Basically, that's all we have to do for our binary search operation. After this loop ends, we can simply return whatever we have stored in the answer. And now let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our code is actually pretty fast compared to a lot of other solutions, and I would be actually posting the solution in the comments so you can check it out from there. Today we are going to do search in a rotated sorted array, and if we see some of the companies where I want to get a job who have already asked this question, there are companies like Amazon, Microsoft, Facebook, LinkedIn, Bloomberg, Apple, TikTok, ByteDance, Google, Goldman Sachs, Uber, and eBay. So that's why I'm paying my utmost attention. I hope you also enjoy the video. This is a LeetCode medium problem and also a very well-liked problem on LeetCode. Basically, we are trying to search an element inside a rotated sorted array. Now, if you notice, this is very similar to one of the previous videos we solved recently, and you can check it out that over here. Now, we are basically given an array called nums, and we are also given a target value, and we need to check that whether this target value exists inside this nums array or not. If it does, we need to return the index of that target value. Now, the special part about this question is that the nums array we are given is actually a sorted array that has been rotated certain times. So it sounds confusing at first that what does a rotated sorted array means. So you can either read this definition that has been provided over here, but let me make it a little bit clear for you. Basically, a rotated sorted array is that initially an array is a fully sorted array, which is the case over here. You can see that all the elements are sorted and they are all in ascending order. And the thing is, whenever we rotate one time, basically we take the rightmost element, we put it on the leftmost side, and then we flip all the elements one side or one position to the right. And that is how we rotate and rotate a sorted array. So if we consider this to be the original array, suppose we rotate it one time, we will get a result that looks like this, where this 5 that was originally on the rightmost position came on the leftmost position, and all the other subsequent value we jumped it one step on the right side. If we rotate it 2 times, again the 4 and 5 would come on the left side and all the values would be shifted 2 times on the right side. If we rotate 3 times, basically all the values would be rotated 3 times, and we would get an array that looks like this. So the idea is we are given a form of a rotated sorted array. The thing is, we don't know that how many times it has been rotated or whatnot. We are also given some target element, and we need to see that whether this target element exists inside this array or not. So suppose this is the array we are given as the input, and we are given target is equal to 3. If that is the case, then in this case 3 exists inside this array and its index value is 0. So we need to return 0 as the answer. And this is what is being asked for this problem. So now let's see that what are going to be a couple of different approaches to solve this problem. The first approach we have is a brute force approach. In the brute force approach, what you can do is, suppose this is the array we are given and we are given the target value to be 0. Well, if we see what we simply do is we start iterating over this array one by one, and every single time we iterate until we find the value that exists. If the target value exists inside this array, whatever its index position is, which is 3 in this case, we return that as the answer. And if we somehow reach to the end of this array and we do not find this target value, we simply return that okay, the target does not exist, right? The thing is, this solution is not the most optimal solution. Why? Because the time complexity for this solution is going to be big O of n. Meanwhile, if we read the problem statement, we are explicitly told that we need to complete this in big O of log n time complexity, and this big O of n is just not good enough. Okay, before we come up with the optimal solution, first let's understand a couple of concepts regarding the sorted arrays, right? For the sorted arrays, if we compare any left element with any right element, if we at any point identify that left is actually less than right, and we know that this given array is a sorted array, right? And this left is actually less than right. So if that is the case, all the elements between this left and right will be sorted in ascending order. That is one of the properties of a sorted array. We already know that. Now, the tricky part we have is that the array we are given is actually rotated. So the thing is, we will have to take care of this rotated part as well, and we don't know that how many times it has been rotated. So suppose we are given an array like this. This has been rotated few times, right? Now, whenever we compare the left element with the right element initially, we can clearly see in this case that left is actually 3 and right is actually 2, which means left is actually greater than right. And remember, we already know that when left is less than right, we already know that all the elements in between, they are actually sorted. And if we are trying to find some target value that falls between this left value and this right value, we can immediately find that target value. Suppose we are given the target value to be 3. We know that left value is 0 and right value is 5. So because of that, this target value has to be somewhere between this 0 and 5, because it can only exist between 0 and 5 because this portion is sorted. 3 cannot be outside of the scope. The thing is, we cannot say that for certain in this case, because over here currently if we see, left is actually greater than right, which means we can determine one thing, that this whole portion is not sorted. But the thing is, we already know that a chunk of this portion is sorted, which is this, that 3 4 5, this is sorted in ascending order. Again, same way, this 0 1 2, that is also sorted in ascending order. Why? Because this was a rotated array, right? So the thing is, what now we are going to do is, we are trying to find some target value, right? So our aim is that, suppose we are given the target value to be 4, right? Now we are trying to find the value 4. The thing is, for this rotated array, the idea we are going to use is that when we determine that left is actually greater than right, which means that this whole portion is not sorted, right? That is the key part. This whole portion is not sorted, but some chunk of this portion has to be sorted, and that we can determine by defining some middle value. So in this case, suppose we put down a middle value. So suppose we have a middle value that is 0, right? Now with this 0, what we are going to do is, we are actually going to compare this left with this middle value. If we compare this left with this middle value, left value is equal to 3 and middle value is equal to 0. So if that is the case, left is actually greater than middle value. So since that is the case, we won't be able to do much over here. And basically what we will do is, now again we are going to compare this middle value with this right value. So currently middle value is actually 0. The right value is actually 2. So middle value is actually less than right, which means because this was the rotated array, we can determine that all the values between this middle value and this right value is actually completely sorted. This is the important property that we have to define, that this whole portion is completely sorted. Because of that, now we will see, okay, our target value is actually 4. The current middle value is 0, current right value is equal to 2, which means 4 does not fall between 0 and 2. Because it does not fall between 0 and 2, we can concretely say that 4 cannot be part of this particular chain. So immediately we can ignore all of these cases, and now what we'll do is, we will shift our right pointer to one step before mid. Why? Because we were certainly able to say that this sorted property of this rotated sorted array help us determine that 4 is not part of this one. All the elements between these portions were between 0 and 2. Now we are going to move our right pointer over here. So let me clean this up a bit. So now currently our left pointer is here, right pointer is here, right? Now if we see, left is equal to 3, right is equal to 5. If that is the case, left is actually less than right, and this is what the golden thing we wanted. Now we can clearly determine that this whole portion 3 4 5, that is completely sorted. Because this is completely sorted, all we will have to do is just use binary search in order to find the target value. So what we are going to do is, we are going to compare the middle value. So middle value in this case is 4. 4 is actually exactly the target value we are looking for. So we will return the index position of 4, which is 1 in this case, as the answer, and the answer over here is going to be the one that we are going to return. Now after explaining this whole thing, let me quickly go over one of the examples to see that how we will solve optimal solution using binary search. Okay, so now as mentioned, we are actually going to do the binary search operation on this rotated sorted array, right? And the target we are trying to find is the value number 0. Now we are going to use our 2 pointers. So first pointer we have is left, that is located at this position number 3, and right pointer is located this position number 2. In this case, currently left is actually greater than right, which is not what we want. So now we will have to determine that which portion of the array is sorted, and based on that, where this target value could lie. So we are going to compare with the middle value. So in this case, the middle value is going to be 7, right? So now we have this value number 7 that is located as the middle value. Okay, now for this middle value, we are going to compare it with left and right value. So currently if we see, left is actually less than middle value, and this is what we wanted. The moment we identify left is actually less than middle value, we can clearly determine that this whole portion is completely sorted. Okay, now we will compare the target value we are looking for with the values of left and mid. So if we see, the target value is actually outside the scope of this left and mid, which means that target value cannot exist between these places. Immediately we can determine that. So we will ignore all of these cases, and now we will have to update our left pointer to go on the right side of the middle pointer. So we will do that. So now we will have our new left value located at this position, and the new right value located at this position. Now we are again trying to find the value 0. Okay, now immediately over here we can see that left by itself is actually 0, so that makes our life much more easier, and we can simply return the index value of this left to be 5 as the answer. And in this case we are going to return answer as the 5, and basically all we are doing is we are actually using the middle value to determine that which portion of the array is sorted. Depending on that, and based on the target value, we decide that which way we will have to make the jump, and then we get our desired answer. If we see time complexity, in this case the time complexity is actually going to be big O of log n only. Why? Because remember, in a single iteration we were able to get rid of all of these elements immediately, which means every single iteration we are doing like half, we are getting rid of half of the elements. So that is why the time complexity is log n, and that is what we wanted. If we see space complexity, in this case the space complexity is actually going to be constant space, because we are not using any additional data structure. First of all, we are going to define a couple of variables left and right. Okay, now we are going to initialize our while loop, that while left is less than or equal to right. And inside our loop, first of all, we are going to calculate the mid pointer. Now we are going to check for the condition that if the given value of mid, if that is equal to target, if that is the case, we can simply return the index at mid. Okay, if that is not the case, now we will have to first of all define that which portion of the mid pointer is actually completely sorted. So first let's put the condition that if the given value of left, if that is less than or equal to whatever the value of mid is, if that is the case, we can define that the values between left and mid is completely sorted, right? So now all we will have to do is we will have to see that where target lies. Does it lies between left and mid value, or it lies somewhere else? So first we are going to see that what if the target lies outside of left and mid value. If target lies outside, basically we will have to update our left pointer to go mid plus 1, and we will continue with our journey. If that is not the case, which means target lies between left and mid, and if that is the case, we will have to update our right pointer to come between left and mid. So we will do right equal to mid minus 1. Okay, now we take care of the scenario that the numbers of left is not less than or equal to mid, which means that the values between mid and right is actually sorted. And if that is the case, again we are going to repeat the same process. First we are going to check that whether the target value is outside the scope of mid value and right pointer. So if the value is outside of the scope, which means we will have to update our right pointer to search on the other portion of the array. So right is going to become mid minus 1. And if that is not the case, which means that the values lies between mid and right value. If that is the case, we will update our left pointer to search between mid and right. So left would become mid plus 1. And basically this loop should take care of the scenario, and we would be able to find our answer. And just for the sake of putting something outside so we don't get a compilation error, we are going to return minus 1, but our answer would have been returned by this. Now let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs pretty efficiently compared to a lot of other solutions. And I would be posting this solution in the comments, so you can check it out from there. Thank you.
Hello friends, hope you are having a fantastic day today. So once again, we are going to solve an awesome LeetCode problem, but now we are also going to learn a very popular advanced data structure in this problem. So I'm going to pay my utmost attention. I hope you also enjoy the video. So the LeetCode problem we are going to solve today is called time-based key value store. We can see that this one is a medium problem and also a very well-liked problem on LeetCode. The problem statement is actually quite a long. Basically, we need to implement a time map class, but there are a lot of conditions in order to implement this time map class. So we need to design a time-based key value data store that can store multiple values of the same key, but based on the timestamp. So depending on at what timestamp, what key value we received, we need to store that. And we also need to retrieve the same key value pair depending on the certain timestamp, the value that we have been provided. Now, number one, we need to initialize the object for the time map data structure that we are trying to create. And we also have to set two methods. First one is a set method where we are providing three values. First one is the key, second one is the value associated with that key, and third one is the timestamp associated with both of these keys and values. Now, next one is a get method where we are providing the key for which we want to get the value, and we are also providing the associated timestamp. So based on using the combination of these two, we should be able to find the value associated with this particular key. The other thing is, if say for an example, for this timestamp we don't have the value associated with the key, then we need to find the closest value that was present at that particular timestamp, and for some reason we don't find any value for the key, then we need to return an empty string. So let's try to understand this with an example. Basically, we need to create a data structure, and that data structure needs to store three items. First item is the key, that is going to be the unique pointer. Second value is the associated value with that key plus the timestamp. Now the other thing is that typically we usually see that keys tend to remain common in data structures like hash map and other like hashing based algorithms. But in this case, we can have multiple keys with the same value, but the only difference would be timestamp. So in this case, the value would not be truly unique because the entire value portion is actually combination of value plus timestamp. So let's try to understand. Currently we have an empty data structure. Now let's try to enter the values, parth as the key and the vyas, that is my last name, as the value. And we are also providing the timestamp at 1. So at timestamp 1, we enter these values, which means in our data structure, we should have the key as P, and we should have associated value as vyas, and the value, this was located at value number 1. Now let's say for some reason during the timestamp number 2, once again I provide the value parth. I also provide the value as, let's just say j, and that's it. The timestamp is 2. Now once again I'm going to store the value p, and this time the associated value is going to be j, but this is located at timestamp number 2. Now once again I have another value parth. Once again the value is k, and once again the timestamp is 3. So once again I'm going to have another entry in my data structure for parth. The value associated is k and the timestamp is 3. Now say that I do a get operation. For the get operation, I provide the value as key parth, and I also provide the timestamp to be 2. So in this case, the answer I should be receiving back would be value number j, because j was the value stored for this parth key at timestamp number 2. So this should return a j as the answer. Let's say once again I do another get operation. This time I provide the value parth as the key, and as the timestamp I provide value number 7. Now you must be wondering that, hey, we don't have any value stored at value number 7 as part of the timestamp, because we currently only have 3 timestamps, that is 1, 2 and 3, and for each one we have a subsequent values stored inside our data structure. So in this case, the idea would be to find the closest value for this particular one. So the floor value associated with this timestamp, which is going to be value number 3, because 3 is the first value we can reach from timestamp number 7, and for this the value associated was k. So we are going to once again return k as the answer for this one. Now let's say that for some reason I do a get operation for, let's say, John, and I provide the timestamp to be 5. So once again I don't have any entry for John, so this should return us an empty string. And once again I can do a set operation. I can add value number John, I can add the associated value as Sina, and I can associate the timestamp to be 6. So now in this case, the value once again we are going to have a new entry called John and associated value Sina. So this is the whole idea of the type of data structure that we are trying to design.
Now let's try to see some of the possibilities with this type of data structure that we are trying to convey. Now think for a scenario that if we only had to design a data structure where we are simply dealing with a key and its associated value. There is no such concept of timestamp. Let's just say that if this is the case, how would the things might behave? The idea would be quite simple. We can simply implement a hash map. Inside the hash map, we typically store values based on the key and its associated values. And we can store all of these values one by one based on the distinct key values. And we can simply complete all the operations in big O of one time, like insertion, deletion, searching and whatnot. So this is a very easy way for us to store the values. Now in the same example, what I'm suggesting is that instead over here as part of the key, once again we use hash map, but now for this hash map, in part of the value, rather than storing just the value as it is, we actually store an instance to another hashing solution, and this hashing solution should have another block like this that contains two values. First one is the value and second one is the timestamp. And based on this, it should be able to store all the values that we need, and we should be able to find particular timestamp on that particular value, and we can return all of those values. And this is actually the whole solution that we need to build up. The idea would be that we are actually going to use the combination of hash map to store the standard key and its association to store another hashing solution. And we all can understand that why are we using hash map to do that, because hash map does all the operations in big O of one time, plus it's a hashing solution. If we identify at any point that there is an existing key, we can do that operation in big O of one time. And also for the associate value, we can actually directly have multiple values. But in this case, we don't need multiple values. We need a separate hashing solution. For that, I'm suggesting to use a tree map. Why are we using a tree map? Well, first, before going down deeper into understanding that why are we using tree map, first let's understand that what a tree map is. So tree map is actually built on top of a hash map. That is number one thing. Tree map contains a very similar property where once again we can have a key value pair operations and we can store bunch of different values. But the other thing is that tree map is actually contains a property of a binary search or logarithmic time valuation storing property. So how does it do that? Well, actually tree map is built based on red black trees. Now let me know in the comments if you want to understand more that how does red black trees work, because in itself it's a very interesting topic to learn, and it has many practical use cases and applications. Basically what red black trees allows us to do is that instead of normally having a single hash map where we are only dealing with simple key value, in tree map we are dealing with three values. We are dealing with a key, we are also dealing with a value, plus we are dealing with an extra bit that stores the value of a color. And storing the value of this color actually allows us to identify at any given moment whenever there is a conflict, this color has to be the difference maker, which we can actually use to find that what was the value associated at that particular time. So I know it sounds confusing, but it's actually very simple to understand, because this property actually allows us to store all of these values in a binary search manner. And we all know that how does a binary search work, that typically we can go in any particular direction to find the value we want. And in this case, the particular direction or the color would be dependent based on the timestamp that we fetch the value at. And that's it. This is the whole solution. So let's try to run the solution with some example, and then it would make more sense to you. We know that we need two items. We need our hash map and we need our tree map. Now the thing is, for hash map we are simply going to have key as part of the key that we are coming in as an input. As part of its value, we are actually going to store the subsequent tree map instance. So as the tree map instance would be unique for every single value, And inside the tree map instance, the unique part is that we need two items. One is key and second one is value. So as part of the key, we are going to store the timestamp, and as part of the value, we are going to store the associate value that we are given in the input. So let's say that first input we have is key is parth. So I'm just marking it as P. Associate value is Vyas. So once again, I'm just marking it as V, and the timestamp is value number 1. So in this case, currently we don't have any entry. So we are going to create a new value P. Associated with parth, we are going to have associated tree map that we have to consider. So this instance of the tree map would be marked over here. Okay, so let's just say that this is the instance of tree map. Okay, and inside the instance of the tree map, we are going to store 1 as the value that we have, or as the key, because this is the timestamp, and its associate value, we are going to store value number Vyas. Now let's say that once again we received the value for the same key parth, and now this time the value is H and the timestamp is 3. So once again for this same path, we already have the entry, so we already have this one. Now all we need to update inside the existing timestamp. So for this one tree map, once again we are going to have another entry 3, and now this time the value is going to be H. So we store the value H over here. Once again we get another entry parth. Once again the value is, let's say, X, and the timestamp is 5. So once again we only have one entry inside our hash map. We have the timestamp to be 5, and we have the value X associated with that. Now let's say we receive another value John. Now the value is Sina, and the timestamp is 7. So we don't have entry over here, so we are going to create a new entry John. Now we also have to create a new instance of the tree map. So we are also going to do that for the John. And over here we are going to have our timestamp and value. Timestamp in this case is going to be 7, and value associated is going to be Sina. And this is how the whole solution would work. Now let's say at any given moment I want to do a get operation. If I try to do get parth at timestamp number 7, so currently I will go over here because this is the key for parth. Now once again this would take me to this tree map. For this tree map I don't have value number 7. But I have something closest. Now the thing is, all of these keys inside the tree map are actually stored inside some sort of a binary search tree or a red black tree, which means finding that where does value number 7 exist should only take us logarithmic n time, and not actually n time in a normal hash map it would take. So in this case, we can find out that 7 is not present, but 7 is not present. We can also find out that what is the largest value present, that is value number 5. So associated value is X. So for this operation, we can simply return X as the answer, that, hey, this is the value associated closest to this particular timestamp. And same way, if we get another entry, let's say get John. And for John, we also get timestamp to be 9. So once again, we can just go to John. We go to its a subsequent tree map. For this tree map, the largest entry is 7. The associate value is Sina. So we can return Sina as the answer. And that's it. This is how we can use the combination of tree map and hash map to store all the values. Now let's try to calculate the time and space complexity. In this case, the time complexity is going to be big O of log n for the set operation, and also big O of log n for the get operation. And why log n? Because tree map operates in logarithmic n time complexity, because it's a red black tree, and I'm also repeating because this is a very popular concept, so that's why. Space complexity. So space complexity is actually unique to calculate. It's going to be big O of k. So k presents number of unique keys multiplied by number of total values that we are being given. So k multiplied by n, because we only need one hash map to store all the unique keys, but per unique key we also have to create multiple tree maps. So that's why space complexity is a little bit higher, but time complexity is extremely fast. And this solution actually is being used in many applications such as cache or some sort of like high time functioning time based data structure that you are trying to design. So that's why this question remains a good amount of popular. Okay. So let's see the coding solution for this one. First of all, we are initializing our private hash map where we are going to store the value of the key and its associated tree map as its subsequent value. Now let's initialize our tree map with a new hash map.
Now for the set method, we are given 3 values as an input. First one is the key, second one is the value associated, and third one is the timestamp. So for that, we are actually going to store the value inside our hash map, and we are going to check that if the key is not present, so then in that case, we need to create a new entry for key and its subsequent tree map. If that is not the case, then we are going to simply put down the value inside our time based on the timestamp and the value inside the tree map, okay, after creating the new instance. So this is the set method. For the get method, we are simply checking that if inside the what is going to be the key portion for the tree map, for that we need to do map.getKey. So that is going to give us the value of the value that we are looking for inside the tree map. And we are going to check that if the tree map is equal to null for that particular entry, then we can simply return null. If that is not the case, then we need to check that what is the floor timestamp associated with the current timestamp that we are given. And we can check that if we don't find any entry, we can simply return null. If we do find an entry that is closest to that particular timestamp or that timestamp exactly, then we can simply return that value. And this is how the solution works. Let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. Okay, our code runs pretty good in terms of time and space complexity. There can still improvements be made, but this is going to be good enough solution. So once again, the solution is present inside our GitHub repository. So if you want, you can go ahead and check it out from there. Thank you.
So we got a job at FAANG, but we are not going to stop making LeetCode videos because it's pretty fun for me. So today we are going to do median of two sorted arrays LeetCode problem. And if you see some of the popular companies who have asked this question, there are companies like Amazon, Apple, Goldman Sachs, Microsoft, Google, Bloomberg, Uber, Facebook, LinkedIn, and ByteDance. So that's why I'm paying my utmost attention. I hope you also enjoy the video. So despite being a hard problem, this is a very well-liked problem on LeetCode. Basically, we are given two sorted arrays, nums1 and nums2, and we are told that they could be of different size. So the size can be respectively m and n, that is given over here. Now we need to return the median of these two sorted arrays. We are also told that the overall runtime complexity should be big O of log of m plus n. The solution I'm going to show you today is actually going to do even better than this big O of log of m plus n. I'm actually going to solve this problem in big O of log of minimum value of either m or n. So before we understand this problem any further, first let's see that what does a median mean. So a median is basically any single position inside any given array where everything on the left hand side and everything on the right hand side is actually of same length. So whatever the amount of element it has on the left side, the same amount of elements it has on the right side. Now there could be two cases. There could be like odd numbers or there could be even numbers. And for each one of them, I'm going to show you how to calculate the median. So suppose if we take this first example, in this first example, we can clearly see that we are given three elements, and based on the definition of a median, everything on the left and everything on the right has to be same. So if we consider this element number 5 is the position where the left of 5 is there is one element and the right of 5 is also there is one element. So in this case, 5 is going to be the median for this given array. Now if we take a look at this one, in this example, things are a little bit tricky because this is an even number. So in the even case, we actually have two elements in the middle who form the middle portion such that their left portion and right portion becomes of equal size. So in this case, for this particular middle portion, the left value has one element and the right value also has one element. So both of these are part of the median. But the thing is, in the median, there cannot be two values. So if such case arises, which is for even numbers, we are actually going to do the average of them. So in this case, we are going to do 3 plus 4 divided by 2, which is 7 divided by 2. So we get the answer as 3.5, which is the median for this particular array. If we take this example, again, this is simple. This value number 5, again, this falls in the middle. So because of that, we are going to note 5 as the answer because there are two elements on the right and two elements on the left. Now, again, for this case, we have the value this 4 and 6. that creates the middle point such that the left values and right values becomes of the same length. So in this case, the median is going to be 4 plus 6 divided by 2. So again, we get 10 divided by 2. So the answer is 5. And this is the median for this kind of case. Now, after understanding what a median is, first let's see these two examples so it makes things more easy. So in the first example, we are given two arrays nums1 and nums2. We can clearly see that they both are sorted array. Like this one only has one element, but still it's sorted, right? And now we need to find the median of these two arrays. So if we find the median of these two arrays, if we combine these two arrays, we will get an array that looks like this, that is sorted, right? Because we need to find the median of two sorted arrays. So this is the combined array. In this case, 2 is going to be the median because that is the middle point where there is one element on the right and one element on the left. Same way for this one, if we try to see, the length of this is actually 2 plus 2, so the total length is 4. Now if we make a combined array, the combined array looks like this. And in this case, if we want to find the median of this one, we will actually have to do an average of these two middle portions. So we'll do like 2 plus 3 divided by 2, so we get the answer as 2.5, and this is what we need to return as the answer. So let's see that what are going to be the different approaches to find the median of two sorted arrays. The first solution that comes to our mind is a brute force solution. In the brute force solution, the idea is actually simple. If we just combine these two arrays and create like a combined sorted array, we get an array that looks like this. Now once we have this combined array, all we have to do is just find the median. So in this case, the median is going to be this value number 5, because on the left hand of the 5 there are going to be exactly 5 elements, and on the right hand of the 5 there are also going to be exactly 5 elements, and this 5 is the answer we need to return. So this solution would give us the correct answer, this brute force solution. But the issue with this solution is that in order to create this combined sorted array, we will actually have to complete this solution in big O of m plus n time. So that is a linear solution, and the thing is that is not what we want. We actually want a logarithmic solution. So let's see that what is going to be the approach for the logarithmic solution. Okay, so before we come up with the optimal solution, first let's try to understand some really important concept. Suppose we are given two arrays that are x and y. We are told that they both are sorted in ascending orders. Now we know that their length is actually respectively 5 and 6 in this case. So the total number of elements we have is actually 11 if we do like 5 plus 6. Okay, so now here we are trying to find the median of two sorted arrays. And the thing is, the median, how we are going to find is that, okay, currently we are given these 11 values. So these 11 values, they are combined of these two. Now this 11, we can actually create two partitions. How we are going to create two partitions? So the logic we are going to use is that every single time, whatever the combined sum is, we are actually going to do like plus 1 divided by 2. So in this case, the value we will get is 11 plus 1. So that is 12 divided by 2. So 12 divided by 2, the value we are going to get is 6. So now first partition we will have to do is of 6 elements. And second partition we will have to do is remaining elements. So remaining elements in this case is 11 minus 6. So that this is going to be 5 elements, right? And whichever is going to be the maximum element of this 6. So maximum element of these 6 is going to place somewhere over here in the middle, and that is going to be our median. Now the thing is, how can we define that this maximum value is going to be the median? What are the properties we are going to take for this 6 and 5 value per partition that we are trying to create? And the answer lies right in front of our eyes, that the sorted property has to be maintained. So what does the sorted property has to be maintained means? It means that all of these 6 values that we are trying to create on the partition, they all has to be less than or equal to the values of the 5 on the right hand side. Okay, so that is a very important property for us to understand. I am telling this again, that all those 6 values that we have on the left hand side, they have to be less than or equal to all the values on the right hand side. Why? Because we are trying to find the median of two sorted arrays. If they are not sorted, then it's like a big mess for us, right? So because this is the sorted properties maintained, now what we are going to do is, we don't care about finding these 5 values. All we are going to put our focus is to finding these 6 values. Now these 6 values, they can exist anywhere inside this x and y. It could be possible that we take like 3 values from x and then we take 3 values from y, and that is how we create the 6 values. It could also be possible that we take like 2 values from x and 4 values from y, and that is also how we create these 6 values. No matter whatever the logic we are going to use, we will always have to be certain that all the elements on the left hand side, they have to be less than or equal to all the elements that are on the right hand side. And using this property, we are going to come up with some very interesting results. So the idea we are going to use is that first of all, we are going to take whatever the lesser value we have in terms of length among both arrays. So currently in this case, the lesser value of length we have is of array x. So currently for this x, the length we have is 5, right? So what we are going to do is we are actually going to do 5 plus 2. So 5 plus 2, we get value of 2.5. If we take the ceiling value, we get the value to be 2, which means that now we are going to take two values from this x. So if we take two values from this x, we will get the values x0 and x1, that is on the left side of the portion. Now, if we take two values from the x, which means total we are trying to find like 6 values, because remember, we are trying to find like the two partitions. One partition is 6, second partition is 5, and all the 6 values has to be less than or equal to these 5 values. So because we are trying to find the partition of 6 values, which means we took two values from the x, so we are going to take 4 values from y. Now, if we create a partition like this, what is going to happen? Well, all the remaining elements, they are going to be on the right side of the partition. So currently the remaining elements we have. So now we have our two partitions, right? Now for these partitions, again, we will have to make sure that this property is maintained. So how can we check that? Okay, over here we are 100% certain that this x1 is always going to be less than or equal to whatever the value of this x2 is. Why? Because we are told that this x array is already sorted. Same is true for this y array, that this y3 is always going to be less than or equal to this y4. This property is always going to be there. So there are no issues with that. But where the issue comes? The issue comes to the place where we don't know that whether this x1, if that is less than or equal to this y4. Same way, we don't know that whether this y3, if that is less than or equal to this x2. So in either case, we are going to do the following. First, we are going to take the smaller value. Then we are going to find that what is the partition we are trying to make depending on the starting and ending value. So currently the starting value over here is 0 and the ending value is 4. Okay, so we will, if we do that, we get the value of 2. Now we are going to take two values from here. If we take two values from here, then we will have to check that what are the remaining partition for y and how many values we are going to take from y. So currently from y, we are going to take 4 values. Now for all of these values, we are going to check that whether this x1 is smaller than this y4, and same way whether this y3 is smaller than this x2. Once the moment we find both of them to be matching, great. If we don't find anyone to be matching, suppose we find out that this x1 is actually greater than this y4. If that is the case, then what needs to be done? Well, the idea is simple. Because this is a greater value and this is a smaller value, which means that this x1 has to go on the right side and this y4 has to come on the left side. Now you will ask that why both of them has to happen simultaneously. Well, if both of them does not happen, how are we going to maintain the number of elements that are needed? Because currently the number of elements that are needed are 6 on this side and 5 on this side. So we have to make sure that we maintain that property. So how can we do that? We can do that by shifting this ending point to come on this side. And rather than keeping like both of these values, we might only keep one value over here and we will try to keep 4 values from here. And same way, if we find that this y3 is greater than x2, again we are going to repeat the same process by shifting the starting point on the right side and repeating the same process. So let me quickly explain the whole process with some examples, and then it is going to make things a lot easier to understand. Okay, so now suppose this is the example of x and y values we are given. I have calculated the total number of elements we have, which is 11 in this case, which means, as explained previously, the left partition that we will have to make, that is combined of x and y elements, that has to be of size 6. Now for this x partition, what we are going to do is, depending on the starting and ending value divided by 2, we are going to calculate that how many elements are needed in the x position, and based on that we would calculate that how many elements are needed in the y, from the y side or from the y side of array, based on this formula of like 6 minus whatever the value we achieve from this x position, and then we will try to compare the values. So first of all, okay, currently this value is 0, this value is 4. If we do like 0 plus 4 divided by 2, we get value as 2. So now, which means that inside this x portion, we are going to take 2 elements, which means for this y portion, we will have to take 4 elements from this y. So now, because this is the left portion, we are going to take the leftmost two elements inside the left array, which is 0 and 3 in this case. And from this y portion, we will have to take 4 elements, which means we are going to take the first 4 elements over here. Once done that, basically now we have our left partition setup. So now because we have our left partition setup, we can automatically create our right partition from the remaining values, which are, now we know for sure that this 3 is always going to be less than this 5 because they both belong to X array, and same is true for these two. The thing is, now we are going to do the cross comparison. So currently this 3 is less than 13, which is great that we don't have to worry about anything. The thing is, for this 12 is actually not less than this 5. 12 is actually greater than 5, which means that because we have some element inside this Y array which is greater, we will have to move this one on this side, and we will have to move this value on the left hand side. So now what we are going to do is, because we will have to add more values from the X, we are actually going to shift our starting point. So where we are going to shift our starting point, the idea is that previously we had the values of S plus E equal to 0 plus 4 divided by 2, like, okay, this value. So we had the middle point as 4 divided by 2 is equal to 2. So now, because this is a binary search, we are actually going to do like 2 plus 1 for the starting point. So now our new starting point comes at position number 3. Okay. So now this is the new starting point. This is the new ending point. Now again, we are going to use the same logic. So now for this X partition, a few things have changed. So currently our starting position is 3, ending position is 4 divided by 2, which is 7 by 2. So we get the value 3.5, but we use the ceiling value. So now from this X portion, we will have to take 3 elements. So if from the X portion, we will have to take 3 elements, which means even from the Y portion, we will have to take 3 elements. So let's do that. So this is how the two partitions are going to fall now this time. Now again, we compare. Okay, so this 5 is less than 12, so which is good. Now this 8 is still greater than 6. So again, we will have to move one element from this to the right hand side. So again, we are going to update the value inside our X pointer to move the S element to the next side. So how we are going to do it? Okay, currently this value is 3, this value is 4. So now again, we are going to repeat the same process. So we get the value, okay, 3 plus 4 divided by 2. So we get the value of 7 divided by 2, which is 3. Okay, so now we get the value to be 3 plus 1. So this is going to be the new start point. So currently our start and end point, they both fall on the same position. So this is the start point, this is the end point. Now again, for this X partition, let's see that how many elements we are going to need. So we will have value 4 plus 4 divided by 2. So 4 plus 4 divided by 2 is going to be 8 divided by 2. So the value is going to be 4, which means we are going to need 4 values from the X partition. So from the Y partition, we are going to need 2 elements. So let's do the math, and now let's create the new partitions. Okay, so these are the two partitions we have. Now let's compare. Okay, so 6 is less than 8, great. 2 is less than 11, great. So now we have created two partitions such that on the left hand side we have 6 elements, on the right hand side we have 5 elements. We were able to calculate that using the total elements we had. The sum we used was total plus 1 divided by 2. So 11 plus 1 divided by 2. So we get 6 elements on the left hand side. Now from these 6 elements, because the total length was odd, so because of this was odd, so what we are going to do is from this left portion, we are going to select the maximum value. Now you would say that, hey, do we need to calculate all the values on the left portion to calculate the maximum value? And the answer is no. Why? Because all we have to do is check these two values. Whichever is greater value is going to be the maximum value on the left portion, because all of these values are sorted. So amongst first 4 values, this is the maximum value, and same way amongst these two values, this is the maximum value. So if we compare the maximum value between these two, basically we will get our desired answer. And in this case, the answer is going to be 6. And because this was the odd case, this 6 is going to be the median that we are looking for, and this is going to be the correct answer. Now let's take one more example with odd case and see that how things work out over here. Suppose this is the second example we are given. I did some math. So total number of elements we have is 12. which means that if we want to calculate that how many elements we need in the left portion, basically we are going to do like 12 plus 1 divided by 2. So in this case we get the answer to be 6.5, but we choose the ceiling value, we choose the floor value, which is going to be 6. Now for this x portion, we are going to do like starting plus ending divided by 2. So first, currently the starting and ending positions are this one, so we get the value to be now, which means we are going to take 2 elements from the x portion. So if we are going to take 2 elements from the x portion, we are going to take 4 elements from the y portion. So let's do that. These are the two partitions that we have created. Again, let's compare the values. So first, 8 is less than 6. No, that is not true. 8 is actually greater than 6. The moment we find 8 is greater than 6, we will have to move this 8 on the right hand side and we will have to move this 6 on the left hand side. So let's do that process. So in this case, now what we are going to do is we are actually going to update our end value to come on this side. So again, previously what was the end value? The previous end value was position 4. Now the new end value we are going to create is we are going to find the middle value. So the middle value currently is 0 plus 4, depending. I'm talking about these like starting and ending values. So 0 plus 4 divided by 2. So this is the middle value is 2. So for this ending value, we are actually going to do 2 minus 1. So now let's update our ending position. So our ending position is now going to come at this position number 1. Okay. Now again, we have the updated value of starting and ending values. So now let's try to calculate this x portion and y portion again. So for now, this time this x portion is actually going to be 0 plus 1 divided by 2, which is going to be like 0.5. But again, we are choosing the floor value, so we will get the value to be 0, which means we are going to take 0 values from this x portion. So if we are taking 0 values from this x portion, which means that we will have to take 6 elements from this y portion, which is okay, cool. No, nothing wrong with that. Okay. So now we have these two values. Now let's do our partition. So now we have created our two portions. Now in this case, because from this x portion, we are not going to take any values. We currently have 0 values, right? Now the thing is, previously we have been comparing like this. The thing is, currently in the x portion, we actually have 0 elements. So if we have 0 elements, how we are supposed to compare with this one? The idea we are going to use is that every single time we are going to compare we are going to consider that this like first value is actually negative infinity and this last value is actually positive infinity. So the minimum and maximum value possible on each one of side. So in any case, we come up to this edge case where we need to find, we don't have any values on one portion, we don't get stuck. So we will try to consider this to be negative infinity value. Now negative infinity value is always going to be less than whatever value we have. So it's always like going to be less than 15, which is great. Now we compare these two values. So 7 is actually greater than 0. So because 7 is greater than 0, now what we will have to do is we will have to move our 7 to go on the right side and we will have to try to bring one element from this x portion. So let's do that. So now we are again going to update the values of our starting and ending values. Now this time we will have to update the start value to go on the right side. So currently the starting position is 0, the ending position is 1. Okay, so the new start value, we will have to find the middle value. So middle value is going to be 0 plus 1 divided by 2, which is going to be 0. We have already established we are trying to taking the ceiling value. So the new starting value is going to be 1. So let's update that and now we will try to recalculate the whole thing. Now this x position, the number of x element is going to be 1 plus 1 divided by 2. It is going to be 1. So we are going to take one value from this x position, which means we are going to take 5 values from the y position. So let's compare x and y positions. So now we have our two partition setup. So if we compare the 0 with 7, the 0 is less than or equal to 7. That is correct. If we compare the 6 with 8, 6 is also less than or equal to 8, which means that this is a correct partition amongst left and right values. Now in this case, the combination value is actually even for left and right case. So because this is even value, what we are going to do is we are going to pick the maximum value from this one. So maximum value from this one is going to be 6. And we are going to pick the minimum value from this portion. So minimum value from this portion is going to be 7. Now again, same logic, we are only going to compare these two values to find the maximum value. So in this case, we will get that value to be 6. In order to find the minimum values, we are going to only compare these two values. And in this case, the value we are going to get is 7. So now we are going to do the average of these two. So we will get the value of 6 plus 7 divided by 2, which is 13 by 2. So 6.5, that is the answer. And that is the median we need to return. And that is the whole logic behind using this technique. Every single iteration, we are updating the values of starting and ending point only in the array that has the smaller length. So in this case, both the times x had the smaller length. So we are only working on that, and depending on that, we are generating our answer, and we are able to find successfully the median value. So if we calculate the time complexity in this case, the time complexity is actually going to be big O of log of minimum of m or n, and in this case, whatever the minimum value is, we would be able to find the median easily. See space complexity, in this case the space complexity is also going to be big O of one constant space. Why? Because in order to store like the portion, we don't have to store this whole things. We are only concerned with 4 elements, like the minimum of x, the minimum of y, maximum of x, and maximum of y. And using these 4 elements, we can do all sorts of magical things. So this is a very good time and space complexity, and this is a very tough question in my opinion. So if you are able to crack this in an interview, all the companies would be like more than happy to have you as the candidate. So first of all, we are going to compare the lengths of nums1 and nums2. The idea is that whichever has the smaller length, we are going to keep it first. So if not, we are just going to call it recursively again with different inputs. Now we are going to initialize two variables called x and y, and we are going to assign the length of respective numbers. Remember, x is the smaller length and y is the greater length. We are also going to assign two variables called start and end. So start position is going to have the value 0, and end position is going to have the value of whatever the value of x is. Now we are going to run our while loop, that while start is less than end. Now first we are going to calculate that what should be the x portion. So we are going to name it as x part. Once we calculate the x portion, it's easy to calculate the y portion. Okay, now we are going to calculate 4 important characters. Those 4 characters are left value of x, right value of x, left value of y, and right value of y. Now each one of them, we are, for every single left portion, we are going to see that if that subsequent like x part or y part, if that value is 0, we will have to put like minus infinity or plus infinity for those values. If not, we will put whatever the subsequent value we can find from this nums array. So let me calculate those 4 values. Now we have our 4 values that we are going to need. Now we are going to compare that if the x left and y left, if they are both less than y right and x right, if that is the case, which means we can simply return we have found the correct portion, and depending on whether the total number of values are odd or even, we can simply return the answer. And if that is not the case, we will have to update our start and end variables. So first let's calculate for the correct case. Now we will have to calculate that whether the sum of these nums1 and nums2, if they are odd or even. So if they are odd value, we will simply pick like the maximum value that we have on the left portion, and if it is like the even value, we will pick the maximum value from the left portion and minimum value from the right portion, average of both of them. And if that is not the case, which means the value is odd, so in that case we can simply return the maximum value. If that is not the case, we will have to check that which one end we will have to update. So first we will see that if the given x left, if that is greater than y right, which means we will have to update our end value to come before mid, or else we will have to update our start value. It's basically it. We should get our answer this way. If we don't get our answer, we can simply return 0 outside the loop, so we don't get a compilation error. Let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs pretty efficiently compared to a lot of other solutions. And I will be posting this solution in the comments so you can check it out from there. Thank you. Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to do reverse linked list problem, and essentially this is a very easy but very important lead code problem, as it has been asked at a bunch of different companies. So this problem has been asked in companies like Amazon, Microsoft, Apple, Bloomberg, Facebook, Google, Nvidia, Adobe, Uber, and also IBM, eBay, PayPal, other companies like Goldman Sachs, and then ByteDance, and a few other companies. So I'm paying my utmost attention. I hope you also enjoy the video. Hello friends, I got my results back from my Goldman Sachs interview and I didn't clear it, which means that I have a long way to go and I still have to do a lot of work on my coding and lead coding skills. This is a LeetCode easy problem and it is one of the most liked problems on LeetCode. Basically, we are given a head of a single linked list and we need to reverse the given list and then we need to return the reverse list. So problem statement is quite easy to understand, and even if we see the example is also quite easy to understand. Basically, we are given a list like this 1 2 3 4 5 and we are at this position and we are given this head value of this linked list, and basically we need to return the reverse list. So in this case the reverse list is going to be 5 4 3 2 1. So essentially we are just iterating over in this direction and this is what we need to return. The thing is, there happens to be a little bit more complexity because we are told that this is a single linked list. So in single linked list all the elements are just stored in a single manner, which means that this element only knows that what elements comes after it. It does not know that what is the element before it that is pointing to this position. So this is the concept of a single linked list, and we will see that how can we solve this problem. Okay, so we need to reverse the linked list and we are told that the linked list we are given is actually a single linked list. The thing is that what is the property of a single linked list? That every node in the given linked list actually has the value of that particular node and also has the pointer towards the next node inside the linked list. And whenever we encounter that next node is actually pointing towards null value, we can determine that this is the end of the given single linked list. The issue over here is that we know that at any single position what is the value after it using this next pointer, but we don't know that what was the value before it. There is no way for us to identify this particular item, which means that our aim is to find that how to reverse this linked list. And in order to reverse this linked list, what we can do is, rather than pointing towards the next pointer, we can, if at any given position for all the nodes, if we just point it towards the reverse direction and basically start our linked list traversal from the last node, we can simply return the reverse linked list immediately. And this is the approach we are going to take. Now the question comes that how at any point we can actually, originally we were pointing on this side, how can we start pointing on the reverse direction from any single node? And in order to do that, what we will have to do is we'll have to keep track of the previous character or previous node as well, and apart from keeping track of the current node. So the approach we are going to use in this case is that every single position, suppose we are at this element, so this is the current element we are at, right? From this current element we know that how to get to the current dot next, or which means that how to go to the next element we already know that. The question is we don't know that how to go back. So what we are going to do is we are going to keep track of a previous character or previous node that will always be behind this current node. So in this case this would become our previous node, and all we will have to do is that over here the current dot next is actually pointing towards this node 3. So rather than current dot next pointing towards this node, we are going to have current dot next point towards the previous element, and we are going to do iteratively for all the values. So initially at the beginning this would be our previous and this would be our current. So over here this value will be pointing towards this on this side, so null value. Now again we will switch our values for previous and current. So this would become our previous and this would become our current, and again we will flip the value, and again we will repeat the same process. So this would become our previous, this would become our current, again we will flip the direction, and at the end this would become our previous. And if we see the previous dot next element, it would be a null sequence, so we would know that okay, this is the end of the original linked list, so this has to be the start of the new linked list, and then we can just start iterating over, which means that we would have taken care of all of these pointers, and now we can simply return the reverse linked list in this fashion, and this would be our answer. So if we see the time and space complexity in this matter, the time complexity for this one would be big O of n, and the space complexity would only be big O of 1, because at any given position all we have to do is just keep track of couple of variables, nothing more than that, and that should take care of all the scenarios. So first of all, we are going to create a new list node, and we are going to name it as previous, and we are going to initialize the value as null, and we are also going to create a list node called current, and we will have it start at the head value. Okay, now we are going to iterate over the given linked list. So while current is not equal to null, we are going to keep running in the loop, and inside the loop essentially we have to flip the values between current and previous. So what we can do is current dot next would be our previous node, and then for the previous node we will have to flip it to current node, and for the current node we will have to go to the next node in the original singly linked list. So for that we will have to create a temporary variable. So let's create a new node and we are going to name it as temp, and we are going to store the current dot next node over here. And now for the current node we are going to point it to this temp, because remember over here we are updating this current dot next value, so that's why. Okay, and yeah, I think this is it. After this loop ends we should have our linked list reverse, so we can simply return the head as previous variable, and this should be it. Let's try to run this code. It seems like our solution is working. Let's try to submit the code. Okay, our code actually runs 100% faster than all the other solution because it's running in constant time, and I would be posting this in the comments. You can check it out from there. Thank you. Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to do a linked list problem called merge to sorted list. So this problem has been asked in tech giants like Amazon, Facebook, Microsoft, Apple, Uber, Google, Bloomberg, ByteDance, which is TikTok, and then companies like Yahoo, LinkedIn, Indeed, and Roblox, and also IBM. Plus recently in news, Twitter. So I am paying my utmost attention. I hope you also enjoy the video. This is a LeetCode easy problem, and it is also one of the most liked problems on LeetCode. If we understand the problem statement, we are basically given the heads of two sorted linked lists, list 1 and list 2, and we need to merge these two linked lists in one single sorted list. So this is the important part, that it has to be sorted, and in the end we need to return the head of the merged linked list. Okay, let's try to understand this problem with an example. So over here we are given two lists, list 1 and list 2, and we can see that both of them are increasing in ascending order. And now we need to create a merge list from this. So this is the merge list that has been created. Even if you observe the merge list, the ascending property is maintained. So which means that the merge list is also sorted. And how it is sorted? It has taken values from whichever the nodes that had the smaller value. So in this case, these first two values were 1, 1. So we can choose from any one, right? Now this second value, and now we are done with this value 1 and 1 over here. Now we need to take care of this 2 and 3. So when we compare this 2 and 3, we find that okay, this value number 2 is actually smaller. So that's why we add a 2 node over here, and now we are done with this one. And now we still have to compare this 3 with this 4, because remember we are not done with this 3 yet. So we identify that this 3 is actually smaller. So in this case we are done with this 3, and we add the 3 node over here in our merge list. Now the values are 4 and 4. So again we just enter the values 4 and 4, and now we should be done with all of them. And this is the new list that we have created. And in the answer we need to return the head value. So we would be returning this value as the part of the answer. So this is the expectation of the problem. Let's see that what could be the potential solution. So let me quickly draw just one more list, and we'll see that what should be the approach. let's see that what should be the merge list at the end. So I'm denoting this as M. Now we are going to compare two values at any given moment, and we are going to have two pointers. So let's say left 1 and left 2, we are going to keep track of them. So over here both the values are same, so we can enter any value. So we will add 1 over here and then again 1 over here, because both the values are same, so you can put condition to choose anyone. Now we are done with both of them, and because we are done with both of them, we will have to update the values of this L1 and L2. So we are going to update its values. So now this becomes our L1 and this becomes our L2. Again we do the comparison. Now in this case we find that okay, this value is actually smaller. So because this value is smaller, we are done with this element. Essentially we will add that value to our merge list, and because in the list 2 we found that that value was smaller, we will update the list 2 pointer to go to its next element. So we will do a jump like this, and now this becomes our list 2. And again we will compare list 1 and list 2 elements. So in this case we find that value at list 1 is actually smaller, so we will add it to our solution. And again we are done with this one now. So we will update the left 1 pointer. So left 1 pointer would fall over here, and now again we will compare both of these values. So in this case we find that okay, this value is actually smaller, so we will add one more node to our merge list 4, and again update the value of list 2. So list 2 actually goes over here, and this is done. So this is list 2, and now we compare this value with this value. So over here we would find that okay, this 5 is actually smaller, so now we will have to update the value 5 over here. Now because we have updated the value 5 over here, if we do a next jump for this list 1, we identify that this node is actually null. So the moment we identify that there exists a null node, there is no point of us moving forward in this direction because we are done. And essentially whatever the remaining values are still pending in the L2, they directly needs to be appended on this merge list. Why? Because so far all the elements we have entered, they were entered based on the some sort of relative comparison. But once we are done with one loop, there is nothing for us to compare. So because there is nothing for us to compare, whatever is the remaining portion we can directly add over here. So we'll over here we only have one node 8, so we'll directly add the node 8 over here. But even if we had some other nodes over here, they all would be directly appended without any issues. I hope this makes sense, and this actually would be our final solution. Now what would be the tricky part in this one? The tricky part in this one would be that because in this merge linked list we are iterating over here, so at the end we would be somewhere at the last position. And remember, we need to return the head node. So what we will do is we are going to use a trick. We'll create some dummy node, and this dummy node would be actually as the head node. We will just assign some random value, whatever, 1, 2, whatever. This does not make any difference. And the next value of this would be pointing to the merge.next, and that would be the trick. So at the end we will just return the next value of this dummy node, and then that would be the start point of our merge list. So if we calculate the time and space complexity, in this case the time complexity would be big O of n actually, because we will have to iterate over all the nodes that are given in both list 1 and list 2. So actually it would be big O of m plus n, where m is the total number of nodes given in list 1 and n is list 2, but in general we can write it as big O of m plus n. And in terms of space complexity, we are only using couple of extra parameters to store the value, and anyways we will have to create this merge list, so we wouldn't consider that to be an additional space being used. So we can say that we are actually solving this in constant time, and this would be the most optimal solution. So first of all we will create a list node, and we will just call it as dummy. And for this dummy node, actually we are going to use this dummy node to keep track of the first element inside our merge list. Now we will create another list node, and we will call it as a merge list. So let's just call it merge, and we are actually going to initialize it with dummy value. And now we are going to run a while loop. Now we are going to run a while loop up until the point that when we have elements in both list 1 and list 2. So at any point we encounter that list 1 or list 2, either of them is empty, we are going to break out of this while loop. And inside the while loop, we will have to check that which one is a smaller value. And suppose list 1 is smaller than list 2 value. So in that case, we will have to add it to our merge list. So now we will add the value to merge list, but we are actually going to add it to the next element inside the merge list, and you will come to know that why we are doing it. So let's just do that. And now we will also have to update the value of list 1. So this should be list 1, and now let's update the value of list 1. Okay, and if that is not the case, which means that we will have to add the value from list 2. And after we break out from the loop, we will actually have to see that which list still has values remaining, because remember, at any point we encounter null in any either list 1 or list 2, we break out of the loop, which means that there could be still more elements that needs to be appended to this merge list, and that should be taken from whatever the list that is still not empty. So we will just put a condition: if list 1 is equal to null. If that is the case, we know that we will have to append the value of list 2. And if that is not the case, which means that list 2 is empty and list 1 still has elements, so we will add list 1 to our merge list. And once that is done, we need to return the head of this merge linked list. But the problem is that now we are actually at the end of this merge list. So how can we get the head of this? Well, actually we can get the head of this is by using this dummy node that we created, because remember that dummy is actually the start value of 1, and dummy.next would be the value of merge.next. So that's why we actually have to create this additional node. And in the return, we are actually going to return dummy.head and dummy.next, and this should give us the head value. So let's try to run this code. Okay, looks like we made some mistake. Oh, we are not updating the value of merge element, because at every iteration the merge node also needs to go to the next element, because we are already adding a 1 value to this merge linked list. So now let's try to run the code. Okay, seems like our solution is working as expected. Let's submit this. And our solution is actually 100% faster than all the other Java solutions. So hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to do reorder list lead code problem, and solving this one problem is actually equivalent to solving 3 different lead code problems, and I'll show you how in this video. So if we check out the list of companies that have asked this problem, there are tech giants like Amazon, Microsoft, Adobe, Facebook, Bloomberg, Uber, Google, Yahoo, Apple, eBay, Lyft, and Expedia. And these are some of my dream companies, so that's why I'm making these videos. I hope you also enjoy the video. So this is a lead code medium problem, and basically we are told that we are given the head of a singly linked list, and we need to reorder this linked list and return in a different manner. So let me quickly show you by an example that how do we want to return it. So suppose we are given a linked list like this, that 1, 2, 3, 4. This is a normal linked list we are given, and now we need to reorder it in a manner that one node we take from this left to right direction, and the another node we take from this right to left direction. So in this case, the first node is going to be this one, this node number 1. And now once we have taken this node from this left to right direction, the second node we are going to take is from the opposite direction. So second node in this case is going to be this value number 4. So second node would be the value number 4. Again, since we have taken node from the end of the list, so next node we are going to take would be this one, the value number 2. So again we will take a node this value number 2, and now At the end we will continue in the reverse fashion, and the next node we will take would be value number 3. So this would so this is the sequence we would need to return in this case after all the nodes that we have taken. Now let's take one more example. So again in this case we will take one node from this left to right and one node from this right to left. So the first node would be node number 1, second node would be node number 5, then again next node would be node number 2, then again next node would be node number 4, and then again next node would be node number 3. So in this case this would be the sequence that we will need to return as the result. Suppose this is the linked list we are given and we need to reorder this linked list. So what is the approach we are going to use? Basically we need to understand that what are the things we need. Well, we need all the nodes that are going from left to right, and we are also need all the nodes that are coming from left to right. But the critical part is that this is a single linked list, which means we don't have any way to move in the reverse order. So what we are going to do is, first of all, we are going to create a reverse linked list, and then we are going to merge it with this original input, and the second linked list we are creating, we are going to create it smartly. So this is the input we are already given, right? So we already have our first linked list that we need to create, which is this one. What we are going to do for the second linked list is, for the second linked list, actually for this original given input, first of all we are going to find what is the middle of the linked list. So in this case the middle of the linked list is going to be this node number 4, and the sequence starting from this node to 4, 5, 6, this is going to be the middle of the linked list, right? So in this case the first linked list we have is, and for the second linked list we are going to choose it from this middle node. So the second linked list would be, okay, now we have for both our linked list first and second. What we are going to do is, we need all these nodes in the reverse order. So we are going to for the second linked list we are going to flip it in the reverse order. So now for the second linked list we are going to change it in the reverse order. So the second linked list we will have would be like, okay, and once this part is done, for the third part we are going to merge this first and second linked list. So first of all, let's see that what are the first and second linked list we have. Okay, so this is the first and second linked list we have. We are going to merge two linked lists until the point when we get the second node to reach to this null value. And how we are going to merge the list is that first we are going to take the node from this first node, first linked list, then we will take the node from the second linked list. Again we will take a node from the first linked list, again we will take a node from the second linked list, and we are going to keep iterating it until the second reaches null. So let's see that in the action. So first node would come from the first linked list, so this would become our first node. Second node would come from the second linked list, so this would become our second node. Again we will repeat the same process, and in the end we would add this value number 4, and then we realize that we have already reached to the null value for the second linked list, which means that there are no other nodes to be added in the second linked list, which means we would stop adding even from this first linked list, and we would not add all the remaining entries, and this would be our answer, and we can simply return this one. So this is the solution we are going to use, and notice that in this solution we are actually doing 3 different activities. So let's see that how to do each one of them. First of all, we need to find the middle of the linked list, and I have already solved this problem, so you can check out that particular solution over here. Let me quickly go over the solution that I had already proposed. So suppose I have a linked list like this, and if I wanted to do 2 partitions of it, all I'm going to do is I'm going to create 2 pointers. One pointer is slow pointer and second pointer is fast pointer. For the slow pointer, it is going to do 1 iteration to the next element, and for the fast pointer it is going to do 2 hops to the next pointer. And whenever this fast pointer reaches to the end of the list, this slow pointer would be at the middle position inside the given linked list. So let me show you how. Initially the fast pointer and slow pointer both would be at the same position. Then fast pointer would take 2 jumps and slow pointer would take 1 jump. So fast pointer would reach over here and slow pointer would reach over here. Again both of them are going to take subsequent jumps. So slow pointer would reach over here and fast pointer would reach over here. Now again slow pointer would take one more jump, so slow pointer would reach over here. But if fast pointer takes 2 jumps, we already reached to the end of this list, which means that whatever the position of the slow pointer is, this is the part where we need to do a partition, and this would be the middle of the linked list. Next thing we need to do is that we will need to reverse the second linked list. So suppose we are given a linked list like this. So I have already solved this problem as well. You can check out that solution over here. And the idea is that we are going to have two different pointers. One pointer is previous pointer and second pointer is current pointer, and at any point we are going to have the current pointer point to the previous element. So which means, because this is a singly linked list, all the nodes are pointing to the next element rather than them pointing towards next element. We are actually going to have any single node point to its previous element, and then this would become our head, and then we would have reversed the linked list. So let me quickly show you how. Initially we would have our current pointer over here and our previous pointer over here. So now right now this current dot next is pointing to the next element. So first of all we are going to create a temp variable, and in this temp variable we are going to store the value of this current dot next. So current dot next we stored. Okay, so temp variable is currently over here. Now we are going to have this current variable which is pointing to this next element. Rather than pointing it to next element, we are going to have it point to this previous element. So now this 4, rather than pointing to this 5, it is going to point to this previous element. So this would be null in this case. Okay, and now once this is done, we are going to have this previous pointer jump to the current pointer. So now this previous pointer would come over here. So this is the previous pointer because we have already updated the value of this value number 4, and then the current pointer, we are going to take its value from this temp variable. So current pointer would also end up over here. So this would also become the current pointer. Once we have this done, now in the next node we are going to repeat the same thing. So first of all, this temp variable, we are going to jump it to the next element. So this would become the temp variable. Again, for the current variable, we are going to point it to the previous element. So now this 5 is going to point to this node number 4 rather than pointing to this node number 6. So we are breaking up this connection. And then for the temp, for the current variable, we are going to flip it to this temp variable. So again, current is going to be ending up at this position. So this is where current is and this is where temp is, and then we will update the value of the previous node as well. So this is where the previous node is. So once this is done, again we will repeat the same process, and then we will point when the previous element reaches over here to the last node, we are going to return this as the head. So in the answer we would have reversed the original list. So we would have a linked list like this, and then once this is done, all we need to do is, now we have two separate lists, we will need to merge them. Okay, so for the merge of two linked lists, you can check out that solution over here, and let me quickly show you over here as well. We will start taking one node from each of the given list, and first node would be node number 1, second node would be node number 6, then third node would be node number 2, and next node would be node number 5, and then we will take node number 3, and then we will take node number 4 from this list. And now we realize that the second dot next is actually null, which means that now we don't need to take any more nodes from any other linked list, and we can, whatever the answer is, we can simply return this as our answer, and this would be the final solution that we are going to use. So let's see that what would be the time and space complexity in this case. So for the time complexity, we are actually doing 3 different things. So first thing we are doing is that we are actually splitting the linked list in 2 parts. So that takes big O of n by 2 time. Plus second thing we are doing is we are reversing the linked list, which takes big O of n time, and third thing we are doing is we are merging two linked lists, which take big O of n time. So in general we can say that we are doing big O of n work, and in terms of space complexity, we are actually using an additional linked list, this second linked list, to store the values, and over here we are actually storing like half of the nodes, which means that we will require big O of n by 2 additional space. So generically we can write this as big O of n as well, and this would be the time and space complexity. Let's see that what would be the implementation. First of all, we are going to check that whether the given head is equal to null, If that is the case, we can simply return immediately. And if that is not the case, we will start with our implementation. So first of all, we are actually going to find the middle of the linked list. So let me create two list nodes for that. Now once we have our slow and fast list nodes, we are going to run a while loop. That while either fast is equal to null or fast.next equal to null, we will move slow and fast pointer up until that point. Once this is done, we will have a new linked list starting from the slow endpoint, and we will have to reverse that linked list. So in order to reverse the linked list, we will need a previous node. So we will create a new list node called previous, and we will assign it to the value null. We will also have a current node, and we can initialize it to the value of slow, and we will have a temporary node. Now we will run this loop while the current is not equal to null. So first of all, we will store the value of current.next into temporary variable. And after that, we will exchange the values of previous and current node. So current.next will get the value of previous node, and previous node will come at the current node, and current node we will need to move one step forward. So we will assign it to the temp node, where we initially store the value of the previous current.next. And after this second loop runs, we should have our second list, the slow list that we created, to be reversed. And now all we need to do is merge our first list and our second list. So let's create a couple of list nodes, and we will create a list node called first, and we will assign it to the value of the head. And we will also create a list node called second, and we will assign it to the value of the previous node. We will run a loop that while second.next is not equal to null. So over here we will need to take the values from the second node and put it behind the first node. So we are going to use the temporary variable for that. So first of all, in the temporary variable, we are going to store the value of first.next. And after that, for the first.next value, we will take a value from the second node, and for the first node we will get the value of whatever the temp value we had already stored. And after that is done, we will repeat the same process for the second node as well. So first of all, we will create the temp to setup as second.next, and then we will have second.next to point to the first node, and in the end we will have second node point to the temp node. And once that is done, our code should be working as expected, where we would have updated the value of this original given list node. In this case, we don't have to return anything because the return type is void. We only need to update whatever the given input is. So let's try to run the code. Okay, seems like our code is working as expected. Let's submit the code. And our code is actually pretty efficient, and it runs faster than most of the other Java submissions, so which is pretty good thing to do. I would be posting this in the comments, so you can check it out from there. Also on the GitHub, I have created a repository of all the questions that we have solved so far, and I have made it public so anyone can access it. I will be posting this link in the comments as well, so you can check it out, this link, and it can be helpful to a lot of other people. So far we have around 60 to 70 questions, and we are growing it by the day. Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to do remove nth node from an end of the list problem, and this problem can be asked in many different ways. And if we see some of the companies that have already asked this question, it's really nice. So companies like Facebook, Amazon, Microsoft, Google, Bloomberg, Uber, Apple, ByteDance, Goldman Sachs, and Salesforce. They have all asked this problem, and they are some of my dream companies that I want to work at. So that's why I'm making these videos. I hope you enjoy them. Let's try to understand the problem statement. This is a LeetCode medium problem, and the title of the problem actually is self-explanatory, that essentially we are given the head of a linked list and we need to remove the nth node from the end of the list and then return its head. So this is the whole problem. If we try to understand it using an example, in the example originally we are given a list called 1 2 3 4 5, and over here we are given that n is equal to 2. So we need to remove second node, but remember, we need to remove the second node or nth node from the end of the list. So in this case, this would be the first node at the end of the list, and this would be the second node at the end of the list. So we will need to remove this 4, and once we remove this 4, the answer would be something like this. So this is what we need to return, and in this case we will need to return this head pointer, and then automatically it will traverse towards the entire linked list. Okay, so let's see that what would be the most basic solution to solve this problem. Suppose we are given a custom example like this, and we need to remove second node from the end of the list. Now in this case, this would be the first node from the end of the list, and this would be the second node from the end of the list. So we know that we need to remove this value number 5. But the thing is, we are able to know it because I have drawn in the picture over here, and it is very evident to us. But actually we don't know that what is the length of this given list. So because we don't know the length, what we need to do is that the answer is quite simple. First we need to identify that what is the length, and then we need to, based on this given value n, we will need to determine that what is the element that we need to remove, and then it becomes easy for us to remove the element. So what we are going to do is we are going to use a 2-pass approach, and inside the first pass we are just going to have a variable called n, l, and this L is to take care of the length of this given linked list. So in this case we would find that okay, length is equal to 6 because there are 6 nodes present in this given example. Now once we know that there are 6 nodes present and our given n is equal to 2, we will need to remove the 5th node. Why 5th node? Because the node we need to remove, that is going to be determined based on the formula that total length minus whatever the n is given plus 1. Why plus 1? Because we are using one index calculation over here, that this last element, this 6th element, is also the first last element. Remember that this is the critical part, that this is the first last element, which means this is the second last element. And because of that, if we see over here that this L is equal to 6, this n is equal to 2. So 6 minus 2 plus 1 becomes 5, and that's why we determine that we need to remove 5th node. If we don't do this plus 1, essentially 6 minus 2 would be 4, and we don't need to remove 4th node because 4th node is actually 3rd node from the end of the list. So that is why I gave you this long explanation. Now in the first pass we determine that okay, this is the node we need to remove, that this 5th node we need to remove. So all we need to do is in the second node, in the second iteration, we are just going to iterate over this given list again till we reach the 5th node. So the moment we find that okay, our current node is 4th node, which means that the next node is 5th node, right? So all we need to do is that whatever the 5th dot next is pointing, so currently 5th dot next is pointing to this value number 6, we are going to append this value to this 4th dot next. So rather than over here this 4 pointing to this 5, we are going to remove this link and we are going to make this 4 point to 6, which means that this 5 is automatically removed from this given input list, and that would be our solution. But the moment you present the solution, your interviewer is going to say that rather than using 2-pass system, suppose we want to complete this whole thing in just a single pass, in just a single iteration, then what should be your approach? And this is the critical part. So let me show you that what would be the most optimal solution. Let's use the same example, and inside the same example, first let's try to understand a couple of things over here. Suppose over here in this case we are told that remove n is equal to 1. So how can we determine that n is equal to 1 is which element? We can determine that okay, this is the first element from the end of the list. Why? Because the very next element of this one is actually null, and this is the key point, which means if we are given that n is equal to 2, so which means we need to remove the second element from the end of the list. So how can we determine? We can determine it by saying that okay, currently if we are at this position, the second node from this one, so next to the next node would be a null node. And if that is true, we can determine that, okay, this is the second node from the end of the list. And this is a very important property that we need to identify. So basically what we are going to do is we are going to use two pointer system over here, and inside the two pointer we are going to have a back pointer and a front pointer, and the position of this back pointer and front pointer is determined based on whatever this n is given. Say if our back pointer is going to be at this position, which means our front pointer needs to be 2 steps ahead. So 2 steps ahead from this back position would be 1, 2. So this is where our front pointer would be at the beginning, right? And now since we have both of these positions set up, all we need to do is just keep iterating to the next element, and we are going to iterate until we find that this f or the front element is actually at this null position. So let's see that what would be the different pointer situation. So now our back pointer is come to this position, and again our front pointer is going to come to this position, because back pointer jumped from here to here and front pointer jumped from here to here. Again front is not at null, so again we will have to do one more iteration. So now the back pointer will come over here, and the front pointer will jump to one more step, and front pointer will come over here. Again front is not null, so again our back pointer is going to take one more jump, and our front pointer is also going to take one more jump. So front pointer will come over here, and over here we've identified that this front pointer is at null position. So this is the critical point. Now this front is at null position, so we have identified that, okay, now this back pointer is exactly enough spaces behind it that whatever the next node is, that needs to be removed, and that is what we are going to do. So over here we identify that, okay, this back is at correct position. Now what we need to do is currently back dot next is the point that we need to remove. So what we are going to do is simply we are going to point this current back dot next. So current back dot next is this 5 value. We are going to point it to whatever the back dot next is, and this would be the solution. Because what would be the next dot next? It would be this one. So rather than this 4 pointing to this 5, we are going to break this link, which means that there is no way for us to reach to this 5, and now 4 is directly connecting to 6, and then we need to return the solution. Now we need to return the head of this linked list. So we are going to use the same point we have been using so far, that initially we are going to create a dummy node, and this dummy node is going to act as a placeholder, and that is going to store this head value, and we are going to return that in the solution. And let's see that what would be the time and space complexity in this case. So for the time complexity, it's only going to be big O of L, where L is the given length of the linked list, and in terms of space complexity, we are only storing couple of parameters, so it would be constant time, and so we are not using any additional space. So first of all, we are going to create a dummy node, and inside this dummy node we are going to give it some random value. We are going to create dummy dot next equal to head, and we are using this dummy node as a placeholder. Now let's create our two front and back list nodes. Okay, once that is done, now we will need to bring the front node n steps ahead of the back node. So we are going to run a for loop. After this loop ends, the front and back are at the current position, so now we only need to run a while loop till the front element is not equal to null, and all we need to do is just increment the value of front and back elements. And once that is done, now we are at the correct position for back to remove the next node. So we are going to do back dot next equal to back dot next. Okay, and now we have removed the node, that the nth node from the end of the list, so we can simply return the head of the list, and this should be our solution. Let's try to run the code. Okay, seems like our code is working. Let's try to submit the code, and our code runs pretty efficiently. I will be posting the solution in the comments, so you can check it out from there. Thank you.
So the problem we are going to solve today is called copy list with random pointer. And if we see some of the popular companies who have already asked this question, there are companies like Amazon, Facebook, Bloomberg, Microsoft, Apple, Adobe, Google, ByteDance, eBay, and Uber. So that's why I'm paying my utmost attention. I hope you also enjoy the video. This is a LeetCode medium problem and a very well-liked problem. Basically, in this problem, we are being asked to copy a linked list. The thing is, this linked list is actually kind of a tricky linked list. It's not your common linked list. So if we know by a definition, the linked list that we understand has a structure that looks like this. And the last pointer points to a null value. So this is a typical structure of a normal linked list. But the linked list that we are given in this case is actually kind of little bit of tricky. It is a linked list that looks like a structure that is something like this, where in this structure we have these two parts common. So the green values over here are defined as the regular linked list pointers, where we have a value and we also have a pointer that refers to the next item inside the linked list. The thing is, at times we are also given these random pointers in our linked list as well, and the purpose of these random pointers is that they can point to anywhere, and basically we need to keep track of all of this, and on whatever the given linked list that we have been provided, we need to create a deep copy of that particular linked list. So this is what is being asked in this problem. Like, if you cannot find, or if you try to understand, you can read this problem statement again by pausing the video right now, or you can see some examples that I have shown over here. So let's take a look at the first example. As I was mentioning, that this is not your typical common linked list. You see, in this linked list, we are given one value for every single item. But thing is, with this value, rather than having just a single pointer that points to the next element, which is defined over here as this next pointer, we are at times also given this random pointer as well that can point to any direction, and we need to keep track of that, and we need to create an exact copy. So inside the input, we are only given the head of the linked list, and this is the original linked list structure behind the scenes. And in the output, based on this given head value, we need to iterate over this entire linked list, and after iterating, we need to create an exact copy of it. So if we see some structure of this given linked list, it is going to look somewhat like this. So in the output, basically we are initially located at this position. This is the head of the linked list, and we need to find a way to iterate over this entire linked list in the exact manner and create a deep copy. So what does creating a deep copy means? Means that if some node does not exist in our copy, then we would create a new node, take all of these values exactly as mentioned, and put these values inside our new node and mark it as the node in our sequence, and then in the end we need to return the newly created linked list. So basically we are going to create like 5 different nodes. Every single node is going to look pretty much similar to this, and they are all going to have a structure that is common over here, and basically we are going to return this as the answer. So this is the whole ask. There are few other examples given as well, but they are not as important. They are just kind of simple. So I think you get a general gist of what are the things are being expected. Now we have already done similar questions like this, and even say for an example, if this was just a random linked list, it would have been too easy for us to solve this problem, because what we could have done is we initially start with the first position, so with this head position, and just keep on creating a new linked list based on whatever the values we are iterating over right now, because we have a very certain path in any linked list where the first node is the value, so we can just copy whatever the value this has. So say for example, this has value number 5, we can just copy this value as value number 5, and this has value number 6, we can also copy value number 6, and if this has value number 10, we can also copy value number 10. So these things are easy to do. It is also easy to iterate to the next node inside the linked list, because we are directly given the pointer, and using that we are also going to do the same thing.
And basically in the end, when we reach to the null value, we have reached to the end, and simply we can return this as the answer. Now copying is not as simple in this case, because we are dealing with a structure that looks like this, where there could be potential possibility of cycle. What do I mean by potential possibility of cycle? Say for example, we are given these two nodes, the values are 7 and 8, and we know for sure that this node is going to point over here and this node is going to point to the null value. These two things are fact, but it could be possible that these two random nodes, so this random node points over here and this random node points over here. Now if we try to iterate over this, like a different version of this linked list, what is going to happen is that, okay, currently we are located at this head value. So what would happen in these cases? Well, the thing that would happen in these cases is that over here, rather than coming back to this point, we might end up creating a whole new node with the same value 7, and we will try to iterate over this value. And this over here again, for this particular 7, the value is pointing towards 8, so we might create a new node 8, and then we keep on repeating. So basically, because there exists a cycle over here, it is possible for us that while creating the copy, we could end up in an infinite loop, and that could be disastrous. So we will have to avoid that in any single cost. Okay, so say for an example, this is one of the input that we are given, and we are trying to convert this and trying to create a deep copy of this. Basically, we are given this as the head node, right? And now we need to iterate over this one. Now, but the thing is, in this case, if you see, there is the cycle present amongst these random nodes. So this is a cycle, and if we don't take care of it, we will actually keep on ending it in an infinite loop. Now the thing is, in order to detect any cycles, we actually have a great way of doing it in all the graph problems, right? But the thing is, you would say that why am I mentioning graph over here? Because clearly this has been shown as a list or a linked list kind of a problem. The idea is that rather than treating this as the linked list problem, we can actually treat this as a graph problem, where every single items can be treated as the form of vertices and edges. Because remember, in the graph, the two most important items are vertices and edges. So for the vertices, we can actually consider these input nodes of the linked list as the vertices, and for the edges, we can actually consider these like next edges, so the white edges and also these purple edges, to be considered as the edges. Now in this case, the edges are going to be directed and also unweighted. Now after doing this, after treating this and trying to consider this as graph, things becomes much easier for us to keep track. Why? So I have actually drawn this figure where I am visualizing this given input as a graph. Now in this case, if we treat this as a graph, it becomes very easy for us to copy and maintain. Why? Because the logic we can use in this case is that any single node, we can actually create a visited directory or a hash set or a hash table where we keep track of all the nodes that we have visited so far. So that way it is going to be great for us to keep track of everything. And once we are done with all the nodes, we can simply return the copied nodes. So the logic we are going to use is, okay, let me make this a little bit smaller. Okay, so now let's try to iterate over this given node, and we will start iterating through its head. So this is the head pointer, and every single time we are going to keep the same logic that we use in any single graph problem, that first we will check that whether that particular node has been visited or not. If it has been visited, we will skip it. If it has not been visited, we will add an entry over here and we will create its clone node, and we will keep on repeating the same process. Now for every single node, we have its edges. So basically we are going to go in depth first search manner, and in depth first search manner, we are going to go over all the neighbors of any single node and keep on repeating the same process. And also because we are repeatedly doing the same thing, we are actually going to do this recursively. There is also an iterative way to doing it, but the thing is, I like recursion better, so I'm just going to show you the recursive way. But remember, there is also an iterative way. And if we see this diagram, basically there are just few functionalities. So these white edges, they refer to the values of the next pointer, and also these purple edges, they refer to the values of the random pointer. And let's start iterating. So first we are at this head pointer, so we are at this node number 7. 7 is not present inside our visited hash set, so first we will add an entry 7 over here.
And now let's just create a new node called 7. So we will create a new node. Okay, 7 has been created. Now what is the next node of the new node? This is the random pointer. So where the random pointer is pointing towards, it is pointing towards null value. So if it is pointing towards the null value, we do not need to add it to our visited set, because remember, null is not a new node, but it's just like the end of the list. So we'll just keep track of it. So okay, this one is like the null. And also if we see in this case, the next pointer we need to go over is the next edge. So next edge is pointing towards value number 15. So we will check that whether 15 has been visited or not. 15 has not been visited, so we will add entry 15 over here. Now we will start visiting the 15's first edge, which is the random pointer. So if we go depth first search recursively, okay, so this 15th random, so let me just create a new node 15 over here. And this 15th random edge is taking towards node number 10. So 10 has not been visited. We will add an entry 10 over here, and we will also create a new node for 10. And in this case, the 10th next node, or the node in sequence, is the random pointer. So random pointer is pointing towards 13. So 13 has not been visited, so we will go over 13 node. So we will create a new entry called 13 over here in this case. Awesome. So now we have all 4 of our nodes set up, and we have also iterated towards the random pointers. So now at 13, when we iterate over the random pointer of 13, it takes us back to the node number 15. And because this is taking us back to the node number 15, which means we will check that, okay, whether this has been visited or not. Yes, 15 has already been visited, which means we are in a cycle. So we need to break out from there. So basically we do not care, and we will not get ourselves involved in this one, because we have already created a copy of 15. So because we have created a copy of 15 in this case, so rather than creating a new node, for this particular random node, we will simply point it towards this 15 that we had already created. And that is how everything is going to work. And then we basically have taken care of this cycle without getting secluded in the infinite loop, because we use the visited hash set. And then for every single node, there is still the next node remaining that we need to traverse over, which is simple to do, because for next node it is only pointing towards the next node. And in this case, from 15, after completing this sequence, when we go to the next node, okay, this one is pointing towards value number 13. We already created a new node, so we do not need to create anything. We simply need to add the entry over here to point it towards the correct direction. Same with 13, next node is going to be 10. That is also good. And in the end, this 10 is going to point towards the null value. And this is how our traversal is going to be completed. And we would have created an exact deep copy of this particular linked list with random pointers without doing any extra work. And this is like a wonderful approach. So all we did is we treated linked list as graph. And this is a great way to understand that how can two different data structures can be interchanged, and we can use trick of the one data structure in the other data structure. So I know this was a little bit complicated to understand, but if you just like try to put some thought behind it, things would make much more sense. And if we see time and space complexity, in this case, the time complexity is actually going to be big O of V plus E. So V plus A is the number of vertices plus edges. Why? Because this is a graph problem. So this is what we have to deal with. And in general, in this case, rather than treating it as V plus E, we can actually treat it as big O of N, where N is the number of nodes given in the input. And in terms of space complexity, in order to use the recursion, we will have to use big O of N space. So this is a decently good time and space complexity. Well, I just need to make a quick remark. If we use the iterative approach, the space complexity would become big O of 1 in that case. First of all, we are going to create our visited hash map, and inside our hash map, we are actually going to do things a little bit trickily. So as its key, we are going to keep the values of the old node, and as its subsequent value, we are going to keep the newly generated copy that we have created. So at any given moment we encounter any already visited node, we can simply return its copy rather than creating a new node every single time. So this copy random list method is also going to be our recursive method. So first we will create a terminating edge case that if the given head is equal to null, we can simply return null. If that is not the case, first we will check that whether the current head value we are at, has it already been added to our visited node. And if it has been visited, we are simply going to return the subsequent reference value that we have stored inside our visited node hash map. If, say for an example, this has not been visited, so in that case we will have to create a new node. Now as a new node, we are assigning it to the value of the current head value that we have received as an input, and as its random pointer and next pointer, current values are null, but we are going to populate these. Now once this has been done, since this is a new node, this needs to be put inside our inside our hash map. Now notice in this case, the head is the existing node that we are taking as an input, and this node is the new node that we have created, which means we are storing the copy as the value inside our visited node hash map, and as a key we are using the older value. So now for this particular node, we have taken care of the value of that particular node, but the thing is we haven't taken care of the next pointer and also the random pointer. So we will do that. In order to do that, we will actually have to call for the next pointer, we will actually have to call head.next value, and we will have to call our recursive copy random list method again. So let's do that. In same way, for the random pointer, we will also have to do the same thing. Basically, once this has been completed, we simply need to return the node. Let's try to run this code. It seems like our solution is working as expected. Let's submit this code, and our solution runs pretty efficiently in time complexity compared to a lot of other solutions. In terms of space complexity, there can still be improvements made, but I guess you can figure that out. I'll be posting this solution in the comments so you can check it out from there. Thank you. Today we are going to do a very interesting LeetCode problem called add two numbers. And if we see some of the popular companies who have already asked this question, there are companies like Amazon, Apple, Bloomberg, Microsoft, Facebook, Google, Uber, Paytm, TCS, ByteDance, Goldman Sachs, and Airbnb. So that's why I'm paying my utmost attention. I hope you also enjoy the video. This one is a LeetCode medium problem and also very well-liked problem. Basically, we are given two non-empty linked lists that represents two non-negative integers or two non-negative numbers. Now we are told that these digits are actually stored in a reverse order, and we need to find the sum of these two values. So this is the whole problem. Basically, we are given just two numbers, n1 and n2, and we need to find the sum of them. So n1 plus n2, what is that going to be? And we need to the tricky part in this case is both of them are given in form of like linked list. So we are given linked list 1 and linked list 2 that represents both the numbers, and we need to add them and just create an answer linked list, and we need to return the head of this linked list. So let's try to understand this with an example, and that would make things more clear. So suppose over here we are given two linked lists L1 and L2. Now notice that the numbers represent are over here are 2, 4, 3, and this one is 4, 6, 5. But we are told that these are actually stored in the reverse order, which means that the least significant number that in a number system can be actually comes in the first position, which means that the actually this one represents the number 342 if we want to put it in the decimal system. Same way this one represents the number 564, and now we need to do sum of these two values, and whatever the answer is we need to store it in a similar linked list kind of a fashion in reverse order. So the logic is going to be quite simple. Let's try to understand this with an example. So basically in this case the two linked lists are 2, 4 and 3. So this one is linked list 1, and linked list 2 is going to be 4, 6 and 5. Now if we want to do sum of these two and store it in the result, basically the answer is going to look something like this. So first of all we are going to do sum of these two values 2 and 4. So the answer is going to be 6. We can put 6 directly over here. Now in this case the value are 4 and 6. So if we do 4 plus 6, basically the answer we get is 10. So 10 we cannot put directly as it is because we can only store one single character in this kind of a block, which means we can only store 0 over here, and 1 is going to be a carry that will be forwarded over here. So let's just add one carry over here. So it's going to be 1 plus 3 plus 5. So it's going to be 8, and the answer is basically 806. But again, since we have stored it in the linked list fashion, the answer has been stored reversely, but the actual answer is going to be 806. And basically this is what we need to return. So this is a really simple problem to understand. So say for an example, these are the two numbers we are given.
I'm also noting them over here, 708 and 503, and we need to do some of these one. What is going to be the most simple logic that we are going to use now, given the fact that we are given these two as linked list 1 and linked list 2? The logic we are going to use is just a simple arithmetic, nothing more than that. The most basic approach that we have studied in second grade, this is what we are going to do. We are just going to do simple arithmetic. So the idea is that we are going to have a variable called carry that is going to keep track of that whether there is any carry that exists or not for any single pair of sum that we are going to do. That is one thing. Second thing we need to iterate over is until the possibility of whether we run out of both of these linked lists, because it could be possible that this linked list could be only of length 3 and this linked list could be of length 4. We might have an additional variable over here, something like 6, and basically this value is going to be 6503, but sum is going to be amongst these values and this value is going to be by itself. So we are only going to concern about this value plus the carry in case we need to do it. But since this is not the case, we are not going to do it, but I'm just letting you know that these are the possibilities that could exist. Now we know till what points we need to run, we know how to start, and we know what are the values we need to do the sum of. So the logic is going to be that we are simply going to create a new dummy node. So every single time we are going to create a new node. Now in this case, I know the answer is going to be this, so I directly created this, but typically we will only be creating just one dummy node, okay, at a time. And then we would do sum of these two values, and initial carry value is going to be 0. So initially this carry value is going to be 0. Okay, now let me get rid of these numbers, they are causing some confusion. So first we are doing 8 plus 3. 8 plus 3 is going to be 11. Since 11 is greater than 10, we are only going to put 1 over here and we are going to change the value of the carry. Now carry can only have two values, either 0 or 1. Why? Because the maximum possible number we can get amongst two digits is always going to be 19. Why 19? Because the maximum two digits could be 9 plus 9, and we could have a previous carry that could be 1. So even if we do sum of all of these, it could only lead up to the value of 19. So there can only be two possibilities for the value of carry. So I'm just letting you know these things. Now in this case we have this value 1. Okay, now we are going to move to the next value. So if we move to the next value, basically this is 0 plus 0, but the value of carry is 1, so it's going to be 1 plus 0 plus 0. So the value is going to come 1 over here. Now again in this case, since we have already used this carry and we do not have anything, the carry value is going to go back to 0 again. Now we have the value 7 plus 5, 7 plus 5 plus 0, so that is going to be value 12, but the 12 is still greater than 10, so we are only going to put 2 over here and we are going to have a carry that we need to go over. And now notice in this case, even though we ran out of both of these linked list and we do not have any more values to iterate over, we still have carry that is not 0. So again we are going to add one more node over here and we are going to add the value of carry in this case, and that is going to be 1. So in this case the answer is going to be 1 2 1 1, and this is like the numeric sequence if we go in this direction. But since we are only needed to return the linked list, we can simply return this linked list as the answer, and this is the whole logic. So the problem is really simple to solve, easy to understand, and nothing more complicated. Time complexity in this case, the time complexity is basically going to be big O of maximum of either length of m or n, where m is the length of this one and n is the length of this one. So whichever is the maximum value, we need to iterate those many steps. So first of all, we are going to create a new list node called dummy node. This dummy node is going to act as a placeholder for our actual answer. Now we are also going to create a new list node called answer. We are also going to have a variable called carry and the initial value is going to be 0. Now we are going to run our while loop, and inside our while loop we are going to keep on running until we have values in either L1 or L2 or the value of carry is not 0. Inside the loop, first of all, because these are list nodes, we will have to create two integer variables called x and y, where we will store the value of the subsequent list 1 and list 2 variables if they are not null, and if they are null we are going to store their values as 0. We are also going to initialize a variable called sum and we are going to do x plus y. We are going to calculate the value of carry.
So for that we can only do sum divided by 10 and we will get the answer. Now for our answer node, we will have to add the value of the sum that we have calculated. But it could be possible that the value of the sum could be greater than 10. And we only need to store a single digit between 0 to 9. So what we can do is we can inside the answer dot next, we can simply store the value of the sum modulo by 10. And now for the present pointer, we will need to update the pointer inside the answer list. So we are going to move to the next element. And same way, we will also have to update the value of the L1 and L2 to move to the next nodes, but we will only do it if they are not null. Basically, that's it. This is the whole meat of the operation. And now all we need to do is we simply need to return the value of the dummy.next, because dummy.next points to the first value where the answer node starts recording all the values. Let's try to run the code. We are making a mistake. So inside the sum, we are not actually adding the value of the carry. So we will also have to do that. Okay, seems like our solution is working. Let's submit this code. And our code runs decently efficiently compared to a lot of other solutions. So this is a very good approach. And I would be posting the solution in the comments, so you can check it out from there.
Hello friends, we are still not employed by FAANG company, so let's not stop lead coding till we get there. Today we are going to do linked list cycle problem. So basically it is a problem to detect cycle inside the linked list, and this problem has been asked by a bunch of different companies. So let's see that what are my dream companies that have asked this problem. It contains the companies like Amazon, Microsoft, Shopify, Goldman Sachs that we recently got rejected at, Google, Bloomberg, Apple, Facebook, Yahoo, Splunk, and eBay. So these are some of the companies that I'm really interested to get a job into, and that's why I'm paying my utmost attention. I hope you also enjoy the video. So this is a LeetCode easy problem, and it is really simple to understand. Basically, we are given the head of a linked list, and we need to determine that whether this linked list contains a cycle or not. Now, first of all, we need to understand that what is the property of a linked list. Basically, inside the linked list, we are given two items. First item, we are given some data point that represents that particular node inside the linked list, and we are given the information about the next node inside the given linked list. And that is how linked list keeps on progressing. So we will keep this in mind. Hopefully everyone should be familiar with this one. And now the question is that we need to determine that whether inside our given linked list does there exist a loop or not. So suppose we are given a linked list like this, and in this case we can clearly see that there exists a loop between this 4 and this 2. The question is that how do we detect that there exists a cycle? And first solution that comes to mind is the solution that we have been using at different graph and some other problems. So basically what we can do is at any moment we are given this head position. So what we can do is we can create another data structure called hash set, and inside this hash set we are going to keep track of all the visited nodes that we have passed so far. And what we are going to do is initially, first of all, we are going to check that whether at any given node we are currently at, if that exists inside this visited hash set or not. If it does not exist, we will add it to this visited hash set, and we will keep moving forward. So at any moment, if we encounter the same node, we can clearly determine that there exists a cycle. So in this case, first of all, we will check that whether this one exists in the visited hash set. It does not exist, so we will add 1 over here. Then again we check for 2 does not exist, so we will add 2 over here. Then again we check for 3 does not exist, so again we add 3 over here. And again we check for 4, so 4 also does not exist, so we will add all 4 entries. Now from this 4, the next value it points to, it actually points to this value number 2. And whenever we check that whether this 2 exists or not, we can clearly see that 2 exists over here, and we can immediately say that because we came back at a node that we have already visited before inside the hash set, we can determine that there exists a cycle. And in this case we will return true, that okay, yes, there exists a cycle over here, and that would be our solution. Now this solution is perfectly fine, it works okay. If we calculate the time and space complexity, the time complexity in this case is going to be big O of n, because we are iterating over all the nodes just one time. And the space complexity in this case would be big O of n as well, because we are using this additional visited hash set to detect that whether there exists a cycle or not. The next thing that your interviewer is going to do is he is clearly going to ask that solve this problem without using this additional additional space, and the space complexity should be big O of 1. So let me show you the most optimal solution where the space complexity would be big O of 1 and time complexity would be big O of n. I have a short announcement. I have recently created a GitHub repository. The link is in the description and I will quickly show it to you as well. So this is the repository that I was talking about, and I have left it public so anyone can access it. It contains list of solutions of all the LeetCode problems that we have solved so far. So you can click on any problem and you can go to its solution, and it will contain the Java solution for that particular problem that is acceptable at LeetCode. Our aim is to see this list growing, and I would be posting all the solutions that I solve, and hope it helps other fellow coders. And our aim is to get into FAANG, and hopefully this can be a big stepping stone towards that direction. Basically what we are going to do is we are actually going to have two pointers that iterate over this given linked list, and we are going to have a slow pointer and a fast pointer. And the aim is that at any moment this fast pointer is always intended to stay ahead of the slow pointer. And if we identify that this fast pointer actually reaches back to the slow pointer, we can determine that there exists a cycle. Let me show you how. So what we are going to do is we are at this head position. So we are going to first of all initialize our slow pointer and our fast pointer at these positions. So slow pointer would be at the first position and fast pointer will always start at the second position. Now we are at these position. We are going to have one more condition, that slow pointer will always do one jump. So slow pointer will always do slow plus 1. So it will always go to next node. But for the fast pointer, we are actually going to have fast pointer do two jumps. So fast pointer is going to do fast pointer plus two node jumps. And let's see that how things will turn out in this case. So initially we are at these positions. Now this first pointer makes two jumps and slow pointer makes one jump. So their corresponding position change. So slow pointer will reach over here, and meanwhile fast pointer actually made two jumps. So fast pointer will end up over here. Now in the next case, the slow pointer again is going to make one jump. So slow pointer will reach over here, and this fast pointer is going to make two jumps. So fast pointer will make one jump over here, and second jump it will reach over here. So in this case, fast pointer will also reach at this place, and slow pointer also reached at this place. So over here we determine that this value at this fast is equal to value at the slow node. And because we identify this condition, this can only happen true if there existed a cycle somewhere. And because there existed a cycle, we are able to determine that okay, there exists like this fast and slow reach at the same point, they met at the same node. So that's why there for sure there has to be a cycle. What happens if there does not exist a cycle? So say for an example, in this case, again let's just go back to this scenario that okay, this is the list we are given and there does not exist a cycle, and let's add one more node over here. We'll just name it number 5, and this is the whole linked list we are given. Now in this case, again this is the slow pointer, this is the fast pointer, and we are always going to have a terminating condition that either if slow reaches at the end or if fast reaches at the end, at any given moment we reach to the end of the list and we find that the value of this slow or fast pointer is actually null. If that is the case, we can determine that we are able to successfully traverse over the entire linked list without detecting a cycle, and that would be our final solution. So in this case, slow is here, fast is here. Let's make one jump. So again, so now the slow would be here and fast would actually be here. Now again let's just make one more jump. So in this case, slow would be here, but fast would have already crossed this portion. So fast would be somewhere over here, the node is null. which means immediately we can determine that because we find that the fast pointer was at null value, that there does not exist a cycle in this case, and we will return false in this scenario. So this would be the most optimal solution for this problem. It is very easy and very trivial to understand as long as you get this trick. And if we calculate the time and space complexity, the time complexity would be big O of n, because in any case we will have to iterate over all the nodes. In terms of space complexity, apart from using couple of additional variables, we are not using any more space, so we can say that the space complexity is actually constant time big O of 1, and this would be the most optimal approach. Okay, so first of all we are going to check that if the given head is equal to null, we are going to return false. So this would be an edge case that we took care of. Now we are going to create two list nodes. One is for slow, and we are going to initialize it to the head position, and second one is fast, and we are going to initialize it to the second position. Okay, now we are going to run a while loop, that while slow is not equal to null or fast is not equal to null, we are going to keep iterating over. And we are going to check that if the fast.next element, if that is null, we can also return false immediately. If that is not the case, if at any point we identify that the value at fast is equal to value at slow, if that is the case, we can immediately say that there exists a cycle and we can return true. Otherwise we will have to update the counter. So slow would be slow.next. So because we are incrementing slow by one value, but for fast we are actually incrementing fast by two values. So fast would be fast.next.next, and that's it. And if at any moment we are able to get out of the loop, we can always return false, and this should be the solution. Let's try to run the code. Okay, seems like our solution is working. Let's try to submit the code. Oh, okay, we are going to check that if fast is equal to null or fast.next equal to null. Okay, seems like our solution is working, and it's actually pretty fast. It's actually it runs in 0 milliseconds, so 100% faster than all the other solution. And even in terms of memory usage, we are beating out most of the people, because over here we are actually ending our loop early by using both these conditions. And again, inside the GitHub, I will be providing the solution to all these problems, so you can go and check it out over here. I would be posting this link in the description, and hope this video helps all the other communities that I feel so dear for, and not stopping till we get into FAANG. See you next.
Hello friends, hope you are having a fantastic day today. So now once again we are going to do an awesomely LeetCode popular, I can't speak. So let's get started with the question. So the LeetCode problem we are going to solve today is called find the duplicate number. We can see that this one is a medium problem and also extremely well-liked problem on LeetCode. The problem statement is quite simple. We are given an array of integer called nums that contains n plus 1 integers, where each integer is in the range of 1 to n. Now we are told that there is only one repeated number in this nums array that we are given as the input. So we need to find that what is that repeated number. On top of it, to make things more compelling, we are given two conditions: that we must solve the problem without modifying the existing array. So that is option number one. And second one is we must solve this using a constant extra space. So we don't want to use any other data structure. So let's try to understand if this is the input we are given. Currently this input contains 7 elements, and we can see that in this case we are given values 1 up until 6, but the values, there is one value that is being repeated, and that repeated value right here we can clearly see is value number 4. So in this case we need to return 4 as the answer, that 4 is the repeated character that we have been able to find. So really simple problem statement. Now let's quickly try to understand the brute force approach, and then we will build our solution on top of that. So the brute force approach is actually very simple to understand. We can just simply create a new hash set, and inside this new hash set we will first check that whether the entry we are trying to iterating over, if that is already present inside the hash set. If that is the present, that has to be the repeated element. If that is not the present, we can move on to the next element. So first we find value number 6, it's not present, so we add it to 6. Then we find value number 3, once again we find value number 1, once again we find value number 4 and value number 2. So far none of these values were present inside the hash set, so we added them. Next we identified value number 4, so 4 is already present inside the hash set, and we can check that in big O of one time, which means because this is already present, so in this case we can say for sure that 4 is the repeated element. So this solution works well in big O of n time, which is great. But the issue is we are actually using an additional data structure to store the value of this existing array. So this is basically not allowed. So over here space complexity is going to be big O of n, so this is not a good solution. Let's try to see a better solution where we can actually make changes to the existing array that we are already given. Once I know that we are not supposed to do that, but this is one of the way where we can find the solution very easily. The idea is that at any single index position, we try to go to its subsequent index value and keep on repeating the same process. So eventually it should be able to lead us to the repeated person. So in this case, we can see that if we go to element number 6, on the position number 6, we actually have value number 5 located, which means we are going to swap the values. So the value we are going to swap over here is that 5 would come on this place and 6 would come on this place. So in this case, we would have on position number 0, element number 5 located, and so on and so forth. So we would keep on swapping the elements. So now this one will become 6, even eventually this one will become 4, and this one will become 4 as well. So eventually we would be left with element 4 hanging someplace. So the moment we identify that, we can say for sure that 4 is the repeated character. Now the problem with this approach is that in terms of swapping the elements, we can actually complete this problem in big O of 1 space complexity, but we would be actually modifying the input array. So this is also not a legitimate solution. I mean, the solution is legitimate. The other thing is, if you can find this solution in any of your interviews, the interviewer would be more than likely to be happy with this approach. But the thing is, now we are trying to find the most optimal solution without modifying the array. For that, we are actually going to take use of a very popular technique that we have seen in a linked list. So in any particular linked list, whenever we had repeated characters, we actually were able to solve that whether we have a cycle inside the linked list or not by checking a very popular algorithm, and that algorithm is called a tortoise and hare algorithm, where we simply take use of two pointers. One is a fast pointer and the other one is a slow pointer, and we iterate fast and slow pointer over the linked list until the fast pointer either reaches to the null value or we identify that fast pointer and slow pointer meet at some position. So let me quickly go over the solution and then we will understand that how can we utilize that fact for our approach. So the idea is that let's say that currently I am given one particular linked list, right? And the values are quite straightforward. The thing is, I realize that in this particular linked list, this value number 4 once again points back to value number 2. So which means in this case, I can actually point value number 4 back to value number 2. So in a sense, I can say that value number 2 is actually present twice, or it is the repeated element. Now I need to identify that whether there is a repeated element or not. The idea for a typical linked list is that you start with a fast pointer and slow pointer both at the same location. Fast pointer is going to do 2 jumps at a time. Meanwhile, slow pointer is only going to do 1 jump at a time. So during the first iteration, fast pointer is going to end up over here. During the second iteration, slow pointer is going to end up over here. Okay, now we are going to keep on repeating the same process. So during the next iteration, fast pointer is going to go to 4 and once again go back to 2. So fast pointer is going to end up over here. But meanwhile, at the same time, slow pointer is also going to make a jump. So slow pointer will end up with 1 jump over here. during the next iteration, fast pointer would end up over here, and at the same time slow pointer would also end up at the same position. So the moment we realize that both fast and slow pointer are at the same position, which means we can say for sure that there is a cycle inside this given linked list. So now the thing is, this only confirms that there exists a cycle inside the linked list, but we don't know for sure that what is the repeated element. So repeated element in this case is value number 2. But the thing is, there is a very easy way to find that repeated element as well, where we identify that fast and slow pointer met at this particular position, right? At value number 4. So the thing is, what we are actually going to do is that instead now currently fast pointer is just going to stay inside the loop, but we will need to have slow pointer to come outside the loop somehow. So let's say that our slow pointer comes outside of the loop. It is right now over here, and fast pointer is now inside the loop. Now we are going to have fast pointer just hop one element and slow pointer also hop one element. If we do that, actually the funny thing is that mathematically the fast pointer and slow pointer both would end up exactly where the repeated character lies, or exactly where we are able to identify the cycle. And we can see it over here, and we are going to see it in a couple of other examples, so you can understand that my hypothesis in this scenario is correct. So now currently we are only going to do one jumps because we have already identified the element. Now in this case, okay, currently this F is located over here, the slow pointer is located over here. If slow pointer makes one jump, slow pointer reaches over here. If fast pointer makes one jump, fast pointer is going to end up over here. And this has to be the repeated character because we identify both a slow and fast pointer ending up at the same place. So now trust me, this solution works. We will try to understand this with a couple of examples, but first let's understand that this solution was actually really good and simple, that it worked for a linked list. In the input, we are actually given an array. So how do we deal with this one? The idea is actually quite simple. And what I'm suggesting is that instead of treating this whole array as set of an array, we are actually going to make use of the idea of our second example, where rather than swapping the values, we will just try to create the links. And how we are going to create the links? Based on, so currently let's say that in this index number 0, this is the 0th value. So we are going to treat it as node 0, and this has value number 6. So we are going to assume that 0 points to node number 6. Then 6 has node number 5. So 6 points to node number 5. And this, using this logic, we will try to visualize this as a linked list type of variable. Okay, so let me just show you what I mean, and then it would make much more sense. So let's assume that, okay, currently we are at 0th index. So currently our 0 index, now it is pointing to index number 6. Okay, index number 6 now in this case is pointing to index number 5. 5 is once again pointing to 4. 4 is once again pointing to value number 2. 2 is pointing to value number 1. And 1 is once again pointing to value number 3. And once again 3 is pointing back to value number 4. So rather than doing this, we can just say that 3 is pointing back to the value number 4. And in this case, we know for a fact that 4 is the repeated character because this is where the cycle starts. So now let's just start running our algorithm. We are going to have our slow pointer and fast pointer both start at the same position. Slow pointer is going to make one jump. Meanwhile, fast pointer is going to make two jumps. Once again, repeatedly, same thing is going to happen, that fast pointer is going to make two jumps and slow pointer is going to make one jump. So let's also quickly do that. So now currently we have our slow pointer over here, our fast pointer over here. Once again, fast pointer makes two jumps. So fast pointer ends up over here, slow pointer ends up over here. Okay. Once again, fast pointer is going to make two jumps. So now fast pointer is going to cross inside the loop. So fast pointer would be one, would be the first jump and this would be the second jump. So fast pointer is going to end up over here. Same way, after making one jump, slow pointer is also going to end up over here, which means we identified the place that both fast and slow pointer met. Okay. Now, because fast and slow pointer both met at this place, we know for sure that both fast and slow pointer are currently inside the loop. We will have to find a way to break for value number or slow pointer outside the loop. So we are actually going to start slow pointer at the beginning of the loop. And now we are simply going to do one jump, just like we saw inside the linked list example. So slow pointer will take one jump, fast pointer will take one jump. Once again, slow pointer will take one jump and fast pointer will take one jump. And once again, when slow pointer takes one jump, fast pointer will also end up at the same position, and this index position has to be the repeated character. And we found the culprit that we were looking for. So this is the whole approach to solve this problem. If you want, you can take as many examples as you want. This distance and where the place where both fast and slow pointer meets up, distance from there to the starting pointer is always going to remain same, and this is going to allow us to find the duplicated item without using extra space or without modifying the existing array. So this is a pretty good equation to open up your mind and open the horizons of what can be different possibilities. How can you start understanding that what type of solutions can be there. So that's why this is pretty popular amongst top tier companies. So if we see time complexity, it's pretty obvious it's going to be big O of n, because we are simply going to iterate over the given array like a couple of times, one to find the matching point and second one to find the duplicate number. Okay, and space complexity, we know that this is going to be big O of 1. And now let's quickly see the coding solution for this one. So the coding solution is actually quite simple and straightforward. We are going to have our two variables, fast pointer and slow pointer, initialize at the very first element. Then we are going to find the intersection between 2 points. So we are going to run our while loop that while slow is not equal to fast. And then we are going to have slow pointer make one jump. Meanwhile, fast pointer is going to make 2 jumps. Once that is done and we do find the intersection, now fast pointer is inside the cycle. So slow pointer, we are going to kick it out of the cycle by marking it initial position as 0. And then we are simply going to check that while slow and fast are not the same, we are going to have slow pointer iterate one step and fast pointer also iterate one step. In the end, we can simply return either slow or fast because both are at the same position. So we will try to run this code. Okay, seems like our solution is working. Let's submit this code. And our code runs extremely fast compared to a lot of other solutions. And it's especially difficult for a popular question like this. So yeah, you can imagine, once again, the coding solution is going to be present inside our GitHub repository. So feel free to check it out from there. Thank you. Hello friends, hope you are having a fantastic day today. So now we are going to do a very popular LeetCode problem called LRU cache. And this is a very well-liked problem and it is a LeetCode medium problem. Now this problem can be asked in two manners. This is a very popular system design constraint as well. It's very simple for a system design, but still it is there. And also it is a LeetCode problem, so it can also be asked in your technical interview. So I ask you to put higher attention to this problem because it can be asked in two different types of interviews. Now let's understand the problem statement. Basically, we need to create a data structure that follows the constraint of a least recently used cache. So first let's understand that what are going to be the constraint for the least recently used cache. The simple thing is, purpose of cache is to store some values. Let's assume that currently we have this cache and we can store 3 values inside the cache. So the idea is that first I add value number 1, then I add value number 2, and then I add value number 3. Now, because value number 1 was the very first value that I entered, or it is the least recently used item in the cache, because relatively number 2 and number 3 have been used after number 1 was being used. So number 1 is the least recently being used value. So if I have to add value number 4 inside the cache, I need to kick out 1 and I need to add 4 over here. But in this scenario, now the least recently used item is going to be value number 2. And if next element is 5 I need to enter, then I need to kick out 2 and add value number 5. But
Currently now this 3 is the least recently used, but say for an example, for some reason I ask this cache that, hey, get me this value number 3. In this case, now this 3 is no longer the least recently used value. Now the least recently used value is going to be this value number 4. So in case if I have to enter value number 6 in this case, now again I'm going to kick out value number 4 and add value number 6 over here. This is the constraint of least recently used cache, and this is what we need to implement. But now let's go back to our problem statement and understand what exactly being asked us to do. So number one thing is we need to create a class LRU cache class where we need to implement few methods. Number one method is a capacity method. So the capacity method defines that this is going to be the size of cache. So in this case, currently our capacity is 3, and this is what we come up with. Okay. Next one is that we need to create a method that gets any particular element from the key from our existing cache. Now the thing is, the value we are storing inside the cache is actually a key value pair kind of the thing. So in the input we would be given values like 1 1. So in this case, the value we need to store is a key value pair, that is 1 1. This is the whole node where 1 is defined by the key and its subsequent value is value number 1. Okay. Now, in order for us to put the value, now if we have to add a new value inside our cache, then we are given some more constraint. Number one constraint is that we need to update the value of the key if the key already exists. Okay, so that is number one constraint. Number two constraint is that if the key does not exist, then we need to add the whole key value pair inside our existing cache. And for some reason, if we move out of the capacity, then we need to evict, or we need to kick out the least recently used key. So the same thing that we just saw in the example. Okay, so now let's try to understand this whole scenario with like a slightly broader case, and we will try to understand that what are the things we need and what are the constraints we have, and how can we actually start implementing these methods. Now, for all of you, I must know that the moment you heard that we are using key value pair, the number one thing that comes to your mind is that we are actually going to use hash map, and you are exactly correct. In order to store all the values inside the cache, we are actually going to use the hash map. Now the thing is, in the hash map, the typical structure is that we have a key and we have associated value. Now in this case, the node we are trying to store, the node is actually structured as a key value pair in itself, and this is going to be the value, and the key is going to be the same key that we are being given inside the node that we are going to use. But one different thing we are going to do is that instead of storing, let's assume that currently the value of this node is that key is 1 and value number is 5. If this is the value we need to store, we are not going to store it like this, that number 1 as the key and value as number 5. No, this would be correct, but we will not do that. Instead, what we would do is we will see that what is the pointer location of this node, and we are going to store the pointer location that points to this particular element, and it would be the same thing because we are using the hash map. So access is always going to be big O of 1. We can always find this value in big O of 1 time, but this is going to be greatly helpful for us in order to maintain the order in which the elements came in. This is the most important part, because we are not only storing the values inside the hash map and kicking the values out of the hash map, we also need to keep track of that what was the least recently used item, which means at the same time we will also have to keep track of that which was the most recently used item because of the get operation. You understand my point? That what I'm trying to say, because remember, we need to implement 3 methods. Number one method is a capacity. Now capacity is really easy to make sure, because that is going to be the size of our hash map that we are going to implement. So we will never be able to exceed our capacity. That is number one, that has been taken care of. Second method is the put method. Okay, put method is also relatively easy, that I just explained, that we as a key, we are going to store the key, as a pointer we are going to store the node that we are going to point. Next method is the get method. This is also very easy, because we know that in the get we are being asked that, hey, this is the key and fetch me the whole value. Now inside the hash map, it is really easy to fetch out values. We can do that operation in big O of 1 time. Let's assume that currently we have a value like 2 and its subsequent pointer that points to the value of 2 and 5 in the node. If we are being asked to fetch this value, we can fetch it very quickly in big O of 1 time. But the problem is, when we have to, for this put operation, when we run out of the capacity, then in that scenario we will have to do an eviction. Now for this eviction, we need to keep track of that what was the least recently used element that we came up with. And in this case, first instinct is to use a simple queue, because let's assume that for a second we don't have this get operation. Okay, let's assume for a simple second. Now what would happen is, currently we have our hash map. Now inside the hash map we need to store the values of key value pair. Okay, and what we are going to do is, let's assume that the current capacity is 3. Okay, so let me add 3 blocks. Same way the current capacity of the queue is also going to be 3. Now number one thing is, first value we are trying to enter is 1 1. So let's assume that I am entering value 1 1 over here. Same way the very first entry I am going to enter inside the queue is going to be 1 because of the key. Second value is 2 2. Once again second value is 2. Next value is 3 3. Once again the value is 3. Now let's assume that there is value number 4 I am trying to insert. What value should I evict? It's very simple. The very first value that entered inside the queue has to be the first value that gets kicked out of the queue. So this is very simple to implement. But the problem is that currently this sequence is fine, but the moment I apply the logic of get, and now in this scenario, let's assume that I decide to get value number 2. Okay, let me add this value number 4 before. Okay, so let me go ahead and quickly do that. Okay, I added value number 4 over here. I also got rid of 1 and I adjusted the flow of 2 and 3. Okay, so now I adjusted the flow of 2 and 3 and 4, and now I have already added the value number 4. Now the thing is, I apply get operation. Currently in this scenario, the least recently used element is value number 2. That is very simple to understand. But now if I do get 2, immediately 2 becomes actually the most recently used element because I just accessed 2. So now what would be the new flow of the queue is that it's going to be 2, 4 and 3. And now suddenly 3 becomes the least recently used character. And in this case, if I have to kick one value out, I can also kick that out. Basically, if I want to add value number 5 in this case, now I need to kick value number 3 out. Now the question is, you must be thinking that, hey, even with the queue, we can actually implement the same thing. What we will do is, whenever we are being asked to run a get operation, all we need to do is we first need to find the value that is currently present inside the existing queue, move it to the very first element of the queue and shift all the other nodes one step forward. And then also this logic would work. But that would be a suboptimal approach. Why? Because hash map is going to run in big O of one time. No issues with that. Queue, typically it is going to run in big O of one time because we are simply popping elements out from behind the scenes. But when we have to do the get operation, we need to iterate over the entire queue in order to find the position of that element. And that operation takes big O of n time. And if we see the problem statement, we are very explicitly being told that the functions get and put must run in on an average big O of one time complexity. So we need to take care of that scenario. So now let's just break down the same problem and try to come up with the thinking that what are the things we need, what are the things we have, and how can we make the solution better. This is the approach you should be thinking in your actual interviews as well. And that is why I created this whole 10-minute preamble of the whole things that we are now going to come up with the optimal solution. So in this case, once again, we already mentioned few things, that we are using hash map in order to store the values. Now you will understand that why instead of using hash map to store just the values, why am I storing the pointer of that particular value? Now it will come to your senses. Okay, what I'm suggesting is that currently, remember, we need to keep track of two items. Number one item is what is the least recently used item. Number two item is the moment we use the get operation, we also need to keep track of what is the most recently used item. And there is going to be all of these bunch of different elements that fall between each other. But basically, the moment we are accessing any particular element, that becomes most recently used element. The moment we want to kick out any element, we kick it out from the least recently used element, which means we need a data structure where we can actually work on both sides of the queue to either enter the value or remove the value. And we need to do it in fast and efficient manner.
And for that, the very simple thing is one of the most basic data structure, that is a linked list. But this is not a simple linked list. We are actually going to use a doubly linked list. And how this doubly linked list is going to help us to solve all of this issues, let's think about it. So now let's understand that suppose currently this is our hash map where we are storing all the values. Let's assume that this is our doubly linked list, okay? And currently for our hash map, once again the capacity is 3. Now why are we using pointer instead of actually using the value? That will come to your mind very quickly. So let me just add few values, okay? Number 1, number 2 and number 3, these are the 3 values. And let's assume that for these 3 values, I'm marking as pointer 1, pointer 2 and pointer 3 as the 3 nodes that contain all the information. Now once again, I'm marking these 3 nodes over here, pointer 1, pointer 2 and pointer 3, okay? And currently inside our doubly linked list as well, because we added values sequentially in the same sequence, we are going to have, okay, so this is our least recently used item and this is our most recently used item, okay? Now the very first item we have in the least recently used is going to be pointer 1 or the value 1 or the node 1, okay? You can think of it, all of these things. So basically value 1 and 1. Same way second is going to be P2, basically value number 2 and 2. And third one is going to be pointer 3, that is going to be 3 and 3. Now the thing is, where this pointer would come into useful is when we have to change the positions, because same logic will come to your mind that, hey, in the queue, why we were not using queue? Because in order to find any particular element, we had to jump through all of these places and that was causing big O of n time. But in this case, we have the additional benefit that because we have the hash map, based on any particular key location, we can directly find that where is that particular value is located inside the existing queue. And all we are concerned about is to storing least recently used and most recently used values. So now we are going to start manipulating these values. So let me just clean this up a bit. And now we are going to start working our magic. Now let's assume that currently we need to add value number 4 in this case. Okay, so we are going to add value number 4 over here. Once again, now the logic is quite simple. We are because least recently used value, we already know that is P1. We are simply going to get rid of it. But now what we need to do is we simply need to say that whatever the value that is, because we removed the least recently used value, which means we removed the head of the existing linked list. So the moment we remove the head of the existing linked list, automatically the second value becomes the least recently used value. So now we have P2, that is least recently used currently. Next value is going to be P3, and then we are going to have value number P4 as the most recently used value. So let me update those values. So P3 and P4. Okay, currently we have these values associated, and subsequently we have pointers that point to those correct values. Now let's assume that for some reason we decide to access value number 3. Okay, we create another operation, that is get operation, get 3. Now the moment I do get 3 operation, suddenly now even though 3 is in the middle, what I will do, in order to do the get 3 operation, first I'll do that whether key number 3 exists inside the hash map or not. Yes, it exists. If it exists, all I need to do is I need to fetch the value of the 3, so I can simply return that. But at the same time, I can go to this pointer's location and I can say that, hey, whatever your pointer location is, now you need to jump to the head of the to the tail of the linked list, because currently now you are the most recently used value, and that can happen in big O of 1 time because it's a doubly linked list. So we are just going to use the same logic, and now in this case P4 becomes our second least recently used value, and P3 becomes most recently used value, and we are able to find this value because we are using pointer. So we are avoiding the scenario where we have to iterate over every single value inside the linked list and saving up on the time. Okay, now for the same scenario, let's assume that instead of this, now we are trying to add value number 5. Okay, so if I want to add value number 5, I need to kick out least recently used value. I already know least recently used value is P2, and in the P2, because I'm storing the whole node, it contains the value as 2 and 2. So all I need to do is that whatever the head position has the node, I just need to go to that key position, and the moment I go to the key position, I simply delete or remove that key. So now I'll get rid of this 2. Okay, I'll also get rid of this 2 over here. Now my least recently used is automatically going to adjust, that is going to be P4 and P3, and now there is going to be P5 as the most recently used because I can easily manage that. And in this scenario, now once again I need to enter the value 5 and P5 over here, and that's it. This is the whole logic of least recently used test case scenario. And you can add as many nodes as you want, the logic will remain same. And now let's try to understand time and space complexity. Time complexity, pretty simple to calculate. We are using, okay, so let's assume for capacity it doesn't matter because it is like we are just allocating some value, so this does not take part in the time and space complexity scenario. Now let's assume for the get operation. So what are we doing for the get operation? If we want to get any particular value, get 3, let's assume, we are going to check that whether this key exists inside the hash map or not. Yes, it exists. Now we can easily fetch the value from the pointer, there is no issue with that, but at the same time we will have to mark 3 as the most recently used value, and that can also be done in big O of 1 time, and this hash map can also operate in big O of 1 time. So get operation now works in big O of 1 time. Awesome. Now let's take care of the put scenario. Once again, for the put scenario, we will also have to repeat the same thing. Basically, let's assume that now we have this value number 6 we need to add. We realize that the capacity is full. So because capacity is full, we are going to go to the hash map first, take whatever the head position is, find what is the key associated with that because it stores key and value both. And this key contains the value number 4, so go to value number 4, kick value number 4 out, add value number 6 over here, and that's it. You solve the problem. And now this operation also happens in big O of 1 time. So this is the whole approach. Now let me quickly go over the code. Now let's look at the code for our problem LRU cache. So first thing we are going to do is we are going to create a static class node where we are going to store the definition of the node that contains the values key and value. On top of it, we are going to keep track of the previous node and the next node for any particular node, and this aligns with our doubly linked list concept. We also have a simple constructor to store the value of key and value that comes in as the put method. Now we have some variables that we need to define. So first variable is the capacity. Next one is a hash map. Now inside the hash map, as a key, we are going to store the integer value of the node, but as its subsequent value, we are actually storing the pointer of the node and we are pointing it to the element that we needs to put in. This comes along as we understood during the explanation. And then we have two dummy nodes that are head and tail, where head is going to keep track of the most recently used and tail is going to keep track of the least recently used element, and then we can simply manipulate those values. Next thing is for this is the method in order to instantiate the capacity. So it is a very simple method. All we are doing is just creating a hash map of the same size. On top of it, if we have to, let's understand the logic for the get method, in which we are given the key as an input. So first thing we are going to check is whether this key exists in the hash inside the hash map or not. This we can do it in big O of 1 time. If it doesn't exist, we can simply return -1. If it do exist, we can simply return the node value. That is perfectly fine. But before that, we need to create, or we need to put it as the most recently used value. So what we are going to do is we are going to instantiate a temporary node that is going to be associated with the given key. And for that, we are going to remove that from our doubly linked list, and we are going to put its position as at the head value. And both remove and insert at head values, I have created helper method for those. So this is the remove method and this is the insert at the head method. These are just very basic pointer manipulations inside our existing linked list. Now going back to our get method. Now in this scenario, and in the end, once this node has been mentioned as the most recently used node, then we simply return the node's value. So that fulfills our get method. Next, let's understand the logic for the put method. That is slightly more complicated. We are given the two input values for the node that we need to put in. Now, first thing we are going to do is we are going to check that whether this existing key already exists, and if it does, we simply need to update the node associated with that. So if it exists, all we need to do is just assign a temporary node. Whatever the value of the new node is, assign that to the existing value for our existing hash map key. And then we need to remove that node pointer and insert it at the head, because now this becomes the most recently used value. If that is not the case and we need to enter the new value all by itself, so first we are going to check that whether we are running out of capacity or not. If we are running out of the capacity, we are simply going to remove the last element that exists at the tail, so that we can simply do it in big O of one time, because we can already always find that what is the value associated or at the least recently used using our doubly linked list, and then we can simply remove that value, and then we can simply add a new. In either case, now we simply need to add a new node inside our existing hash map, and after adding this new node, we need to add this new node at the head, because now this becomes the most recently used value. So I know that this code looks like a little bit complicated, but overall the simple logic remains the same. Now let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs pretty fast compared to a lot of other solutions in terms of time complexity, and also great in terms of space complexity. So once again, I will be posting this code inside the GitHub repository that we have, and you can check it out from there. Let me know in the comments, what do you think about this video? Do you think is there anything else I could have done to make it better? I'm always open for the feedback. So thank you so much for that. And
Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to do merge k sorted list problem, and this is one of the most asked linked list problem. And if you just see that the number of companies that have asked this question is really huge. There are companies like Facebook, Amazon, Microsoft, Google, Apple, ByteDance, LinkedIn, Bloomberg, TikTok, and more companies like Uber, Goldman Sachs, Lyft, Twitter, Yahoo, Wish, Plantier, Tesla, Roblox, Pinterest, Airbnb. So these are my dream companies, so that's why I'm paying my utmost attention. I hope you also enjoy the video. This is a LeetCode hard problem, and it is one of the most liked problems on LeetCode. But in my opinion, this should have been a medium problem, and I'll tell you why. Now, if we understand the problem statement, basically we are given k distinct linked lists, and each linked list is sorted in ascending order. In the answer, we need to merge all the linked lists that are given in one single sorted linked list and then return that merge linked list. So this problem is very similar to a previous problem we did, merge two sorted lists. So you can find that solution over here. And if we see the example for this case, basically we are given bunch of different linked lists and all of them are sorted. So if we see this first example, we are given linked list like. Now we need to merge all of them in one single linked list, and that single linked list needs to be sorted. So if we see the answer in this case is going to be that, okay, the smallest values are 1 1, so they will always come first, so it would be 1 1. Then we will have 2 3 4 4, so 2 3 4 4, and then we will have 5 and 6. And this would be the answer that we need to return in this case. That is the combination of all three linked lists. Basically, in the brute force, what we can do is we are given few distinct number of lists. So it could be like list 1, list 2, list 3, all the way up to list k. These are the list we are given in the input. What we can do is, whatever the number of nodes they have, we can take all of those nodes, we can combine all the nodes, we can put it in a giant list. Let's just name it as merge list. In the merge list, initially we put all the values together once, and then all we need to do is, if we just sort this given merge list, then the sorted list would be our answer. And basically that's the whole solution. This solution would work perfectly fine, and then in the end we can just return whatever the sorted list we have found. Okay, what could be the issues with this problem? Like I won't find too many issues, because this is also a decently good enough solution. If we see the time and space complexity, in this case the time complexity is going to be big O of n log n. Why n log n? Because initially we will have to do big O of n work to iterate over all the nodes inside the given linked lists, different linked lists, and merge them together. So that takes big O of n time, and plus it takes big O of n log n time to sort the given list. So overall we will write them as big O of n log n. And in terms of space complexity, the space complexity in this case is going to be big O of n, because we need additional room to space to store one additional parameter of all the merged list before we sort it. Let's see that what could be another solution. So in terms of the second solution, suppose we are given three different lists like this. In this case, k is equal to 3 because we are given three distinct values. What we can do is, at any point we can denote three different pointers to each location. Let's name them L1, L2, L3. And what we are going to do is, our aim is to find the minimum value. We already know that for these three values, all the values are already in ascending order. So the approach that comes to mind is, okay, let's just create our merge list, and inside the merge list at any point we are going to compare all the values between this L1, L2 and L3, and whichever is the smallest we are going to pick that one. So in this case, okay, the smallest value is 1, so we'll pick 1 over here, and then we'll update the value of L1. Okay, so this is already done. L2 and L3 will still remain same. So now we have these three values that we need to compare. So the smallest value is 2, so again we will update the L2, and this we are done. So now we have these three values to compare. So now again we'll add value number 3, and then we will be done with this one, and we'll update the value of L3. So let me just do it, do the whole thing, and hope you would be able to understand that how am I doing it. Okay, so this is how we will progress, and this would be our final merge list. So we can simply return this one. So this approach also works fine. There are no issues with that. If we see the time and space complexity in this one, the time complexity actually becomes, so suppose if we consider that all the elements in this L1, L2 and L3, the total number of nodes are given n. So we can say that the time complexity is going to be big O of n times whatever this k is given. So in this case k is 3, so we can do n times k, so it's going to be n times k, and this would be the time complexity. So why n times k? Because remember, in order for us to enter any single element, we will have to do k work. We will have to compare all these three elements, and at any point we find the smallest element, we will have to update that value. So suppose if k is equal to 1000, then we might have to compare 1000 elements at once. So that adds a little bit of complexity to it. So is this approach good? This approach is okay, but not very good, because as I mentioned that if we are given million elements as k, then basically what we are doing is just big O of n square work, while we already know that even in brute force we are able to solve this in big O of n log n. So why do we need to do n square work? Okay, so there is no point in doing that. Let's see that what would be the most optimal solution. Okay, so suppose we are given three lists like this, and I know you are thinking that why I only put two elements in each list. I'll just show you why. Basically, what is our aim? Our aim is to find that all the nodes that should be merged, and that merge list has to be in ascending order, right? We need to maintain this ascending order. So one of the best thing that should come to your mind is that, is there any data structure that already exists where no matter how many number of elements you put inside it, whenever you start taking the elements outside, they should be following this ascending order property? And yes, there exists a predefined element or data structure that can do it, and that name is actually heap. So if we maintain a min heap in this case, if we add all the values inside the min heap and then we start taking values or the nodes outside of the min heap, it is actually going to give us the sorted list where it is the combination of all the merged elements. Let me show you how. So let's create a priority queue that will represent this min heap. Okay, and now let's start adding elements one by one. So first we will add 4 and 7. Okay, next element is 3. So the moment we need to enter 3, we will have the priority queue is going to fix itself. So now it is going to be 3, 4, 7. Okay, now we need to enter 8. So 8 we can enter over here. Now this node we have to enter is 1. So again, when we need to enter the 1, the priority queue is going to adjust itself. So now the solution is going to be 1, 3. And the last node we need to enter is 11. So this, we have all the elements inside our priority queue. And now because we have this priority queue setup, what we can do is now we can start polling all the values from the priority queue. Because remember, the property of priority queue is that all the values are entered at the back and they gets out from the front. So now we will create a new merge list. Now inside this new merge list, all we need to do is just keep on adding all the elements that are coming out of this priority queue. So sequentially we will be adding 1, 3, 4, 7 and all those elements, and this would be the final solution that we need to return, and we can simply return this as our answer. And this would be the most optimal approach. Like this is there are other approaches that work in the same time and space complexity, but why this would be an optimal approach? Because your interviewer would like to hear that okay, you are aware about this min heap concept and you can use priority queue when needed. So this sounds reasonably fine. If we see the time and space complexity, in this case the time complexity is going to be big O of n log n. Why n log n? Because in order for us to enter all the values inside the priority queue, it takes a log n time, and we need to do it for all these n elements. And in terms of space complexity, the space complexity is going to be big O of n because we need to use this additional priority queue. And let's see the coding. So first of all, we will initialize the priority queue, and let's name it min heap. So now we are going to run a for loop, and we are going to iterate all the lists and all the nodes, and we are going to keep on adding those inside our min heap. And after adding the value to the min heap, we will have to update the value of list as well. So we'll do list is equal to list.next. Okay, so after this loop ends, all the nodes should be inside our min heap, and now what we need to do is take all the elements out of the min heap and put it inside our merge list. So first of all, we are going to create a dummy node that would act as a placeholder so that we can call our head when we need it. And this is the same trick we use in previous videos as well, so you might be aware of it. Once this is done, we will create our list node called merged list, and for the merge we are going to assign the first value as dummy, so that in the future we can call this dummy node to find the head of this merge list. And now we simply need to run a loop that while there exists an element inside the min heap, we will have to add all those elements to our merge list. And once this is done, all we need to do is just return the dummy.next. And this should be our solution. Let's try to run the code. Okay, seems like our solution is working as expected. Let's submit the code. And our solution works pretty efficiently, as you can see. And I would be posting this solution inside the comments, so you can check it out from there. Thank you.
And my aim is to empower every single person to be better at technical interviews. Keeping with that goal in mind, today we are going to do a very interesting LeetCode problem called reverse nodes in a K group. If we see some of the popular companies who have already asked this question, there are companies like Amazon, Microsoft, Apple, Bloomberg, Google, TikTok, Facebook, ByteDance, Uber, Snapchat, Paytm, and Tesla. So that's why I'm paying my utmost attention. I hope you also enjoy the video. So this is a LeetCode hard problem and also a very well-liked problem on LeetCode. Basically, we are given the head of a linked list and we are also given another value, integer value called k. Now, based on this given head of the linked list, we need to reverse the nodes inside the given linked list k at a time, and we need to return the modified list. There are also some additional parameters given which states that basically if we have the number of nodes that are less than k, we do not need to reverse them. Let's try to understand this with an example. If we see in this case, we are given a linked list and we are given the value k is equal to 2. Now, if we understand the problem statement, basically we need to reverse the nodes inside this given linked list k times at a time. So in this case, 2 nodes are given. So we are going to reverse 2 nodes and then keep on repeating the same process. So the idea is first we are going to reverse these 2 nodes. Whatever the answer is, we'll store over here. Then we will reverse these two nodes, and again we will store that answer over here. And since this one is only one node and we are given the value k is equal to 2, we are not going to change anything over here. So if we see the answer in this case, basically if we just reverse these two nodes, the reverse node is going to look like this, 2 and 1. Then we have the nodes 3 and 4, which are the two next k nodes or next two nodes. So again we are going to reverse them, and since this is only the single node, we will not reverse them. So this is going to be the modified reverse list that we need to return as the answer. If we see, basically we are reversing k nodes at a time, and at any point we identify the nodes less than k, we do not do anything. Now, the most basic thing we can do to solve this problem is, first of all, we need to check for the edge case scenario. The edge case scenario is that if the given number of k is actually greater than the number of elements present inside our linked list, if that is the case, basically we don't need to modify the given input linked list and we can return the answer as it is. Why we can do it? Because the given k is equal to 6 and we are being asked to reverse k nodes. But in this case, since k is greater than the given number of nodes present, there is no way for us to reverse all 6 nodes, which means we don't need to modify the answer as at all, and we can simply return as it is. Now let's try to think about some logical scenarios. Suppose our given value is equal to k is equal to 2, 3, something like that. If that is the case, what is the approach we will take? The approach is quite simple. First, we will take these two nodes. We will do the reversing function. For all the remaining ones, we will repeat the same process after we are done reversing these two elements, which means first we will do like a reversing function, and then for all the other nodes, so currently this 1 would be pointing towards this 3. Now for this newly created list, we would be able to repeat the same process. If we repeat the same process, now this time we will reverse these two nodes. And again, if we keep on repeating the same process, we will only be left with just a single node which only contains one value, which is again less than the value of k, which means we don't need to change this portion. If we see logically, this becomes a very good candidate for a recursive approach. Why recursive approach? Because essentially every single time, first of all, we were considering all of these 5 nodes to do like k equal to 2. Once we are done iterating these two nodes, we can get rid of them, and now our input shrinks to the 3 nodes, and then again we will repeat the same process, and then again if we get rid of these two nodes, we only are left with just a single node, and then we need to repeat the same process, which means recursively this is going to be a very beautiful approach to solve this problem. Now we already know the overall framework on how to solve this one, but one key important piece of information missing is the reverse function that we need to perform. In order to perform the proper reverse function, first let's identify that what is the methodology we are going to use. Okay, now let's try to figure out that if this is the given input linked list we are given, we are simply trying to reverse this whole linked list. We are not currently considering about the k values because we already know the solution. So if we want to reverse this entire linked list, what is the approach we can take? Well, let's try to see that what are things we have. We currently have a head pointer that points to the first value inside our linked list. Now since we need to do the reverse linked list, basically the reverse linked list is going to have a new head, and this would be the head of the reverse linked list. So we will also, first of all, we need to create a new node called new head, and initially new head value is going to be null. So let's just create a new head. I'm going to mark it as nh, and currently the value is null. Okay. We will also need to find some way to iterate over the given input existing linked list. For that, what we can do is we can create a pointer node, and this pointer node, we are going to initially assign it to the value of the head pointer, and then we will use the pointer node to move towards the next values. So let's just create a new pointer node in this case. After creating these two values, we will need to at any given position keep track of the next node, because for the pointer node we will need to iterate to the next element. At the same time, using the pointer node, we are going to manipulate the values of the new head variable because we are reversing the linked list. So we will need to create a new variable called next node, and initially the next node value currently is null. Just understand for the sake of understanding that this is null. and now we don't need the head node. So after initial setup or initially setting up everything, let's see that what would be the approach to reverse the given linked list. Okay, now first thing we are going to do is, since we need to keep track of the next node, we will first assign the value. So we will keep the next node to be the pointer dot next. Okay, we set up the value of next node to be pointer dot next. So at this position, the next node is going to be here. Okay, now we also need to keep track of the value of pointer dot next. But the thing is, since now we are trying to reverse the linked list, basically the pointer dot next is going to point towards the new head. So let's mark that. So pointer dot next should move towards the new head. Okay, so currently the new head value is null. Keep it that way for now. Now we need to update the value of the new head. So for the new head is going to be the existing pointer we are at. So existing pointer currently is 1. So in this case, the new head is going to be the value of 1. Okay, so let's just mark this value. So new head is going to be the existing pointer value. And in the end, we need to move this pointer to the next element. How would we be able to do it? Using this next node, because we already updated the value of pointer dot next. So we will need to move for the pointer to the next value, which is going to be pointer is going to move to the next node. So nn. And this, using these steps, we would be able to reverse this linked list easily. So now after the first iteration, this is the current setup we have. That new head is located at 1. Currently the pointer is located over here, and new node is also here, but during the next iteration the values will be updated. So now let's update the values again. So now, okay, new node becomes to the next value. So this is going to be our new node. Now at the same time, pointer dot next points to the new head. So currently this pointer 2 is pointing towards 3. But rather than pointing towards 3, now this 2 is pointing towards 1. So we are going to have a configuration. So currently the new head value is 1, and we are going to have 2 point to the 1. This is the current logic we have. Okay, at the same time, new head is now going to move towards pointer, which means that rather than new head having the value of 1, it is going to have the value of 2. So let me write this in a little bit separate manner. So if I do that, basically currently the new head is going to be the pointer value, and the pointer dot next, we already define it to be the previous new node, which is going to be 1. Okay, so now this is the setup we have. And also now pointer moves to the next node. So next node is 3. So now pointer again moves to the next node. So pointer is here, next node is here. Again, if we repeat the same iteration, basically the next node is going to be pointer dot next. So this is going to be the next node. Now pointer dot next is going to become the new head. So pointer dot next is currently pointing towards the value number 2. Value number 4, but rather than pointing towards value number 4, pointer dot next is now going to point towards value number 2. At the same time, new head is going to become pointer. So now let's just make this changes as well. Now in the end, we simply need to move pointer to the next element. So now pointer will move to the next element. And in the end, if we repeat the same process again, basically the next node will end up at null, and we will have the new head to be value number 4. And since the next node is null, we cannot do anything. So we can break out of the loop here, and whatever the next head is, we can simply return that. But at the same time, we reverse the given entire linked list, and this solves the major concern of our problem. So now we already know that how to reverse nodes. Okay, so after understanding all the small pieces, now let's see that what would be the optimal solution. Basically, for the optimal solution, we have two options. First option is that we use the recursive function, and then things becomes much easier for us. Basically, we take these two elements, we apply the recursive function where we basically reverse them, and after reversing, we update our value, and again repeat the same process for these 3 remaining items. Again, we reverse these 2 items, and then we keep the last item. And then basically using the recursion and the reverse function, we would be able to solve this problem quite easily. Now for the recursive approach, if we see time and space complexity, basically the time complexity is going to be big O of n, because we need to iterate over the given input twice. Why twice? Because first we need to check that whether for the given input, if the given value of k is greater than or not, or less than or not. And then secondly, we need to do it for the reversing the k nodes. If we see space complexity, the space complexity is going to be big O of 1, where big O of n, where we will use n space for the recursive stack. So the next question your interviewer is going to ask you is that, rather than using the big O of n space complexity, can you solve this problem in big O of 1 space complexity? So that is also very simple to do. Basically all we need to do is that at any given position, first we will try to see that whether the given k elements exist or not. If they exist, then we will simply reverse them, and we can simply use like couple of while loops and do this iteratively. And the logic is going to remain the same, but first we are only going to check that whether the number of k elements are present or not. If they are present, we are going to simply apply our reverse function, and after keep on reversing the values, eventually we would be able to find our answer as needed. And iteratively, this is the answer we need to return. If we see time and space complexity, in this case the time complexity is actually going to be big O of n, and the space complexities in this case is going to be big O of 1. Now for the coding solution part of this particular reverse nodes in k group portion, actually I made a blunder before. I recorded the whole video explaining the code, but I forgot to use my microphone, and that's why I didn't record any of the voice. Now I'm not going to do the whole thing again. I can just go through the code, and then I'll post this code in the comments, and also I can post this code in the GitHub repository that I have created and provide links for both of them. So basically you would be able to see the code. Now in this particular solution, basically we are using the iterative approach by which we will have a better space complexity, and definitely we need a way to reverse a linked list. So I'm creating a helper method that takes in any list node as an input and a k value, and return the reverse linked list new head. So these are all the steps that we discuss in the explanation part of the video, and we keep on repeating the same process, and this is just the helper method. Okay, now let's move on to the main method. Now inside the main method, first of all, we are defining a few of the variables that we need to keep track of different things. So basically we have a variable pointer that will iterate over the given entire list. We are also keeping track of a k-tail variable, and what this k-tail variable does is that whenever we are done iterating like any set of k nodes, and we are planning to go to the next step. So if we see on the left side of the screen, suppose we have done iterating reversing this 1 and 2 node, which means we still have nodes 3, 4 and 5 to process. So k-tail would be pointing towards this node number 2, and we would be able to do certain things with that that we will see next in the code. Now first of all, we are going to initialize a while loop that while the pointer is not equal to null, which means this is the loop that runs over entire given linked list. Now inside that, first of all, we have a counter, and we also have pointer located at the head position. We first check that whether the current count, if that is less than k, we will move the pointer towards the next element and keep on updating the value of k. And now we would be at the position if the count is equal to k, which means we are at the position where currently we will need to reverse the nodes that are between those values. So say for an example, initially count would be 0 at this value number 1, and count would be 2 at this value number 2, and basically we need to reverse like these two values. So we will use our reverse function, and after in this condition is only there for the first case scenario, because if we see in the output, the head is always going to be the reverse portion of first k nodes. All the other k nodes doesn't matter. So that is why this is to define that what is going to be the new head value, and then this checks that whether the k-tail, if that is not equal to null. If that is not equal to null, which means that the k-tail value is actually going to point to the new reverse node value, and that is why we are using the k-tail variable. And in the end, we just update the k-tail pointer and also the head pointer and keep on iterating the while loop. So basically using the combination of these two, we are able to solve this problem, and in the end we are simply returning the new head. So we will check that if the given new head is equal to null, if this is the scenario, this will only happen if the given k is actually greater than the number of values present inside our linked list. And in that case, we simply need to return the old head. And if the new head is not null, we need to return the new head value. And this is the whole solution. I hope the solution makes sense. And now let's try to run this code. So our solution seems to be working. Let's submit this code. And if we submit this code, our solution actually runs 100% faster than all the other solution. And that is because the runtime is actually 0 millisecond. And even if we see in terms of space complexity, this is really good. So this is a very good solution. Again, I would be posting this in the comments, so you can check it out from there, or you can check it out from this GitHub.
Hello friends, we are not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to invert a binary tree lead code problem, and if we see some of the companies where I want to work at who have already asked this question, there are companies like Amazon, Facebook, Google, Apple, Bloomberg, Microsoft, Uber, Goldman Sachs and LinkedIn. So that's why I'm paying my utmost attention. I hope you also enjoy the video. So this is the LeetCode easy problem and also very well liked problem on LeetCode. Basically, we are given the root of a binary tree and we need to invert the tree and return its root back. So let's try to understand this with a couple of examples. First of all, we'll take this example. So over here, we are given a tree that looks like this, where this 2, 1 and 3 are part of the tree, where 1 is the left child and 3 is the right child. So if we invert this tree, we will get an answer that looks like this, where 2 remains the root because it is the root node, but this 3 that was originally the right child will become the left child, and this 1 that was originally the left child will become right child, and this is what we need to return. Let's take a little bit more complicated example. So over here we are given the root to be 4. Now we are given that the left child and right child of this 4 is actually 2 and 7, and further down we are given more left child and right child for this 2 and 7 as well. Now if we invert those all of them, we will actually get a result that looks like this, where 4 remains the common, this 7 that was originally the right child will become the left child, and this 2 that was originally the left child will become right child, and same thing will happen for these leaf nodes as well. And this is the answer we need to return in the answer. This is what the problem is asking us to do. Let's see that what would be the different approaches to solve this problem. Before we come up with the optimal solution, let's understand a very important concept. Suppose this is one of the kind of a binary tree we are given and we need to invert this tree. Well, if we see over here, we are given a root node, then again we are given some left child and we are given a right child. Now further down, for this left child and right child, they also have the children of their own and they also form a bigger binary tree. So at any given moment, suppose we are given this root node, we are given this left child and we are given this right child. So if we want to invert this tree, all we have to do is whatever this right child is and whatever this left child is, if we just swap them or if we invert them, basically we are at least done with this root level and with this left child and right child level. Now again, if we further break down that, suppose this is the left child, now we are treating this left child as a root. So suppose now this is the root and this is the left child and this is the right child for this root. So again, if we want to invert them, what we can do is we can take whatever the left subtree and right subtree is. So in this case, for this root, the left subtree is going to be this, the right subtree is going to be this. If we swap them, essentially we have taken care of up until this level for this inverting part, and same way we can keep on repeating the process. So now this becomes our root. Again, we flip these two values, and even for this level, we have taken care of inverting the binary tree. So this is what exactly I'm suggesting us to do in order to solve this problem, that we starts breaking this given input into bunch of smaller inputs and start inverting binary tree in that manner. So the idea is that for every single time we will have a root node, we will swap its left and right child, then again for if there exists any left or right child, we will repeat the same process and keep on swapping those values, which means that we are actually doing the changes recursively. We can actually solve this problem pretty efficiently. Let me quickly show you how. Suppose this is the input we are given and we are trying to invert this binary tree recursively. So what we are going to do is, suppose we will take initially this as the root node, and for this root node we actually have a left child and we actually have a right child. So what we are going to do is we are going to swap its values, and we are going to swap the entire left subtree and entire right subtree. Then at any given moment, as long as we have some nodes, we are going to keep on treating them as different root nodes, and then we will keep on flipping their values or their children's values, and at the end we should have a completely inverted binary tree.
tree. So let's see that in action. So first of all, this is the root node and this is the left and right subtree. So what we are going to do is we are going to swap the values. So we will have a tree that looks like this. Okay, so far treating this as root tree, we have actually swapped these left subtree and right subtree, and we will get a tree that looks like this, where you can see that this value 3 and 2, they are actually inverted, but their subsequent children values, they are not inverted, and we will still have to repeat the same process. So let's see that in action. So now again, what we are going to do is we are going to treat this 3 to be root child, and we are going to repeat the same process with the 6 and 7. So if we invert them, we will get a tree that looks like this. Now we are going to treat the 7 to be the root node. If we treat the 7 to be the root node, actually it does not have any children, which means we don't need to flip any more values. Now again we will treat the 6 to be the root node. If we treat the 6 to be the root node, again it does not have any more children, so we can skip that. Now we will treat this 2 to be the root node. So if we treat this 2 to be the root node, it has children, so we will have to swap their values, and we will get a value that looks like this. And we would have taken care of both of them. Now again, this 5 and 4 does not have any children, which means we can't do anything about it. And then in the end, this is going to be the answer we need to return. So we can simply return the root value, and basically we would have inverted the entire tree recursively. So that is the approach we can use as an optimal solution. There is also one more way to iteratively approach this problem, but the thing is, I believe that for tree kind of problems, the recursive approach is better than the iterative approach. Let me know in the comments if you want to see the iterative approach as well, and I can make a separate video on that. If we see the time and space complexity, in this case the time complexity is actually going to be big O of n, where n is the number of nodes that are present inside any given tree, because we will have to iterate over every single tree to invert them. Now if we see the space complexity, well, at any given moment, because of the recursive function, we might have to store bunch of different node values, and that would depend on the height of the tree. So basically the space complexity is going to be big O of h, where h is the given height of any binary tree. So because we are going to solve this problem recursively, first let's create the terminating condition, that if the given root is actually null, we can return. If the given root is not null, we are going to make the recursive call for right and left values. So for right tree, we are going to make the recursive call to the same function with the right child. Same thing we are going to do for the left subtree. After that, we are going to replace the values of left and right subtree. So now that should have taken care of all the cases, and now we can simply return the root value. And that should be it. So let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our solution is actually pretty efficient. It's actually 100% faster than all the other solution, and that is because the runtime is actually 0 millisecond. I would be posting this in the comments, so you can check it out from there. Thank you. Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to do maximum depth of binary tree lead code problem, and if we see some of the companies where I want to get a job who have already asked this question, there are companies like LinkedIn, Amazon, Microsoft, Google, Facebook, Apple, Bloomberg, and Uber. So that's why I'm paying my utmost attention. I hope you also enjoy the video. So this is a LeetCode easy problem and also very well liked problem on LeetCode. If we understand the problem statement, basically we are given the root of a binary tree and we need to return its maximum depth. Now we are also given the definition of what a maximum depth is. It is basically the number of nodes along the longest path from the root node down towards the farthest leaf node. That is the depth of the tree. And if we try to understand this with an example, suppose we are given a tree over here that looks like this. In this case, the maximum depth is going to be 3. Why? Because the nodes at the root level is currently at position 1 or height 1. The root at this level is at depth 2 or height 2, and root at this level is actually at depth 3. So in this case we need to return 3 as the answer, because 3 is the maximum depth we can get from this root node. So let's see that what would be the different approaches to solve this problem. Okay, suppose this is the input we are given and we are trying to find the maximum depth for this particular given tree. Suppose this is the root of the tree. If you want to find the maximum depth for this tree, the answer is going to be 4 because of these two nodes. We can see it clearly over here, that over here the value is 1, this is 2, this is 3, and this is 4, and this is the answer we need to return. The question is, before we return this answer, we will actually have to build some intuition behind it. And the intuition is, suppose at this position number 5, if we want to determine that what is the maximum depth over here, well, what we can do is we will check on the left side, we will check on the right side, and whatever has the greater number of nodes on either side, we will actually take that as maximum depth and we will do it +1. Well, in this case, the 6 and 7 both are located at the same position. 6 and 7, none of them has any children, which means that over here we can determine that this is actually 1 and this is also 1. So on the left side and on the right side, both values are actually 1. So what we can do is we can do 1 plus 1. So 1 plus 1 will give us the answer that the maximum depth at position number 5 is going to be 2. So in this case, okay, we have found the maximum depth over here to be 2. Well, if we take this value number 4, well, at this value number 4, it does not have any more children. If it does not have any more children, which means we can determine the maximum depth in this case is going to be 1. Well, now we have these two values. That now based on these two values, it becomes pretty easy for us to identify that what is the maximum depth at this position number 2. All we will have to do is we will take whatever the maximum value amongst these two is. Maximum value is actually 2. So what we can do is we can do 2 plus 1, and 2 plus 1 is actually going to be 3. So we can determine that 3 is going to be the maximum depth we can achieve at this node number 2 if this was to be the root of the given tree. And for this position number 3, the maximum depth we can achieve is only 1 because it does not have any more children. So that is a given fact. Now we have these two information. Now it becomes pretty easy for us to identify that what is going to be the maximum depth at this position number 1. And all we will have to do is take the maximum amongst these two values. So maximum value is going to be 3, and all we need to do is just plus 1. So if we do 3 plus 1, we will get the answer 4, and 4 would be the correct answer in this case, and that is what we are going to return. So the maximum depth we need to find, we can simply do it by using this method. Well, now if you see, for this particular solution, we are actually able to achieve this solution, but what we are doing is that at any given position, we are seeing that what is the left max value or right max value, and whichever is greater amongst either one of them, we are taking that and we are adding 1. Now again, we are repeating the same process, that we are taking the left max and right max value, and again we are adding 1. So which means that in order to solve a bigger problem, we are actually solving a smaller problem and then again a smaller problem. So basically we are doing it recursively, and that is how we are going to solve this problem using recursion, which is very powerful and it is highly used in different kinds of tree problems. So that is how we are going to solve this problem, and this would be the optimal solution we can use. If we see the time and space complexity, in this case the time complexity is actually going to be big O of n, because we will have to iterate over every single element in order to get the answer. And if we see the space complexity, in this case the space complexity is also going to be big O of n, because we might have to store all the values inside our recursive function. And this approach is actually very good. It works as expected. There is also one more approach which uses stacks, and that does not use recursion. It actually use iterative function. So let me know in the comments if you want to see the stack solution as well, and I can also explain that. But for now, if you show this recursive solution in any interview, the interviewer would be more than happy. So let's move on to coding now. So first of all, we are going to take care of a edge case. If that is not the case, we will have to call our recursive function. First of all, we are going to have an integer called left max that is going to take care of the left subtree for any given root position, and we are going to call our recursive function again. And same we are going to do for the right subtree as well. We are going to create a parameter called right max. And in either case, all we have to do is simply return whatever the maximum value we are able to find, and then we will add 1 to it. And this should be it. Once we get out of the loop, our solution would be done. So let's try to run this code. Okay, seems like our solution is working. Let's submit this code. And our code runs as expected, and it's actually pretty fast compared to a lot of other solutions. So I would be posting this in the comments so you can check it out from there. Thank you. Hello friends, so now once again let's do an awesome LeetCode problem that is going to solve all of your problems. So without any delay, let's get started. So the lead code problem we are going to do today is called diameter of a binary tree. We can see that this one is an easy problem and also a very well-liked problem. The problem statement is quite straightforward. We are given the root of a binary tree and we need to return the diameter of the tree. Now the question is, diameter of a tree is the length of the longest path between any two nodes inside this tree, and we are told that this path may or may not pass through the root, but it's gonna pass through the root. Okay. Now the length of the path between any two nodes is represented by the number of edges between them. So let's try to understand that how does a diameter of a tree is being calculated. Let's say that we are given a tree like this. So in this case, what is the longest path we can make? Well, let's just give them the number. So 1, 2, 3, 4 and 5. These are the numbers of this given nodes. So we can see that the longest path over here is this one. So 3, 2, 1 and then 5. This is one path. Second longest path is once again 4, 2, 1 and 5. So in either case, the longest path we are able to make contains 3 edges. This is going to be the first edge, this or this, either one of them. Then this is the second edge and this is the third edge. So the answer is going to be 3, that this is what we need to return. Now the problem statement is quite easy to understand, but the thing is, how do we actually calculate the diagram? And if we start iterating over every single path and then try to find the answer, then this becomes a lot of complication. So we need to avoid that. And if you look at it from the other way, at any given moment or at any given node, the diameter of that node is nothing but the height on the left hand side. So left hand height and the height on the right hand side. That's it. This is all a diameter is. And we can see that in action over here, that the height on this left subtree is actually going to be 2, because this is the first level and this is the second level, and the height on the right subtree is going to be 1. So if we do 2 plus 1, the answer is going to be 3. So this is what we need to calculate. Now we need to understand that how we are actually going to be able to calculate that for any given binary tree. And for that, we simply have to iterate over any given tree, nothing more than that. Now, iterating over the tree is actually quite simple, and we can use the common logic of recursion in this problem. Now for recursion, we need 2 items. First item is a base case. So base case in this case is going to be that if the current node, if that is equal to 0, which means we have reached to the very end and now we cannot go anywhere further. So then we start to do the backtracking. This is the first base case. Now what is going to be the recursive equation or recursive scenario? Well, recursive scenario is quite simple, that at any given moment or at any given node, the height or the diameter of that node is actually going to be the sum of the left diameter and the sum of the right diameter. And same way, even at subsequent left node, the diameter at that node is going to be sum of the left diameter and right diameter, and that's how we should be able to calculate the answer we are looking for. So in this case, the height on the left hand side is going to be 2. The height on the right hand side is also going to be 2. So the longest path we are going to be able to make is going to be of size 4. And we can also see some examples of that. So one of the longest path starts from this node and then once again to this node, and once again to this node, and then once again to this node, and once again to this node. If we see the number of edges included, this is the first edge, this is the second edge, this is the third edge, and this is the fourth edge. So this is exactly what we are looking for in terms of finding the answer. So we also found out the recursive solution, that the diameter at any given node is going to be the sum of the left node and plus sum of the right node. Okay, and then we can have a recursive function to iteratively recursively call our entire tree and then return back the answer. So this is actually going to be the whole solution. We are simply iterating over the tree, calculating the height, and whatever the sum of the height is, we simply return that. If we see time complexity, in this case, the time complexity is going to be big O of n, where n is the total number of nodes that are currently present inside the tree, because we will have to iterate over every single node. And in terms of space complexity, well, this is also going to be big O of n, because we are using the recursion, and in order to store the recursive stack, we might use big O of n space. So if you want, you can also do this problem iteratively, and in the iterative solution, we actually don't have to do or use the stack. But the only reason I am using the recursive solution is because it's good to do it like recursively. It's small amount of coding and also looks cool. Okay, so now let's quickly go to the coding. So the coding solution is quite straightforward. We are going to initialize our variable maximum diameter, and we are going to have our method diameter of the tree, from which we are going to call our get height method for left and right subtree for the given root element. Okay, now this our get height method is our recursive method. So let's quickly see what is happening. As a part of the base case, we are having the scenario that if the given node is equal to null, we need to return 0. If that is not the case, then we are going to find the left height and the right height. For both, we are going to recursively call the get height method with the left child and with the right child. Now for every single position, we will have to check that have we reached a new maximum diameter. So for that, we are going to do a simple equation of the current maximum element or maximum diameter we have been able to find. If that is greater, or if we find that the current left and right side subtree's height is greater than the current maximum diameter we have been able to find, then we need to update the max diameter. If that is not the case, then we can simply leave the max diameter as it is. Next, we need to return the height that we have been able to find. So in the end, we are simply going to return 1 plus the maximum value of either left height or the right height. And why are we doing 1 plus? Because at any given root node, we also have to consider the node by itself before propagating the height to its previous level. So that's why this 1 plus is there. Okay, with every new level, basically we add one value to the height. And this is the solution. Let's try to run the code. Okay, seems like our solution is working as expected. Let's submit this code. So our code runs 100% faster than all the other solutions, and that's because the code actually operates on a very simple principle, and it runs in 0 milliseconds. So that's why it's 100% faster. It's nothing magic. Now, once again, the coding solution is present inside our GitHub repository. Let me quickly show it to you that this is the GitHub URL where we have actually stored hundreds of LeetCode questions and their answers. These are some of the most popular questions in the entire world. These questions has been asked at tons of different companies multiple times. So for each of the problem, you can go ahead and see we have the Java file for that. You can go and find the LeetCode link. If you don't find, you can also find the subsequent video solution, and also a list of most asked problems at the FAANG companies, which is this list, which contains a lot of important LeetCode problems. They have been differentiated based on the topics, and for each of the topics I have provided that how many times they have been asked at different top tier IT companies. So there are 130 of most fabulous questions that I have been able to find. Then also I have solved most of the NeetCode 150's problems, and they are also provided over here. So both of these resources are amazing. So the LeetCode problem we are going to solve is called balanced binary tree. Now we can see that this one is a LeetCode easy problem and also one of the most liked problems on LeetCode. The problem statement is quite straightforward, that we are given a binary tree and we need to determine that whether it's a height balanced binary tree or not. So the question is, what does height balanced tree means? It's actually quite straightforward. Height balanced tree means that at any given moment, the height of left subtree and the height of right subtree, if they do not difference more than 1, so which means that there is the maximum difference of heights is like 1 or 0. If that is the case, then we can say that this one is a height balanced binary tree, okay, or balanced binary tree. But if we identify, so let's try to understand. In this case, currently this one is our root node. Now if we see the left subtree, we can see that the height of this left subtree is 2. For the right subtree, the height of this right subtree is 3, which means the difference between left and right subtree is no less than or equal to 1, which means this one is a balanced tree or like height balanced tree. But in the same scenario, let's imagine that if we had one more nodes like this, then the height of this right side binary tree is going to be 4. Meanwhile, this left subtree is still going to 2. So if we do the difference of the height, we get the answer as 2, which is definitely greater than 1. In this case, we can say that now this binary tree is not a balance, not a height balance binary tree. Okay, so this is what we need to determine. Now this is like a very straightforward problem. Basically, at any given moment we need to check that for any given node, what is the height for both left and right subtree, and this we can calculate very easily by simply traversing over the given tree in like any BFS or DFS fashion. And once we do the traversal at any given moment, we will have to keep track that for any particular root node, what is the height of its left subtree, what is the height of its right subtree. And if the moment we identify that the difference is actually greater than 1, then we can clearly say that this is not a balanced tree. If we identify that we iterate over the entire tree and we did not find that the height to be greater than 1 at any given moment between left height and right height, then in that case we can say that this one is a balanced tree. So that's it. This is all what we need to do. The approach is quite straightforward, and the idea we are going to use is that we need to traverse over the given binary tree. So for traversal, we know that there are iterative methods and recursive methods. Let's try to do it recursively. So recursively, we are simply going to iterate over the given tree. We need 2 items for the recursive case. First recursive condition is the base case. So base case is going to be that if the given current node is equal to null or 0, then we have basically exhausted every single child that we can visit for that particular tree. So we can do that. What is going to be the recurrence call that we need to make for the recursive level, that we are going to check that for any particular root node, first we are going to traverse its left child and then we are going to traverse its right child. So that is also good. Now while traveling, the moment we enter a new height or a new left child or a new right child, we are going to have a counter that is going to keep track of the left height, and we are also going to have a counter that is going to keep track of the right height. We are going to update it sequentially with every single level that we are increasing, and during every single update we are simply going to check that if the difference between left height minus right height, and we are going to do an absolute difference. So we don't care about which one is greater, as long as the delta is greater than 1. The moment we find this one, we can say that this one is an invalid or not a proper height balance binary tree. And if we reach to the end, we can say that this one is a height balance binary tree, and we can return this answer very easily and very simply. So the approach is quite straightforward. If we see time and space complexity, in this case the time complexity is simply going to be big O of n, where n is the number of nodes that are present. For the space complexity, because we are using recursion, we will have to induce or create a new recursive stack, so that might increase the time complexity to big O of n. And if you try to do this recursively, you can also do this in big O of 1 space complexity as well. But I don't think like any interviewer is going to have any issue of you using recursion, because that is a great way to save some time. And now let's quickly see the coding solution for this one. So if we see the solution, it's quite straightforward. We need to return a Boolean answer that whether the given tree is balanced or not, and in the input we are given the root. Now first we check for our base case that if the given root is equal to null, we can simply return true. If that is not the case, we are going to calculate the left height and we are going to calculate the right height. For that, we are going to use a helper method called getHeight, and we are going to pass in the root value. Now inside the getHeight method, we are also going to check recursively that whether if the given node is equal to null, we can return 0. If that is not the case, we are once again going to recursively call the same method for the left child and for the right child, and at every given instance we are simply going to calculate the maximum height we have been able to find both for left height and right height, and we are going to add +1. So this is going to give us the height at any given left subtree and right subtree that we are going to fetch values over here. Then we are simply going to have our math.absolute formula that if the difference is greater than 1, then we can simply return false. If that is not the case, then we simply need to say that yeah, if this given tree is balanced. So that's it. This is the whole solution. We can simply run the code, and then I think it should be working fine. Okay, seems like our solution is working okay. Let's submit this code.
and our code runs 100% faster because there are very few test cases. So this is pretty awesome. Now once again, this whole solution is actually posted on our GitHub repository that you can find over here. Now this GitHub repository contains hundreds of very popular every single LeetCode problem that you can imagine, and for each and every problem I have also provided that what is the LeetCode problem statement for that particular problem, what is the Java solution, and for some reason if you cannot understand the solution on your own, you can actually go to the video solution as well. I have provided the link. So this is a great resource for anyone trying to prepare for LeetCode or DSA problems. The other thing is, I also want to show you one more resource that I have created, or not the LeetCode one, but the document that I have been able to curating. Now this document contains two very important lists. First list is the most popular and liked technical interview questions of all time. Now over here I have created a list of 130 questions. For each of these 130 questions, I have divided them based on the topic that you need to prepare. And I have also provided the key important information that how many times that particular question has been asked at what type of company. So this will help you in a couple of ways. Number one, you would be able to understand if you're targeting any specific company, you can find that how many times that question has been asked at that company. Number two, based on just looking at the question, you can understand that how important that question in general is. So some questions have been asked like literally hundreds of times by many top tier companies. So you should be able to identify that as well. And each of the topics are distributed based on like easy, medium and hard LeetCode problems. So that is one option. Second one is the NeetCode 150 list that I'm currently working upon. So this is like the 150 most asked questions list created by NeetCode. That is an addition to Blind 75. Now this is also a very pretty and very important list. Once again, all the questions are differentiated based on topics. We can also see that for most of the questions, I'm trying to go through them and generate solutions for them as well. So yeah, if you want, you can also check out this resource. Maybe it can be helpful with your prep journey. Okay.
Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to do same tree lead code problem, and if we see some of the companies where I want to get a job who have already asked this question, there are companies like LinkedIn, Amazon, Google, Bloomberg, Apple, Microsoft, Facebook and Uber. So that's why I'm paying my utmost attention. I hope you also enjoy the video. So this is a LeetCode easy problem, and as the name suggests, same tree, the problem is self-explanatory, but let's go over it. That basically we are given two roots of a binary tree called P and Q, and we have to write a function to check if they both are same or not. So let's try to understand this with couple of examples that are given over here. Here we are given this two trees P and Q, and in this case we can see that both of these are 1, both of these are 2, and both of these are 3. So we can say that okay, they are actually same, and we can return true in this case. But for the second example, if we see the P and Q values over here, for 1 is same, so root values are same. But if we see over here, this is actually 2 and this is actually 2. Despite being the same value, the positioning is not same, because this is actually the left child of this given P tree, and this is actually the right child of this given Q tree, which means that these two are not same. So in this case, we will return the false, and this is what we have to achieve. So let's see that what would be the different approaches to solve this problem. So solution of this problem is actually quite simple, and if we see the approach one, we are going to use an iterative approach. In the iterative approach, what we are going to do is we are going to iterative over both of these given trees in the same manner, and we are going to keep on checking subsequent nodes of every single position. At any given moment, if we identify that any single node does not match, we can return false immediately, and if somehow we can reach out to the end of the tree and iterate over every single nodes, we can return true in this case. So let's see that in action. So first of all, we are at this P, for this P and Q tree, currently we are at this root position, so we will check that value, and both of them are actually 1, which means we are good so far. Now we are going to iterate over on the left side. So on the left side, this value is actually 2 and this value is also 2, so again we are good. Now again on the left side, this value is actually 3 and this value is also 3, so again we are good so far. Now we go back, and now for this position number, we also have a right subtree, or so we will check that right position.
position, this is 5, and this also has the right position, which is also 5. So far we are good. Now again we go back to this root node. We still have this right side that we haven't traversed, so this node is 4 and this node is also 4. So again we are good, and at the end this node is 6 and this node is 6. Now we don't have any more nodes to go back to, so essentially we have traversed over all the nodes inside given both the trees, so we can return true in this case. And this is the approach we are going to take. Let's see what would happen in a scenario where trees don't match up. So here I have drawn that example as well, that over here all of these nodes are same, but actually this node and this node, these two are not same. So because these two are not same, the moment we iterate over all of these nodes and eventually we would reach to these positions, we can return false immediately in this case. So this approach would work as expected. And if we see the time and space complexity in this case, the time complexity is actually going to be big O of n. Why big O of n? Because we will have to iterate over every single node inside the given tree for both the p and q trees. And the space complexity would be big O of log n. That is because this is a binary tree. Well, in the second approach, we are actually going to solve this problem recursively. And the idea is at any given moment we have to identify that whether two trees are same or not. The thing we are going to do is we are going to compare their root nodes. If they both are same, we will have to compare their entire left subtrees, that they have to be the same, and also we will have to compare their entire right subtrees, that as they also have to be the same. And if that is the case, we can define that tree to be the same. But if we take a look at for the left subtree, again we are going to repeat the same process, that even for the left subtree we are going to compare the root nodes. If they both are same, then we are going to compare their left subtrees and their right subtrees to be the same. So essentially we are doing the same thing repeatedly for different kinds of input, and recursion is the best way to approach that. And also your interviewer is going to expect you to do this recursively, because that would be more efficient way of doing it. So let's see that in action. So the idea is at any given moment we are going to compare the root node. So over here root node is same. Because root node is same, we will have to check that whether the left subtree is same and right subtree is same or not. So first we will do the left subtree. So now for the left subtree we have these two trees for p and q respectively. So again we will check the left node. So left node is this 2 and this is also 2, so they both are same. Now we are going to check the left subtree and right subtree again. So this, both of these are 3, so we are good. Now we will have to check the right subtree. So right subtree is also 5 and 5, so again we are good. Now again, so far we have calculated the entire left portion, but we haven't calculated the right portion. So now we will do that. So again for the right subtree, this value is 4 and this value is 4, so again they both are equal, so we are good so far. And then these values are 6 and 6, so again we are good so far. Now we have iterated over every single node recursively, that is the important part, and we have found all the values to be the same. So because they were same, we can return true in this case, and everything is good. And at any given moment, suppose we identify that any single node does not contain the same value as its counterpart, then the moment we are comparing these two values, we can return false immediately, and that would be the solution for this problem. If we see the time and space complexity in this case, the time complexity is also going to be big O of n, because we will have to iterate over every single value, and the space complexity is going to be big O of log n. So the time and space complexity is not different than the iterative approach, but recursive approach just is a lot less coding, and I will also be showing that in the code. So first of all, we are going to check that if the given p and q both are null. If both are null, we will have to return true, because essentially they both are same. If that is not the case, and if any of either p or q is null and the other one is not null, then in that case we will have to return false. And if both values exist, then we will have to compare their values. And if both values are not same, we can return false immediately. If that is not the case, we will have to iterate over left and right subtrees of a subsequent p and q trees. So now we are going to make our recursive call. And that's pretty much it. Let's try to run this code. Okay, seems like our code is working as expected. Let's submit this code. And our solution runs pretty efficiently. It's actually 100% faster, but if that is not the case, because runtime is 0 millisecond, that's why it's showing 100% faster. I would be posting this in the comments, so you can check it out from there.
So if you are listening to me in this section of the video, first of all, I just want to say congratulations on completing nearly 12 hours of DSA. I know it's not easy, and it really shows that how dedicated person you are for your career. So many congratulations to you. And because of YouTube restrictions, I cannot upload video more than 12 hours long. So that's why the remaining questions are part of the second video that you would be able to find very easily. That would come right after this little monologue that I have to share with you. I just have a small request. If you have reached at this point, just comment word pineapple. So at least that way I would know that how many people are actually able to reach to the end. And once again, I genuinely say thank you for seeing my video for at least 12 hours, and hope you find it interesting for the other questions as well. Good luck.